Welcome to our lecture on dynamic web content. In some ways, this lecture is the most important lecture of the course. Whether you end up writing in PHP or Angular or who knows what, a web application makes request-response cycles. That is how a web application is different than, say, a desktop application, even though a desktop application, if it talks to any network resources, is also often making network requests that are request-response cycles. So, this may seem like, why do we even need to know this? But it turns out this is the thing you need to know. This is what you will be comfortable with. And after a while, you'll be like, of course, I know how that works. But this is the foundation of all web applications. And so the web applications that we are working with are sort of three-layer applications. And in the modern world, there's all kinds of variations on this three-layer application, and I don't want to get into right now which is best and which is not. This is sort of the most basic. What we're going to do is learn the basics, and then later you can use a fancier user interface. So the way this works is, let's make sure I get my scribbling thing on. Come on. Okay. So you're out here, the end user. That's you, end user, and you're using a browser. And in that browser, you do a click of some kind. And that click goes across the network, and the first thing it encounters is a web server. And then that web server may actually form up some structured query language, like a select statement or something, talk to the database, read some stuff off the disk, and then send the rows back, and then PHP will format these rows up and send the page back to the end user. And so we as a developer eventually be writing PHP that creates SQL. So far, up to this point, what we've been doing is we've actually been functioning as the database administrator, where we're using a tool like PHPMyAdmin. We type SQL by hand, and then it goes back to the database, and then we see it in our user interface. But we are going to transition from the role of DBA to the role of developer, and then what we'll do is we'll write application software that will do the SQL on our behalf. And by now you're probably a little tired of writing SQL by hand, and when we start writing software, it's easier to write the SQL. So the SQL will help us write that software. So that's kind of where we're going. And in a sense, it's a little more than that. And we have this web server that I just showed you that has PHP, MySQL, and Apache in it. And we got this network, and then we got the browser. And we have these requests and responses that are going back and forth. But then we're also going to learn how to do more intelligent stuff in the browser. HTML, CSS, the document object model, JavaScript, and jQuery all work together along with the data and that comes back and forth between the server to then produce the user experience that we see in a web page. So the thing that we're learning about today is the Hypertext Transport Protocol, and HTTP is what we call it, and it was one of the great inventions of Tim Berners-Lee and others at CERN when they first conceived of the web in 1989 and then 1990. It really was intended as a rather simple protocol to retrieve documents and images and PDFs and then navigate from page to page. And because it was a very small development team that was building the first web servers and the first web browsers, they kept it simple. And frankly, we benefit greatly from that simplicity. And what we'll do is we'll even do this by hand, even though in the future, as we go from HTML1 to HTML2, it'll be a little more difficult to do this by hand. But for now, we can do it by hand and learn how it does. The basic concept is you connect to a server, you navigate down and grab a document, and then you get the document back. And the other tremendous innovation was the URL. And the idea of the URL is it captures three basic ideas, and that is what kind of protocol we're going to use. HTTP, Hypertext Transport Protocol. That's mostly what you see on these, but that's not the only thing that you can see. A host that you're going to connect to, and then a document that you're going to retrieve. And so we split this out. This is how, this is where, and this is what. And that's the U of Uniform Resource Locator, is that you can know what to get, where to get it, and then how to get it, all in one long string, as long as you tear the string apart according to the rules of parsing. So, the basic request-response cycle is you have a page, you're looking at the page, in general it's not permanently connected to the server, you're offline in a sense, you're seeing the page, even though there's sneaky stuff going on sometimes in the background. But in a sort of very simple world, you're reading a page, then you click on a link, and then you go get another page from that link. So let me just show you real quick how that works. So I go to a page, drchuck.com/page1.htm, and then at this point I'm not talking to the network, but at some point I will click on this link, and that will direct my browser to go get another. So sorry for the interruption. That lecture was being recorded, and I was late to the airport, and I had a small technical difficulty, and so I had to go to the airport, and I had to fly to South Korea, and so we're going to pick this lecture back up from South Korea. So hi and welcome to South Korea. So the last thing we were talking about before we had to get on the plane to South Korea was what goes on when we retrieve a web page. I'm going to start with drchuck.com/page1.htm. And so make it a little bigger so we can see it. So this is a page. We typed this URL into our location bar, and it looked at HTTP, www.chuck.com is the host that it goes to, and page1.htm is the page that it retrieves. And so at this point, we're not really interacting with the network. The more complex pages do have little background things that they're interacting with the network, but for now, we're not talking to the server in a traditional web page. And if I hover over here, you can see down in the lower left-hand corner that it's telling me where it's about to go. This browser is an application running on my computer, and it's receiving the clicks. When I click on my mouse, it sees that I've clicked on a designated hotspot, an href, a hypertext reference, and that href includes another page to go retrieve. And so the idea is that I'm going to click on this, it's going to retrieve a whole new page, and then in the blink of an eye replace what I'm seeing here with the text from that page. So here we go, it's connecting, and it's retrieving. And so there's the second page, okay? And we can click again. If we click on here, we can go back to the first page, and we can go back to the second page if we like. So now we're going to look at exactly what happens here in the browser. When I first started, I was looking at a web page. That's not worry about how the page got here, but I typed a URL, and I'm looking at a web page, and then this is an application, the browser application running on my Macintosh in this case. And then when I clicked on here, that is an event that happens locally that my browser application, in that case it was Chrome, receives the click event. And it looks at what I clicked on to decide what to do. And so then it makes a connection to the web server on port 80, and it sends a command, this get command. Now we'll take a look at that get command in some detail. And then the web server receives the command, and it goes and reads the data, whatever it's going to do. It looks up page2.htm, wherever that is, and then it sends that back to us. And the response includes some HTML. So HTML is the markup language that this page comes back to us. And then our browser receives that data, and then it parses it, looks for the less thans and the greater thans and the hypertext references, the anchor tags and the hrefs. It looks at all this stuff and then produces a second page for us. And so that's the request response cycle. Request, response. The page, some action, request, make a page, the page comes back, and then it's rendered. That process that we just looked at, the request response cycle, is covered by a number of different internet standards. And the internet has been around a long time, since the 1960s, ARPANET, internet, etc., and they produced a lot of standards, and they created an organization just to produce these standards for the internet work. And it's called the Internet Engineering Task Force. The standards are called Requests for Comments, which is a bit of play on words with the idea that none of these standards are so perfect or solid that you can never comment on them. Even years later, we comment on them. And so if we were to look at this RFC 791, it talks about the low-level internet datagram protocols, and so some of the early standards were about how we built the internet. But then there are more later standards that are things like how the web and how web browsers interact with web servers. And so this is RFC 2616, and it talks about the HTTP 1.1 hypertext transport protocol. So if you want to, go ahead and download this and look through it. And if you look far enough down, you will find in section 5 how it is that you're supposed to send data if you want to request a new document from the web browser. And it's pretty simple. You connect to a server on port 80, and then you ask for the document. And there is a specific thing where you send the get command, you send the document you're looking for, and then you have to tell it which version that you're looking at. Your old, super old stuff was HTTP 1.0. HTTP 1.1 has been around for years, and now actually HTTP 2 is coming out, and so we have to start figuring that stuff out. Now, luckily, with HTTP 1.0 and 1.1, they're simple enough that we can hack them. And so what we're going to use is a program called Telnet. Telnet is basically make a connection to this host, www.drchuck.com, and port 80. Now, ports are a way to have multiple applications responding to different kinds of requests. Port 80 is the default HTTP port. We might telnet to some other port. If we telnet to port 25, we'd be talking to a mail server. Now, if you're on Windows, if you're on Linux or Mac, this is going to work just as I show you. You can do this on Windows, but you might have to install something. So go Google how to install Telnet on Windows, and you'll be able to figure it out. You'll install it, and then you'll be able to, on Windows, pretty much replicate this. Now, not all web servers want to talk this really simple protocol that I'm showing you right now. And so what we're going to do is we're going to telnet to port 80, and then we're going to type a carefully constructed command. I'm going to cut and paste this, and then a blank line, and then the server is going to respond with some headers, metadata about the page we're going to get, and then a blank line, and then the actual page. And then you're going to see the connection is closed. This is exactly what's going on in the request response cycle between your browser and the web server. We're getting back both the headers and the data. The headers are metadata, like when this document was last modified, how to show the document. Text HTML says that this part down here is actually the HTML syntax. And so so if we look at this, we'd see images, etc. If we were retrieving an image, this stuff would look very different. We'd barely be able to understand it, but this would tell us that it was an image. Okay, so let's go ahead and do that. So let me run my terminal. Let me make it a little bigger. Now I'm going to copy the thing I have to type really fast, because some web servers don't like it when you don't type fast enough. So I'm going to type, make it a little bigger, telnet www.drchuck.com port 80. The port 80 is important because the default port that telnet connects to, I got a typo here. Default port that telnet connects to is not port 80, but web servers by default live on port 80. Okay, so as soon as I connect here, I can type a command, and I'm going to type the command that I typed, get, and then I have to hit one more new line, and then this is what came back from the server. First, it gives me some header information, and then it gives me the exact page. And so I'm, sort of just hacking in the back door of this thing, but this literally is what the browser does. The browser makes this connection. It uses code to make this connection, like a socket library to make this connection, and then it sends a message. And if you were to look at the RFC that tells you how to do HTTP, it tells you exactly what the format of these things are. It tells you what these headers look like. 200 means that you found a document you were supposed to look for, etc., etc. So let me, for example, make a mistake on this so you can kind of see how it works. Telnet get blah HTTP / 1.0. Let's see what it complains about. Okay, so you see here that I did this, and I gave it a URL, and it somehow is unhappy with me, 400. So 200 is a series of HTTP codes. This 400 means it was a bad request. So let me type another one, and then it gives me a little HTML, which would say bad request. So let me do another one and make another mistake. Oh, that one's going to work. Sorry. Let me see if http www.drchuck.com page 9.htm http / 1.0. I have to type this fast because, okay. I typed it too slow and it said, you're not really a browser. Browsers talk faster than that. So now I'm going to run it again, and this time I've cut and pasted that so I can type it faster. Okay, telnet, paste, type really fast, be like a browser. Okay, so this is another error message. I wanted it to give me a 404 not found. It says, oh, there's a couple of other things. But basically, you know, when you type bad errors or do this, the server and the browser are communicating using this protocol. And it's not so important that you know this protocol. It is important that you're able to understand roughly what's going on. So if you get an error code or something else, you have a basic understanding of what's going on in behind. And so I'll just call your attention to a fun thing you can see if you saw the Matrix 2 movie. You saw Trinity hacking into the power grid to shut the power grid down in the a critical moment of the movie. A former student of mine was the one that actually wrote this, and the original script said that Trinity was going to be using some cool full-screen interface to break in, and he said to the Wachowski brothers, he said, that's not how people break into computers. People break in using command line and crazy little stuff like that. So this is rewritten, and this Nmap is actually software that people do use to break into computers. And so this is a pretty accurate. He actually set up some vulnerable computers and ran software to break into those vulnerable computers, and then they recorded the session, and it was kind of impressive. And now it's become kind of a cool thing to actually try to make the breaking into computers seem more like it's really done. So not that I want any of you to have a future in hacking computers, but you might have a future in protecting the security of computers, and knowing all these sort of back-end command line things is kind of essential for that. So now what we're going to do is we're actually going to play with this in the browser. Now, you're not going to have to do telnet. In the old days, I mean, sometimes I would use that telnet command to figure things out when something wasn't working. But actually, the browsers have wonderful debugging capabilities. And so there is a developer mode that, the first real developer mode was a thing called Firebug inside of Firefox. And but since then, all the other browsers are building native debugger modes. Sometimes you have to go in and tell your browser to show you developer mode in the drop downs in each browser. So if you have to Google turn on developer mode in Chrome, or turn on developer mode in Safari, or turn on developer mode in Firefox, you'll get it turned on, and then you'll be able to use developer mode. And what happens is when you go into developer mode, you see a second panel that shows you network activity and various other things. And you can do things like inspect the headers of web requests. Okay? So let me just show you how this works in Chrome. It's a skill that you will want to figure out. Now, you won't always have view developer mode or developer console here, but you might have to do something in the preferences to read that. There are a couple things here. I'm going to focus on looking at the network console. And so this network console will show me all the network requests as they go by. So I'm going to go back to page 1. I'm going to hand type the URL into, and so you can see the request response on this. So here we go. It went and made a request, and I can click on this request. Oops, that's not what I wanted. I double clicked on it, so it actually did it. And so you can see the headers. You can see that the URL, and this is directly from that HTTP. It did a GET request. It asked for this page, and it got a 200 OK, and from this address on port 80. So it saw how that all worked. The response headers, remember, those are the things that we were seeing. We saw when last modified date, et cetera, et cetera, et cetera. And there also are request headers, which I didn't show you, that are part of, you send the GET request, and then you send the request headers, and that communicates things like what your default language is, et cetera, et cetera, et cetera. So I'm going to clear all this. I've disabled the cache, and I'm going to click on second page, and we see that it makes a request here. So the key thing is to get to the point where you've seen the request, and now you take a look at the headers. We're doing a GET, again, to the page2.htm. Got a 200 OK, the response headers, the request headers, okay? And so you should be able to, and if you go to a more complex page, like drchuck.com or web applications for everybody, let's do this, and I'll turn on the network console. And if I go to www.wa4e.com, you will see it's going to make lots of requests. So it requested the main page, it's some data, some CSS, etc. And it keeps requesting things. And it looks like it made a total of 26 requests, 408,000 bytes, took 8.3 seconds. And so I can actually look at any of these requests. And as your applications get more complex, you'll have to page through here. Now we can see that the original page was just get to the main page. The response, you can see the HTML that came back. You can see the headers that we sent. We can see the headers that we got back. And here you can see things like the language. Our preference for language is English. And so the request headers are things that inform the web server. If I had a different preference for language, I could tell as I'm requesting a document, if this document's available in multiple languages, which language I prefer. And so you'll get used to scrolling through here. Some of these are just retrieving files. It's got a CSS thing. Here's the response. That's this data here. Here's an image. This is what an image looks like. The content type is an image/PNG. So this is a response header. So again, you can dig through all this stuff and you don't actually have to write telnet commands, and you can figure all these things out. And so getting to know how this panel works is important for you to be a good software developer, a good web developer. So get used to it, start figuring this out, okay? So we have talked about this request response cycle. We've talked about how you do it by hand. We've talked about how you can watch it using the developer console. But this is really the only beginning, because I'm focusing on the part where it's going back and forth between the web browser and the web server. There's so much more. Things that we're going to do in the browser, like HTML and CSS and formatting, and how to look up stuff in the document object model, how to run JavaScript and jQuery and then JSON. So many other things. Then there is the whole PHP bit, how we're going to talk and do code in the web server, running Apache and PHP extension and doing all the PHP code to format stuff and return it. And then we're going to have to learn about the database server and SQL, and how do we make tables, and how do we join those tables together, and how do we produce the data efficiently that the user wants to see. And so there's a whole lot. And so what you'll see throughout the rest of this course is this picture in various forms. And what I just showed you was, somebody clicks here and it goes and sends a request to Apache. Apache would grab a file and send the response back, and then the response is parsed and then shown to us. That's what I showed you. A simple thing. There's a file sitting on a server and we're requesting the file. The GET request goes in, the HTML comes back. And so that's the simple one. It's going to get more complex, right? By the time it's all said and done, we will, the worst case, they're very complex. We'll send a GET request. The GET request will be PHP code, which will be run in PHP. Code will happen in PHP. It'll call a database call with SQL. SQL goes across here. And then a row set or set of rows talks to the database, gets some stuff back, and then it comes back to the PHP code. Then the PHP code writes a bunch of stuff and sends it back. So the web page comes back and it comes back as a response. So this right here is where the request response cycle is happening. And then that's sent into parsed and put on the DOM, and the document object model is shown, but then some of the code's in JavaScript, and then the JavaScript can change the document object model so your website page changes, and sometimes you'll even click something and that'll go into JavaScript, and JavaScript will make its own request response cycle. I should probably change the color of that one, right? Right. JavaScript will make its own request. It'll make a request response cycle. That'll run some PHP. That PHP will do some database. It'll read some stuff. It'll come back, send some JSON back in this case. JavaScript will read the JSON, update the document object model, changing your screen. So we're just at the beginning. We clicked a page. We did a GET request. It was a flat file. It came back. It was parsed. It was put in the DOM, and we saw it. But there is so much more to learn. So our modern web applications are going to start with this basis, the request response cycle, and there's a whole bunch of stuff that we have yet to learn. As I said before, if you use a framework like Angular or Ruby on Rails, they simplify some of this, but at the end of the day, all they're doing is you're still doing request response cycles. You're doing some of the work in the browser, some of the work in the server, some of the work in the database. It's just kind of a changing style. And so everything that you learn about the request response cycle by writing PHP, MySQL, JavaScript applications is actually equally applicable to any framework that you're ever going to use. Okay? Hope you found this useful. See you on the net. Hello and welcome to our lecture on HTML, the hypertext markup language. So we're going to place this in the context of our request response cycle, and sort of here's us in the request response cycle in our browser and what we're seeing. We make a click, it goes across the network to the web server, runs some code, maybe talks to a database, formats up some new stuff, and we get the response. Then HTML comes out, and then that's parsed to make the DOM, and what we see is the document object model. And we're going to ignore most of that in this lecture. We are really only going to talk about this part here, and that is what this response is. It's HTML, and it is parsed, and it's read through, and it's used to construct the document object model, which then shows what we see. And so HTML is just a technique of using some special characters, less than and greater than, to add tags to indicate what we want to see, like the paragraph tag. The paragraph tag, that's a paragraph tag. Strong tag makes things bold. Emphasize tag and a paragraph tag. And so we have these tags and we just mark up. We're communicating meaning. If you're old enough to remember, word processors used to have ways to look at the actual codes that were being stored in the word processor file. So the web is, the HTML and hypertext transport protocol and all that stuff is a relatively recent invention, and we're doing so many cool things with it. It's continuously evolving, and really, we're less than, we're 20 years old, and so we're doing so much with it. It's continuously evolving. So HTML and CSS are really kind of at the edge. Looking back in the early days, if we take a look at what HTML was really intended to do, it worked on a Next computer in the early 1990s, and so this is the Next browser, which came from CERN, and it had everything in a new window. Images were not shown in line. And then there was the NCSA Mosaic browser, which was the first browser that was universally available on Unix, Windows, and Macintosh. And you see things like gray background and blue links and highlighted links that you visited in purple. And so in the early days, it was nothing like what we see today. In the early days, we were just amazed and happy that we could see a link, and you'd click a link and something would happen. But today, money is to be made based on making stuff super beautiful, and the number of pixels, and how things line up, and how things are shoved over, and how navigation looks. And so today we need to create beautiful web pages, whereas in the old days, we were just amazed to have web pages that worked in the first place. And of course, computers have gotten much faster, capable of handling video and images. Back in the old days, images were costly, both for network bandwidth and for the time it took your computer to display them. And so that just affected how we did it. And it's kind of fun to use the Wayback Machine, otherwise known as the Internet Archive, to go back and look at some of these older web pages and realize that it's still amazing that a lot of them pretty much work. And in the good old days, HTML was kind of a Wild West. The browsers did not want to show broken HTML as broken HTML, and so they compensated for it. And so in the old days, we had things like tags that could be uppercase. We would have a paragraph tag that didn't finish. We would have LI tags that didn't finish. We would have attributes that didn't even have double quotes in them. So there was all kinds of stuff, and literally you can take this bad page and you could put it into a web browser and it will still display. So HTML, while it technically is a very precise language and you can make syntax errors, browsers are extremely flexible in terms of parsing it. Now, you're not going to get predictable results. The browsers can go into what's called quirks mode. And so in order to create the standards environment that we have today, Tim Berners-Lee, one of the original founders of the World Wide Web, helped found an organization called the World Wide Web Consortium, or the W3C. And it really decided that instead of just letting people write a browser and having HTML be defined by the browser, Instead, they would write a spec for what HTML was, and then multiple vendors could produce the browsers. And it took a while for this to become successful, but there was a need for every vendor to build a web browser, and so they worked with the World Wide Web Consortium. And like the mid and late 90s, 95, 96, well 94 through 98, 99, World Wide Web Consortium created a lot of wonderful standards around the World Wide Web. Now, once we started having rules, then we tend to want to follow those rules. And so tags need to be lowercase. Attributes like this image source equals have to have double quotes around them. You have to have open tags and closed tags, open tags and closed tags. And so there's a set of rules, and now we are much more precise about our HTML, and we try to write it as precise as we can so that we get the best performance and the best sort of rendering out of the browsers that we can possibly get. Because if you don't write precise HTML, then the browsers are going to make decisions as to how to render things, whereas if you write precise HTML, then you really are in control of how the browser lays things out. So up next, we're going to talk about HTML itself, look at some HTML documents, and take a look at the syntax of HTML. Welcome back. So let's talk about some of the basic syntax of HTML. The first thing is to look at the overall document layout. And they start with an HTML tag. You might have a thing called a doc type up here, and we can put in one if we like, but HTML is the outer tag, and then there is a head tag and an end head tag, and this is sort of non-printing information. We set styling up, we declare the title of a page, perhaps load some JavaScript, and then the printable page of the content is in between a body tag, and mostly what we're going to talk about is the stuff that we put in as page content. So you'll find that there are special file names that we use. It really has to do with the fact that what we do is we make a directory within the web server, and when we go visit the directory, the web server looks through a series of files that it's configured to look to, things like index.html, index.htm, or index.php, and each one has a slightly different order and a slightly different set of things. It might even be called default.htm or default.asp if you're on a Windows box. It is configurable, so different systems do things differently, but usually index.htm is probably the safest thing unless you're doing PHP, which we will be doing later in index.php. And so those are usually the safe bet. Now, when you're viewing things off of disk, which we can do, if you download all the code that I've got in html.zip, then you'll have to open the index.html by hand. So we can put multiple files in the same directory, and then we can use them in what are called relative links. And so we can easily create links between one file and another. And so you'll tend to see, if you look at the zip file, that you've got a whole bunch of files in the same directory. And with little anchor tags, they point back and forth between each one. And so, like I said, you got tags like the paragraph tag, the strong tag, and the emphasize tag. They have to start, they have to stop. But another thing that's really important about HTML is the fact that most of the time we are logically marking up the text. And so we're saying we want this stuff right here to be a paragraph. But the end of the lines that we put in the HTML that we write are not really that important. What happens is depending on the width of the browser, if you change the width of the browser, the text will be rewrapped. And that's because there's still a paragraph, but we don't want to hard code it because we're not working on paper. Sometimes browsers are really large, sometimes browsers are really small, sometimes you're on a phone, right? And on a phone, browser's really small. And so you don't want to tell exactly how many pixels it is wide, except when you start doing really fancy layout. But in things like paragraphs, you just say, hey, make it a paragraph and rewrap it. And that also, the rewrapping then also changes how tall the pages are, because the narrower pages, it kind of extends the page down. But the white space inside of the HTML is really generally ignored, and the lines are generally ignored. There are some tags, like the pre-tag, that changes that, so white space is respected and new lines are respected. But most of the time we just let the browser rewrap things, and it's good. You have beginning tags and ending tags. So here's a beginning tag, and then here's the ending tag. The slash is our indication of an ending, and they're paired. And they're also nested. So this P tag has a strong tag within it and an M tag within it, and that's totally okay because this whole thing is a paragraph and this is a piece of bold text. So they have beginning and end, and slash is the end. You can also have self-closing tags that have like an image tag that has like a slash, and that means that you don't have to have like a slash image over here. That's the same. You just put a slash here and it self-closes. Another thing that you will get used to is the fact that you can put on the opening tag attributes, so key value pairs. And you'll go define what you go read the documentation on the image tag and it'll say, oh, put a source attribute on to say what picture, what file we want to display as the picture. The image tag is to show pictures, basically. So given that less than and greater than and other things are special characters, we have to have a way to print the special characters. So how do we print a special character? Well, we use ampersand LT semicolon, and there's a whole list of these things. HTML special characters. And you can look them up. And there's some that are kind of fun, like the special characters for the deck of cards. There's mathematical special characters, and you go look these up and you can find them. The key thing is they're cute, and you'll see that I'll use some of these arrows in the things that I'm doing. But the key ones that you really need to know about are less than, greater than, and ampersand. And just because ampersand becomes a special character, less than, greater than, or ampersand are really the special characters in HTML. And so to represent less than, you do ampersand LT, ampersand GT, and ampersand MP semicolon to get those things right. HTML comments, like in any programming language, any situation, the start of an HTML comment is less than exclamation dash dash. It's a little clunky, but we just want to make sure it's really clear. And so dash dash less than comments can go across many lines if that's what you want to do. So that works as well. Links is a critical element of HTML. It's why search engines work. It's why, when I first saw it, I'm like, I click on a thing and there's a new page. Isn't that amazing, right? And so hyperlinks is the H in HTML. It's the H in HTTP. And so it is how we, in effect, use this thing that we're sort of just scribbling on to create knowledge that Google then can extract. And so the anchor tag, the A tag, is the tag that we use to do these things. And so, there's a header one, a paragraph, and the anchor tag this is the start tag, and this is the end tag. And so the text that's clickable is second page, and you can see that it's clickable right there. It is styled with a underline and blue to indicate that it's a link. And so there's the href, which stands for hypertext reference, and then it's an attribute, so it's key value with double quotes, and then this is another URL. And so that's like, in effect, putting that URL up and going into that next page. So it's a hotspot. In the early days, and I'll show you a few of these links were like the coolest thing ever, and so we made them pretty colors, like the blue with the dash. People didn't when they first saw the web, they didn't know to click places, so we sort of styled them quite brightly. And then because you were often scanning and searching the whole web, because the web wasn't so big in the beginning, we would mark them as purple after you'd been to it. So you could sort of slowly but surely work your way through the whole internet as it existed back in the old days and keep track of the ones so you didn't have to go back to the ones that you'd seen before. And that was an absolute link, and here's one with a relative link, and that assumes that we are now in the same folder, same directory on the server, where we have href, and so here's the start tag, here's the end tag, and then first page is the clickable stuff. And you'll note that that is a purple link because I have already been there, because page1.htm was exactly where I just came from. And so you click on that, and then you can go back and forth, and those are the pages we played with in the HTTP lecture. And so these absolute references are references that start with, HTTP or HTTPS or whatever, and relative references don't. And so that basically means that this page1.htm file has to be in the same folder as whatever file we happen to be viewing right now on the same server. So if you want to switch folders or switch servers, you have to use absolute references. And if you are just moving between files on the same server, you can use relative references. Images are a lot of fun. In CSS, we'll see how to wrap text. One of my favorite things was to wrap text. There is an image tag, which we saw before, image, and then the source equals is the attribute, and then in quotes the name of the file. And it can either be an image that's all by itself. In this case, it's this paragraph is what we're seeing, and you can see that this image is a tiny image, but it's sort of like blah 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 blah. The image right here works kind of like a character. You got to be careful because the images can be really big. That's why I made a tiny image. And you could even, for example, in this case, I have an anchor tag, and the clickable part of the anchor tag is an image. So if you click right there, that will move you to lists.htm. And so you can make an image be a hypertext reference as well. Now we're going to do much more with these things, and this is just, at this point, the basics. Lists are an important part of HTML. There's ordered lists and unordered lists. And so the unordered list starts with the UL tag and ends with a UL tag, and then that sort of bounds the whole list. And then each list element starts with an LI, list item, and /LI. And I want a little bit of spacing. If you don't put them in paragraphs, you don't quite get the default spacing. This blank line is really coming from the paragraphs. So I'm putting a list of paragraphs, basically. It doesn't have to be a list of paragraphs. You could make a little denser list with a list of links or something, but I'm putting paragraphs in. And so you can see that I have LI to end LI, LI to end LI. I'm putting some links in here, etc., etc. And so dot, 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 and it puts all the bullets in. It does the indenting automatically. We'll see in a bit how we can control all that formatting and do different things if we want to do those different things. But for now, we're just going to play with the default formatting and learn the HTML, which is our way of representing that we want a list on the screen, but we're not so fancy about exactly how it's supposed to look. So in HTML, we really are looking for the meaning of the page, not how pretty it is. Tables. Tables have a bit of a checkered past. In the early days, people tended to use tables to lay pages out on grids. And they would just put, a paragraph here and a paragraph here and then a paragraph underneath it, and they would move them around, and they would put images in some of the table cells. And that turned out to be really bad, and that notion of tables as graphic layout is long gone, and we use CSS now, which is the next lecture. But tables were always a good idea for tabular data. And so if you have something that sort of makes sense, is like a list of cars with some make, model, and mileage columns and a list, then you mark them up. And so the table markup is pretty straightforward. We start a table with the table tag, and then we have a series of rows using the tr tag, tr to /tr. And then if there's a header line, which can be formatted a little bit different, we do a th to /th. And then this basically says it's going to be a 3-column table because we have 3 table headers, 1, 2, 3. And then we're going to put TDs for the data. TD stands for data, 1, 2, 3. And so that's the Ford, edge, and then the mileage of that, and on and on and on and on as we go. And so it's not hard to build them. You kind of have to keep track of how many of these things you've got. And there are tricks where you can make a table that has like 4 things, but then in one row this expands so that's, I can't erase it. Can't erase it. So there are ways to do things where a data element spans more than one column, call span, for example. But the key to tables is that we use them for tables. We don't use them for arranging things that are not themselves row, 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 row. So I'm going to stop there. I'm going to record some exploration of some sample code at www.webapplications4everybody.com/code/html. And I really am intending that you will, these are very simple pages, but the idea is to look at them in developer mode and take a look at them, and then you can see how the various things work. And you can also then look at the source code and see, oh, here's how a pre-tag works. Or where's the pre-tag? No. Oh. Yeah. So we look at the source code, take a look at things, and show that the line wrapping does not actually matter. We look at pre-tag in another one. So I'll record some walkthroughs of all this sample code, but I encourage you to take a look at it because it has a lot of good examples of the basics of HTML. And so HTML is a continually evolving thing. It's a very creative space. It's a lot of fun. We have to be really tempted. We have to avoid the temptation of trying to make everything look pretty in the HTML, but instead delegate that to the CSS, which is what we're going to talk about next. Hello and welcome to Web Applications for Everybody. In this screencast, we are going to play with some of the sample code, and you can either download it and play with it on your own computer, or you can look at it in your text editor, or if you just want to browse it, you can browse it here and take a look at the version that I'm using. It's really been intended that you look at this in the developer tools, and so you can do things like, say, inspect element. And so here we are. We're going to This will also be a little more valuable even when we're doing CSS, but you can see the document object model. Now the interesting thing here is it shows something I'm always talking about, is the difference between the document object model and the source code. So this is the document object model. It's kind of stylized. If you look at the source code, you have to say view page source. And so the source code, this is literally exactly what's in the file. And if you go look at this file in a text editor, you will see this. And if you're looking at it here, it doesn't quite look exactly the same, and some things have been done a little bit differently. You know, they kind of got this extra stuff, and this is kind of after the browser has looked at it. And when we start talking about JavaScript and changing some of this dynamically, you'll see this part is the document object model, but the source never changes. The source is what was originally downloaded when the server sent this back to us. So let's take a basic look at this. I'll hide this unless I need it. I'll go back and forth between the source. So we have a basic document, HTML, with a head tag and a body, and then a header. And of course, here's our header. We're using default styling, and paragraphs are an important part of things. You can squeeze this up as much as you want. White space sort of doesn't matter, right? So this white space kind of doesn't matter here. The fact that this has got extra space, it doesn't much matter. And so you can see an a strong tag that leads to a boldness. Let's just go ahead and look at it here in the inspect. We'll go down here. We'll find like a strong tag. That's the bold. We got an emphasized tag, and if you look a little farther, you'll see there is the anchor tag, which is the whole anchor tag is this whole tag from the A to the /A list.htm. That's where we're going to go if we click on this text right here. And so you can see, now this is a relative link, and it turns it into an absolute link, and that's because the browser knows where we're at. And so it sort of prefixes everything up to that to the relative link. But that's nice, because if we look in folders, we will see that these folders are all here. Here, let me go find you that folder. It's pretty deep in my... Later, this will all make wonderful sense to you. I do a lot of stuff with web. Code, HTML. Okay, so here we have, after all that, here we have the files, right? And so this is index.htm, and index.htm is right there, and list.htm. And so if I click here, I'll go to list.htm, and that'll pull this other file up. And so these guys are all in the same folder together. It just means that I can use relative links to go moving between them. A tag that's really becomes more important, especially as when we're talking about writing code inside HTML and showing people code, is the pre-tag. And so the pre-tag, and you can just say inspect to hop right down to where the pre-tag is. The pre-tag respects spaces, so all these spaces happen, the new lines happen, and it also shows it in monospace font. Now you can change all these things once we get to CSS, but pre-tag, when we're printing debug out from, not in files like this, but when running code, sometimes it's good to print debugging out in pre-tags. So let's go to the next page. And so here's a whole series of things we're going to play with. This is a
unnumbered list. This whole thing is an unnumbered list from top to bottom. So when I highlight this, you see the whole beginning to end of the list. Then each item in the list has a start and end li tag, right? Down, down, down. You know, so here's this. We should learn about tables, and there's a href. There's another relative link, and so this is sort of my jumping off page to get to all those other things, right? Learn about tables, etc., etc. And so you can see these. We probably use just to take a look at the source code of this page. And so that's the source code that I typed in, and you can see the li tags, the p tags. I'm putting p's inside of li's to get space. Let's see if I can sort of show you that. So if you look at this and you look at the li tag, the li tag is that, and the paragraph is what actually creates the vertical and horizontal space, right? So that orange that you're seeing, that's paragraph. There's space that the paragraph tag has preset. So that's how I do that, putting paragraphs and hrefs. And so that's what this all looks like. So let's take a look at special characters. And so this is an interesting thing because it's not really what came out, because less than requires ampersand LT, but it's kind of processing that. So let's take a look at the source code to this one, because that'll be more instructive. So ampersand LT, ampersand GT, ampersand amp. This is an ampersand in HTML, and then just the letters AMP semicolon. Semicolon's not special. There are only really 3 truly special characters: less than, greater than, and ampersand. And you can put all kinds of fun stuff: clubs, hearts, and diamonds. And so you got the clubs, hearts, and diamonds, some arrows, stuff like that. What's nice is browsers just have these built in, although they're not necessarily the sexiest or coolest things. And I think what happens when I go back on this link is I go back to the list. So that's just special characters, and you'll notice that the default styling that says we've seen this one, and this is how the web worked 1,000 years ago, back in the 90s, is you sort of, oh, it's kind of nice that it's turning purple. And you'll notice that Google does this as well when you're doing Google searches. It actually lets the links change color after you visited them. So let's take a look about links. We look at links. I'll view the source of this guy. Absolute link, href, right? And then /a. This is the clickable text, right, between the beginning tag and the ending tag. The attributes are on the beginning tag. Another attribute that you can add, and I do it all the time, is target equals blank. And that basically is the way we say, open this up in a new tab. So you'll notice pop up in a new tab. And so that's where that one goes when it pops up. And so you can decide whether or not you want this to go in the same page back or in a new page. And then I got to close the tab to get back. And now I'll go back, because that's just a relative link to list.htm. So I can go back and look at the next thing. Let's take a look at how images are represented. So so this is just a paragraph that has an image in it. Right, so it's a paragraph, but there's the image. Source equals medium.jpg. If you look in my folder, you see the image right there, medium.png. You don't see the suffix because Mac is trying to hide it from me. And so that's just, you see this space here and here. The image doesn't have any space. We could add some with CSS later, but the paragraph is what's adding that space. Then we have just a regular old paragraph. I'm not supposed to use the center tag. We'll get to the how to center stuff, so that's what that is saying right there. And you can have an image that's right in the middle, so you see where that image is. I think of images, if they're right in the middle of text, they're like a giant character, and so that's how that works. And you can even sort of stick an image as the thing inside of a link. So here's the anchor tag. It's that bit right there, and then the anchor tag body is an image. And so if I click on that, it's going to go back to list.htm. You'll notice these all go back to list.htm, so I can work on the next thing, right? Tables. Again, you're not supposed to use tables for laying out like blocks of text, which we used to do. We used to do things like use tables to draw borders around things, which we'll see in CSS. But now that's totally verboten, and you're supposed to look at tables in a way that they're, you know, nice and pretty. So let's do a view source here. So let's see, there's our table, our slash table, and a table row. Now let's take a look at the DOM. So apparently I didn't put a T-body. We're supposed to put a T-body in there, and I didn't do it, but this is the DOM. The DOM put it in. That's put in by the parsing, and so clearly I made a little mistake in my HTML because I didn't put a T-body tag, and so that was added by the browser. As it was parsing and reading through this, like, oh, he forgot his T-body, so it just like slapped one in for me. And I think the mistake is this is my header row, and I think that should be like a T-head. So there I go, bad HTML. It's the story of my life. And then I've got the rows, and you'll notice that the DOM is kind of prettier. So sometimes I do this. The DOM is indented nicely. So this isn't really the source code. This is the data that represents this visual, right? It is the thing that you're seeing, but it read this from the file or from the server, parsed it, and produced the document object model. I only say that like 1,000,000 times. Okay, so back we go to the lists. We're making pretty good time. So here's some really bad HTML. I'm going to view source on it, and again you'll see sort of the difference between the document object model. When you're debugging these things, you will have to sometimes view source. Sometimes document object model will be the only way to debug it, and sometimes view source. So this is the one that's got bad stuff, like H1 is uppercase. This paragraph tag is not terminated. This UL tag is uppercase. This LI is not terminated. I don't have double quotes here. So there's a series of mistakes that I've made in this HTML, but it looks pretty good. And you'll notice in the document object model, it's fixed all that. Now, each one is lowercase. The P tag is finished. There are double quotes, meaning the document object model is not just your HTML source code. It's like the sensible, parsed, pretty version of the HTML source code, you know. And so, you know, this UL tag, these LI tags are now done. The UL is lowercase, everything's lowercase. So it's like, I'll take care of your mess. I'll patch up and fix your HTML, and then I'll display it for me and make sense of it. So the document object model is not the same. It is sort of like a sweet, awesome, better version of it. But this is what changes that. So let me just show you something, how I can change the document object model. Let's see. Let me see if I can change this text. I change the document object model. That changes. So I'm actually, but that didn't change the source code here. The source that it was retrieved to produce it, but I can change the document object model. And later in the class, we'll write code that will actually change the document object model. So we'll change this. We'll call this be going to lists yet again. So I can change the document object model. Doop. So you see it changed it. So when we change document object model, what we see in the browser changes, but the source doesn't change. Did I say that enough times? So let's click on this and go back to lists. Okay, so some HTML can be broken so badly so that it doesn't render at all. Whoops, that didn't work so well. I'll do a view source on it, and then I will let you figure out why this doesn't work, why this doesn't show. You take a look at the source, you figure it out. I hope this has been helpful to you. See you on the net.
Hello everybody, and welcome to our lecture on cascading style sheets, CSS. Of course, this follows right on the heels of our HTML lecture. I'm going to use a bunch of examples from webapplicationsforeverybody.com, and you can just bring these up in your browser. I love to place everything that we talk about in the context of the request-response cycle, because that's the whole Web Applications for Everybody. You, of course, are out here. You do a click, it sends a request, HTTP request, maybe runs some PHP, maybe talks to a database, gets some stuff back, sends some stuff back. This is the request response cycle right here. And the thing that comes back is HTML. And then that is parsed, put into the document object model. And the thing that you then see, the pixels you see on your screen, are from the document object model. And so that's what we've been doing so far. And so far, in that HTML lecture, we just talked about this, what the format was when you parse the response. So what we're going to talk about today is we're going to talk about, in addition to that, we're going to go and pull another file, a CSS file, CSS, and that is going to inform the document object model, and it's going to change how things look out here. And so, you know, we'll have some CSS in the HTML, but we'll also have some CSS in separate files that make separate request response cycles. But so we're going to be putting files like our HTML files in here and our CSS files in here. So we're going to be serving them a little bit, but mostly what we're worried about is sort of the form, how to make the DOM look pretty, and that's sort of what CSS is all about. Really, we're coming up pretty soon to talking about, you know, PHP and what we do in the server, and we already did talk about SQL, even though we haven't yet connected all these dots. So we're coming close. We're going to get there. So, in addition, I would like you to install this thing called Web Developer from Chris Pedrick. Chris Pedrick has been doing this a long time, before there were even developer consoles in browsers. And it's funny that the developer consoles don't do what this does. And I don't use all of its features, but it has some wonderful features for CSS, in particular turning on and off various styles. And so it's a great way to sort of dig through CSS issues in addition to the Web Developer Console. And you can do a lot of sort of fine debugging, but there's some real nice stuff with Web Developer. It's just a plugin for your Safari or your Chrome or your Mozilla browser or whatever. So please install that. I recommend it, and some of the assignments actually require it. So like I said in the HTML lecture, the HTML started out with, we were just amazed in 1995 when we could see a page with a gray background and blue links, and it was lists, long lists of links, and the links turned purple, and we would click on a link and another page would come up, and we were like, holy mackerel, this is the future, right? And we were so happy. And our curiosity was piqued. We did interesting things. But, you know, in the 10, 15, almost 20 years since all that, it's become a business. And in business, the look and feel for the average non-nerd user, they don't care that there's a request response cycle. They just want to do a thing, talk to their friends or look up information or whatever. And so the CSS is in the middle of this time frame, that the ability to precisely lay things out and make pages beautiful became super important for the web to take its sort of leap into commercialdom. So if you look at the Yahoo web page, for example, this is just a screenshot I took a while back. They do studies as to how much white space is in between those two pieces. And they'll add a pixel and take away a pixel, and they'll see how their revenue goes. And so these user experiences, these visual looks and feels are highly tuned and highly sort of taken care of. And so CSS needed to be able to precisely have a pixel perfect layout in every browser. And so CSS is a very, very precise thing. HTML has become precise, but we don't want to do our markup and layout in HTML. I showed you tables previously, and in really early versions of HTML, we used tables to create look and feel, and that was never good. So one of the things you can do with the Chris Pedrick Web Developer plugin is you can show a page without CSS. And what you should expect when you see a page without CSS is it's sort of beautiful even without CSS. It's beautiful in a logical and a structure. And so here's my web applications for everybody website, right? It's got cool stuff. It's got these little things that go over there. It's got the little border. The color's gray here, and it's a little lighter gray, and this wraps around and it looks really awesome, right? Well, turn CSS off, and you should still see a page that you could effectively navigate. It's like going back in time to a simpler time. of, okay, I want to see this. This is really a list of links at the end of the day, and there you go, it's a list of links. And the default is I've already clicked on lessons, so lessons is purple now. And here's this video, and if you scroll up and down on this, I mean, it's really fun to go to a website and, you know, turn CSS off and see how good their HTML developers are and how pretty it is. And so it's supposed to be pretty in a simple way. And what's nice about this is it really leads to good accessibility, meaning some people do not see the graphics, they hear the page read to them. And this way, this is how it's read. And the simpler and more beautiful and elegant your HTML is, the easier it is for a person who has reduced visual ability to understand your site. And that is, I remember the joy of hearing from people who were using the web and Gopher in the early days, how they all of a sudden could go anywhere and see anything and do anything in a way that that visually impaired people could never do for like hundreds of thousands of years. And it's joyful. And then what happened is we ended up with this really nasty markup. And then it was like the web was simple and they loved it. And then the web became ugly and nasty and HTML became nasty. And they're like, the world is horrible because now you go to all these cool websites, but I can't go to these cool websites because I'm visually impaired. And now we're back. We're back to that. We're back to beautiful HTML, simple HTML, and then beautiful web pages, and CSS is the matter. Okay, I think I've done enough advertising for CSS and accessibility and beautiful HTML. So ultimately, if you look at how this thing is assembled in your browser, there is an HTML page that is pulled down, and then there is CSS, sort of both inside the document. Sometimes there's CSS in the document. If you look at this, not that it matters, there's a little bit of CSS in that document, and then a whole bunch of other CSS that brings all the beauty to this. Sometimes it even takes some JavaScript and whatever. And so we understand that the HTML does not have the beauty in it. The beauty comes from the CSS. And that is part of what we try to do, is learn CSS. So if you're going to be like a coder and you're not going to be a graphic designer, you still need to know enough CSS so that you don't write horrible HTML, so that you know what a really good CSS developer is capable of doing on your behalf. And on large projects, including like Sakai project, which is an open source learning management system, this allows separation of concerns. And you can have people that specialize in the back end and the HTML, and then a web designer can, the web designer, so if you think of the developer, usually there's a back end, and then they generate, from the back end, they generate the HTML, and then the designer will build the CSS. The designer will often have skill enough to sort of tweak the HTML if the developer built bad HTML. So they kind of meet in the middle at the HTML, with the developer mostly being responsible for building the back-end developer. And then the front-end designer can then tweak the HTML a little and then tweak the CSS. And so the HTML is where the back-end developer and the front-end developer come together. But it means that you can have lots of people working, and you can develop highly specialized skill sets in larger projects. I know that my skill set is in this side. I am not skilled in this side, right? I can clunk my way through CSS, and everything that you'll see is my CSS, and you'll be like, whoa, that's not very good. And if it even looks pretty of mine, I'd probably use Bootstrap, and I cheated and found a CSS framework, and I didn't build it, I just did it. Now, there are people who are smart enough to build Bootstrap. They can build such gorgeous websites, and my job is to build beautiful HTML that then they can add CSS to and make it super gorgeous. So the CSS basic syntax is different than HTML, right? HTML is less thans and greater than. CSS has curly braces. I don't really know who invented the first. I should find that out and go videotape that person. But it has curly braces and semicolons, so it kind of looks like a little bit of C. And it's really a set of rules. And it's not sequential, although the order does matter. Because what comes later has more importance than what comes earlier in CSS. But it's not like code that gets run. And so the anatomy of a CSS rule is that there is some kind of a selector, and in this case the simplest selector is the tag that we want to affect. We want to affect the body tag. Now there's only one body tag, but you could have a P for a P tag and say I would like to do this to all P tags. And so it's implicit, kind of like SQL, in that a body tag means for all body tags. There's an implicit loop for the whole document, and we'll see how to reduce that later to it so it's not always the whole document. But for now, a tag means a tag there by itself means every tag in this document. And then there's a series of rules, and so this is really when to apply. This is sort of what aspect, and there's a whole list of aspects that you can have, and then what you want to do. I want to make the font size 100%, I want to use Arial, and then sans serif, etc., etc., etc. Holy mackerel, my little pen is undoing itself. And so then these end in a semicolon, and you can have a bunch of these, right? You can have just one, you can have more, but that's the basic idea. Is a CSS rule is go find a part of this document and paint it. I like to think of this as like, go find a thing and then run a paintbrush over top of it that is this paintbrush. That is the paintbrush that you go select a piece of the document and then paint it yellow or paint it bold or whatever. That's kind of how I think about it. Now, I'll admit I am just I'm really a very weak CSS developer, and I need a cheat sheet. And if I'm going to do CSS, having this, even a single page cheat sheet, is super helpful for me, just because I don't use it all the time. And so the attributes like background color and the border dash bottom, you know, for me, they're all very self-explanatory. They're really easy to understand, or if you don't understand them, you just Google and you go Stack Overflow. But like for me, I'm like, is it border bottom or bottom border? I just can't remember that stuff, and so I just have to have a cheat sheet whenever I work. And this is one cheat sheet that I happen to like. And these are the kind of properties that we're going to be playing with. Color, the background color, how to align it vertically, how to align it horizontally, padding, which is space on the sides, etc., etc., etc. So there's just tons of CSS properties, and there's tons of great documentation on each of these CSS properties with little samples all over the place. And I have my own samples as well that I'll do some recordings and walk you through like line by line on my sample code as well. But this is the kind of stuff that we're going to play with in CSS. So up next, we're going to talk about how we connect CSS and HTML together. So welcome back. Now we're going to talk about how you use CSS within HTML, how you take these CSS rules and apply them to the various parts of HTML. And there are three basic ways that we do this. One is we take an HTML tag and use the style attribute and just put those little CSS key value, CSS settings right there, very close. The other thing is you can put it in the background of the HTML document, usually in the head area. And the other, probably most common thing, especially when the styles get large, is an external style sheet that's a separately loaded file with a separate request response cycle. So we'll start with sort of the simplest but sort of least used of these things. And that is, like I said, you can put a style attribute on any tag. And you say any attribute, you say it's got a double quote and a bunch of stuff and another double quote. And in there is a series of CSS rules that are basically CSS setting like border style, colon, and then the border style setting that you want. And so in here I'm saying I would like a solid border, I would like it red, and I'd like it to be 5 pixels. And that effectively determines how that particular thing gets painted, right? In this particular one, I said font family monospace for that particular paragraph. So this paragraph is painted with a font family monospace. And so you can just put these things here. I put on the body tag, I want an Arial sans serif font. So the whole body is not Times New Roman, except for the fact that this particular one is monospace. And so these two tags are rendering opinions about what the font's supposed to be. But because this one is closer, the monospace wins here, but the Arial wins everywhere else because none of these other tags render an opinion. And so that's kind of the cascading bit, meaning the closer it is, the more priority that it has, unless of course they put important up here. And important is something we'll talk about later. You can make the farther away override the local, but it's not something you want to use too much. If you're using important, that's a trouble. But don't worry about important right now. Just imagine cascading means the closer, the higher priority. Closer to the tag the statement of CSS is, then the higher priority that it is. So another place that you can put the CSS is right there in the header, right? So instead of putting it on a tag, we can use a style tag in the header. And so here we have the header of the document, right? The head, the body starts down here. And up here, we're going to set a set of rules. And now we're using the thing where we have to say which thing, a tag it goes to. So now I can say the body tag, even though there's only one body tag. We want a font family Arial sans serif. And because they're all inheriting from the body tag, then all the paragraphs inherit from this, and the headers inherit, etc., etc. So it's like body on down in this particular case. The header 1, which is this, is blue. And paragraphs are supposed to have a solid border, red, 5 pixels. And so border style, border color, etc. And that means that each of the 2 paragraphs here are away you go. And I'm going to dig into the anchor tag, and here's my little anchor tag. And I'm telling the anchor tag that I would like to have a green font, and I would like no underline. The default is to underline them. If you look at links, they're always underlined. I'm overriding that. And then I want the background color of that text to be light gray. And so this is a set of rules. All that HTML is down here, lower down, and there are no style tags. There are no style attributes on the tags because we have basically said for all paragraph tags, for all anchor tags, for all H1 tags, and for all body tags, and we put it up here in the top of the document. Now the problem is most websites have multiple pages, and this gets really frustrating after a while. So you really want to pull some of those widely used or repeated things out into a file and include them. And all we do is take pretty much that same set of CSS rules and we put them into a file. And in this case, we'll put them in the same file, same directory, same folder as the HTML. Although you can pull these things off of a website if you want. So http:// or whatever. But you put a link in here and tell it's a CSS. And it's going to be a style sheet, and then you give it an href, which is then going to pull this file in and sort of expand it as if it were right there in the middle of a style tag. And so it knows it's a CSS, and it pulls it in. So that's how you change your HTML. So now if we take a look at the next example, we see that in this next example, we've got a link, right? And down here, we've got no style. Ignore this little thing. That's how we're putting this little, don't ignore that page. But in the real stuff here, we've got this. We've taken our, we got our pre-tag. We've moved it in. We've got some things here. We got all that stuff that we've done, right? And if you look, here is that rules.css file. Rules has all that same stuff. H1, border color, a tag, all that stuff that we put in the head now is sitting in this rules file, and we're just pulling it in right here in one fell swoop, and it accomplishes the exact same thing. Okay? And so this, including in a separate file, is by far a superior way to do it than putting it in the head tag. So, but sometimes you have to change 2 things and you put them in the head tag. And it's up, you use all 3 of these ultimately, but generally you tend to start with a large amount of CSS in a file, and then you tweak in the head, and you might tweak on a tag here and there. And that's kind of how these 3 things tend to work together. And the whole cascading thing works out well. You can put the link first and then style tag second, and then it kind of overrides some of the stuff that are in the linked, and then you can have something on a tag which overrides the stuff that's in the head. Unless, of course, it says important. So, as the world went from hacking look and feel in HTML to finely tuning look and feel in CSS, all these tags, paragraph, H1, body, they all had default styles that had kind of evolved, and links and all that stuff that evolved, and a lot of pages depended on those default styles working. And so they couldn't say, welcome to CSS, and now all the styles, a paragraph that's unstyled will look terrible. Not that they look great. And so we couldn't take the paragraph tag. Everything had a style. That's the problem. All the existing tags had something on them. So they had to make new tags, and the new tags that they made are the span and the div tags. The key to the span and the div tags is span is an inline tag that has no styling associated with it, no default styling. It is defined as having no styling, and the div tag is a tag that has no styling associated with it, but it's a block tag. And so we sort of use these to sort of mark text, but don't inherit, without inheriting any styling from some long ago 1993, 94 defaults. And so the span tag here, that's kind of broke over a line. The span tag has no styling except that styling which you add. In this case, I'm adding it with a style attribute. And the same thing is true for a div tag, right? The div tag, and also divs can be within divs. So this is a nested div, right? There's an outer div and an inner div. And basically you know that styling, the div has no style whatsoever, right? The span has no style whatsoever. So if you just put something in a span tag and you don't do any, you don't sort of render an opinion about what it looks like, the span doesn't change it. It just is, it inherits from whatever else is there. And so if we take a look at this, right? So here we have a p tag with a green border, 1 pixel border solid. Now the interesting thing is you say, well, did the paragraph tag have styling? It turns out it does. It has some margin in padding to make it look better, right? And so the paragraph tag is not an unstyled tag. It is expected to create blank space around itself. And so, yeah, so the paragraph tag has a default style. It's supposed to have a default style. But then if you look at the div tags that we've got here, like this div tag, this div tag, remember, goes all the way down to here. This div tag, I just put a blue around so you kind of know what's going on, right? So this blue goes from here to here. But you can see right away that the div tags have no padding or margin or side of little white space to make them look prettier. And that's okay, you've got to do that. You've got to add the padding and the white space. They just start with nothing. It's just a block, right? And the span tag, this one here, changed it green because we put a style color equals green right there. And okay, so we did that. And the div tag, and you'll notice, interestingly, because the divs I'm using end up with a 1 pixel border as their style, meaning they started with nothing. You can even see that if you look really close, it's impossible, but you can zoom in. This orange border, the blue border takes up space, and then the orange border's on inside of it, and that's 1 pixel wide. So I'm adding to these through the style attribute, I'm adding CSS to them, but they start with absolutely nothing, and they kind of look ugly when you just like put something in a div, like right next to each other, because they didn't want anything. And again, they're nested, and there's reasons, because we'll use divs to say, this is the main body, and then there's divs within the main body, and then this is the navigation, and this is the footer, etc., etc., etc. And so we have, divs are ways to describe blocks without adding CSS styling by default, and it's, as such, letting you define all the CSS for these things. So these are cool. They're like the non-tags, the untags, the tags that don't cause anything to happen but let you cause everything to happen. So they're really important. They're really important. So the next thing I want to talk about is making a sort of finer selection of which tags that you want to apply a rule to, right? A rule to. And so if we look at this tag right here, this is the body tag, and that basically says I want everything from body to /body, then everything inherits. So unless it's overridden, I want Arial sans serif to happen. Okay? And I can do that with a paragraph tag, but I want to show you this other thing. So there's a way to mark a tag. Let's find this one. Where's first? First right there. So there's this ID attribute. An ID attribute is an attribute that was added kind of specifically for CSS as well. And so you can only mark one tag per document with an ID. And then there's this class tag, and you can mark as many tags as you want in the document with a class tag. And the idea is like ID tags are for chunks, like main page, like left navigation, top navigation, or something that's only going to appear once on the page. And so if you want to sort, in effect, what #first means is look through the whole document, find a tag. Where's div ID equals first? Where's that stop? Div, right there, right there. Find the tag that's got an ID of first, and then paint it with those rules. The class can happen more than once, but more space. Let's see, classes more space here, that's there. And so that basically says, let's change clear and change color here. More space says look through all the document and find all the class. There's that paragraph. Ooh, do I not close that paragraph? Oops, mistake on my HTML. Here. Yeah, so that basically says change the margin left. That means shove this in, and change the margin right and shove it in. So we'll see all these things. And loud, and then you can also see a situation where when you put classes on, you can have more than one. And so this basically will respond both to the shout and to the loud class. Okay, so let's take a look at what this page looks like. So here we go. It's a little busy. So if we take a look at first, it grabs this tag here, the div tag is first, right? And then if we look at like more space, this more space is affecting this one, and it's shoving it in both on the left and the right, and that's because it's this paragraph more space. Okay, shout, let's find the shout ones. Well, we can see them right here. They're all the loud ones. So that is red. No, that's shout and loud. Oh, here's one that shout. Oh, entire has been shouted, and all has been shouted. So you'll notice these guys are lowercase, but shout is a text transform to uppercase. So you can even change the case of things. And then in third, for example, where's third at? Third says within. So this says find the third div, which is right there, and find all the p tags within the third div. This p tag and this p tag, and then apply a background color yellow to all those, which leads to this right here. Okay? And so # means find ID and apply. Dot means find class and apply. You can have multiple classes, right? Pull in the definitions from two classes, shout space load, go find the whatever's in CSS. And then you can kind of have hierarchical things, and this is quite useful because you don't have to get special. It saves you putting classes on. It saves you from putting classes on all the paragraph tags here. You don't have to do anything, but you're not affecting the paragraph tags outside here. You're only affecting the paragraph. I think of this as go find third and the paragraph tags within third, and then do something to them, and that way, otherwise you'd be making more classes than you need to be. And so this is a very well-liked technique for really fine-tuning your selection, your selector for CSS to touch only the things that you want to touch. So up next we'll talk about images and colors and fonts and a few other things. So welcome back. Now we're going to talk about making our stuff look a little prettier with images and how we can play with images, colors, and fonts. So CSS and images are a lot of fun. We can fool around with them. We can move them around. Actually, this for me years ago was the thing that in 1994 that made me fall in love with the World Wide Web. So what made me fall in love with the World Wide Web was the ability to take a picture of me, and I love pictures of me, and then float it to the right, and then I put a little border around here. And so that's what I've done with CSS. So let's take a look at how I've done that. So if you look in line here, the navigation, which I'll show you when I go through the code walkthrough how the navigation works. But at this point, at the end of the navigation is right here. And I put this image in. So if you were to watch this inline, the image is right there. But what I do is, when I say float, that actually, and there's other things that we'll see when we start looking at fixed and absolute positions, you can pull it out of the regular stream. And so this is like pulled out of here. It's as if it didn't exist. And it floats to the right, but then it's vertically aligned. So the next thing you see is this header 1. This header 1 CSS, there's a typo there. I got to fix that. So I'll pretend that was an H1 there, but that's okay. So this header at Quarks mode, I should run this all through the validator to make sure I'm okay. But okay, so the top box of this CSS and images H1 is right here, and then this floats over, but then it top aligns. Now you can change this alignment if you like, but it top aligns here, and then it actually looks at the width, in this case the width of the picture, but you can also control the width up here in the CSS, and then it carves out this space, and then I do a margin of 1em. And so on M, so you sort of sometimes wish they would put default formatting on, but then they kind of tend not to put default formatting on, because if they did, then you have to turn that off. And so I wanted some white space, and so I had to put some white space around it. And so I said I'd like a margin of 1em, and so that puts a little bit of space here and here and actually here as well. So you see that this lines up over there. And then that talks about what is a 1em. So 1em, I could have said 5 pixels, 5px, and that would have been fine. But 1em is basically the width of the letter M, roughly. It is a width that changes with the size and nature of the font. I think of it as the width of an M, and I think that might be a soft definition of it, but I don't think it's a precise definition of it. But that's what I did. So float right hoists it and sends it over here, and then shoves this over so that this text is now, it reserves this space so the text is wrapped, basically. And then I held out some space just for prettiness, right? And so that's like CSS is making it look pretty. Now, what happens here is sometimes you want to basically force, after this float has happened, something back to the left margin. And there's this clear equals all that says clear any floats is what it's really saying. And so it means that even though this, if it wasn't for clear equals all, this next paragraph would have been kind of up in here. And then maybe it would have wrapped if it was long enough. And when you play with this, you can resize it and see how the wrapping changes. But no matter what the size is, after the BR clear equals all, this is going to format back to the left nav, right? So that clears that hanging wrap, that sort of, but you don't have to. You could not do this, and then it would wrap and wrap and wrap, and then it would get longer and it would continue on. But if you want control over that, you can with the BR clear equals all. And of course, you can have images right in line, and this is just from the HTML bit here. There's nothing fancy CSS here. Images kind of are like big characters. I sized that one so it sort of fit nicely, and you could even make this a clickable link. But that's really just, this part here is just HTML, not CSS. But I could have, if I wanted to, change the width and the height of this. That'd be kind of fun. Make this guy be like the width of an M, and then you'd see it more like a character. So there's a bunch of colors, and the colors have to do with, there's the simple thing for us simple folks. You know, we just put in things like red and green and stuff like that, and especially if you're doing a developer and you're just trying to get basic stuff working, I often use colors in my testing. That, like, put the border red. I do that all the time to say, where was that div at anyway? So I'll throw a 1 pixel border around it, red border, like, oh, that's where it is. Although the Chris Pedrick plugin has a thing where it puts 1 pixel borders around everything for you automatically. But whatever. These are not necessarily most graphically beautiful colors, even though I like them because they're super primary in terms of primary colors and strong. You'll see that I kind of use those colors in my slides a lot because I'm not a graphic artist, of course. I just like, oh, the greenest I can be is good. So there's 16 official colors, and they're here. Once you get a little more sophisticated, you can use precise colors from like I think this is a, I don't know, 32-bit. Yeah. So this precise colors are the ones that start with £. And so £, and these are hexadecimal numbers. These two numbers are effectively 0 through 255, but they're in hex. So hex is like A, B, C, D, E, F are actually numbers. 0 through 9, this is actually 10, 11, 12, 13, this is 15. And so E is bigger than 9, and F is bigger than E. But basically these are 0 through 256, that's a three tuple of 0 through 256 numbers. And so the more red you put in, the higher this is, the more green you put in, the higher that is, and the more blue you put in, the higher that is. So RGB, red, green, blue. And if you're playing with like a slider inside your UI, you might be changing this, but you're just changing these numbers ultimately. And so you can find these things. You know, so white is all Fs, and so if you turn it all on, it's white. If you turn it all off, it's black. The absence color is black. Red green, so you turn, that's max, max, and max, and so you can make sort of a pure red, pure green, and pure blue. Picking these advanced colors is sort of way beyond my ability as a graphic artist, and people will pick colors. There are sites that help you pick palettes for your pages, etc., etc., etc. There is also a sometimes these colors can have a transparency, and there's a fourth set of two numbers that have to do with how transparent the color might be. So fonts are also important. The default font is a Times Roman because that's what computers had in 1994. And I think they're ugly, especially on screens. They're not so bad on print, but they're ugly on screens. And so I tend to want a sans serif font. It's too bad that and maybe they have changed on some browser default for sans serif. I just change it to sans serif all the time I want. Now if you look at fonts, the font family is kind of a special tag in that you ask it a set of fonts, and what you're really doing is you're setting a priority. And the problem is depending on whether you're on Windows or Mac or which version of Windows or which browser or what fonts they've had installed, fonts might not be there. And so what you basically do is you basically say, okay, I would like this. I think this is a Microsoft font. And if that font's not there, then I would like this font. And I think that might be also a Microsoft font. And if that font's not there, then there's Arial. See how much I know about graphic arts? I have no idea. I think this might be a Mac font. And if that font doesn't work, default into the fallback font sans serif. And there is always going to be a serif font, Times New Roman-like, sans serif, Arial-like, monospace, which is Courier-like, cursive and fantasy, which are whatever. And so all browsers are supposed to have those fallback fonts. And so you tend to see them here at the very end. And so when you see me, I usually will say Arial sans serif or something like that just to get sans serif. Although it's quite common, the more sophisticated a page is, the more likely. And the other thing that's increasingly the case is people are downloading fonts and having special beautiful web fonts, and then they download them and then they put that font in here, but then they probably still have fallback fonts. So font family is kind of a weird and unique and glorious thing that leads to some really gorgeous web pages, because so much graphic and arts work is going into making web pages beautiful, and we're going way beyond the operating system installed fonts and having pages that download their own fonts. Things that you can do is set the things to bold, italic, text decoration. Remember, links have underlines and we can turn them on or off. Font sizes are kind of troublesome in that you can set them to pixels, but then you're in danger if you get to a certain kind of a screen size or people start zooming the screen and stuff. And so you can tend to use these relative ones, but they're not as guaranteed as you might like them to be. And so just these are a little bit tricky. Absolute font sizes are a little bit dangerous. I tend to just go like, here's my font, here's the one that's a little larger, here's a little smaller if I need that. So most of the time I'm tending to do things that are like smaller. If I'm putting like a copyright statement and I don't want to distract from the main page, I'll just make it a little small. I'll say, okay, make this small or extra small, and what if it doesn't turn out to be that much smaller? It doesn't matter. I'm just kind of trying to so I'm not an expert in how to use those. I tend to use them as simply as I possibly can because they're not as predictable as it would be nice if they were. So links were a big part of the early web, and it's called a hypertext markup language, hypertext transport layer, hypertext. And so links got really special treatment. They used to be blue before you clicked on them and purple after you clicked on them. The blue was to jump out at you and say, please click me. And the purple was to say, I've been there, because a lot of what you did in the early web is you wandered from place to place to place to places like, oh, I found a new thing. Let me explore this. And so you're always like exploring by clicking links. Once we got to the point where people assumed the web, these links didn't need to be blue and garish colors to teach us these things because people just clicked on everything. And so it became more important to make things pretty. So we have a lot of control as to how we style links. We can say the A tag, we've already colored an A tag with just the A at the top. You can basically say an unvisited link is supposed to have the color black, After the visit, it's supposed to be gray. While you're hovering over top of it, it's supposed to have text decoration in none and be black, white with a background of navy. And then active is not so heavily used. It's once you've clicked on the link while the page is loaded. So it's a way to kind of, maybe disable it or turn it a color so people think, oh, I better wait until this next page loads. And so when I do the recording, you'll see this. It's a lot easier to see this dynamically. And so there's a whole bunch more samples that I have, and I'll record some walkthroughs of every single one of the samples. And so you can take a look at that at Web Applications for Everybody or in the recordings. So this has been a zoom through CSS. CSS is quite the art and science, and it's evolutionary. I mean, people specialize in this. They're very good at it. It's a modern form of graphic arts. The basics are there, and I think every programmer who does anything on the web should know the basics of HTML. They keep moving things better with things like nav tags and Bootstrap, etc. And while there will always be like edgy new things in CSS, and so sometimes you'll see CSS with like these Moz fields, which are for Mozilla for the Firefox, but people are always pushing that boundary. And before you couldn't put rounded corners on things, but then the browsers added extensions to put rounded corners on things, and then everybody kind of agreed on that. So CSS is kind of always going to get better and better and better, because for the mobile and desktop, they really want to create as beautiful experience as possible and use standards wherever possible. And so the basics are there. You can do so many wonderful things, especially if you pull in something like a Bootstrap that just kind of cleans up the rough edges of HTML and makes it generally pretty and takes a lot of responsibility off of you. But you can certainly make a lifetime study of CSS if you like. So I hope you found this useful. I will see you on the net.
Hello and welcome to Web Applications for Everybody. We are taking a look today at cascading style sheets. You can download the source code and unzip it on your computer if you like, or you can browse this code and just play with it in the browser, because it's all static content, so it's just as easy to play with it in the browser. And of course, we're going to want to take a look at this in the developer console. It just makes a lot more sense to get into this, and so here we go. We're taking a look at CSS. There's a couple of ways to do this. We can see here, we can see the style attribute. Style color equals blue, and there's all kinds of various CSS parameters. Color is the parameter and blue is one of the values, and you gotta look all these things up. One of the nice things that we can see is we can see over here, as we move between elements in the document object model, we can see what the CSS values are. And so Arial Sans, like for example, this is cascading. The body on here is Arial or sans serif, and that means that Arial font, if we can get it, sans serif is a fallback font. And so that this H1, this little bit right here, this H1 is being colored. This is ours. Browsers have their own default, so display block, font size 2EM, which is twice as big as the rest of the font, etc., etc. And so this came from the browser, and then this came from the style sheet. So this is cascading, and the bottom ones here are this is the most important one because this is the one we said that's closest, and that's how the cascading works. Yeah, we already saw that. And then the cascading is, again, we take a look at this little guy here, right here, and so the closest one is we want a monospace font family, but the body said the font family is Arial and sans serif, but this one has been overridden, and we can kind of see that, and that's why this particular text is monospace. Another thing we can do is we put border style. Now, when I'm working with this stuff, I tend to remember border a lot because it's a good way for you to mark something out and say, what am I doing here? And we'll see, like when we're moving text around, border, solid border, a red border, and a 5-pixel border. And so that's what we see. And you can also see that there's some extra padding around there as well, or some extra margin. And margin top, that's another one. I'll scroll this up a bit. Margin top throws 5 ems of space above the above the text, and so this is a normal paragraph. We got 5 extra M's. Now what's an M? M is the height of a character in the current font, and so M's is a really convenient measure. There's M's and pixels and percent. So margin before, that's 1 M over here. The paragraph already has an M. Margin before, and then, well, hang on, come down here, down to here. We've added the margin top. So this margin top overrode the margin top that was part of the paragraph tag automatically. So that's these style rules. So let's keep on going. While this is technically possible, this would really be overwhelming to put a style on every tag. And so one of the things we tend to do is we want to put style rules that are generic. So we'll say we would like the body tag, and this is a style rule. This is the selector, body, and then font family. And again, font family works as please give me the Arial font, and if that's not available, give me sans serif font. Curly brace, H1 tags. Go through the whole document and paint H1 tags blue. Go through the whole document, find every paragraph tag, set the border style to solid, border color to red, 5 pixels. So you see that every paragraph, and we're going to change our anchor tags to have green and have no text decoration because they're defaulted to have underscore, and we're going to make the background color light gray. Why? Just so we see it, so you can see that particular thing up there. And then if you look down into the text here, we have paragraph tags and an anchor tag, and no style equals down here. So what we've done, ignore that little part there, that's what puts this little thing in the corner, so that's not what we're talking about. We put no style tags whatsoever, and we put all the style tags up here, but now we've also done something that all the paragraphs have to have the same style, which sometimes is what you want, and sometimes it's not what you want. Now what happens again now, if you have multiple pages, as we have here, it gets a little tiresome to put this text in every page, and so what's really common instead, so now we have the same basic rough paragraph stuff here, nothing in here, we have a pre-tag, of course, we have a paragraph tag, there's no style equals on these things, but up in the head we have one line right here that basically says, let's take a look at this style sheet, and if we were to look at the style sheet.css, it is in the same folder, rules.css. It's in the same folder as that HTML file, and it's exactly the stuff we had there. It's just a set of selectors and then a select of key values we want, color blue, border style, border color, etc., etc., etc. And so it really is the same as what we showed before, except now that we have to put this into every file, and you'll see we'll put this now from now on in every one that I'm looking at. And so, but now our problem is that we've done something with this to do all the headers, right? All H1s, all paragraphs, but we need better ways to mark text. And so, we have these tags, and these tags that we use just to put handles on. In the old days, like this paragraph tag has this border. See that has the margin up there. I mean, it has the border, but it has this 1M margin. That's that space that you're seeing that makes paragraphs look good. I mean, it's not a bad thing. And so if you look at that, we have all these colors. We've got the strong tag. By default, the thing uses a serif font. I don't like that. So let's get down to here, and this. Well, let's just look at it here. The span tag, inspect element, right there. Okay. So the first thing is the span tag is an inline tag that has no styling. The problem is before CSS, which is a long time ago, all these tags had default styling. But the span tag is an inline tag with absolutely no styling whatsoever. And then the div tag is a block tag that has no styling whatsoever, and it can be nested. So it's kind of like a paragraph tag, but it has no styling whatsoever. Now I've added a 1-pixel style, and you'll see that these div tags don't have any extra space, like the paragraph tags came with space. Now some people would go and turn off the space on a paragraph tag, And there's even CSS files that you can to take all the styling, default styling off tags. But you'll notice these divs don't have any space. They're really kind of a block. When I put these pixel on, you see the border. If you look really close, you'll see that there's a 1 pixel blue line and a 1 pixel orange or sienna line right there. But the divs can be nested, and they don't themselves start. So you'll notice that here they don't start with any kind of formatting that comes from the browser, whereas if we look at paragraphs, there is formatting that comes from the browser. And so the div tag and span tag are just are ways to put handles around blocks of text or chunks of text and then style those. But then we still have to figure out how to grab our handles and make it so that our styling doesn't just touch one thing. And so here I've got a couple of things. I've got the body tag, and I'm setting font family. You'll see me do this all the time. And now I have a pound sign, and this says go find all the tags named body. This says go find all the tags with a attribute of first, ID equals first, ID equals second, and then class and shout. So if we take a look at the text, there is the notion of an ID tag. Okay, an ID tag that is unique within the document. So we're going to call this div first. We're going to call this div second and this div third, and they correspond to first, second, and third. Okay, and so first is monospace. What is it? First is monospace. Second is green. So everything that's in this block that's second has been green. And then, but you can only have one ID named first. But class you can have all over the place. So we can have we can put the more space class on a couple of different tags. So this tag, more space, all more space does is shove it in from the left and the right, margin left and margin right. So it kind of pushes this in, and so you can put this on here, you can put it another place, and so the more space pulls in something here. So here's another paragraph that's got more space. That one has more space. This one has more space. See that one? And so you can put more space on as many times as you like, and then div third. Right. And so the hierarchical section means, in this case, this one's a little bit, and loud is red. So where's loud at? So let's inspect that one. Inspect element. Yeah. So that's the loud is not only red, but it's also forced uppercase, text transformed to uppercase. Shouting and loud, and you can have more than one class on on a tag, and then you can be even more precise with your selection. This is basically, this says find a third ID, and then only paragraphs within that tag third make their background color yellow. And so that means that background color yellow does not apply to this tag, it doesn't apply to this paragraph, doesn't apply to this paragraph, but when you see div ID third, we have selected this paragraph, and they have a background color of yellow. So continuing on, let's take a look at a simple navigation bar. Now, there's this nav tag that's an HTML5 thing, and if you look at most navigation on pages, let's go to the next one. They're pretty and they got colors and they move around and stuff. But what we want to be careful when we build our HTML for these kinds of things to make them very, very simple. And so what I've got is a navigation is usually, we describe it, we use a nav tag, which is a block tag that says, hey, this is our navigation, useful for screen readers, etc. And then we're going to say we're going to have a list of two links, and so that's what we're doing. Unsigned list, unordered list, and a list element that's just no paragraph here, just an include, just a anchor tag, and we're going to put a class equals back and class equals forward so we can style these two things differently in the future. And so this is what this looks like with no CSS whatsoever. And so this is a nice, elegant, clear HTML. And so if you were just looking at this HTML like a screen reader might be looking at, you can see what this really intends to mean. Now, then what we do is we add a little bit of HTML to this. And so for now, we're just not going to bother, but in navbar.css is the HTML or the CSS that makes this pretty. And so there's a whole bunch of stuff. And we'll come back and take a look at that in a second. Okay, and so there's our styled navbar. So I'll come back in another video and pick up right here. So welcome back. Now we're going to take a look at some more examples. We're not going to, the one thing we're not going to look at is exactly how this navigation bar works, at least until a little bit later. So the next thing we're going to take a look at is how fonts work. And there's a couple of ways that you can put fonts into a file. There are default fonts that every browser is required to produce, like serif, sans serif, monospace, cursive, and fantasy. And so you don't exactly know what's going on, but they're often used as fallback fonts, and so you can have those. There are any font that is on the system, like Arial or Helvetica, and so if you're going to use Arial, not all systems have Arial, although most of them do these days. And you have to have more than one font. Now, another thing that's really common these days is to include a font somehow. You find out about a font, and here's a Lotto font. And you go look it up on the web and you find, oh, include this. And so I included this link because I found this really cool font, Lotto. And this extends the browser. The browser then learns about this font, it downloads the font, caches them, and keeps them in the browser. And then I can make a font that's Lotto. But just in case I'm off the internet, and I can't download this thing, I have sans serif as a fallback for Lotto. So Lotto is a fancy font, etc., etc. So there's Arial and built-in fonts, etc., etc. And so that's how fonts work. Colors, there's a lot of cool stuff about colors. There's a couple different things. We'll ignore the nav for the moment. I'm just using span tags here. There's some default colors in the earliest of browsers. These days we have all these fancy ones, and you can go look these up and you just Google for HTML colors. And there's a bunch of names, and then they're consistent across browsers. But there's like 12 or so really solid names that are in all browsers since the beginning of time. But more modern browsers have a better palette of colors. Although really good graphic artists want to have much better control of colors. And so this is, the pound sign says that this is a hexadecimal number, and it's got 2 digits. Hex means they go all the way up to F. So F is A through F are numbers. 8B is the red level, 45 is the green level, and 13 is the blue level. And so this is a brownish color. And then there's what's called web safe colors, where you just have, this ends up being 88, 44, 11. But it sort of reduces the number of potential colors if you were mixing colors from various sources. And then in HTML5, you can see this color picker. When you have a form, which we'll talk about in a bit, it's a color form for modern browsers. And then you can pop up with this button, a color picker, and I've got a little thing to print out what the color would be. And so it just, when I pick the green, it basically puts 00FF, that's red, green, and blue. It puts that into this thing, which then the program could use. Could read this, or JavaScript could read it, or server code could read it. But right now we're just kind of playing with the picker, and we pick a different color. And so that magenta is all the red, none of the green, and all of the blue. And orange is all the red, some of the green, and none of the blue. So those are all just really strong colors. And so that's what's called an HTML color picker. Anchor tags. In the old days, anchor tags were kind of funky. They were blue if you hadn't yet visited them, and they were purple if you had visited them. And so this one I've obviously clicked on. And so we have a whole series of styling mechanisms that we can have. If we take a look at these, I have put these all inside of an ID tag of cool. So this is basically saying find the ID tag of cool and then style anchor tags to make them font weight bold. So let's take a look here. So I got one paragraph that has this one here, and then I have a paragraph with an ID tag of cool, and that's basically so I don't have to style. Usually you wouldn't say I'm only styling the anchor tags inside of, you know, if I'm only styling the anchor tags inside a tag that has an ID of cool, but that way I can have the default on this one. That was my way of keeping the default. So normally you would just say A. So A links is red. If it's visited, it's orange, and so this one's been visited, so you don't see the red. It means it's unvisited. Hover, you can change it. So you notice when I hover in, the text decoration goes away, the underscore goes away, and I have a color of text font color of white and a background color of navy. And then there is one last moment. Can I click on this one? Oh, that will click. There's one last moment that's really hard to catch, and that is the moment of active. If the web was slow and you clicked on it, then it would tell the user, in the old days this made more sense, that it would turn red and then blink away. I don't know if we'll even see it. It kind of saw it. You sort of saw it. And so there was a color while you click on it. Yeah, there it was. You might not see it in the screen, but that's what the active means, is you've clicked on it but it hasn't yet been retrieved, and then like a moment later the whole page goes away. Another thing we can do is we can play with images, okay? And so here is an image. One of the things that's really fun to do with images is float them to the right or float them to the left. And then what happens is that the image, the text is drawn around the image, so it wraps around the image. And you'll notice where I floated this left. Oh, I kind of got rid of everything. I floated it left before the H1, and so what happens is the H1, top of the H1 and the top of the image line up, and then all the text afterwards, wraps around it. And so you'll notice that I've got the image first and then the H1 second, and that the float sort of disconnects the image from the normal line of flow, floats it over, and then takes this next thing and the next paragraph and saves the space for the image and shoves the margin over so that it comes over here. Now once you start floating images, you got to learn about this clear equals all, because if we want this next paragraph, like this one, we don't want this paragraph for whatever reason to be on the image. Now if it goes far enough, you see this paragraph here moves back to the left margin, and then this next one starts there. But if the browser is wider and the text is, there's not so much text, we don't want this to be up in here. And so you say BR clear equals all. So between this paragraph and this paragraph, we do BR clear equals all. And you can put images right in the middle of the text like a character. You don't have to have them by themselves. And you can even make an image that's a clickable link. And so you can click on that image. Now, C in CSS stands for cascading style sheets. And so the idea is that the tag that's closest has more precedence than a further away tag, unless you say important, okay? So here we have some style. Here we have a body tag, border style of dotted, red, and red, a border color that's red and important, and border width that's 5 pixels, background color, which is kind of a grayish, that's that gray, and an extra padding, so we've got put some extra padding all the way around it, and extra margin. And so if we take a look at this, paragraph right here, we see some things, and we take a look at what we've got. So we've inherited this. We got a border style of color. It wants to have a border color of green, but it doesn't, because it says the border style is solid. So the border style of solid is down here in the second style tag. So the second style tag has precedence because it's closer to the paragraph. And so we tried to say border color green, but that one was overridden. So otherwise this would have a solid green border, except that this red important is up there, and so that the red important wins. And you can see it really easily here that this was overridden, and this is the one, this border color from the previous one is taking precedence. Okay, and so this is the second one, and it would normally take precedence over this one, except that this important is sort of like it is overriding the one that's closer. So another example of closer is the style tag. Okay, and so here we go. This is border. This is we're putting this. I mean, style attribute. We're saying border style equals dash, border color equals blue, and so the border style equals dash holds on, but our attempt to make the border color blue is overridden again by the red important, right? So important is up above that. Okay, and so this dashed is winning and this blue is not winning because there is an overriding red above it. I mean, there's an overriding red important above it. And so if you want to override an important tag, yay, we override an important tag right here. We basically say I want a border style dashed. Come over here. Border style dashed, and I want the border color to be blue, and this is important. So now this one's closer, and it says important. So among all the important ones, the closest important one wins. So now we see that the border color actually takes here, and we are overriding the far away. This one here from farther away got overridden because of this one. And so you can do that. Now, in general, while I've shown you how important works, you shouldn't do too much with important because usually you're taking CSSs from other places and you're patching it, and you can end up with really inconsistent looks and feels with important. Usually when you see important, it means kind of something's wrong and you're fighting with a framework or something else. So let's take a look at some blocks. And so let's see, background color, my H1's color blue. And I'm going to put some padding and a margin. And so div P and H1 sort of live in a box. You have sort of like the actual, so let's take a look at, say, this paragraph right here. That's probably the thing to do. This is just a plain old paragraph. Nothing special, right? There we go. That's a paragraph right there. So let's talk about the padding and the margin, right? So working from the inside out, there is the actual text that is, and it's wrapped. And so if I change the width of this whole block changes, right? It gets taller and narrower. But at some point, the inner part, this inner part right here is, the inner part is however large it becomes. And that, in this case, it's 318 by 38 pixels, right? And then what happens is we sort of work from the inside out. So I'll go down here and see the box model. So the inside of this, the actual text is 619 pixels by 19 pixels. And then I've asked to add 10 pixels of padding, and that is between this sort of text and the border. And then the border itself has a width, and I specified that border width. Right, I said I want a 5 pixel border width, and so the border width takes up 5 pixels. And then there is, outside of that, there is margin. And so margin is space. Notice that the padding and the text itself has the background of the block, border has its own color, and then the margin has the background of the color of the background document. Okay, so this is the margin here, it's the color of the background document. Right, so content, padding, border, margin, and then, but the padding inherits from the text in the box from a background, and the margin inherits from the background document. And you can have different background colors, etc., etc., etc. This is an, oh, by the way, this is an ordered list that we've got going on right here. Okay, so that's CSS boxes. We can change the size of these boxes. It's a little tricky. So and so here we have auto sizing div where we're not mentioning anything about the height. If we take a look at the box model here, we see that this one is simply, you know, the size of the text plus the padding plus the border plus the margin, and that's sort of how that box gets sized. You can say that you want to set the size of the box. Okay. So I'm going to set that to be 3 M's. 3 M's is 3 characters. But if you look, I have too much in here. And so you'll see that even though this box is 3 characters tall, it's 4 lines, and so the 3 would fit, but the 4th one doesn't. And so it just overflows. You can also, so 3Ms, it's good to set sizes in Ms when you can, because then if someone makes the screen larger, oops, I didn't mean that. This one, if someone makes this larger or smaller. Now the problem is, well, I don't know about it, if we'd call it a problem, but in the old days, if you set a height in pixels and you zoom the screen, the box where you set height in Ms would zoom, and the one that you set in pixels wouldn't. But they decided to make zooming work. Otherwise, so many people made boxes in pixels that they made it so that the zooming would pretend that pixels are really Ms. So it kind of converts pixels to Ms, but you're supposed to avoid using pixels when you really mean characters. If you want 3 lines, don't look at your font and say, I'll make this 40 pixels in order to do that. And again, in this box, we still have overflowing text. And so we have a couple things we can do when we want to change the overflow. We can tell a box that we would like the overflow to make a little scroll bar. And so here's that same stuff, and you can see we got a little tiny baby scroll bar, and it didn't sort of blop out of the box, right? And even if the scroll fits, you see you get little scroll bars, but you can't scroll it because there's only 1 line there and it fits in the box. And then another thing that you can do is you can just say chop it off, right? Chop it off. Now, one thing with some JavaScript, you can put a little more here and that expands the box or pops a bilog or whatever, but we're not going to worry about that for now. For now, we're just saying overflow hidden means lay this out as much as you need and then, throw this text away. It's just not there anymore. Like, where did all this text go? But it doesn't show it because we told it to chop it off. Okay, so on to the next one. You can move these things around. This is a little messy. There we go. Let's make this a little different. Okay, so by default, I'll show you the HTML in a second for this, or maybe just do view source. Let's do view source. Okay, so if you just say div, they just follow after each other. And I've given them border because to make them a little picture, give them some border, some padding, and some margin just so they don't touch each other too much. So by default, blocks so I got a little border both on all sides and a little bit of space between them and a nice. So they, however big they get, this one gets bigger, and I put a width on them just so that they wouldn't move around, and there's a width on it right there, 10 Ms, 10 characters wide. So they just follow each other. And then you can say, okay, this block right here, this number 3 would lay out right here, but I have told the number 3 block, that I want to move relative to where you would normally be 20 pixels to the left and 20 pixels down from the top. And so this block, it lays out exactly as if it belongs right here, and then we shoved it over and moved it down. And it came over top of the number 4 block. And so there you go. And so the text afterwards, this number 4 block, just comes next, and it's basically, it's as if this laid out without the position relative, and then this came afterwards, but then we sort of just shifted it, and that's why this overlaps, because this corner here is where 3 would have finished and with a normal layout. So you got to be careful with relative. I mean, you don't usually want to make it so that they sort of blop on top of each other. Okay, and so now we're in 4, and then we're going to look at 5 and 6. And so 5 is what's called fixed text, and you'll see the 5 comes right here, but because I've got this as position fixed, this is fixed relative to the window. So it's 20 pixels up from the bottom and 30% of the way from the left margin. So you can see that this is 30% of the way from the left margin, and it's the bottom of it is 20 pixels up from the bottom. And you'll see that green box never moves, and that is because the fixed text is relative to the window. And that's how we actually get this little link that never goes away. And so there's a link that never goes away. Absolute text, I don't know why they call it fixed and absolute, but absolute text is a little bit different. It's relative to the parent element. And so in this div right here, the parent element is the body tag. And so when it's saying I would like this to be 40 pixels from the top and 30 pixels from the 30% of the way from the left, that means it's relative to the body tag. And so the body tag starts up here, and so this has been sized 30% from there and whatever 40 pixels down. And notice that that one goes with the scrolling, right? So that one goes with the scrolling. And you'll also notice that between 4, 5, and 6, there's like, it's as if there's nothing here. But if you look at the document, 5 and 6 are sitting there. And that's because they are plucked out of the normal rendering stream, and so they don't take up any space between 4 and 7. So they don't count in sort of the normal layout as the page is being laid out. And so here's number 7, for example. Actually, number 8. So here's number 8, and so this is positioned relative with a left of negative 1,000 pixels. And so in a sense, this stuff right here has been shoved off the screen to the left. And so that's how we often will put text on that nobody sees. Just move it to the left. But it takes up the vertical space anyways because it was just relative. It would have normally laid out here, but the left shoved it over there. And so that's basically some layout. And so now we're going to talk about z-index. Let's take a look at the source code here. And so z-index is the ability to what happens when things overlap, okay? And so this is a div. Number 1 has a z-index of 100. Number 2 has a z-index of negative 100. 0 is sort of the background document. And it works out pretty straightforward. And I'm just moving these so they have to lay on top of each other. You know, and so you see this one here is negative 100, so it's kind of behind everything. This one is positive 100, so it's in front of everything. And this number 3 is, yeah, it's in it. I just put that there to be in the original document with no z-index whatsoever. And so it's behind this thing that has a z-index of 100. Okay? And so that's z-index, like this little note way over here by the right margin says, z-index is kind of tricky. Everyone tries to be on top. And you'll put z-index of 100 and then you'll find that the navigation put itself as z-index of 1,000 or something like that, right? And so z-index is hard to debug and hard to fiddle with, but at least now you know that z-index is when things look weird and they're overlapping in weird ways, z-index is what you're taking advantage of. And so now we'll take a look at kind of how this navigation works, okay? And so here's a couple things that the navigation does. The body, of course, is font family Arial sans serif. The navigation bar itself, I guess I'll do a view source on this so we can look at the navigation bar. The navigation bar itself, this block, it's a block tag, right? That has a position of light gray, and I've given it a height of 3em, so it's like 3 lines. And if I zoom this page in and out, right, that gets bigger and smaller. I'll get back to 100%. It's 3 lines tall, and I guess I didn't need to say Arial sans serif. I did that in case someone else wanted to change the body tag, I guess. So then I have I want UL tags within the nav, and that's one of the nice things about this nav being its own tag. I can style just the ULs inside here. Okay, and so what I'm doing here is I'm saying I don't want any little circles, little dots, little bullets. I don't want any of those. I want to take away any padding that it has by default. This is one of those things that this UL inherits. Let's go down here and take a look at this, and you'll see that this UL right here. So what's happening is this is the things that I've said in my CSS, and I'm overriding some default things. It's normally would be display. It's a display block. That's okay. And so I overrode the list type style. And continuing on. the list item inside of nav. That's what it is, nav and list item. I wanted to make that. So let's inspect this guy right here. Inspect. So if we look here, and I've got a class of back, and so I have this positioned absolute, which is relative to the parent right here, and I have it 20 pixels to the left of that upper left-hand corner, and so that's how this comes over here. And then I have it colored dark blue because it's a nav, an anchor tag within an anchor tag within an li tag within a nav. That's what this is saying. Dark blue text decoration of none, and so that's where I get this color blue and no underlines. And then this is the dot back, and so I use a back class to position this right here, and then I use the forward class to position this relative on the right, 20 pixels from the right. And so that's how I make the navigation bar work. And CSS is really a lot of work. We learn a lot about CSS, and this is just a really short introduction to get you a sense of what the basic mechanics of CSS are. Thanks for watching.
Hello and welcome to our screen recording. In this screen recording we're going to install the MAMP software for the Macintosh. So we're going to download from mamp.org. So I'm going to keep this. I don't quite know why Macintosh is unhappy with that. And so I'm going to go into my downloads folder, and here I have this folder. And it's MAMP Pro 0401. That's because I downloaded it twice. And so I'm just going to click on this. And it opens an installation. And I'm just going to accept all of the defaults here. Okay, so it's been installed, so let's take a look at where it's at. So if I open Finder and I go to my computer and I go into my hard drive, Applications, it's in MAMP. And I can start MAMP up. And this tells me a bunch. PHP info here is really useful because it tells you about the configuration of the system that you've got. I've got version 7 PHP, and it tells me where the configuration is for this. And so I'm going to go take a look at the configuration file, and I'm going to make sure I'm going to do Control F and look for display errors. So this is the problem we have when we're doing development with MAMP, is that display errors is off, okay? And so I want to fix this by editing the initialization file, and you got to go to the right one, Applications MAMP bin PHP, PHP 7.10 PHP INI file, okay? Oh, and by the way, I've got this little MAMP control panel. This is your MAMP control panel. Starts and stop, little green dots means that it's running. So I am going to run the Atom text editor. And I'm going to open a file, and I'm going to go to my Mac. Oh, wrong. My Macintosh, Applications, MAMP. Let's see. MAMP bin PHP, MAMP bin PHP, PHP 7.1.0. conf PHP INI. Yay, I found the file. So I open this up, and it's a nice little text file, and this is the PHP configuration. And I'm going to scroll down here. I'm going to use look for display errors. If you don't do this, There we go. So we're looking for this line that says display errors equals off. It talks about this. Print out errors as part of the output for production websites. Do not do this for production, sure. But we're doing development on our local hard drive, and so we want to turn this on. Because if you don't, you won't always see the errors. I'm going to turn up display startup errors. I'm going to turn those on. And so we want as many errors as we can in development. Of course, if you were running in production, you would turn these differently. And so what I'm going to do then is I am going to then save this file. Command S. I've saved it. Okay, now the thing you've got to do at this point is you've got to stop MAMP and restart it. Stop the servers. Now the servers are stopped. And if I go to refresh this, it'll blow up because it's not there. But when I start these servers, they'll come up. Then I'll go to the web start page and I'll look for PHP info. I can close these tabs now. And I should go down and look for display errors on and on. See, that's the success. That means that you are successful, and that's great. Okay, so let's then also write a simple little page. I just, how do I get rid of, oh, I got to escape, I think. Yeah, there we go. So I'm going to make a little file. Hello from my first web page. Okay, so we're going to find out where this is at, localhost 8088, because this is now a web server running on your local computer. And if you go into your Finder, it is, well, let me start at the top. Where's my computer? Come on, computer. MacBook Pro, hard drive, applications, MAMP, htdocs. That's the folder we want to be in. Okay, that's the one we want to be in. So I'm going to take this file here. I'm going to say save as, and I'm going to go to MAMP, htdocs. I'm going to make a new folder called first. I'll make a new folder, and then I'm going to save this as index.php. Save. It also nicely highlights it. So now if I hit refresh here, you'll see that I got this folder name first, and if I go into first, the slash, if I don't have anything there, it's as if I typed index.php, because that's called, for a folder, index.php is the default file that a web server, one of the several default files that the web server looks at to load it. And so that's pretty much it. Away we go. We have successfully installed MAMP and changed the startup variables and written our first little program. Okay, hope it helps.
Hello everybody, welcome to Web Applications for Everybody. Today we're going to show how to install MAMP for Windows. So I'm going to download it here, and I'm on Windows, so it takes me straight to the download. I'm just going to say, I'll go ahead and run. So now it's going to go ahead and run the application. I'm going to say yes. English. Next. I'm not going to install MAMP Pro. That's nice that they give us that checkbox. So you can pay for MAMP Pro. I don't exactly know. I've never used it, so I don't know. Accept the license agreement. Put it in MAMP. Next. Next. Desktop icon. Let's go ahead and run it. Okay, so now we're going to continue. Now we have MAMP. We should also have this on our desktop. So it's coming up. So this is very important. You've got to allow this to happen, because if you don't, well, let's check them both so that MySQL can talk. Now this is HTTPT, and I'm going to say yes to both of those. And that's very, very important. And now that they're up, and so we can open the start page. And there we go. And you can take a look at PHP info. And then you can look at PHPMyAdmin. And literally at this point, if you've got something coming up here in PHPMyAdmin, you have successfully installed MAMP. So congratulations. Hello and welcome to Web Applications for Everybody. Now we're going to install Atom, the text editor. You literally could do any text editor. I use Atom because I like it. It works on Windows, Mac, and Linux the same way. But literally you can use any text editor that you like. Don't use Notepad or Word. Certainly don't use Word. Because if you use Word, it'll mess your files up. Okay? We really need a text editor with syntax highlighting and things like that. So it's finished downloading and it's getting ready to install it. We're going to write right now our first PHP application. So I'm going to go ahead and get Atom started, and I'm going to get MAMP started. So MAMP, I'm going to have to start these servers. I'm going to start the Apache server and our database server, MySQL. So we'll get that started. So let's open the start page, because there's a lot of good information we can get here. We can find out about our PHP configuration. And my favorite thing to do is to run PHPMyAdmin, because literally if PHPMyAdmin is running and you come up with something that looks like this, you are in really good shape. Everything is running fine. Your database server is running and PHP is running. So I'll get rid of this. So what we're going to do is we're going to write our first application. And so I'll have Atom here. And so I'm going to do File, New File. And I'm going to call this H1 Hello from a web page /H1. And now what I'm going to do is I'm going to save this. File, Save. And I'm going to go to a file called /C MAMP htdocs. I've pinned it here to make my job a little easier. I found it once, drug it over here and pinned it, so I can get right here. Now, this is the web document root for your web server, and you can make folders here. So I'm going to make a new folder. I'm going to call this folder first. Make that folder. And I'm going to save this file, call it as index.php. Index.php is a special name. It's a file that if you navigate a web browser to the directory, it will generally serve index.php. And now it's syntax highlighted this for us because it's showing this. Now, the way it works is I can go anywhere from localhost on down to the folder that I just made, to the file I just made, index.php. And so you see that C:\MAMP htdocs is the top of a folder, web folder structure that's sort of from localhost on down. Okay? And so this is just an HTML page. We've seen it. We can view source. This HTML page came from PHP. Now, so far we haven't actually run any code in this PHP. So let's go ahead and write some code. And show you how PHP can run code. So there's a tag called $PHP, and then a tag that's $, and it's already added that for me. And I can run code in here. So I can say something like echo hi there \n semicolon, and I'm going to save this. And I'm going to run this code. Run it again. And so there we go. It says hi there. Let me put a space in here. So this is code. And basically what happens, now let me put a paragraph tag in here. Put a paragraph tag, some HTML, put an end paragraph, something else. And so what happens in PHP is when you drop into the PHP language on the server, it switches from just rendering this HTML to running code, but then in place of this, we get the string hi there. So let me save that and hit refresh again. And so this bit came from the executing code that ran here. And so inside this code, we can put in some logic. So we can say, $x equals 6 times 7 to make a variable, and then we can say echo the answer is, and the double quote was already there, sorry. /n to put a new line in. So I'm going to save that. And now I'm going to hit refresh. Oop. So it looks like it didn't quite work. I got to concatenate this with a dot. Oh, no, this is supposed to be an X. That's why I made a mistake. File, save, refresh. Okay, so you see this came, hi there, all this stuff came from the executing code. So you can think of all this output as the result of executing this code, and anything that is printed out during this code is put out as the web page. And so that's kind of the idea. You put files and folders inside of this htdocs, and then you execute them by running them in a browser. Okay, so we have one last thing we've got to do, and it's a really, really, really important thing. Matter of fact, I make it an assignment. I think it's so important. So we just finished writing our first web application. Now let's go ahead and make a syntax in this application. Make a syntax error. And we're going to make all kinds of mistakes. So I'm missing a semicolon there. So I come up here and I refresh it. And what happens here is we get an error. Now, I just put the error in so you kind of know what the error was. But the question is, what if this was like hundreds of lines of code and you had to figure out what's going on? Okay? So let's take a look. There is a setting. It turns out that printing errors on the screen is great for developers, but it's really bad for production systems. And so they default these systems when they install them to not turning on, not showing errors. So we have to find out how to change the errors. So we're going to go to that start page and then go to PHP info, and we are going to look at the loaded configuration. It's right here. C:\mamp config PHP 7.1.5. You got to remember this perfectly. 7.1.5. Okay? So, let's open that file. File, open file. We're going to go to MAMP. Going to keep going back and forth. Is it in configuration? No, I think it's in, I've got to keep going back. Conf PHP 7.1.5. Okay. conf PHP 715. This file right here is the file we're going to open. And here we are. Now you're going to search down for a field named display errors. Let's just scroll down here. Display errors. I'll find it. So it's turned off by default because of security. Let's not find that one. Okay, so I think I found it. Okay, display errors off. So we're going to change this to on. And might as well display startup errors to on too. So there we go. So it's still going to log the errors. We'll talk later about where these logs are at. But now I am going to save this file. So I've changed that, and then I am going to stop the servers. You don't have to stop the servers very often, but in this case we have to stop the servers because we've changed the basic server configuration. So this will take a moment. So they're stopped. Now let's start them. So they're coming up, the Apache server's up, and the MySQL server's up. And now we can just refresh this page. Okay, so we can go down and we can look at where the display errors are. Okay, display errors on, startup errors on. That's what we want to see. Okay, now that we've got these, when we hit this, instead of giving us a very nondescript, kind of not very helpful, it's going to say, oh, parse error on line 6, unexpected echo. So now I can go back to my code here, close that, and go like, oh, line 6, it was not expecting echo. So let's put the semicolon back in and save it. Now we can hit refresh, and it works. Okay? So make sure to fix these and do it early. You will waste hours and hours and hours if you are just getting those 500 errors while you're writing your code. So please do this and do it early just to keep your sanity so that when you make mistakes that you get some feedback as to what went wrong. Hello and welcome to Web Applications for Everybody. In this we're going to get started. We're going to learn a little bit about how to install XAMPP on Windows. I'm using Windows 10, and so I'm going to go to the Apache Friends website, and let me make this a little bigger. They got a great video here. I won't show it right now. So I'm going to download XAMPP for Windows. So I'm going to click here to make sure the download gets started. Okay, so it's finished downloading and we're going to go ahead and run it. It's in the folder downloads if we wanted to take a look at that. So I've got my download running. Okay, so it says install it. Don't avoid into the program files because the thing to do is install in the default location, which I will show you is /XAMPP. And I don't need a few of these things. I don't need Tomcat, I don't need Perl, I don't need fake send mail. So I'll do that. I'm going to stick it in that default, which is a little inconvenient, but it's nice because it makes life a little simpler. Okay, so this will take a little while. So now that the installer is finished, I'm actually not going to start the control panel right away because I want to show you how to start it in case you don't do this, although you can just skip ahead and do that. So I'm going to finish the install. So the install is now complete. So I want to show you where it's been installed to.
So I'm going to go up to my Windows browser, my local system, go to my C drive, and go into XAMPP. And so I'm in Windows C XAMPP, and this is where it's installed. And if I scroll down here, I can find the XAMPP control panel, and I'll start that. Oops. It's asking me for which language. Now, when this first starts up, it's important if you're being given any security dialogues, that you say yes to those security dialogues. It's a little tricky. So this is the control panel, and the things we're doing is the web server, which is Apache and MySQL. So I'm going to start those. Let me do one thing here. I'm going to right-click and pin this to the taskbar. So now this will stay down here. Okay. So I'm going to start the Apache web server. Now watch for red mistakes or watch for pop-ups, and it's good. So I got no red errors, and I think it's because I'm running on my administrator account. And I'm going to start the web server for the database server, and that's running, and so that's really good. You may have some other trouble. Oh, I clicked the stop by mistake. I got to not hover over them, and then okay. So there we go. I've got to get them both started. Okay, so now that they're both started, I can take a look at the details, and now this is the XAMPP dashboard. It's running on localhost. That means it's running on a web server that's running on my computer. And a couple things that we can do is we can look at the details of our PHP installation. That's nice to have. We'll look at that in a second. You can also look at PHP MyAdmin, and this is how we talk to our database. And so the fact that this is running and it's successfully connecting and doesn't get error messages, that means we've got a very successful installation. This screen here tests a whole bunch of things. Okay, so one of the things that we need to make sure is look for a variable called display errors. So let's go find that. It's right here, and it's on. If it's off, you have to change the configuration so it's on. So let me show you how you would change it. Even though XAMPP seems to install with this the right way, we'll see in a second. This is something you want off in production and on when you're doing development to keep you from going crazy. So you go to this configuration for Apache, and you pick the PHP configuration. And then you scroll down. I'm going to use Control F to find it. Display errors. Find next. And so and I'll go down here until we find it to be on. Now this is exactly describing what's supposed to be on. For developers, you want this on, and for production, you want it off. If we were going to change this, and there's a display startup errors as well, we would save this. We can save it. We didn't. Oops, come back. We would save this, okay, and then we have to restart our Apache web server. So we'd stop it, and then they would start it back up. And then when we come back to the admin page, and then we go to PHP info, and then we'd look for display errors, and we'd see that it's on. So you shouldn't do development until that's on. Now we didn't really have to change it, but I showed you how to change it if it was wrong. Okay, so I'll close some of these windows. We don't need the web page for downloading anymore. So now we're looking at the dashboard, and so what I want to do is I want to write a very, very simple program. So I'm going to start up my Atom text editor, which I assume you've installed. You can use any text editor you like. I just like Atom because it works the same on Windows, Mac, and Linux. So I'm going to make a new file. And I'm going to put some HTML into it. And now I'm going to save the file, save as. Now I have to put this file in a particular location. On my C drive, under XAMPP, under htdocs. And so this is all the stuff that this local web server
C:\xamp, right? C:\xamp htdocs. So what I'm going to do is I'm going to make a new folder right here. I'm going to call that folder first. Now you'll be making lots of folders in here. And then I'm going to save this file as index.php. So in the folder first htdocs first index.php, I've got hello world. Now I can go over here to this URL and take off dashboard and type first/index.php. If I get this right, I should see that little file. Okay? And so there we go. Now I've created my first little bit of web code that's coming out through this web server. And so what I want to do now is I want to grab some of the code that's got some PHP in it just to test. Not that it's a big deal. I got a little PHP in this handout. That's the old handout that I'm fixing. Here's this PHP code. I'm going to copy that. And then I'm going to go in here. And I'm going to there and go paste that in. Oops. I need to paste. Control A, Control V. There we go. And it knows it's PHP and it's got syntax highlighting. This is flat HTML. This is switching into PHP and doing some computations, doing a printout, and away we go. And so now I'm going to save this with Control S. You'll always know that that when that little blue dot there is, you've got to save it or it won't save correctly. So now I go back to my browser here and I hit refresh and it'll run that code. And so this part was from the HTML. This part is running PHP. It did a calculation and there is another paragraph. So I hope this has been helpful. To get this installed, you'll be doing a whole bunch with this. You'll be building databases, you'll be writing PHP code, and so we just have to get you going and get you up and running. Cheers.
Hello everybody and welcome to my lecture on the introduction to PHP. We're going to go through this programming language really fast because I assume that you already know at least one other programming language, perhaps Python. And so this is not so much about how to program, but this is the quirks that are PHP. So it kind of helps to put PHP in a bit of a historical perspective with the various languages over time. And so this is my little chalk talk on PHP. And so long ago in, the 1940s and the 1950s, we programmed in machine language and assembly language where we actually understood the real instructions of the computer. And then the idea was more people could write code if we would have higher level languages. And so in like 1955 we had Fortran, which is my first language and still another language. And then we sort of had languages that end users used because those were the folks that needed to get work done. But the C language in 1972, which came out along with the Unix operating system, was this first language that was approachable enough. It's a pretty challenging language. I'd like to teach a class on it someday. It was approachable enough, but it was also performant. And so that was the interesting thing, is that new operating systems, PHP itself is written in C, Python is written in C, Linux is written in C. And so C is sort of like the lowest level language that we use these days because we can do a lot more. And so what happened is C became kind of the new base of languages, and things like Objective-C and C++ and Java and even JavaScript and C# were all very derivative of that. And you can always know a language that is derived from C because it uses curly braces for its control structures. At the same time, there's other languages like Perl, which were even higher level languages. They were kind of end user languages. Perl was originally for report generation and data analysis. And so this sort of high performance, although JavaScript is moderate performance, the high performance nerd languages up here at the top were all very based on C, and then Perl came out, and Perl really influenced a lot of things. And Python and PHP are kind of like scripting, interpreted languages, not thought of as fancy supercomputer languages or languages for super cool software developers. And and so PHP is an interesting creature in that sort of Perl is written in C, Python's written in C, PHP is written in C. PHP of those three languages took a lot of syntactic inspiration from Perl, but it also took syntactic inspiration, from C, but it also took syntactic inspiration from Perl. And so this kind of leaves PHP, which is the language we're talking about today, in an interesting, a schizophrenic kind of a situation, and we'll see that. And I'll try to point out where PHP is schizophrenic a little bit. So the syntax is inspired by C. We see semicolons, we see curly braces, we see no significant white space, although we always do it. But also Perl is a big influence on it as well. So things like the $signs to start variable names and the heavy dependence on the notion of associative arrays. Now in the last 6-7 years, PHP has been influenced increasingly by languages like Python, Ruby on Rails, and Java, just to kind of keep up. Things like the object-oriented patterns, etc., are more recent additions to PHP, and so they really take off of other languages, not sort of Perl and C. But the base, if you go back to like PHP 4, it felt very C-like with Perl weirdness. And we're not talking about the more advanced stuff in this lecture. We're talking about just the basics of it. So if you watch my interview with Rasmus Leerdorf, the creator of PHP, you will realize that PHP is a productivity tool. PHP is not a computer science exercise to make the most glorious and beautiful programming language. It is a language that makes you productive. And with that comes responsibility. With power, with great power comes great responsibility. And so they didn't worry about flexibility and syntax. If you wanted to do something, you knew what you were doing. So PHP is not a language that's trying to coddle you in any way. If you type something and it works, you are kind of responsible for that. And so there's lots of like silent errors, silent auto conversions, etc. And I'll try to call those out in the rest of this lecture so you just understand that it does things and it's purposeful. It's purposeful because it assumes that you're a moderately good programmer, and when you type, x plus y, you know what x is and you know what y is and you know why you're trying to add them together. And so it really is a much more forgiving language, but you can get yourself in trouble. If you make a mistake, you won't always catch it. And so a language like Java, which is a really good language for really large programs because it has all this rigor and enforcement, and you make the tiniest mistake and it checks 1 million lines of code and catches the 14 places that that mistake was caused. That doesn't happen in PHP. If you make a mistake, you are responsible for it. So here is basically how PHP works. PHP is designed to be embedded in a web page. And there's this special tag, and not a lot of other languages have used this > tag, which is switch into a programming language. So it's like, originally it was called server-side includes, where you would say, oh, here's some HTML, just like any old HTML, and let's run some code on the server, > PHP, so run this on the server. And so this is like a little program running, and the output of this program is what replaces this. So when the program code runs on the server while this page is being rendered, it's like, write this out, run this code, and then write whatever comes out in the web page. So what we see in the web page is the HTML plus the output of this thing. And so that's how this works. And so if you take a look at the source code to this HTML page, you will see that it just intersperses it, and you can't tell the difference between the text that came from the original HTML in this file and the PHP code. And so the output is just merged. This output is just merged into the into the HTML, and the browser, when it reads this page, didn't know what came from HTML and what came from PHP. And so there is the moment of the request response cycle where the HTML is delivered. The PHP is not delivered. The output, this code runs and it is replaced with whatever these lines are, this little bit right there, right? Okay? And so that's how this works, is it's running on the server as the page is being delivered, and then the browser gets it back. Now this is quite different than JavaScript, which is the source code of JavaScript is delivered to the browser and it runs on the browser. But in PHP, the source code runs on the server, and the output of that, it comes back to the browser. Now, I just put this in there just because people do this. I've seen people who know PHP is their only programming language do things on the command line that have nothing to do with the request response cycle. I don't recommend this. I say that Python is the right language to do data analysis and computer maintenance tasks on your computer, etc., etc. But people do it in PHP. So if you ever see it, don't be super surprised. And maintenance tasks, sometimes people will write PHP scripts to connect to the database and run a long-running thing from the command line, because you can't run a long-running process as part of a request response cycle, otherwise your web server will time out. So up next, we're going to start hitting on the basic syntax of PHP and how we do semicolons, etc. So welcome back. Now we're going to go through some of the basic syntax of PHP. So PHP has a whole bunch of keywords. A lot of these are kind of taken from C. Probably the weirdest thing when I write PHP, when I switch back and forth between PHP and other languages, is the fact that the variable names start with $signs. And you'll find this is annoying for a while, but you get used to it. The lack of a variable with a $sign can be a kind of a weird thing, because in different places, like a string that looks like this in PHP sometimes can be sort of like misinterpreted. But they all have to start with $signs, followed by underscores and letters and numbers, just like any other language. But just understand that they've got to have $signs. And it turns out that I actually like it when I get used to it, because we're increasingly mixing PHP and JavaScript. In JavaScript, you can put $signs in the variable names, but we tend to avoid that, so that then I can kind of be looking at a line of code and immediately know, like with $sign variables, oh, that's the PHP code that I'm working in, and the JavaScript code, because JavaScript is kind of similar to PHP in case matters on variable names. Like I said, there is certain situations that if you omit the $sign, sometimes it freaks out more than others. And so in this case, it doesn't freak out, and in this case, it does freak out. And it has to do with the fact that there are these predefined constants that you use this define statement to define. So y or x in this case with no $sign could be a predefined constant. A predefined constant could participate in an expression, and that ends up seeming like 0 with no error. But it's certainly not, you can't do an assignment statement to a predefined constant. And so just understand, and this is kind of a PHPism, when you forget the $sign, it may or may not blow up on you, and so you should mentally have a background thing in your mind like, oh, wait a sec, what am I doing here? Look for the $signs. Again, this is another weird thing depending on how your PHP is configured. In early versions of PHP, this syntax was allowed where this string maps to that in an array, and it actually sort of adds the double quotes here. Not all PHPs do it, because you can compile PHP in different ways. So it's just, don't omit the $sign. That's the lesson here. Don't omit the $sign. So there's a lot of things in PHP that I actually love and wish were in other languages, but not likely. All these other languages have their worlds and they love them and whatever. So string literals can be single quotes or double quotes. The backslash is used as an escape character. That's pretty typical among C-based languages. Strings can span multiple lines. You just start it, enter, 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 and then stop it. I love that. The weirdness is that double quoted strings are quite different than single quoted strings. In a language like Python or JavaScript, they tend to be the same, and we have reasons to use them. And concatenation, these are different, and PHP's own language does this. Concatenation is the dot operator, not the plus operator. Most other languages, and historically it had to do with the fact that other languages that do object orientation use the dot in object orientation notation, but PHP existed without OO, object orientation, and so it used the dot operator for concatenation. And I love the dot operator for concatenation, but no other language is ever going to adopt it, and so it's quite frustrating, even though I think it's a super elegant choice that PHP made. So, and I like the double quoted strings, but you got to be, it's like you got to be responsible when you use the quick and dirty $ substitution in double quoted strings. It's again, with great power comes great responsibility. So here's some examples of double quotes, and so the fact that we have a double quote, I mean, you know, there's an echo statement which does the printing, a new line at the end, just like most C-based languages, and Python is also like this. The new lines are rather explicit, and you got to manage the notion that we come to the end of a line and we go to the beginning of the next line. You can embed new lines in a multi-line string, so this one starts here and ends there, and there's a new line there and a new line there. You can, you know, put a new line in the middle. It's the same. And this is probably the weirdest part that people don't understand and don't get so well. And that is in double quoted strings, when there is a $, it looks for a variable with that name, and out comes the 12. So this actually substitutes and puts the 12 in here. And so that's cool. I tend to only use it for debugging. It's kind of dangerous because you got to be careful not to introduce bad HTML into your output. So that's double quoted strings. And so single quoted strings are quite different. Single quoted strings are really simple. They don't do any substitution, and the backslash doesn't work quite the same, right? So here's a single quoted string. You can have embedded new lines that have new lines in them, and that so that part works. And you can. One of the reasons I tend to use single quoted strings is so I can use a double quote as a character. That's kind of nice. You can put a single quote into a single quoted string by backslash single quote, but a lot of the other backslash characters don't expand, and that's actually kind of frustrating. If I could change one thing, I would want the new line to expand, but it doesn't. It actually prints out \n. And it doesn't do variable expansion, and that is a good feature of PHP strings, that it doesn't do variable expansion, because that can get you in some trouble. You can kind of end up in a mistake where you didn't mean for an expansion to happen. So I actually, when I'm writing code, I tend to use single quotes whenever I can, and only use double quotes when I have an intention to use double quotes. So single quotes is my preference, and then I use double quotes. And so if you look at some of my code, you'll see I'll have a single quote, blah, 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 concatenate with double quote, blah, blah, blah. And so, I mean, I use single quotes and double quotes very consciously in PHP. PHP is one of my favorite languages for comments, and that's because they just took all of the comment styles and made them work. And so there is a comment style with C++ where you say // and it's a comment to the end of the line. There is a block comment that comes really out of C, that is /* as much as you want to */. It's a multi-line comment. And then the shell style comment, which really comes from Perl, says anything after the # is a comment. And so whatever language you come from, you can use the commenting syntax of it. I definitely use this kind of comment and that kind of comment all over the place. We use this kind of comment for built-in documentation, and that's really nice. And I tend not to use the #. I just want to think of PHP like C or C++. PHP is actually getting like C++ in the later versions. So I already mentioned that echo is the way we print, but there's also this thing called print. And it has to do with the fact that shell scripts say echo and Perl said print. And so both of them work. They have subtle differences. Echo is part of the language. It's a language construct. And print is actually a function, which only takes one parameter, but with parentheses that are optional. So in all my code, I don't quite know why I chose to do this. Maybe it's because I don't like Perl, but I don't use print at all. But you know, you're going to look at code and people might want to use it. That's just my choice. I tend to use echo for everything. It's shell script and print is from Perl. Neither of them are from C. If there was something from C, I would probably prefer that one. And so up next, we're going to talk about operators and expressions and how we perform calculations in PHP. Hello Hello and welcome back. We're going to talk about expressions now in PHP and how these things work together. And so there's a lots of things in the PHP language that work like every other language. Plus, multiplication is asterisk, etc., etc. But the one thing, and I'll talk about this a bunch of times as we go through this, the one thing that I think charming, delightful, and weird about PHP is how aggressive it is with type conversion. So here we have a plus, and in some languages that might seem like concatenation. And plus is an arithmetic operator in PHP, and it looks to its left and looks to its right and says, hey, I got the string 15 and I'm going to add it to the integer 27. You know, I'll just silently convert that 15 to a number for you. Away we go. So that's 42. And so most people would look at that. In most programming languages, you know, self-respecting programming languages, that would blow up, right? But not in PHP. Because I guess you meant to do that. If you typed it, you meant to do that. So expressions are things that turn into a value, whether it's a string, a number, a floating point number, a true, false, Boolean, and you can call functions during the order of during the evaluation, etc. And they can also produce like arrays and other things. So some operators of note. We'll talk about these: the post increment and post decrement. They're subtle operators that are used in a few very specific places. String concatenation, which I love, but no other language. Equality, there's double equal sign, because assignment is equals. It's too late for that. We have too many programming languages that use double equals for the equals question, right? Equality is when you're asking a question. Is this equal to, is $X, is that equal to 14? That's a question, right? That's the true false. And $X equals 14 means put 14 into the variable $X. Identity, we'll talk about this. It's the stronger than equality. It's equal in both type and value. Equality is also an aggressively converting operator. It's saying, like, if I can convert these two things, I got a string on one side and a number on another side, I can make them equal. I will make them equal, and then give you a true false as to whether it's true. The ternary operator, most people think the ternary operator is tacky, and I agree with that, but I have to show it to you because there's a couple of places where we canonically use the ternary operator over and over and over again, and so you've got to be able to look at that code and understand it. So again, side effect operators, again, one of these things where we try to avoid them in decent code, but every once in a while they are canonically used, so I have to talk about this. The bitwise operators come from C, and they work pretty much the same as C, unless you're writing like an encryption bit or a hashing function. You tend not to need those, but they're there in case you need to write a hashing function or an encryption function. So the increment and decrement operators, there's pre-versions of these in Post where you can put either the plus plus after a variable, here, $X plus plus. What this says is retrieve it, and after it's retrieved, increment it. So it's like pull the variable out and then add one to the variable that's sitting there in memory. And again, other than in certain canonical situations like for loops, we don't write this. We just write, x equals x plus 1 instead. You say, okay, look, if I really want to add 1 to x, I will bust this out, and I will pull the variable x out in one expression, and then I'll add x equals x plus 1. There's this sort of notion in programming that you just don't show off. You're like, ooh, watch the really crazy little thing I can do to confuse you, because the reader of the program needs to be able to parse and understand what you've done. PHP really does not care the difference between this set of code and this set of code, right? 30 years ago, there might be a performance difference between this set of code and this set of code, but today I assure you there's no performance difference, and this is easy for humans to understand, so we tend to not do this. Bad. Except later when I'll tell you it's okay. So whatever, there's rules, mostly bad, most of the time bad, most of the time do this, but you're going to see code. You're going to see code, and so I got to show you the kinds of things that you're going to see code so you understand it. I don't want you like, whoa, I look in some code and like, Chuck didn't explain that, so I feel this need. Okay. Here's one of the things I love about PHP, but like I said, it'll never get to any other language because they always use the dot operator for object orientation, which whatever, we got it. So dot is concatenation, and it is not just concatenation, it is string concatenation, which means it looks to its left, looks to its right. Now these are both strings, and if those aren't strings, it turns things into strings, like floating point numbers, etc., etc. And so it's an aggressively type converting operator. So one thing I like about PHP is the operators have an opinion, and they're going to, you know, a plus operator in Python concatenating a, well, you have to convert everything, so it's deterministic. But these just aggressively do type conversion. Now, the other thing to note on here is this little space is why this space. This dot does not add a space. The dot does not add a space. So if you want a space, you've got to add it explicitly. The ternary operator. Just don't write code except in the one place that I'll show you later. Don't write code like this generally. And as a matter of fact, in PHP 7, there is the null coalescing operator, which I'm not covering here, the double question mark operator. And when I re-record this in 2 or 3 more years, then I will not even mention the ternary operator. But the problem is that we are somewhere between PHP 5 and PHP 7. And this works in both PHP 5 and 7, and I am forever torn when I write code for other people to use whether I should just like start using PHP 7. It's too early, but in a couple of years there will be time, and then we will all use PHP 7, and we will use the null coalescing operator. So go look up null coalescing, and if you decide that you want to write uniquely PHP 7 code, that's fine. For me, for now, I'm going to keep using the ternary operator and is null, etc. So okay. So this ternary operator, like I said, in the future we won't have to use it, but for now you're going to see code for decades that has this in it. So you got to think of this ternary operator as this is an expression. I'll put parentheses around it, and it's going to produce a value. Some value is going to be stuck into this variable when it's all said and done. And you can think of this as one of these two things is going to get put in, and there's a question mark that decides which is going to happen. I should probably have a bigger screen for this. Right, so think of it's like this assignment statement has these two things in flight, and then we're going to make a decision as to which one makes it. And this question mark is this bit right here. So you could think of these as it's like an assignment statement, but only one of these two things is going to make it, based on whether it's true or false. And this is a question. So you have a question followed by the question mark, followed by the value that the assignment statement is going to get if it's true or false. And it's not really an assignment statement, it's this expression on this right-hand side. So if we look at this code, what this is saying is it is going to assign large into message if www is greater than 100. And it's going to assign small into this message if it not, but that's not going to work. So it's going to end up with large. Okay. Here we're looking for an even number. If it's evenly divisible by 2, meaning has no remainder, then it's an even number or an odd number. And so 123 is odd. And this is how we check for an odd number, and I actually use modulo to check for even and odd numbers all the time. Side effect assignment. Again, these are simple contractions. We find ourselves, especially like when I'm creating SQL statements in PHP, concatenating by appending to the end of a line. And so we write code, so we start with a string, and then we like add a blank to it. And we, so the out equals hello, and then out equals out concatenated with another blank. And so this is a contraction, right? And so what happens is you can say out dot equals, and that says concatenate with myself, right? And so it's called a side effect assignment, in that this out is sort of on both the left and the right side of the assignment statement, meaning that this is out equals out concatenated with world. This is out equals out concatenated with \n. And so it's like hello world, right? And so you can do this with addition as well. This is concatenation operator. You can do it with addition operator. Again, I don't like doing this. I do this as long as I'm going to do it for sort of more than a couple of lines. And you'll see code that I've written that I'm doing like concatenate, 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 concatenate. And I don't bother using this whole thing. If I'm only going to do one line, I might not use that. But again, you're going to see it. So again, use them sparingly. Pick your moments when you're going to use these things. I mentioned that PHP has aggressive type conversion. It's at times humorous when it gets a little too aggressive in its type conversion. And so the operators in PHP and the equality operators in PHP, they're sort of like trying to get to a point where they can achieve what you've told them to do. They don't want to give up. And you can do this explicitly if you want. Other languages like Python and Java and C demand that you do this explicitly. So here we go with some fun stuff. So division forces a floating point number. Division forces a floating point number, so that's good. Python 3 forces a floating point number as well. Here's a kind of freaky thing. The string 100 plus 36.5 plus true. True turns into a 1. So this, it says, oh, I'm going to do some addition here. This turns into the number 100. It converts that to a float. So that ends up being 137.25. So there you go. Now we can use a casting operator like this and force that to be a string, but it really doesn't matter because this is going to force it to be a string anyways, and the dot is a string operator. You can also sort of cast this into a 9.9 to an int, which is going to truncate it, and so that's going to be 9 minus 1, which gives us the 8. And then, again, the string operation that we have here is converting this 100 so that it can turn it to 136.25. But if we get a string that's not a number, it's not even an error. So Sam plus 25 is 25. So this, if this doesn't convert, that's not really a traceback. That's not an error. That turns into a 0. So that's why this is 25. And the concatenation is like, oh, I got an integer over here. I'll convert that to a string. So that gives us the string Sam25. And so you kind of see how these operators, like, you told it to do it, it's going to do it. If it can find a way to do it, it would rather do what you said, even though you might be crazy. It's not making a value judgment. It's not like, whoa, that's crazy. Why'd you even do that? So this, if we compare this to Python, you know, we do these concatenations, and when in Python we have to be really explicit. So because we don't have a separate concatenation operator, so we have to convert things to string, we have to convert things to integer, and you know, so that's sort of the key difference, is that in PHP it tries to guess what you meant, and it just goes ahead and does what it is that you meant. True becomes 1, so here we're concatenating a string x, string y with the variable, the constant true, which is a Boolean variable. True becomes 1, false becomes 0, but if it's being concatenated with a string, false is nothing. Some of my most frustrating time debugging PHP is when I'm printing debugging output, and I print a variable and it's got false in it, and I can't see it because false is basically invisible. Okay? So equality versus identity. The double equal operator is a type converting operator, and it's aggressive in its type conversion. So if we look at this bit of code right here, it looks at the 123 and the string 123, and it converts that to a number before it does the equality. So this becomes true. If we see this 100 plus 23, which is a string, that's also true. Here we have false. I think the 0 becomes the Boolean, and that becomes true. And this one here is kind of crazy in that 5 is less than 6 becomes a true, which becomes a 1 in this equality. And then the string 2 minus the string 1, these get turned into integers, and that becomes a 1. And so this overall question mark becomes true. Okay, and so that is the equality operator, and it's really trying to aggressively convert its operands to figure this stuff out. And if 5 is less than 6 is triple equal true. Triple equals is equal in type and value. So it's equal with no conversion, basically. And so the 5 less than 6 is a true, and this is a true on that side. so this also evaluates to true. Okay, so identity is really important. They talk about it even in the documentation because functions sometimes return false as an indicator that something either went wrong or whatever. In the case of stirpose, which is looking for a string within another string, it returns false if it didn't find it. Sometimes this would return -1 in some languages, but it returns false. And the problem is false can be converted to 0. So you can't, to tell the difference between the string matching on the first character, which is the 0th character, and not matching at all, you have to use the triple equals operator. And so even in the documentation, it's reminding you use the triple equals operator. So for me, I always use the triple equals operator if I'm using true or false, and later we'll learn about null. These are predefined constants that can be turned into numbers so easily because true turns into 1, false turns into 0, and null turns into 0 in anything that might want to compare integers. And so that's really dangerous. And so we just use triple equals. Don't overuse triple equals, just use it when you need it. And so here's some examples of what works and what doesn't work with triple equals. So and we'll use stirpose as the example. And so we're going to look to see if the letter W, the string WO is in hello world. And so it tells us that that starts at position 6 and strings are 0 based, and so that's position 6. Where's HE? Well, that's in position 0. And here's the one that kind of drives me nuts. If you say, where is the letters ZZ in this string, that's going to return false. But look what we see. We see nothing. I have stared at lines of code like this for a long time. So always just in the back of your mind when you're doing PHP, say that echo doesn't show false. Var dump, var underscore dump, which we'll see in a bit when we get to arrays, does show false. So just know that false doesn't print. True turns into 1. False doesn't print. Okay, so here we have the problem where we need to use the triple equals. So if we say, oh, is the string, where, this is asking where is it, and this is going to be in position 0 because HE is the first character there. And we're asking, is it false? But we're using double equals. So that's going to do type conversion. It's going to see an integer on one side, and false will be turned into a 0, and it's going to become true. Yeah, it's not false, right? And so, so we're going to get the wrong answer, basically. And so this will give us the right answer because this is going to return false, and false is equal to false. And so this just says that when you're comparing with false or true, you use triple equal. And so this basically will give us 0 on this side because that's where it's founded, and not triple equals, it's not, and so it's going to be there. And then and then this is going to give us back false, and the triple equals is not going to convert that, and so that's going to make this thing be false. I mean, that's going to make this thing be true, and so it's going to give us the right answer. And here we go. You can't use print, you can't use echo, you can't use print R, which we'll use when we get to arrays. None of these things show false. Only thing does is var dump. That shows if you do a variable, you will see false. So remember that. And use, when you're really stuck debugging, use var dump as it's ugly output and it's not pretty, but you can't always find false when you need to. So up next, we're going to talk about control structures, ifs and fors, etc. Hello and welcome back to control structures. This is our last little segment of our introduction to PHP. So as I've been saying, PHP is heavily influenced by the C language. And so the logical operators are pretty much taken straight from the C language: double equals, not equals, less than, greater than, less than or equal to. Double ampersand is and, so that's and, or, and then exclamation point is not. Of course, assignments like $x equals 4, that's the assignment. So single equals assignment and double equals is the question. It's asking the question, is answer 42 without changing 42? And of course, the classic problem is only putting a single equal sign here, which turns this into an assignment statement, but not a syntax error, so avoid that. We use curly braces to indicate the beginning and end. If then else. You have to put parentheses for those of you coming from Python. The other thing from Python is or, and not are the logical operators, and we have these sort of short versions of them. And so Python just uses words for those, and that's actually something that messes me up when I'm going back and forth between C-based languages and Python. White space does not matter, like all C-inspired languages, but of course, so these two things are completely equivalent, except that your friends will not like you if you write code like this. And so we are very disciplined in our coding to put indents, and so that you can easily match things up, so you know where blocks start and stop. So all those Python indentation techniques that you learned hold you in good stead. It just doesn't cause syntax errors if you use a tab instead of a space, although you want to still be consistent in your tabs and spaces. There's a number of different coding styles for C-style languages. There is sort of the original coding style, which we call the Kernighan and Ritchie. I call it Kernighan and Ritchie for the original white and blue textbook that was written when C was introduced in the 70s. It's the language what I learned it from. It's a beautiful thin book. I like my books to be thin. And K&R is a more compact. And what they do is we put the starting brace on the same as the if, and then we put the ending brace to line up with the if, and then we put the new starting brace on top of the else, and then the ending brace ends up. And this is good for if you were typing cards, which I actually never coded C on cards. I did code Fortran on cards, but not C. And cards, or if you had a really tiny terminal, and sometimes you do. And so this is a more compact. A more expansive for younger people who think that screens are all gigantic, tends to like the idea of lining up the curly braces. I can't argue that one of these is somehow better than the other. I personally prefer this. I prefer the compact because I want to see as much concept on the screen as I can, even if my screen is large. And the other thing I don't like about this is it turns this simple else concept into 3 lines. But if you run into an organization, and in the Sakai project that I work on, we have 1 million lines of code, and some code is this way and some code is this way, and you just accept it. You should learn to read both styles, and you should learn to write both styles, and don't argue. It's perfectly okay to have a personal preference, and it's perfectly okay for that personal preference to be different than other people's personal preference. That's my personal preference. That's okay. It's fine. So a multi-way branch is like most languages, in that it basically is checking the ifs one at a time, and the moment that something becomes true, it executes that code block, and it doesn't come back and doesn't check any of those other things. It doesn't even check them. So if more than one of these is true, only the first one that's true is going to trigger. And so we construct them very carefully in the order, especially if you put more than one else if. The order matters because you don't know which order they're going to be. I mean, you know that it's not like PHP looks at all of them simultaneously. It literally sequentially checks, then it checks again, then it checks again, and so away you go. And so that's how the multi-way, and it's else if concatenated, but really else if is its own keyword basically. If you have only one statement, and statements, of course, in PHP are ended with a semicolon. If you have one statement, you can leave off the curly braces. These two things are equivalent. I wouldn't. These things are. I would probably never do this else if. Neither of these are particularly good code style. I mean, I'm just showing you because you can do it. I tend to only allow myself to use the if on the same line. If it's really short and this is short and I don't want it to go long, if I have to spread it across 2 lines, I always put curly braces on it. And so again, you're just trying to make life easy for the person who's reading your code. And 99 times out of 100, the person reading your code trying to figure out what you're doing is yourself, or maybe someone trying to help you. So we should put a lot of energy into making our code readable. In terms of looping structures, there is a top-tested while loop where it's asking a question, and it's a 0-trip loop in that it functions the first time. When it first encounters it, it really functions kind of like an if statement, and if this is false, it skips completely, which means if the statement is false, it won't execute the loop body even once. In a sec, we'll see a 1-trip loop, minimum 1 trip. So it functions as functions as an if statement. This particular loop is bad because it's an infinite loop, infinity, meaning that it's going to run forever because this is going to stay true. Fuel is greater than 1 and we're not doing anything to fuel, so we make an infinite loop, which is going to run out your battery or crash your computer or who knows what. And so that's like a badly structured loop. With a while loop, you have got to do something that has to do with your iteration variable. And so in this case, it's going to run until this, true, 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 false, and then it's going to get out and finish the loop because we are modifying the iteration variable as we are progressing through the loop. And so with a while loop, we'll also see in a bit how you use a break that gets out of the loop. So you have got to manage the exit from the loop. If you don't, it's not going to be all that smart for you. There is in PHP a one-trip loop. It's rarely used, but I'll just cover it here just so you kind of know it. I don't think I've written a one-trip loop, a do-while loop in, I'm not sure I can recall when I used one of these things. But the difference is it's got a do at the top and it's got the test at the bottom. And so it's a one-trip loop, which means it doesn't check the question that's down here at the bottom that's true or false until it has made it through the loop once. And so that's why it's a one-trip loop. So even if this is false the first time through, it has executed the loop before it even knows that it's false. Now, here we are using in this, it's going to, we are doing, again, we have to manage the iteration variable. And this is a situation where I'm using the pre-increment. And so if $count has in it a 4, well, let's make it be a 2. Let me clear this and do that again. So if the count variable has a 2 in it, it comes in and it adds 1 to count. That's what the plus plus count means. And then it takes this 3 and it participates in the less than or equal to 5, which in this case is going to be true. So it's going to go up and run the loop again. When this loop becomes, when this comes in and count is 4, and it comes in here, it adds 1 to it, and then the 5 participates in it, and so then that becomes a false, and then the loop finishes. So it just kind of comes down here. Now when we start looking at break and continue and the ways we can sort of actually continue, it turns out that it's important that we use this post increment or pre-increment in this particular thing, because if you continue, you want to make sure that the iteration variable is updated. And so there, again, I tell you not to use these things, but this is a canonical place that we tend to use these. And then this is a counted loop, and so this is a for loop. This is a weird little syntax. It's got parentheses and it's got colons, and I remember when I first saw this, it seemed super crude, but after a while you just kind of get used to it. You just have to remember that the first part before the first semicolon is what runs before the loop starts. It's like helping you construct a while loop, basically. Before the loop starts, it initializes the precondition for the loop. Then it's like a top tested, the second piece is a top tested question that is, as long as it's true, the loop is going to continue. And if it's false before the loop starts, it's a zero trip loop. And then count plus plus is the thing we do at the end of each iteration or before the beginning of the next iteration. And this, of course, is a good place where we do use the plus plus. If you said count equals count plus 1 here, they'd be like, oh boy, you apparently didn't get the memo, because we always say this. And we've said this since the 1970s when we first started using C. And so that basically is going to run this, and it's going to start count from 1, and count is going to go, and when count is 6, this is true, so it runs one more time when it's 6, but then count becomes 7, and this becomes false, and then it skips out. So that's a counted loop. And so it's pretty elegant. You just construct a counted loop. You create a variable that is your iteration variable. You initialize it in the first part. You check its ending value in the second part, and you make sure that you add 1 or subtract 1 or whatever it is that you need to do for your loop. There is a for each loop, which we'll see in the next section when we talk about arrays. That is a non-counted loop that goes through all the items of things. That's a very nice loop, but sometimes you do need a counted loop. So like most C-based languages or C-inspired languages, we have a break, and break is an executable statement that basically says when this runs, it it breaks the loop that it's in. If there's a couple of loops that are sort of a loop inside of a loop inside of a loop, and there's a break inside this, it actually only breaks out of the inner loop. It doesn't break all the way out to the outer loop, and so it's the innermost loop. In this case, I've only got one loop, so it is the only loop. If this code executes, it's like magic jump and gets out and jumps to the line afterwards. It basically says, we're done with this loop, leave. Now all the other iterations have run, and then so when it would come down and say count 5, this becomes true, so the break happens and it just does done, even though it would have run until 600, you know, if we'd have just left it to its own devices. So that's, again, people might say this is not structured programming. I hope among decent people we've stopped arguing about that. I'm sure at some coffee shop somewhere they're going to argue about whether or not this is structured programming, whatever. This is really, it gets to code that is direct and easily understood. Continue it doesn't exit the loop, it exits the current iteration of the loop. And so it says, okay, I'm not going to finish this iteration, but I'm not going to stop the loop. I'm going to go right to the next thing. And what's important is that when the continue goes up, it runs the third piece in this case. And that's why back in that while loop, if you do a continue, you have to put the increment in the while bit because you want to make sure your iteration variable moves ahead. That's why we tend to use, instead of do whiles or while do's for counted loops, we tend to use for loops for counted loops because the continue works perfectly, and and the loop continues. And so if this is basically saying if it's even, you know, divide by 2, look at the remainder, continue. So it's going to run this 10 times, but it's only going to run this 5 times on the odd ones. Count 1, 3, 5, 7, 9. So the even ones ran, they just ran the continue, so it just went up, and so it didn't print this. That didn't happen on the even iterations through the loop. And so that's a quick summary of zooming through PHP. We will next talk about arrays and other aspects of PHP. This is really just the core language. PHP arrays are very flexible and they're very, very powerful. They're sort of like Python dictionaries, but way better. They're better than Java hash maps. They're associative arrays, basically. Or associative arrays are the notion of key-value pairs, and in PHP they're completely untyped. We'll talk only a little tiny bit about untyped arrays. But associative arrays are very powerful and flexible data structures, especially in a language like PHP that sort of is an untyped language that a variable can take on any old type. So if we think about classic lists, we can make an array. This array has 2 elements. In this case, we're creating an array named stuff, and high is the first element, and there's the second element. Arrays are 0-based if you're using integer indices, and so sub1 is actually the second thing. So when we print out $stuff sub1, square bracket operators are the, you know, lookup or index or sub. I read them as sub. So stuff sub1 is actually the second item. And that's kind of like Python lists if you're familiar with Python. The thing that's like Python dictionaries, and it's the same structure. The array is the array in PHP. We'll get to classes and objects later, but key value arrays are just key value arrays, and you can actually have integer keys inside of an array and string keys and other kinds of keys and arrays all at the same time. We tend not to do that very often because it confuses us, and so we don't want to be confused. And so in this case, the little arrow, I call that maps to. So the key name maps to the value Chuck, and the key course maps to the value WA4E, and then you can look up based on the key. Stuff sub course is the way I read that. So that says go in the array stuff, look up the key with the string course, and pull that out. And so it prints out the thing that's in there as web applications for everybody. Arrays can get a little complex. These are super simple ones. And so we need to print them. And there's some very convenient ways to print arrays in PHP. The print _r, I think the R stands for recursive, I don't know, will dump out an array. And if there's arrays within arrays or other things, it prints them out nicely. And if you're doing this in HTML, you want to print out a pre-tag. So pre-tag is the tag that respects new lines. And so there's new lines at the end of each of these things. And so I tend, if I'm going to print it on a web page, print out a pre-tag, print the array, and then print a /pre so that you actually see them. Otherwise, it'll all get run together on a big long line in wrapped, which is readable but not pretty. So I won't show the pre's going forward, but just if you want to print this stuff on a web page, you want to enclose it in a pre-tag. And so again, we can print this stuff, and it's really good for debugging. We can print an array that has integer indices, so sub2 and sub9. Now, the other thing that this kind of shows is that the integer indices do not have to be dense. They do not have to be 0, 1, 2 like a Python list. You can think of them as it's really a key value array, and it has integers as can be keys, and that's it makes perfect sense. There is another way to dump stuff out that's a lot more verbose called var_dump, and I tend to do print r if I'm just looking for what I know is in the array. If I'm a little more concerned about is this an object or whatever, var_dump gives you a lot more detail. It shows you both the the key name maps to a 5-character string with the value Chuck. The key course maps to a 5-character string with the value SI664. And so the var_dump is much more detail, but it's if you know what you're looking for. var_dump also is the one thing that prints out false. One of the hardest things that bugs me, and I've wasted lots of hours in PHP, is printing out false and not seeing it. So false, and if you print it out with an echo statement or a print r, it prints nothing out. So if I'm just going to set the variable thing to false, I echo 1, that comes out. I print r false, and that is nothing. That's the problem here, right? That's the problem here, that nothing prints out. It doesn't say, oh, I'm printing a thing out and it's false. It doesn't say that. So the echo 2 comes out. But var_dump is good because var_dump is not only telling us the type, but it's also telling us the type and value. And so at some level, if I'm printing variables out, if I think they might be false, I tend to use var_dump rather than print. So you can build up an array dynamically. You don't have to put all of the stuff in the parentheses in the constructor. You can append to the end of the array, which basically is adding integer indices. So VA and then empty brackets means put it at the end. So stick hello at the end and stick world, and so we end up with 0 and 1 in that particular array. You can also build them up by key values. So you can say, here's my array, stick in subname and stick in subcourse and print it out. So you're building that out. And so it's really often more common to build these arrays up and start with an empty array and then put stuff in it, or you can use the kind of array parenthesis syntax as well. We have a lot of different ways of looping through arrays. There is sort of a determinant loop, meaning a loop that will go through all the key value pairs. And so here we start out with an array that has two items, a key name maps to Chuck and a key course maps to SI664, and that's in the array. And so the for each is the, give me an array and I'll loop through all the elements in that array. So for each stuff as part of the key, as a keyword of PHP. And then you have two iteration variables and you mark it this way. This maps to, but $k is an iteration variable and $v is an iteration variable. And it will take on the success, K will take on the successive values for the keys, and simultaneously V will take on the successive values of the V. The V will take on the successive values. And so this loop is going to print out twice, and it's going to print out key and value. Now the interesting thing is, if you're coming from Python dictionaries, the arrays stay in order, and we'll see later we can sort them, etc. And so it's deterministic that we put name in before course, and so name comes out and course comes out second. Name comes first and course comes second. Whatever order you put them in, PHP maintains that order. If you do a indexed array with a for each, the k ends up being the integer, right? The key is the integer, and it will do a for each loop and go through and give you the index position. Remember that unlike Python, you have to, Python lists have to be compacted, meaning no gaps, but you can have gaps in PHP arrays. You can build a counted loop, and this counted loop is is basically the for loop has, you know, an initial position, a check to see when to stop the loop, and then a change. And we talked about this in the previous lecture. So because arrays are zero-based, for I equals 0, I less than count of stuff, I plus plus. So that means that I is going to be 0, 1, 2, whatever, until we get past count of stuff. And count of stuff is 2, and that's why we say less than here, because we can't look at the sub 2 element. We can look at the sub 0 element and the sub 1 element, and then we just index and pull the stuff out, $i. Now this counted loop assumes that it's compact, or no gaps, right? Because that's, if we're generating, if you could in here, you could have, you know, element 2 and element 4, and this would not work. But the for each loop would work. The previous for each loop, this would work if the values were, you know, if the positions were 2 and 4. Now you wouldn't get it if you built the array this way. You know that this is going to position 1, that's going to be, I mean, 0 and 1. So this will always work. This would only work if you absolutely knew that the array was compacted and started from 0 and went up with no gaps. You can make arrays of arrays. We don't think of these as two-dimensional arrays. We think of this outer array as this outer array from here to here has 3 elements, and one has a key of paper. First element is paper, pens, and MISC, and it just maps to, and then this is a constant. So from here to here is another array, and from here to here is another array, and then from here to here is another array. And if you want to grab something out of the middle of it, you can say products sub pens. Well, you can think of this right here. That little expression is this array right here. So that is an array. And if you just printed that out, you would print that array out. Oh, Echo doesn't print it very well. Print R would be better to print that out. And then you can say sub marker, and then that goes into here. And so sub marker gets this string. And so that's what prints out as markers. Okay? So that's how arrays of arrays work. They're not really kind of two-dimensional arrays in the classic sense. And what you'll find after a while is that you have arrays that have arrays, or objects that have arrays, or arrays that have objects, and we create rather complex data structures, especially when we're doing with things like talking to web services and pulling data structures across the web. They're often pretty complex, a mix of arrays and objects. And so up next we're going to talk about array functions. So now let's talk about functions and arrays. There are a lot of functions that deal with arrays, and part of this is because PHP started out so long ago and was not an object-oriented language, and so it has to do a lot of things that are not sort of natural in the language, and object-oriented patterns are more natural, as we'll see. Object orientation is coming to PHP. I mean, it's here, but things like arrays still kind of throw back to the pre-object oriented. So you'll see a lot of array functions that have array underscore in front of them, and that's a way of namespacing them to keep them out of colliding with other things. Some of them don't have counts. Some of them don't have, like count doesn't have array underscore in front of it, and it's used for various things. So here is a series of array functions that we'll talk about. There's far more array functions that do things like merging and searching and flipping and doing whatever. Here's some that I tend to use a lot. So, so the first thing that we often need to do is check to see if a key is present in an array. And there's a couple of different ways that you can do that. So I'm going to make a little simple array, just append name and course and have a map. Array key exists is asking whether the key exists or not. And so that's asking the question, is this key in this array? And that returns us a true or a false. And in this case, it says it does exist. Now there's another way to do this called isSet. And isSet is a little stronger than just whether the key exists or not. If the key exists, isSet is true. And if the value under that key is not null, then this is true. And so we often use this in the form, or you'll see this all over the place, is a ternary operator. So this is a true or a false. IsSet name, that's going to be true, and then this is the true piece of the ternary operator, and this is the false piece of the ternary operator. So what this basically does is this echoes this string right here. which is right there. On the other hand, this adder is not in the array, so it's not in the array, and so it's going to turn this to false, which means the false part of this is what's going to echo out, and so that happens. And so this is set is a common idiom that you just have to get ready for, have to get used to. The is set ternary operator combination is used heavily throughout PHP. In the future, and the future is sort of the present, in the future there will be a more elegant way to do this. And so what I mean by future, so PHP 7 has a new operator that makes this syntax a lot more elegant. It's called the null coalescing operator, and it is the double question mark operator. And the PHP documentation does the best job of explaining this, and it really basically does the exact same thing as that little ternary operator does, except with a lot more succinct syntax. So what the null coalescing operator is, it's either checking is the key present and is the value not null. So it's really checking two things. And it just is really a way to, as they say even in here, it's syntactic sugar to make it look better. And I'll tell you what, I really like it. Now the problem is can you use it? And so PHP 7.0 has been around for a while, and I've got most of my servers upgraded to PHP 7.0. But because I write code for other people, when I'm writing code for myself, I can use PHP 7.0 because my server's 7.0. But I have not yet indulged in writing this code because I still want my code to run on various PHP 5s, and maybe who knows when. Someone can tell me when the safe time is to assume that everybody's to PHP 7, which is a good thing, and we all should get to PHP 7, but it's not there. And so this is the more elegant way to do this if you can assume PHP 7. And you won't see, other than this, you won't see in the rest of this course any PHP 7 syntax. And so here we go. We make an array, we put two things in, and we're going to do an assignment statement. We're going to use the double question mark operator, which is really kind of like it's homage to the old ternary operator. And so what we're doing is we're assigning, if this exists and is not null, this is assigned into name. And if it's not, either null or doesn't exist, then that's assigned. So it's kind of like a Python get operation. And so name comes out to be Chuck. So I echo name equals Chuck, and so that's true. And the not found, because adder is not present in my array, adder is then not found. And so this is a way more elegant than this same thing. These two things are the same, but prior to PHP 7.0, and if you are writing code that might have to run on pre-PHP 7.0s, you're going to need to do that. You're going to need to write this older code, and there's no more succinct way to do that. We saw how you can use array key exists, but that's kind of long as well. This is pretty. I mean, this is one of my favorite things about PHP 7.0, and unfortunately I can't use it yet. So, but that's okay. Okay, so there's a couple other things we can do. We've got the count, which just tells you how many items are in the array. Because so many things in PHP, a variable can have many different types. There's a series of functions that ask what type it is. So the isArray function gives you a true false if that variable $ZA is an array. And in this case, the answer is yes, it is. It's an array. And away we go. Okay, so because the PHP arrays maintain order, there is ability to sort them. The strange thing is the worst sort that PHP has is the one named sort. Because what sort by itself, and it actually changes the array, and so sort by itself changes the array in place. So if the array before the sort had this in it, it's going to sort it by the values, not the keys, sorted by the values, not the keys, and it's going to produce an array that is integer based. And so it actually wipes out the keys, but the values are now sorted, and they're given 0, 1, 2, 3. If you wanted to write a counted for loop to go through them afterwards, then this is a cool way to do it, because the counted for loop wants an array that's integer indexed and dense, compact with no gaps. But I almost never ever do that, because if I made a key value array, now if I made an integer key array, then sort's just fine, but if I'm so often I'm making key value arrays. So I don't use it. But there are thankfully other ones. And for those of you who are coming from Python, boy, it's nice to have these sort functions that just do what you want to do. Okay, and so here we have that same array. That same array, we print it out, comes out, right? Then we can do a case sort that says sort by keys, and then we print that out. Oh, isn't it pretty? Sorting by keys, pretty, pretty, pretty. And then we have a sort. I don't know why they call it a sort. I would call it v sort, to sort by values. Then we print that out, and now it's sorted by values. This is like, why are you making me in other languages do this stuff? They're associative arrays. I want to be able to sort it by values, and I want to be sorted by keys. Just let me do it. And because it stays in order, once you've sorted it, it stays in order, so life is simple, and you can sort them however you want. So that's cool as heck. A lot of what we do in these languages is processing strings and splitting strings based on spaces or other characters. I don't know the historical accident that led to this being called explode. It might be because Perl called it explode. I don't know. I can never remember Perl because I don't want to remember Perl. But the function is explode. And because PHP is not object-oriented, you got to pass both the string and the delimiter in. And this is the delimiter, so break this on spaces, and that's the string. So it just chop, 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 chop. Just breaks it into pieces and then sends us back as the return value. It sends us back an array with the pieces. So if you want the 0, 1, 2, third word, there you go. It's, $temp sub 3. So that's the third word. So another place that we see arrays in PHP is in the parsing of URL parameters when we hit in the request response cycle. So just a little example of this. Here we go with URL. So this is a big long URL. It's just a normal thing. It's part of HTML. But you can also put parameters. You put the question mark at the end of the URL, and then you have key value pairs, x equals 2, and if you have more than one, you put ampersand and a second key value pair. What happens is PHP puts this into an array, a super global array called $get. And a lot of times we do use these, PHP uses these big global arrays. It's all uppercase. It's trying to tell you that $_get is a special thing. It names it with an underscore. And so you would have to write code to parse all this stuff, but it magically parses it and puts it in the key value pairs in the array $_get. And here we see it both with var dump and with $get. And I'm putting it in a pre-tag so it looks a little nicer, so the print art comes out nicer with the variable, so we can see everything. But you can hit that URL, you play with it, and you can change these values, and you can see that these values change. And so it's a way of communicating from the end of the URL into PHP code. And the way you can kind of think about this is the request is going in and has x equals 2 on the end of it, and part of this thing where we always say parse the request, it figures out which PHP code to run, and then it actually takes these x equals 2 and it places in $get, and that happens before the script starts. And so that is something that is defined at the beginning of the script when it all starts. Okay? So we've talked through a whole bunch of features of arrays. We've talked about the functions that you have to use for arrays. How wonderful they are, the different kinds of sorting that you can do, and how the arrays work when they are part of a URL as well. So we'll find that arrays are just a really foundational data structure in PHP, and we'll keep learning more and more about how to use arrays. Hello and welcome to our lecture on functions and modularity. So why do we use functions? Well, certainly we accomplish so many things in PHP using functions because it's not, strings for example are not objects, and so we pass strings into functions all the time to do basic string manipulation. And of course, as our application gets more complex, we're going to write a lot of functions ourselves to reuse perhaps for ourselves and perhaps for other folks. I think it's a mistake in computer science to basically say that writing functions is important. I mean, it's an important skill, but it's not like you have to write them if you don't feel like it. Straight line code is fine. The key is there will come a time when you'll want to write functions. You'll just want to not repeat yourself and be like, I'm I'm doing this similar thing over and over again. I'll turn a parameter in, I'll pull this stuff out because I got to use it here and in this other file, etc. And so it's just the goal of not repeating yourself, and it greatly increases the reliability of your programs when you use it. PHP is a language. The function calls are a little harder to remember, and so I really kind of need Google all the time when I'm programming. And so, I'll say, hey, what's the string replace function? I know right now that it's str_replace, but I don't always know the order of the parameters. So Google is very good at finding you on the first click right to the kind of documentation that you need. And so you're hitting the stir replace, and there you go, and it's like, oh yeah, the search replace and then the subject. And so if you look at this particular call, this is a non-object-oriented style of a call. In an object-oriented language like with strings as objects, in a language like Python, you'd say string.replace, old, new. Here you have to pass the string in as one of the parameters. I would hope that someday in a future version of PHP they would give us the alternative of a string being an object, but who knows if that's going to happen. But there's tons of string manipulation functions. Here's just a couple. Reversing a string, repeating it and concatenating it to itself twice, sending it to uppercase, and asking how long it is. Okay, so strlen. You'll notice they often start with str, and that is the pattern of how you have global functions that really would make more sense as part of an object, but they're not. So there you go. To define your own functions, there's a keyword called function, and you give the function name, an optional list of parameters, and then a starting curly brace and an ending curly brace, and then the function is the body. And of course, it's the store and repeat pattern where as PHP runs this code, it is simply remembering this new greet thing. It's like, okay, that's what you want me to do later whenever you say greet, and then you invoke it. So it runs the code, comes back, runs it again, comes back. And so this is the invoking of a function, or calling of the function, and this is the defining. The top part is the defining of the function. And so that's the syntax. It's the word function, followed by the name of the function, optional parameters, and then a curly brace block that is the body of the function. Function names are very similar to variable names. You can't start them with a $sign, so that means letters or underscores, and then the rest of it can be letters, numbers, or underscores. You don't want to define your own function that overlaps an existing function, so be careful about that. Case does not matter, but please don't count on that. Always write your code in a way that case matches, because who knows, in some future version, things may be different. Return values, like most C-based languages, the return statement takes a value and it replaces in the expression. And so here we have this expression that's being evaluated, greeting concatenated, function greeting concatenated with this string space Glenn. And so as PHP is evaluating this, it's like, oh, I got to go call this code, so it calls the code. And this happens just return hello. And the return bit sort of replaces the function in the expression that's halfway through being evaluated. So hello gets concatenated to Glenn, and then out comes hello Glenn. We do the same thing. The hello replaces the greeting, and then it becomes hello Sally. And so the return basically within an expression replaces the function call value with the return value. And you can, this is just one line, keep it small on a slide. The return statement is an executable statement. You don't have to be it doesn't have to be the last line. It can be anywhere within. And when it executes inside of a function, it both stops function execution and determines what the residual value in the original calling expression is going to be. Arguments are simply variables they're sort of not really real variables. They're placeholders that are aliases in a sense. So in this particular bit of code, if we're going to we're going to take the language in as a parameter. Now $lang sort of doesn't exist as a variable. It is an alias in the first call to the string quote es quote, and then it runs and does the thing and it returns, in this case, hola Glenn. And then the second time it is an alias to quote fr quote. So it's not a real variable, it is an alias to that which is the first parameter in the call. And away we go. I like how PHP does optional arguments. You simply say, if this argument doesn't exist, in this case, if lang is not presented as a, if it's missing from the arguments, set it to ES. So that's the default. The ES is the default in this particular thing. And sometimes we actually have a default value. In this case, we'll just assume Spanish is our default language. Or you can say false, and then you can check to see if it's false. And so sometimes we set the default in a way to know if it's submitted in your code, and then you have an if statement to say if it's false, and then you can know what you want to do if it's if the statement wasn't if the parameter wasn't present. And if you put the parameter in, then this part here is ignored, and it just is the alias for the first parameter to the function call. Normally, in most languages, we do what's called call by value, and that is that because this variable is an alias to the call, in this case, val is a variable in the outer scope is 10, we get to see the 10. The 10 comes in, but it is that we don't remain connected to the val. So in a sense, you can see at the moment it comes to here, it actually makes a copy of its parameter, and then 10 is working here, and this becomes 20, and this becomes 20. So the return value is 20, and so dval ends up with 20 comes into dval, and then we print out 20, and so that's fine. But we notice here in this line that val is unchanged. That's the key to this. And the call by value, which is the normal way most variables are passed into functions, unless they're arrays or objects, but just a variable like 12 or a string, it's a copy. Copy as it's called, so that you can actually modify this on the left-hand side, and it's not modifying the original. That's to reduce the potential for side effects of a function. You just don't want the function to be able to do something to mess with the variables outside the function, and it's a good way to sort of draw a really solid boundary around the function and pass something in and get something back out, and not have it mess with our variables. It's like just an isolation. And so call by value is pretty typical. What's cool about PHP is they also give an option to call by reference. And so when you say call by reference, and this is sort of a throwback to C, although C doesn't use, it uses the ampersand, but not in the exact same way. You basically put an ampersand in the parameter, and you are then, as the writer of the function, notifying the outside world that you are planning on changing this first parameter. And when you want to change the first parameter, you just put it over here on the left-hand side. And so, real thing is a 10, so val comes in as a 10, but it's not only 10, but it's also $val. So now $real thing is equivalent within the function to $val. It's not an alias to the value of $val, it is equivalent to. So what happens is of course this becomes 10 because it is equivalent to $val, and then 10 times 3 is 30. 30, it goes into real thing. We have no return value, which is totally okay. But then we come back and we notice back here that val has tripled. And that's simply because we ran this assignment statement inside the function, and we said we're going to mess with that. Give us the actual variable, not a copy of the actual variable. It's important because as you're reading the PHP documentation, you might find that the sort function takes an array as a parameter, and it is telling you right here that it is planning on changing it. And so that's a clue to you when you're reading documentation that that parameter is going to be altered. And so you're going to sort this array, and it's going to rewrite that array in place. So you know that that's going to happen. Up next, we'll talk a little bit more about how the function is isolated from the rest of the code, how that function can break out of that, and other aspects of PHP modularity. So welcome back to our lecture on scope and modularity of functions. So what we mean by scope is we mean the idea of if you're inside of a function and you do something to a variable, how broadly will that affect it? And the default is you're very isolated. We call it namespacing. So you can have a variable x out in the outside world, and you can have a variable x inside of a function, and they don't affect each other. So that's the normal scope, right? So even though in this case I have the normal scope is there's kind of this isolation, and you can either pass stuff in and get it out by a return, and then sort of what happens in here is just hidden. It's like isolated. And in this case, because I've got val outside and I've got val inside, it seems as though they're a match, but they're not the same thing because they don't cross this boundary. And so if we look at this code and we take a look at it, we see that it comes in, val is 10, then it runs this code, comes in this val, which is different. You can say like this val is the val, try zap underscore val, because it's the one inside trizap. Doesn't work that way. And so we set it to 100 here, and we come back, and it's still in this outer context. So there's outer scope and inner scope. This one got set to 100, it really did. But outside, it stayed 10. And so that's normal, and that's exactly what you want, because you might have very different programmers writing this code than this code, and you don't want the choice of variable names inside that function to have any effect on the outside world, because a lot of people use the variable I for counters, or count for counters, or who knows what. And so you just don't want to do that. On the other hand, sometimes you want to very explicitly share the namespace, and you have to do this on a variable by variable basis. You can't say that all the variables in this function are shared with the outside world, but you can say that a particular one is. And the way you do that is with this global. You say global val, and so that says that this particular value, we have this little thing, it's all isolated. You have kind of the in of the parameters and the outer return, but val has this special little road to the outside world. So val is connected to the val in the global scope, and this is the global scope out here that's not inside any function. And so that just means that these two things are connected. And so we set the global val to 10 here, we run zap, comes in here, it runs this, and we set the global val to 100, and that is the same thing. And so when we come back, it's 100. And so that just means that you're sharing it. And of course, be very careful. This is really it means that your functions begin to have side effects, and it should be something that you and the outside world programmer, if you're different, need to greatly agree on. Because if you start making global $I, if you put global $I, and people start using your code, and you're changing they're in a loop outside here, and you put a loop in here, and then their loop blows up because you changed the value of I, they're not going to be very happy with you. So don't ever do that. As a matter of fact, we just want to use these things so rarely because you want to do anything but that. If you can pass it as a parameter, or you can send it back as a return value, and if you want to change it, you pass it by reference. If you really, after all those things, can't think that you think you just can't do it with anything but a global variable, I tend to write really long, ugly global variable names to sort of punish myself for even thinking about using them in the first place. But sometimes they're the way to solve it. They really are. It's not elegant, but you got this problem and you got to pass something and it's not really part of the return value, and you want to be able to peek in to see what the last error. You see things in PHP like, show me the last error. Well, that's got some global value, but somebody made it a really long thing. I tend to use all uppercase and make them long and use underscores and have them multiple words, just so that within my function I don't unintentionally hit one of your variables like $X or $line or $handle or $JSON or something like that. I never would do that. It's got to be super long. And then when I document it, I say, oh, and this touches this global variable and sets this, and if you want to look at it, you can look at it. Sometimes I pass information into functions, and sometimes I take information out of functions with global variables, but I use them very, very rarely, and when I do, I give them horribly long names. So one of the things that we do inside PHP is PHP evolves over time, and that's nice. PHP didn't have object-oriented capabilities, and then it did. Certain cool functions that people had to write over and over again eventually were added, but each of these things were added at a particular version of PHP, and so you don't know what version you're running. And often we write code that we're going to share with other people, and so we have to check sometimes what version we have, or perhaps you just have a function. And I've got a bunch of code like this. Over time you can throw it away because everyone's version catches up. But for example, array combine doesn't exist in all values of PHP. And you can call this function called function exist. That's a function. It's kind of inception because we're going all the way down. You say, hey, does this function exist? And you pass in a string, so it's not like a function reference. And it looks in all the functions and finds if it's there. If it is, it gets back a true, otherwise a false. Now usually you don't just print this echo out. Usually what you do actually is you define the function. You do nothing here, and then you actually define the function. And so it's a way for you to put in backwards compatibility code if you want to use a function that may or may not exist in the version your customers are going to be running. You can say, if it doesn't exist, define it, and then write in PHP something that does what array combine does, and then when they run it on a version of PHP that has array combine built into it, then they just start using the default one. And then, like I say, a few years later, you throw the code away because you say, I've got to use PHP 7 for everything. And there is some stuff between PHP, even in the versions of PHP 5 that were added, and then coming to PHP 7, which is a great language, but we got to be careful because not everyone is running PHP 7. So when you look at the documentation of PHP on the php.net, you will see that it tells you often what versions this particular function works in. And so this one is version greater than PHP 4.0.7, and at this point everyone's at least on PHP 5. But again, so this one you probably wouldn't want to do, but you get the idea that they're trying to communicate to you that this is not in every single version, and so that's a function there. The other thing that's interesting is PHP is sort of a moving target. We will have your desktop PHP, which will be a particular version with a particular set of plugins, and then you'll move it to a server, and then something will stop working. And you're like, well, what version am I running on this server? What functions? And it just, sometimes you have to probe the implementation of PHP or the instance of PHP that you're working with. And so they have built into PHP this function called PHP info, and literally you will commonly write this 3-line thing in a PHP file to dump out the PHP internal configuration. And it's a lot of information. And if you did my very first assignment, you've actually already looked at it, because we wanted to figure out if display errors was on or off, and we wanted to make sure display errors was on. By the way, quick little advertisement, please make sure display errors is on for all your sanity when writing PHP. And so those are just some screenshots that come out of this, and it tells about where it was compiled, what options it has. It goes into detail about what things are in it, what software is configured as part of your PHP, what's missing, what's present, all your display settings, etc., 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 etc. And so it's super useful as you're trying to say, why doesn't this thing work the way that I'm expecting it to work? And so that's, you often have to do that to figure out something. And all that output, all those tables and little gray and blue, that all comes out. That's all just coming out of that function. Literally, you write 3 lines of code and it dumps all this stuff out for the configuration. And that's because it turns out to be important from time to time for you to kind of peer into your PHP environment. So now let's talk a little bit about programming in multiple files. And it's kind of like functions, but it's also just a version of modularity. And so there's a couple of PHP statements that allow you in one PHP file to pull in the contents of another PHP file. There are 4 basic variations. There's the include and the require. The difference between include and require is include is a non-fatal error, but often your PHP will complain anyways. So sometimes you have to put this in an if statement to see if you really want it to be optional. You have to say if file exists to see if it's there and then include it. The more interesting ones are the once versions. And so usually if you're pulling something like the header of a document in, you just use the include to say I want to put it here. But if you're pulling in a library code that's just a bunch of functions or maybe some objects that are being defined, you can use the require once. And what that does is if it's above you somehow already been required, don't require it again. And so it just is a way to say that you can say, I need this set of library functions, and then later maybe in another library function says, I need this same set of library functions, and PHP will figure out if it's already been included and then not include it twice, which is a really nice feature. So let's talk a little bit about how you might use this as you're developing a website. So here is Web Applications for Everybody, my happy little website. And as you move between, and you come here and you're on this page, and then you click here and you go to this page. And it looks like this top navigation bit just doesn't change. It looks like a desktop application. And so it really does change the full request response cycle. Now I'm not talking about Ajax or in-browser stuff, but in this case the URL changed. We went from one URL to another URL. A full request response cycle happened, but we want to basically put the same stuff at the top on every page. Could be hundreds of pages literally. And so how do we do that? Well, that's what we use these requires for, or includes or requires. In this case, require wouldn't matter, require once, it doesn't really matter because we're going to demand them. So what I've built is I have built in this particular website, in the same folder as index.php, I've got a file called top.php and nav.php. So what top.php, it doesn't produce any output, it's all the CSS and JavaScript and setup, the header part and the title of the page and all that comes out. And then the nav.php issues the navigation bit, so the nav.php is all this part. And then I'm done, and I'm going to have the body of the document that comes up here. That's this body. And then I've got some stuff that's got to be at the end of every page, so I switch back into PHP, and then I require some footer. So there's an index.php, a top.php, a nav.php, a foot.php, and they're all in the same folder. And now I've separated these things out into modules. Sometimes you could make these functions, and as we increasingly move towards more object-oriented, you'll see some code that uses functions for this. But the classic way to do this is with require statements. So now here's another page, right? Here's the install.php. And so what the install.php does is it requires that same top to get the CSS and JavaScript environment right, the same nav to put out the pretty little nav bar, and then we have slightly different HTML, which is the body of it, the part that you see, and then we make sure we require the footer, which in this case, if you go down far enough, I think this one has a copyright on it, and some stuff so that there's a copyright at the bottom of every page, and there's a little bit of JavaScript that happens at the bottom of every page, and like analytics tracking and stuff like that. So you see this pattern where now you just keep replacing this middle part, and that's really the content of the website. This middle part gets replaced over and over and over as you move from one page to another. And so that's one of the ways that we do these pages that have to have repeating elements on them over and over. And so that's a quick run through functions in PHP, how we make new functions, the different forms of passing like default values, and also including and requiring files, as well as scoping and dealing with the fact that PHP is changing, how to figure out what's in your PHP, what version you're running using PHP info, and then using function exists to sort of patch your PHP if certain things are not present in the version of PHP that you're using. Hope you found this useful. Cheers. So now we're going to talk about form processing in PHP. PHP's goal is not just as a programming language, but it's a programming language to implement web applications. And so it takes some effort, puts effort into dealing with things like forms in HTML as easy as possible. And the way it does this is these super global variables. It takes things like parameters on the URL and post data and puts them in what are called super globals. And the reason they call them super globals, and they give them a name like $_get, is that even inside of functions these are present. You do not have to use the global keyword to get at them, and so they're sort of decided from the outside in that's global. You can make a global variable in a function if you want, as we've talked about, but these super globals are sort of automatically made global. And so we talked about this in the last section where we took a look at the get data, you put a parameter on end of a URL, and that is copied nicely into the key value pairs in the $_get. And we can use something like printr and var dump. Of course, we enclose them in pre-tags to take a look at what's in this. So if you look at how this works on the request response cycle, you click with the URL, it goes in, the get with x = 2 shows up, that goes into the web server, which parses the request and pulls these values off as key value pairs. And there's actually lots of rules for what these things are formatted. X = 2 is just the simplest of them. And then the super global array $get is produced, and it is created before the first line of your code starts. And then, of course, we are doing the printout, and it comes back, and we see that. And so that's just part of the infrastructure that's provided to us by PHP. Now, the web would be kind of boring if we always just had to put these parameters on. So there are many ways to send this kind of parameter data into a web script running on the server. And one of them is a form. And so form is an HTML tag, starts with form and ends with /form. And effectively there's this input tag which creates open little boxes. So you basically say, oh, put a place for the user to type something, an input area of text and the name, and the name will end up being part of the key value pairs that are submitted. And ID is actually part of the CSS, which says that if I want to access this form, I'm going to use the ID of guest. So name, this part is for the server, and this part here is for CSS. Now, one of the things that you do is you put these labels in. The label is just a tag to say that this information is the label for that, and that's useful for screen readers and other things. So a text field opens up a little box here, and the submit field says send the data to the server, which is kind of like an href and an anchor tag. It's like clicking on the text, the anchor tag, so it causes a request response cycle to go in to the browser, to the server, from the browser to the server. So when the form is we go first to this web page and we take a look at the information. We kind of, come back. We take a look at the information. It comes down, it paints the form, and it paints this, and then we move our cursor in and we type 12, and then we press the submit button, and then that submits back to that same URL, except now it adds the parameter guess equals 12, and that guess came from this parameter, and the 12 came from what we typed in. And so that's how, using a GET request, data is moved from a form into the server. Now, form1.php runs on the server, and PHP parses it and puts it in $get, and all that other stuff. It's just a way to get the parameters off of the screen rather than teaching the user to type stuff up in here. Okay? So, this is that code that we're doing. We can see what the get array is, and the get array is this global array. This is kind of review because we've already seen this in the previous lecture, but we'll just print it out. And the field that starts here ends up on there. The name is guess, and then it is parsed and put into the $get. And this name guess ends up as part of the $get array, and the value, whatever the 12 is, that you put in here ends up here. And so that's how you take a user input area and get it into your program via a GET request. So up next we're going to talk about the other way that we send data in from other than a GET request, and that is the POST request. So we've talked about how we can use the GET with forms, and now we're going to talk about how we send POST data to the form. And it works pretty much the same way. We make a form out here, and then we tell it to send the data via POST rather than via GET. It's kind of like send it in a different envelope. And so we send it via POST, and the data that comes in via POST ends up, like the $get, in a variable called $post. Now we'll talk in a bit kind of the technical differences. But from an HTML perspective, it's super trivial. All you have to do if you want to send the data via POST rather than GET is say method equals POST on the form. It's going to do the exact same thing as it would with the GET. Now, one of the things that you'll notice right away is there is no guess equals 12 question mark. And that's because the data is no longer being transmitted on the URL. And it comes in because we've asked it to come in the POST variable, so it shows up just the same as key value pair, and the key is based on the name variable, the name attribute on the input tag, and the GET is empty, right? So the GET's empty because we didn't use a GET and we didn't put anything on there. You can actually have both GET parameters and POST data, but in this case I didn't put anything on the URL, and the browser didn't put anything on the URL because I said, please transport this data using POST, not GET. Now, it turns out that POST is generally more common and so you don't see too often the URL getting ugly with lots of stuff at the end, but there will be times when you do it. And so there are just two ways to send it. On the GET, it sends it on the end of the URL, and it sends a normal GET request, just like we've been looking at so far. What happens with the POST is it actually makes the connection, the HTTP connection, and then adds the data on that connection, and that's why it doesn't show up as part of the URL. And it allows the POST, because it's part of the connection, not part of the URL, you can send a lot more data in POST, and that's why we tend to prefer it. So if you think about how the GET works, the browser sends a GET, and it actually just adds the parameters to the end of the URL that it asks for, And there's some headers of information that it sends, but that's the GET request. Whereas if you tell the browser to do a post, it sends the command post as part of the HTTP request, no parameters here, and then some header information, and then a blank line, and then key value pairs here. And there's a lot of complexity about how this actually works. They're URL encoded and MIME encoded and all these kinds of things, form encoded, right there, form URL encoded. But for the simple one, in the case it's just a key and a simple value, it's key value, and then the ampersand would be here, and there's all kinds of encoding that happens. But the difference is that the reason you don't see it on the URL, you see it on the URL in GET, and you don't see it on the URL in POST, because it just sends it as part of this overall connection, and that closes the connection, and then the code of form3.php starts to run. And so it's just, that's the mechanics of how it gets transferred to the server, right? The mechanics are, it goes in, it is, instead of being on the URL, it comes as sort of an extra bit on the end, it parses it and puts in the post request, and then our code starts up in the server and runs. So this is a pretty complex summary of the rules of when you would use GET and when you would use POST. The key thing is that if you're modifying data, you should never use a GET. And it has to do with the fact that search engines will follow GET URLs, but they won't follow POST URLs. So if you're deleting something or inserting something or say adding a comment to a blog post or something, that should be a POST request, never a GET request. The only time that you would actually do a form of the GET request is kind of like a search field or a lookup field, because they're supposed to be what are called idempotent, which means if you hit them twice, they're supposed to roughly contain the same material. So if you have a, part number equals 1, 2, 3, 4, and you hit that URL, it should give you part 1, 2, 3, 4's page. And if you hit it again, it should still give you part 1, 2, 3, 4's page. It might give you a slightly different, like inventory level or something, but the idea of idempotent is you're not supposed to get different information when going to the same URL. The other thing is there is a limit about how much data you can send on GET. Each browser does it differently, and it changes over time. So there's not a number. It's bigger than you probably need ever for normal things. It just means if stuff gets above a certain size, like if you're like typing a paragraph, you almost always should send it as a post. If you're typing a part number or something. And so given that you're probably typing a paragraph, you're probably sending that data in to modify something. So rule number 1 of if something's being created or modified, always use POST. So up next, we're going to talk about a number of different form input types beyond just this text and the submit button. Okay, so let's just run through some of the form input types beyond just input type equals text and input type equals submit. So text is the basic one that just opens up a little box. Password is gives you a box that hides the characters as you type, but it doesn't encrypt it going to the server. It just hides it from people looking over your shoulder. Radio buttons, text boxes, selects and drop downs, and then text area. So we'll take a look at these. So you can find out all kinds of things on these forms, form fields online, but we'll just kind of hit some of them. So the basic text field, here's a text field, the name, the ID. You can tell it like size to tell it how wide it is. Often you do this in maybe CSS. But the type equals password simply allows you to type text, but doesn't. It's for over your shoulder, but it does not encrypt this. So I typed 1, 2, 3, 4. Right? So the name of this is password, so it comes down here. But the 1, 2, 3, 4 comes in plain text. There's no security between you and the server, unless, of course, you're sending it over HTTPS, but there's no magic. It just means that it shows asterisks while you're typing. And so let's see, this is just another input type equals text, name equals Nick, away you go, okay? And so password versus text is really identical, except that it shields what you're seeing on the screen. A radio button is quite interesting and useful in a lot of situations where you want to choose one and only one of 2 or more options. And it's like something that you're looking at on your car and you're picking which preset station, and you hit 1 and it turns it, switches. So only one of the stations, you might have 5 presets on your radio and only one can be active at a time. And so the way it works is, of course you have a form tag outside of all this, but is what you do is if you make a type equals radio and then you use the same name. And you can actually scatter these all over the place, and it's a little bit weird. But basically what happens is that you pick one of these, you press the little dot button, and then the other one goes away. And so what happens is no matter where these are in the field, if they all have the same name, only one of them can be checked. Now you can say checked here in the HTML to say which is the default when the screen is painted. And then what happens is you put a different value, value equals AM or PM, and then what happens is whichever one is checked, and in this case it is this checked, you get the value based on the name of the form field, and the key, that's the key, is the name of the form field, and the value is whichever one was checked. And so you just put in whatever. You pick these strings, and then you look and you say, oh, it was the second one that was checked, or whatever. So that's how you figure that out. It's a pretty good user interface, really, when you want to choose from a set of 2 or more options with only one allowed to be selected, and the browser does that. But you got to keep the name consistent, or it's going to be weird. You can kind of make some really crazy looking forms. The browser will look no matter where they're at. They don't have to be next to each other. They don't have to be physically close to each other. They just have to have the same name value. And so now a checkbox is a situation where you have a series of things that can be all turned on or off, right? And so let's change the color. And so here we have a checkbox. Any of these, any combination can be on or off. Type equals checkbox. We give them each a different name because you can check any combination of these things. And again, you can indicate which one is defaulted, including any combination. You don't have to have any of them checked if you don't want. You can have all of them checked, any combination, because they are independently checkable. And so you can give a value, right? And you give a different name, right? And so in this case, if you check class 1, if you check this one, it does this, and class 1 will be SI502 based on the value. And if you don't have a value and click it as in class 3, you will get the string on. The default value equals on. And so it sends that in. And so you can tell in your code, did the class 1 checkbox get checked? Yes or no? And you can put those values in, or you can just leave the value off, and then it will say, oh, I tend to just say if it's set, it is set in the array, then that means that class 3 was checked. And again, just like radio boxes, good style says they should be close to each other, but the browser really doesn't care about that. Whatever it is that you're doing that's crazy, you can put those things together any way that you want. A drop-down is also a nice, used all the time in lots of situations. So it's a select tag. You give it the name on the tag. This ID, of course, is just part of CSS that hooks back to there. And then you have a series of options. You have option value equals value, value, value. And really what you're doing is you're going to press this drop down, and then you're going to pick one of these things, whatever it is. And then if that's picked and you hit submit, then that chooses, in this case, what goes in for soda. In this case, I didn't change anything, and so soda is 0 because that was what was there. Okay? And you get to pick this name. You get to pick all these values. You obviously want to make them different, or unless you want that. And so you just get back whichever value it is as they select the selector box. You can pick a default that's different than the first one if you like, right? And so in this case, we picked a default that was the selected one. Now you can only have selected on one of the tags, and in this case it just starts out from the browser. It comes back selected. With Peanuts is the pre-selected one. You could move it. You don't. It just starts there. And this would be a situation, perhaps that was the previous value if you're changing on update screen or whatever. And you can sort of see how snack equals peanuts. Snack equals peanuts is what is sent in the server on a drop-down or option select box. Text area is the kind of thing where you're going to type some text. There are JavaScript plugins that turn into this in bold and turn the stuff into editors. But underneath it all, what you're really doing is you're building a text area. So the text area is a little bit different because it doesn't have a value equals. So most of these other things have a value equals in the tag itself. The text area is for long blocks of text. And so sort of like start of text area, text, and then end of text area. And I get some rows and some columns to give it some width to make it the right size, and then I give it a name. And so then when it submits all this, it takes the whole thing, and it can be quite a bit of stuff, right? With new lines and all kinds of stuff in here, and then it bundles all that up and sends it in to you in one key, the about key, in the array, the post array that comes in. And so that's how the text area works. And the default data that comes up is what you put in. And you don't have to put this in if you don't want. And then this thing will be completely blank and you fill it in. Or you can have default data or something like that. The multiple select is kind of tacky. Most people don't use it because it's really bad user experience, and it's actually hard because it's something that is sometimes inconsistent on different sort of versions of the server. You can kind of Google for passing form values, an array of form values in through PHP, and be like, oh, make sure your setting is this, that, and the other thing. But the basic idea is that if it were easy and it were a good idea, this is how it works. So given that it's not easy and it's not a good idea, just don't do it. But I'll just tell you how it works anyways. So you're basically saying we're going to pass an array of values in, and so now you have a thing. All these can be checked. It's a multiple select. You're saying it's a multi-select right there. Don't do it, but there it is. It's a multi-select. And any of these can be sent, and so what will happen is you will get in the code, you will get not just a value but an array of values, and then CSS and HTML were the ones that were selected. In this case it would have been CSS and HTML were selected, and you have to kind of control click as you move around, and so it's just a bad user experience all around. So let's get off this slide because it's not a good one anyways, right? And then of course the submit button. Now some things about the submit button are, so we talked about the submit, but you can also put a name equals if you're going to have more than one submit button, so that's cool. And you can put a value equals. Now this value equals is a little weird on the submit button because it also gives the button some text. I could have called this, XYZ, and XYZ would have shown up here. And so you can tell it, but then what happens is this value is also part of the submitted post data, and so you get in the key value, you get that particular data. And so this way, if you had a couple of different buttons, you would have different values for them, and then you could have, submit, add, delete, does whatever, and you could have different buttons, and you could detect in the same form one of multiple buttons by looking at the name. Now what I tend to do is I tend to name each of my buttons differently, so I just check to see if it exists, but because the text is not something the user controls, it just happens to be the value. It's a little inelegant. Now another thing you can do when you want to put more than one button here, right? You want to put more than one button. We got a button, put another button. You can also, if you want, this is just a little trick, turn a button into effectively an href by using a bit of JavaScript. We're not doing JavaScript yet, but this is like a baby JavaScript. This is basically saying on click, when this button is clicked, you say location href equals, and then in single quotes a URL, and then say return false, and then that turns this into functioning kind of like an anchor tag. It doesn't actually submit the form. This return false is what makes it so it doesn't really submit the form, but that is a quick way to leave a page with a nicely styled button rather than an anchor tag. Some people just put an anchor tag here that looks kind of ugly, and we'll play with that going forward, and we'll use that in how to write maybe a cancel button or something like that. Okay, so HTML5 is now pretty much the standard, and there's a whole bunch of new input types that HTML5 creates, and they're pretty cool. We won't go into them in great detail. Feel free to go research these on your own. What happens is that there's just these types, and older browsers do not actually freak out by these types because they're actually variations on the text area, right? I mean, not input type equals text. If the browser looks, if historical browsers look at a form and see an input type they don't understand, they just treat it like text. But if it's an HTML5 browser, it sees these others and away it goes. And so if we take a look at this, we have a type equals color, and that brings up a color picker. Each of these is different in every browser. and you can see that it sends a hex color, right? So that is, just like in CSS, that's a hex color. You can make a date picker, and it creates a date picker in the style of the browser, and then it sends you a text string. So all these things turn into text strings eventually. So type equals date turns into a text string. Type equals email. This is a field that has some default validation in it, meaning that if you don't type a valid email, it won't let you submit. It'll give you a little error message, and it will stop you from submitting. It won't send it to the server and let you check it on the server. It'll actually demand it before it actually submits the button. So you hit submit, and it'll complain, unhappy, I don't like that, fix it before you submit it. So that's in-browser validation, okay? You can say type equals number, and then if you give it a range of numbers, you actually get this little thing. You can also type a number in there. And again, if you type 99 in here or something and you hit submit, it'll give you an in-browser validation error and tell you that the data is wrong. Similarly, a URL is like a text field, except that the browser will demand a legitimate, valid HTTPS colon, or whatever. And just to sort of emphasize how the HTML forms fall back to text forms, I made a type of flying with a name equals saucer, and that doesn't care. It treats it just like a text field where saucer and yes get passed to you. So it's not like it freaks out and blows up. And that's what actually happens for all these things in browsers that don't implement HTML5. So up next, we're going to talk about data and validation and film forms back in, etc., etc. So more advanced stuff on HTML forms. So now we're going to talk about some more advanced topics about data security, HTML entities, how to keep people from sending you bad data in forms, etc., etc. The first thing let's talk about is persisting form data. Now, persisting form data is something that we sort of just expect, and we expect that it would be magic, especially when the forms try to fill things in automatically from your credit card to your address and stuff like that. I'm not talking about that. I'm talking about just a basic form field that gets persisted. And so let's just say you're running this thing, it's a guessing game, and you put 20 in and you hit the submit button. When it comes back, normally, well, in this form 3 code, it's blank again. And that's because the browser doesn't remember the old post data and stick it back in. That is all done in the application. So it's important that you have to write code. So if you are seeing a thing where you put in 20, you put in 20, you press submit, and you come back to a page and the 20 is still there, like your guess is too low, that took some effort on the part of the application to restore the old data back into that form field. But it's not that hard to do. And so what we're going to do is, this is the code to do that restoring, and here's how it works. So as the script starts, we're going to create a variable called old guess, and we're going to ask if post sub guess is set, then we're going to make old guess be the old guess, the old data post data, or we're going to put a blank in there. So old guess is either going to be, if we're responding to a post request that has that data in it, it's going to be that old data, otherwise it's just going to be a blank. And the rest of this is all the same. It's just a form, label, name equals guess, and then we add to this a value equals quote, this is HTML, and then we drop into PHP and say, oh, insert the variable old guess right here in the output. Now, I'm using a thing called a PHP contraction that basically is, instead of saying less than $PHP echo $ old guess, which I could say, and then question mark, that would be, if I put that in double quotes, that would just pull that value right in there and put it back in there, and in the HTML it would come out. We do this one thing so often that there is this contraction, this less than equal, which is exactly the same. These two things are the same. And so this is a contraction to pull out, stick between this quote and this quote, go into PHP and pull out the value of old guess string and stick it right there. And so that's how the old guess shows up in there, and the 20 is then persistent, right? That's how this 20 shows back up. Oops, go back up. That's how this 20 shows back up, is it was put in there in the value equals by the PHP itself. And so the PHP looked, said there's old data, I will re-echo that old data. So that seems simple enough, except the technique I just used is very dangerous. And it has to do with the fact that if we are echoing on our page data that the user typed, that includes characters that have meaning to HTML, like double quote, less than, etc., etc., etc. And so if I basically enter into this form, form 4, I enter a double quote and then some HTML, if I come back, it's going to be crazy, and that this will have taken over my HTML. It kind of escapes from the text area. And let's take a look at how that happens, right? What happens is if you're just echoing the data that the user sent you, you know, here's the quote, and this is the exact user the data sent you, right? And so that's what they put in. They typed in double quote, less than, b, die, etc. And so what happens here is this part here came from the variable because it came from the user, and all this other stuff came from the template. But when the browser sees it, it's not how it looks at it. The browser looks at it as, oh, this is the end of the value. There's a blank value. It just sees this as the input tag, and then it sees this as more HTML, and away you go. And then that's a syntax error, but it doesn't matter. And that's sort of how this thing takes over, and you end up with bold, and this turns into text, and you can see that there. If I had worked a little harder, I could have actually hidden that as well. Now, what people are not usually intending to do here, people don't just want to put the word die in bold. What they want to do is put in some JavaScript to steal cookies or something like that. And so you got to be careful to never display user-entered content without what's called escaping it. And so this is probably the biggest weakness in any web application, is not properly escaping data that's coming back from the application that originally came from the users. Luckily, in PHP, there's a real easy way to do this. So there's a function called HTML entities that in effect encodes the old guess, and it does things like turns double quotes, a double quote becomes ampersand QUOT semicolon, right? And so by turning these dangerous less thans and greater thans into their HTML entity versions, which is the ampersand version of it, as we talked about in the HTML lecture, then it works out okay. Okay, and so if you do the same thing, and you do the same thing with form 5, it creates this in a way that the value equals double quote. Well, this is what ends up being printed out because of HTML entities. That's a double quote, and yes, there was a double quote in what was typed, but this comes back out as ampersand quote greater than, less than, ampersand greater than, die less than, greater than, slash b. And so what happens is this comes back exactly the way the user types it. That's coming back. Now I happen not to have, it kind of blew up here. That's sad, because I didn't do HTML entities in my pre-tag that I was dumping my data out of my debug print. And so I still have a security hole in my debug print, which is actually something you should worry about, as you got HTML entity stuff that's even in debug print. But basically by calling HTML entities, we get this version of the string, which basically maps any dangerous character into the entity version of that character. And so you'll never see a double quote or a less than or a greater than. And HTML entity is just built into PHP. You call it as a function, and you will see us do this over and over and over again from now on to the rest of the class. Less than question mark equal HTML entities variable name. End of story. Done. Okay, so now that's called HTML injection. HTML injection, and go ahead and Google that. How to avoid HTML injection in PHP, and they'll say entities. So that's one of the issues of how not to sort of put a security vulnerability into your program by echoing raw data from the user. Now you also want to, before you process the data, you want to actually take a look at it and make sure it's passing a few sanity checks before you're allowing it to run. Things like let's make sure that this particular post value is non-empty. It has a non-zero string length, or it is all numbers, meaning it's not the word Fred, or it's an email address. Let's check to see if it's got an @ sign in it, etc. And so there's sort of this pattern of, before you handle and process your post data, which we're going to start doing, and like stick it in a database, you want to run some data validation on it to do some basic sanity checking to make sense of it. And so this is part of the guessing game, right? The guessing game that you got to write, and it's going to do all of this sanity checking, meaning if you give it a number, it actually checks the guess, but you want to do some checking to make sure that it's okay. And so here's just a little bit of sanity checking we're not doing post data, we're doing get data here, but you kind of come in here, and we're going to do some checking. First, we're going to do an is set. If it's not there, then we're going to say missing guess parameter. So you want to tend to write this in an order where you catch the thing that's the worst problem. So if you don't even have a get parameter, why are you going to check for its length, right? And so then I'm using a series of else ifs, right? And so if it's not set, print this out. If it is set and it's too short, we put out a short message. Else if it's not numeric, then we're going to say your guess is not a number. And at this point, we got good data. So kind of from here on, we've got good data. If the guess is less than 42, it's too low. If the guess is greater than 42, it's too high. And if you make it all the way through all these, like this gauntlet of error checking, and you get the right number, it says you're right. Now, so one thing, and so that's basic before you do the work. And so before you do the work, you do the sanity checking, and then you can say your data is safe. Now, the interesting thing here is, this is just sort of a PHP thing. Less than is doing a numeric this is get sub guess is a string, and 42 is a number, and so PHP is automatically converting that to a number for you. And so that's a benefit, that you don't have to like convert it to a number. If it's less than, it's just going to convert it in a way that can do a comparison, and that works quite nicely in PHP. And it's rather succinct, but you sort of have to remember, I meant to do that, right? You got to be careful that if you didn't mean to do that, that you don't do that. So what we'll talk about next is some conventions for processing this post data and how we structure our whole script called Model View Controller to process the data in the same pattern each time. Okay, so now we'll talk about a concept called Model View Controller, but what we're really talking about is a pattern. There are many ways that you can structure your PHP applications, and sometimes you use a framework like Symfony or Laravel, and they prescribe a very precise structure for your PHP code. Or you just go wild and just write PHP code however it comes to your mind. And so this is that little guessing game, and you know, it just starts with HTML. This is this is PHP, like the old Wild West and woolly PHP. You know, the first line is title, does some stuff, and then it drops into PHP and does some printing, and then it ends with a paragraph, and then it's done. And so, you know, you're sort of dropping in and out HTML and in and out HTML. You're doing some computation, you're doing some whatever. You just kind of put it together the way you want. And if you are doing mostly static work, like just HTML mostly with a few little things that you were sticking in, it's okay, because PHP is like a templating language with little tiny bits of code in the middle of it. That's not all bad, right? But as your application gets more complicated, you end up doing quite a bit of work handling this incoming data. It's not just a guessing game. If everything was as simple as a guessing game, this would be a fine coding style. And so that's where this notion of Model View Controller and the discipline of thinking carefully about where you do what inside your PHP scripts. And like I said, you might be using a framework. You might be using a framework to do some of this, which will give you some really clear structure about when you can do computation, when you're supposed to talk to the database, and when you're actually generating the output. So I have a pattern that I use, and it is a highly simplified version of Model View Controller. And you may or may not like my pattern. I'm going to use it for the rest of this class, but at some point you will run into some other pattern. But for now, it's a really nice way to do a simple model view controller without doing it in a bunch of files. One of the things I don't like about the other approaches is they tend to put little pieces of the model view controller in many different files. And I think for beginning programmers, that makes it a little complex. But so this is how I do it. This is how I organize it. And I write a lot of code this way because I like simplicity and ease of understanding and ease of use. But I also like discipline at the same time. But if you choose to use a framework like Laravel or Symfony or Cake or whatever, no problem. It's fine with me. And all the skills that you're learning here apply equally. It's just where you put the code is a little different in those frameworks. So I think I made it clear. These are they're not rules. They're the rules I'll follow, but they're suggestions. And the way it basically works is if you're writing a script that's going to handle incoming post data, you have the page output, and the page output is the template is at the bottom. So this is like a template. And at the top, you handle the incoming data. So you handle the incoming data at the top, and then you print the output at the bottom. And the key is that you produce no output here at the top. You know, you handle the data, you produce no output. You start as the first line of the file as $PHP because you do your coding at the top, and then you do your templating at the bottom. And so you tend to have as little code down here, as little code down in the bottom as you can, and you really just have markup and you put variables in. Sometimes you sneak a for loop in or something like that, but you tend to put the bulk of the code that's handling any incoming data above where you even start the first line of code. And this is a pattern of the model view controller. And so the idea of the model view controller is that you separate out the different aspects of the request response cycle from the time that the user clicks their button, right? So, you know, the user clicks a button and the controller is in charge of all this. The controller is like the orchestrator. The model is the data storage, so the controller sends all the data back to the database. And then there is a new user interface. The view is what you see, and that goes back to the user. So it's sort of controller, model view, controller, model view, controller, model view. The controller is like the orchestrator of this. The view is the output. The model handles the data, and the controller routes it. And you'll see what will happen is the controller will also sometimes say, we've handled everything in this script, we're going to send you to another script. And that's what routing is the movement from one script or one page to the other is also part of controller. So it's orchestration and routing. And this will all make more sense as our examples get more complex. This is just getting started so that you'll begin to understand some of the terminology that I can use when I'm showing you some of them with more complex. And so the way it works is the top part is the silent part that handles the incoming data, and the bottom part is the part that produces the output. Now, some of the output comes from the processing, and so there is a bit of data that is passed between the model and the controller. And the way I think of it is I always like to be able to draw sort of a line. And below this line is when I start output, and above this line is when I do the majority of my processing. But I have to pass some information from the above the line bit to the bottom bit. And so in this case, I'm building a guessing game, and it's going to pass this variable old guess and message down across this line, and then I will pull that data out in here. Okay? And so the thing that is passed, there's a chunk of data that is created at the point of view of doing processing, and that's passed through, and we call that, oops, got to push the button, call that the context, okay? And you'll hear this in other frameworks. They talk about the context that the controller passes to the view, et cetera, et cetera, et cetera. And so this top part is the model, handles the incoming data, prepares the context, and the view renders the output using the context as its input. And so another of the simple rules is above this mysterious magical line, you're not supposed to produce any HTML. Right? No HTML. And below the line, you can have little bits of code, like I've got this if statement, that's not a terrible thing, but certainly no database activity. So all the database happens up here, all the SQL happens up there, and then it's just sort of simple rendering with, you know, maybe a loop or an if, but not something that actually talks to the database. And that's how I implement model view controller. So if we look at the top part of this, the model part of this, remember that the goal of the model is to do no output, but pass down a context. And so the thing that this guessing game is going to need is what the previous guess was, so it can put it back in the little form field, and a message as to whether or not the post data was high, low, or bad, right? And so one thing you'll see in all my model view controllers is there's sort of a big if statement, and I'm saying, is there any post data? And part of that is because the first time this script runs, it's a GET request, and so it just produces the output. So in effect, on a GET request does this and skips everything else. And then once you submit the data with the POST request, then it comes back in, and the data is here, and then this is for the POST request. So this is the GET request. The GET request sort of skips this, and the POST request does it. Actually, the GET request does these two lines. And so the GET request says the old guess is blank and the message is false. And so that's the context. If it's a GET request, the context is simply old guess and message. Now, if there is some post data, we're going to just add 0. I'm not going to do I didn't put a bunch of validation in here. I'm just adding 0 to it to turn it into a number, although I kind of don't need even to do that. If old guess is 42, it's graded great. The message is great job. In the previous example, I was putting echo statements in here. So now, in this model view controller, you're not allowed to use echo statements. So we have to pass the message down. And so the message is either going to be great job, too low, or too high. And that's going to be passed down into the template. So these two variables, whether it's a GET request or a POST request, these two variables, old guess and message, are the context that's being passed between the model and the view. And now if we take a look now at the view, and so the view is really the start of the HTML, so it has the HTML tag, we could put a doc type in there as well, the head, blah, 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 body, blah, 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 blah. And then, we might put a little bit of logic here to just put this paragraph out, checking to see if that message was false or not, because if there was no message, we don't want to print it out. And so this is okay in the view part. It's really just checking something and continually issuing output. That's no big deal. And then we also have in here the printout of the old in between the values, right? I think there might need to be a double quote there. I should fix that. And so that's the thing. And so you can see the context comes in here and the context comes in there. And so this from here to here is really almost all HTML with a few little dynamic bits that are set from the context. Okay, and so that's the code there. This is the top part, passes down the old guess and message. When you pass it, and you see that it will show you the old value when it's done. So we've talked about GET requests and POST requests. We've talked about HTML entities, data validation. We talked about the various form fields, the new fields in HTML5. And we talked a little bit about model view controller. Model view controller will make sense as we do increasingly sophisticated amounts of work in that top part, that is the silent kind of processing for each of the scripts that we do.
Hello and welcome to Web Applications for Everybody. Today we're playing with a bit of the code, sample code from the course, doing some of the form code. So let's take a look at the forms. Form1.php. The idea of a form tag in HTML is to describe some input that allows the user to type in or interact with and then submit data back to the screen. So you have to think that at least the way this works is it comes through with a GET request and prints this out, and then when we hit this submit button, it goes to a new request response cycle. So there's the source, and let's go into developer console so you can watch what's going on. Take a look at the network. Okay, so when I hit enter and do the original GET request, so there's the GET request, or forms.php, form1.php, and it just runs this code, and there's no PHP in here, but it's HTML, and so it just prints that out. And then basically the form describes a bit of text area that says, oh, we're going to put an input area, type equals text, and then this name equals guest tells the browser how to submit this data that we're going to enter to the server, and ID equals guest the fact that I use the same one doesn't matter. I'm using the ID, has to do with marking this label, has to do with semantically marking up your code for accessibility. And that is that we can look, when we're visually looking at this, we can know that, oh yeah, this seems to be associated with that. But for a screen reader, they want a more accurate and clear association. So this ID, that's really just for CSS. Name equals guest, name equals on input tags are the things that are sent to the server. So input type equals submit shows a submit button, and type equals text gives us a little spot. So if we say 12 and then we press submit, it is going to do another request response cycle, right, and going to run this code again, except at this time it's going to add this parameter question mark guess equals 12, and so that's how that works. And now inside of our PHP code, we are going to want to be able to take a look at that. And PHP has some magical variables that are super global called $_get. And what $_get does, let's take a look at form2.php. Well, I'll just leave the guess equals 12 on. What $get does is $get takes and PHP parses these key value pairs and the query string after the question mark, and then gives us things in here. And if I put like $x equals 42, then it would give me guess equals 12 and x equals 42. And so then this allows us inside of our PHP code to sort of detect the time when it's coming in with just no parameters versus parameters are being sent. And so there's no parameters, and we're printing out an empty array. And we, as the developer, are giving our user an easy way to send us data, and it just concatenated on. And so that's form2.php. Form3.php says there are two ways to send this data. One way is as parameters, but this gets kind of ugly, and there are reasons not to do it, and you're not supposed to modify data. Now, guessing in a guessing game is probably okay to use as a get, but all we have to do to switch to sending the post instead of get is to say method equals post. So the form is exactly the same, constructed in exactly the same way, and we have get parameters, and $_post is a new thing. I'll take off this guess equals 12 and switch to form3.php. And so that's a get request. So if I take a look here, that was a get request. So if I come here and I hit the enter key, that forces a get request to that URL. Hitting refresh doesn't, as we'll soon see, doesn't always force a refresh. If the last operation was a post, it does the post. If the last operation was a get. But in this particular bit of code here, view page source, in this particular bit of code, we have told it that we want to send it the data that's entered by the user, like our 123, is sent via post. And so you'll see that if we look at what's going on here, it sent a post to this URL, and if you cruise down, the data was actually sent as part of what's called form data in a format called URL encoded. And we could look at more detail, but the first thing you'll notice is it's not on the URL as a question mark, as a query parameter, and that's because it's actually sent as part of the connection. The connection connects to wa4e.com on port 80, sends post to that URL, and then it sends these request headers. These are actually part of what is sent, and then a blank line, and then form data is sent. The response headers are what come back to our application in the request response cycle. And basically, just like with get, $post is created for us before the first line of our program, and it just handles this stuff, and it's all magic. You make a form, and then when the post happens, $_post has key value pairs that are properly set for us. Okay, so let's take a look at form.4.php. The one thing that you'll notice here is my previous guess was 123, but it didn't show up here. It's so often that forms put their old data there. 125, submit. Where'd the 125 go? We kind of expect that the 125 is going to be there, but it's not. And it turns out that we have to just explicitly put it there. And so it's so common that developers grab this post data as it comes in and echo it back right there so you can actually modify it. So if your guess was something, long and you wanted to change it, right? It's not there. I wish it were changed. And so in Form 4, we show how to solve that problem. So let's go to Form 4 and view the source of Form 4. which of course is also over here. And so what we're going to do is we know this code is going to run once to do the get, and that just is drawing the form. That's when I hit this enter key, and it draws it, and it sends a get, right? When I hit the button, because method equals post, it's going to send us a post request. And the key is I just have this input tag, and I add value equals, and then this little bit of stuff. And this is a contraction for PHP to print out this variable. And the variable is, if there is data in post sub guess, I'm going to take that data. Otherwise, it's a blank. And so if I do a view source here, in this value here, there is no data because that was a get request. The post is not set. But when I do when I send a post like, hello, this is not a number, and hit submit, well, it comes back. And so if I now do a view source on this page, you will see that my PHP code particularly put this in right here, using this little bit right here to say, oh, generate the HTML, but replace this little variable old guess and whatever's in old guess, which came in post sub guess. Okay? Now, the nice thing is now I can fix this. I go, oh, I typed that wrong, and now it works. And so the idea of is a post still, but the idea that this stuff is persistent is not something the browser does for you automatically. Sometimes the browser does auto fill in, which is tac E of certain fields. It does auto fill in of those fields, but in my browser they're yellow, which is different than the server restoring the data. Okay, so that's cool. That's easy. But in doing this, we just violated the first and most fundamental rule of PHP application security. And the first and most fundamental rule of PHP security, and you can go and Google like cross-site scripting and learn more about this. Cross-site scripting, oh, blah, blah, blah. It's XSS injecting, blah, blah, blah. Go ahead and read all that, okay? And it's nasty. And how did we just allow the user into our backyard? Well, the problem is this post sub guess right here is data that came from the user. Whatever I typed here shows up here. And so if I am clever, I can actually make old guess contain sort of a snippet of valid HTML. So what I'm going to do is I'm going to make my old guess start with a double quote. And I'm going to say double quote slash, and that's going to end the input tag. And then I'm going to start another input tag, type equals submit value equals monster. But notice that I only have the opening quote and not the close quote. Let's put a BR tag in here, or not, an HR tag. So there's an HR tag as well. And so when I submit this, you're going to see what happens. So now I have this monster button. And the monster button is something that I created. And I could do something evil with this little monster button. Now, how did that happen? Well, let's take a look at the view source of this. And you can see with syntax coloring. Now, this part here came out of my PHP, and this part here came out of my PHP. But all this stuff, all that stuff there came from me typing. But the browser, when it sees this, it's like, oh no, that's not good. And so then the browser sees that as an input tag. It sees that as an HR tag. Even though this came from me, sees this as an input tag, and this is the input tag, even though this last part of the input tag came from the PHP. It doesn't know the difference. It just can't tell, okay? And so that's really bad, because this could do something like take your bank account cookies and send them to my evil server if I was super clever and did this. So this is called cross-site scripting, which means that I have typed something into your application. Hopefully I get someone else to stumble into my typed in stuff, so you're viewing somebody else's information. And then in that information, it is stealing something from you. So that's really bad. So this is like terrible, terrible PHP. Good news, not hard to fix. Let's take a look at form5.php. There's this function called HTML entities, and as long as you print out HTML entities of that value instead of the value directly, then you're generally safe. And that has to do with this. So let's go to form5.php, and let's type that same thing here. Got it here. Okay, we're going to type this same thing, and we're going to submit it. And it's going to be like, okay, and now if I do a view page source, it'll be far more clear as to what is going on. So this part came from my PHP. This part came from my PHP. This part came from the user. But what HTML entities did is it saw dangerous characters like double quote, greater than, less than, single quote, that's double quote, and it turned them into these things called HTML entities. And HTML entities are a sort of ampersand form of those characters. But now, even though the browser knows that's a quote, and it shows it as a quote right here, it does not then allow this user to escape and start entering HTML into my background document. You can actually note that this kind of messed up because my debug output messed up, right? Because my pre-tag is still printing that value out without filtering it. So be careful, because I fixed this error, this error right here, but I didn't fix that error right there. Okay, so just rule number one is if this data came eventually, or at any point came from the user, just wrap it in HTML entities. You can wrap things in HTML entities that didn't come from the user. It doesn't harm it. It's harmless, but always for user data, wrap it. I tend not to wrap everything in HTML entities so that I can kind of mentally know where I was getting user data. So that is a zip through some of the forms sample code for web applications for everybody. We'll talk about some of these others in an upcoming video. So again, I hope this was helpful. Hello everybody, and welcome to Web Applications for Everybody. I'm going through some of the sample code in the forms section of the course. Right now I'm just going to go through a few of the extra form fields, and literally this page is not the greatest. You can Google all these form types, away you go. So here's the code we're looking at. We have your basic text, and you notice I'm using this label for pattern over and over and over again, just because I'm trying to make my markup semantic. You notice I'm not perfect at that. The next type that we're going to talk about is the password, blah, and then the password is, super secret, the most common password. And so password is just like a text field, except that it doesn't show it while you're typing. Now, if I'm going to submit this as a post variable, look, the secret just goes in plain text. It goes into the PHP in plain text. If I was to do a view developer console and watch the network, what was that? Credit card. So if I type in the password for secret and I press submit and I look at the post that just happened, it sent the password across the network in plain text. So password is really only there for you to keep people from shoulder surfing as you're typing the password. Okay, so nickname is another text. Okay, this is a radio button. And so type equals radio. And radio button is like a station selector on a car radio. And the idea is that no matter how many of these things there are, one can be turned on at the same time. And you do this by naming it type equals radio, but then grouping them by having the same name. Remember, name is what's sent to the server, key value. And then different values. So value equals AM is what's going to be sent to the server. If this one is checked, value equals PM is sent to the server if this one is checked. And then there's an optional attribute that just says checked, which indicates when this first is refreshed that PM is going to be the default one that's checked. So if I hit AM and press submit, then you can see when equals AM, and so it really picked among the things when equals AM from the source code. Okay, so that's that one. Checkboxes. Checkboxes are independent, so you can have any combination of checkboxes that you want. All of them, none of them, whatever. So they each have a different and distinct name and a different and distinct value. If the value is not given, then on. The string on is what's sent. So I'm going to see all three of these, class 1, class 2, and class 3 are going to be checked from that checkbox, okay? And on is because I didn't specify a value, but most of the time we're just doing an is set to see if this key is set in the $post as compared to looking at the actual value, but it depends. Okay, so the next two examples are drop downs, and again I got a label, and I have the name of the data that's going to be submitted, and then option, and those options effectively in order pick these things. And then when we hit submit, 3, if I pick Mountain Dew, then 3 is going to be sent. In this next one, all we're doing is we're picking a selected one so that it's not the top one, right? Peanuts, I can change it to chips or cookies if I want to. And then in this one, snack equals chips is what's going to be sent. In this one, soda equals 3 is what's going to be sent. So let's go ahead and submit that. And so soda's 3 and snack equals chips. And so that's how the drop down works. Text areas. Text areas are cool in that they don't have a value equals like most. You just put the existing text that you want in between text area and /text area. Name is how it's going to be sent. You can put like blanks in here, blah blah blank, blah blank, 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 blah 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 blah. Okay? And now if I hit submit, you'll see all this is bundled up into a single value, right? So this is the about, and it's a string. It has new lines and all the spaces and whatever, and that's why you can write little paragraphs in here. Now there's all kind of plugins that will turn this into something that turns into bold, because I could say, and I'm not filtering this very well, so it's going to look bad. And so, so I submit some HTML, and look at that, it's bold. Now the danger is I could submit some JavaScript and ugly stuff, and so there's another filtering. Anytime I'm clearly not filtering this stuff when I'm just using print R, and so this is a dangerous page because HTML could come out. The last thing is something that you pretty much, well, second to last thing is a multiple select. And so this is sort of like the option value, except you've said it's multiple, and it actually sends an array of codes because they can all be turned on at the same time. This is generally a hard way to do user interface, and let's see if I can get it. Option doesn't work. I can never remember. Not control doesn't work. Command works. So now I've got 2 of them done. This is a terrible user because no one, including myself, knows how to use it. But when you send it, you get an array that tells you which of the things were checked based on this thing. And then the last little trick that we'll show, we got a submit button, and in this case we got a name and a value. So the value in submit buttons is a little bit weird in that it both changes the text on the button and it sets what is sent. Most people just name their buttons different names. So this name equals due post, and check to see the existence of the button in the post data to figure out which of more than one button, if there are more than one button, rather than looking at the value, because the value is often translated. If you have a multilingual application, submit would not be the text that was here. So checking for the text is a little problematic. And then we have one more little trick, and that is how to turn a button into an anchor tag. And that is, you say input type equals button, on click is a bit of JavaScript, and then you simply say switch this browser to this particular URL, and then don't submit the form. That's what return false is, and you'll just see we will use this for escape or cancel or done or all kinds of things to get out of a form without actually submitting the form. So if I click this, it's going to take me back to web applications for everybody. So that was a really quick zoom through the sample form code, and I hope that it was helpful to you. Okay, so welcome again to Web Applications for Everybody. We're doing a bit of code walkthrough. Right now we're on talking about the forms topic. And so what I want to talk about is this model view controller pattern, but I'm start with some code that sort of I've used before, this guest code, guest.php, where we're supposed to play a guessing game. Guess equals 14. It's oops, I did a minus sign there. Guess is too low. So I want to take a look at this code. And so this is kind of a typical crude basic PHP script, a bit disorganized. It starts with some HTML because that's what they are, is it's a template, and it drops into PHP and then does some logic and then puts a bunch of echo statements. And what it does do well is its structure overall, top to bottom, is not what I like, and I'll show you in a second how I want to restructure it. But it does do a pretty good job of, checking to see if there's a guess parameter and complaining if there's not, checking to see if the guess is too short. This is all input validation that's doing a pretty good job of. In my next application, I'll have it better structured, but I won't do this validation. And then once I know, by the time it gets to here, I know that I've got at least sane data, and it's a number, it's the right length, and it exists. And then I can say if it's too low or too high. And otherwise, if it's equal, then I say congratulations. So this is nice little error checking here, and nice structure with else ifs. I like that. But the fact that I just sort of like intermingle my PHP with my HTML gets a little bit sort of confusing after a while. And so, and this is not either the greatest application, but it demonstrates quickly and simply this notion of what I call, well, what the world calls Model View Controller, and this is my really simple implementations of Model View Controller. You can go Google Model View Controller, and you can View Controller, and you can read so much stuff about Model View Controller. Oh, I even use that slide in my talk. And the whole idea of Model View Controller is that when you're doing the request response cycle, there are three basic things that happen. One is the data model gets updated, the database, the backend, etc. You generate a new page, and there's this thing called the controller, which decides what to do with the model data, what next screen to pick, how to respond to the incoming post data. And so I would call it controller model view rather than Model View Controller. And that's kind of like the picture that Wikipedia is showing you here. And you can read and read and read and read and read more about Model View Controller, and there's whole frameworks that do Model View Controller. But what I do to keep it simple so that you know Model View Controller in kind of this low-level sense, and then when you move to a framework that's more advanced, then you can just use the framework to do all the Model View Controller magic. So in Model View, so this is kind of like the model. And so what I do is I always start my PHP files that are going to do data processing in PHP, not in HTML. And the model is handling the incoming data. And the view, there's always a line in every one of my scripts where you see, oh, I've switched from the model to the view, at least the ones that process data. So above the line, the idea is you talk to databases and do your data processing and handle post data. And below the line, you just mostly generate output. That doesn't mean that you don't sneak a little PHP in here, because PHP is both a programming language and a templating language. And in this case, I'm just deciding if the message is not false, print it, or print out the old value in the form using the HTML entities and the less than question mark equal for the echo. So the idea is there's always this line above which we are completely silent and below which we don't do any major data operations. We can do loops and whatever, but we don't talk to the database, we don't do that thing. And so that's my discipline. And controller is the whole script. And if we get later in more sophisticated things, we'll see that we're doing routing decisions. We're sometimes moving, after we process the data, we send them to a different script. And so orchestration and routing is the function of controller. So this guessing game, Guess MVC, this Guess MVC is going to look like every other guessing game we've made. So if I say 12, now it's a post. If you look, it's going to be a post, so it's not going to show up here. So the old guess was 12, and it says too low and guess is 12. Okay, and then I can change it. 123, it's too high. How about 121? So all this stuff is working. But if you look at it, what's happening is old guess, and a get request, so let me do a get request by just hitting it and hitting enter. So I do a get request. There is nothing in post, so old guess is false and message is false. And there is a thing that's passed between the model and the controller, and the model and the view. I call that the context, and that's really, in this case, it's just two variables. Old guess and message are set and then fall into the template, passed into the template. In other frameworks, we're more explicit about constructing a context and rendering a template with that context, but I'm keeping it really simple by saying context is what falls through from here to here. And we have to do it in a GET request because it's going to run these 2 lines of code and then skip all the way down to here. So old guess is nothing and message equals false, and that's why there is no guess here and there's no message. But then when I say 12 and I hit a post request, this is going to become true. And now there's no error checking. I'm sorry. I'm trying to keep this simple so it fits on a screen. So error checking would go up here. This is actually the logic of the guessing game. I'm just converting this to an integer by adding a 0 to it. That's kind of quick and dirty. And then I'm checking to see if it's 42 or less than 42. But what I'm doing is I'm not putting echo statements here. I'm setting the message and then letting it fall through into the template. So there will be silence up here. There will be a bit of silent work that you don't even see up here where message and old guess are being set right here. And then it falls in, and then it renders it, and away you go. And so that's the basic idea of model view controller. And we'll talk about this a bunch, especially when we have more interesting stuff to just looking at the guess. And especially when we get like 2 to 3 pages of code up here, it's important to really mentally separate the brains of your code from the look of the code. So model at the top, view at the bottom. Okay? So I hope that has been helpful to you. See you on the net.
Hello and welcome to my lecture about relational databases. My name is Charles Severance, and this lecture, audio, video, and slides are copyright Creative Commons attribution. So relational databases are amazing things. Our learning management system here at the University of Michigan using Sakai has billions of records, and you go try to log in, and within a tenth of a second you're logged in, and it has to go through billions of bytes of data in that tenth of a second. Or if you look at Facebook, it's trillions and trillions and trillions of amounts of data just to show you what your latest status update was. And what databases do for us is they allow us to speed through all that data, discarding and getting down to the one little status update that's your status update that just happened 3 seconds ago. It's billions and billions of bytes of data. And there are many ways to speed that up, but relational databases for the past 30 years have been the mechanism to take very, very large amounts of data and drill down very quickly to the exact bit that you need. It came from the 1970s, just as a way to make computers better for interactive processes. Before then, they sort of did batch processes where they read and read and wrote and read and they couldn't randomly move around and look at their data. But as we built disk drives that allowed random access, we wanted to optimize that random access and make our ability to pass through lots of data very fast without reading all of it on the way by. And so there's a lot of mathematics that underlie relational databases, and you can look at database normalization and third normal form and things like that. We're going to keep our life a little bit simple. Just understand that it's amazing. The stuff that we do with relational databases is amazing. Because of the math background that we have in a relational database, there are 2 sets of terms that you will tend to see used, and in different situations or different classes will tend to specialize in these terms. The more common terms are database, table, row, and column, because that's kind of what they look like. But those who are more interested in the theoretical aspects of this will call them relations, tuples, and attributes. And so just understand that just because you switch and look at some different document, you start talking about attributes, like, whoa, I'm confused. No, you're not. It's a column. The essence of the math is that data sort of is at this intersection of an attribute and a tuple. A relation is the connection between those 2 things. And it's not something that matters too much to us, but it is the thing that makes these mathematically powerful, and this speed really comes from that underlying mathematical elegance. So for those of us who are going to think of it in a less math-oriented environment, we can think of it as sort of like a super awesome spreadsheet, right? So this is kind of like our a database. And then these things down here, tracks, albums, and genres and artists, they're like tables. And then we have columns and we have rows. Probably the one thing that's a little different, although we do it commonly, is their databases certainly understand the type of data in each column. And so, something about this first row is telling us what kind of thing and what the name of that column is. In databases, this gets more explicit. And if you would do something like, say, this row is formatted as an integer, databases would get very explicit about that. But if we just sort of back off, we can see that it's a pretty simple concept to think of columns, rows, and tables, and a database. Okay? So when you start building one of these applications, something like a PHP application, we finally start talking in the next chapter about PHP. We really often think of the database kind of running one place, the database application, and this is the application that takes the request and response from our user, much like we've been doing, and we, the developer, will write that code, right? We type in some new PHP, and when we get to it, we'll send queries to a database. The database is like a separate process, could be on a separate server. This might actually be a network connection between here. And we send this language across. We ask for data, send a query across in the language SQL, and then we get a chunk of data back and forth, and then we format that and show it to the end user. And so that's how it works, is the developer writes application that some of the things the application does is makes database queries, other things does, formats output and does various other things, right? So, but we're not going to do this part. We're not going to do this part until the next chapter, okay? What we're going to do in this chapter is we're going to function more like a database administrator. And in organizations, it's often the case that developer and DBA are not the same person. But for this class, you are going to be both a developer and a DBA. This chapter is more of a DBA thing. And we're going to use a database tool, and we're going to pretty much type SQL directly to the database. So there is this database client. PHP-MyAdmin is probably the most common one that you'll use, but I'll show you also the command line a little bit. And we'll type SQL commands, and changes will happen. There's data in here and software and all kinds of really cool stuff in there. And so for this chapter, we are just working on this part of it, and we are a database administrator. We're doing things that in a production system, developers may not be able to do. And you might write code that might take weeks to go into production, and you have no access to the production database in a production environment. So the language we're about to learn is called SQL, or Structured Query Language. Some people, I think, have called it Simple Query Language in the past, but Structured Query Language. It is a beautiful language. It is a beautifully simple language. We're going to learn how to create data, read data, update data, and delete data in this language, and it's very elegant, and everyone really should know this. There's lots of database applications out there. Oracle is the large, very successful commercial one that they have like a sailboat. There's a sailboat that goes flying by. Remember the sailboat, America's Cup sailboat? Oracle sponsors that, so they're a very, very successful company. MySQL is an open source. It's owned by Oracle, but we kind of trust it. There's another one called MariaDB, which is a clone of MySQL. It's not owned by Oracle. And then Microsoft has SQL Server, which is a very nice database. And people have favorites of these. They have their favorites. For this class, I just use MySQL because it's free and it's openly available. And it is very, very commonly used with PHP. And so we're just going to use that. There's lots of other ones that are popular out there. I've used all these: Hypersonic SQL, SQLite, and Postgres. But for this class, we're going to focus on MySQL. And so if you've installed one of these XAMPPs or MAMPs, somewhere on your screen, there is a place that you can start this thing called PHP-MyAdmin. If you are hosting your cPanel, there's going to be somewhere to click into PHP-MyAdmin. And so once you get in this PHP-MyAdmin, this is going to be common. This user interface, once you learn this, is going to be common across most systems that support PHP and MySQL. So learning how to use it and learning how to be good at it is a worthwhile exercise. So we can take a look at our databases. And let me show you the one I've got here. So I'm running map on my Macintosh, and I can run, oops, clear, click, and I can run PHPMyAdmin. And so here I have that same screen. I can take a look at my databases. Now what's really happening is there's SQL going on back and forth, and we can type SQL commands here, etc., etc. Okay? And so there we go. That is one way of making use and talking to SQL. So if you're running in the command line, there's a couple of different commands depending on the operating system. You may not be able to cut and paste these depending, so you may have to type these by hand. So let me just show you the one that I have to run on my Macintosh for map. It might take you a little while to figure out exactly which one. If you're on Linux, you're just going to type MySQL command at the command line, and the defaults will be fine. So let me just show you what I do on my Macintosh. I type this long thing. Now again, if you're having trouble cutting and pasting, just go ahead and carefully type that in. So it's going to log in as the root user and the root password. There's always security connected to these things. In our little development environments that we carry around on our desk, security is less critical. And so now we're at a MySQL prompt. And if we say show databases, we will see the various databases. And this looks the same as what we did in our PHPMyAdmin. So I'll go back and forth for a couple of commands and show you sort of doing it both ways. But in general, I'll switch pretty much to PHPMyAdmin. But if you're on Linux, you got to use this. Well, not necessarily. On Linux, you might be using control panel that comes with like cpanel and MySQL admin. But I want you to be able to realize that these SQL commands can be typed in lots of different user interfaces, not just the ones that I'm using. So here are some examples of the stuff typed in, and you at this little MySQL prompt. And so, like I said, the first thing that you're going to do in PHPMyAdmin, I went and looked at the databases, and in my MySQL command line, I did show databases. It's kind of like hello world for databases. Okay, and so there's some databases that you should leave alone. Be careful, don't go dropping those databases. A database is a collection of tables, and so the command to create a database, and then a command line, you got to tell it which database you're using. In PHPMyAdmin, you tend to navigate. So I'm going to create the database called people in a command line, and I'm going to use it. So I'm going to say create people. I'm going to say use people. And then I am going to show tables. What tables are in there? There are no tables. But now if I switch for a moment to my MySQL admin and I hit refresh, you'll see my people database showed up there. That means the command line is talking to the database server, and my PHPMyAdmin is talking to the database server. So if I go into people, I can see that there are no tables. There's no tables. I can create a table if I want. There's SQL, yeah, and away we go. And this is the equivalent of use, as I'm now in this database. So the SQL queries are going to be sent to that database. Okay, so that's just showing you the sort of equivalence between PHPMyAdmin and the command line. And so here we go. This is what it looks like. So now we're going to do a create table. I'm going to do, I'm going to do this create table. Create tables user. I'm going to do that one in PHPMyAdmin, and I'm selected in the database people. Oops, forgot the C. Create table users. You got a column called name, which is a variable length character up to 128, and a column email that's variable length character up to 128. You'll notice I have a comma here and no comma there, and I say go. So this is going to submit the SQL to a database. And now you see I've got a users table, and I can look at the structure. I've got these columns, and it's the type, and all this stuff is starting to work, right? I can look at this table, and there's no data in it. I can go into my command line, and the describe command is the way that you look for things in the command line. Okay, so I now have a table and a database, and I know what's in it. It's got two columns. So it's empty. There's actually some wizards that allow you to create this inside PHPMyAdmin. And so the next SQL statement we're going to look at is called the insert statement. And the insert statement, so SQL keywords, insert into, are actually just SQL. SQL is a little more verbose to make it a little more readable. And values is a keyword. Users is the name of a table. Then you have two parenthesis lists. One is the name of the columns, and then one is the name of the values to put in each column. And there's a sort of one-to-one correspondence between the number of things you put in the values list and the number of things that you put in the columns list. Okay, so the insert statement inserts a row into the table. Okay, so I'm going to just copy this little guy. Oh, by the way, you may have downloaded my little cheat sheet to make it so it's easier to copy these back and forth. Hopefully it'll work fine if we copy back and forth from the PowerPoint. We won't get sort of strange characters. So this time I'm going to do it in this. So I'm in a table users, I'm in database people, and I'm going to type, insert into yada yada, and then I'm going to say go. And now if I took a look at the browse, you would see that I now have one row with this row has name and email. If I go back to SQL, I can grab the rest of these and put them in. I actually need to put a semicolon at the end of each one if I want to do them all at the same time. And now I can say go, and we'll go and run all those. Yay. It ran them separately, and so now I have 5 rows in my database table. Okay? So that's the insert statement. You don't have to have all the columns. There are rules about what columns need to be there and what columns don't need to be there. Oops, we're going the wrong way. We can do a delete, and again, delete from is the language reserved words, where is a reserved word, table, and then kind of a logical question. And this is a column where, so delete from users where email equals ted@umich.edu. Kind of easy, right? So let's copy that one in. Let's copy that in. Copy that. This time I will go into here. I'll put a semicolon at the end, and now I will go over here and I will rebrowse, and you'll see that Ted's now gone. So we have these two processes. One is this command line terminal, and the other is this PHPMyAdmin, and they're really talking to the same database. There can be literally many of these connections from your online PHP application, from you as the database administrator, from you as database administrator at the command line. They can all be connected at the same time. I'll speed us up, not keep doing that over and over. So we delete it, it's gone. Update. The update has, again, update is the keyword, set is a keyword, where is a keyword. So update the table users, set the column name to the value, Charles, and then there's a where clause. You got to be careful. If you don't leave this where clause, it'll do it down every column. If you don't put the where clause on, it'll do every column. So I say update, set name. So here we're going to see this one here that's going to select that one. So I switch to the SQL tab and then hit go. And then I take a look, and indeed the name's been changed. So that's update. Retrieving records, this is kind of the reading of the information, is the select statement. And the generic one is select star from users. And this column here, this is all the columns that you want. Star means give me all the columns. Otherwise, you can list columns. And then there's a table. And then there's an optional where clause. So come back. So select star from users. I'll type this one in the command line. Select star from users, semicolon. That pulls all those things out. And if I do select star from users where email equals csev.umich.edu, you see that I got just that record that is the one I'm looking for. Okay. So the select pulls out selected things. You can sort, select star from users order by email, or select star from users order by name. Order by is a reserved word. Even though it seems like it's two words, it's one reserved word. Again, they're just trying to make it easy for us. So I can say select by email. So now it's ordered by the email column. Copy. Paste. Order by name. So that gives me the same stuff because the emails and the person's names are in the same order, but you get the picture. You can order by, and you can order by multiple things. You can order in descending. There's all kinds of things you can do. Another sort of operator that's interesting, and there's tons of these, I'm just giving you the high level, is a like, and there's like a wildcard. So the percent sign E percent sign says, look, anything has an E anywhere in it. So I can go to, let me switch back to doing it this way. I can go in here and I can say select star from users where name like the letter E somewhere in there, and then I type go, and then it runs. And so you can see I only got the 2 rows where the person's name has an E in it. So Caitlin and Sally do not have E's in them. Ooh. The limit clause. The limit clause is a great enhancement to performance. If you think about all kinds of user interfaces that say this is the 1 to 25 of 1,000, next, back, that's what's going on here, because if you retrieved all 100,000, that'd be very costly both for the database and the server. If you're only going to do show 25, use this limit clause, and you can start at the beginning or you can start like at 26 if you want. And so I can add this limit 2 that says the first 2. Limit 1 says start at 0 base. Start at the second one and give me 2 more. So I'll just run this one. Select star from users order by email limit. That's starting with the second one and going to. So we'll just go and type that into SQL. So it sorted it and then went down. This is how it's in the middle of something. And so the limit the limit is a starting row and a count or just a count. You can ask for a count, and that's how when you're on one of these page things that says 1 to 25 of 10,000, because the database is actually very fast at being able to do this. So instead of selecting the actual information, we can ask for a count of a certain number of things. So let's just go in here. So I can count 4. There's 4 of them. And I could also do that. I'll leave that up to you with a cool where clause. That would give you 1 if it was going to do that. So at this point, it's like, this is the summary of what we've shown you. How to insert, how to delete, how to modify, and how to retrieve. I'm giving you a couple of choices with the retrieval, like a where clause, like a limit clause, ordering, etc. And at this point, you're kind of thinking like, wow, why does everybody make such a big deal about this? And you honestly are sort of right at that point. And so that is basically the basics of SQL. Of course, we haven't gone to multiple tables or foreign keys and stuff like that, but we'll get to that eventually. So, but this is why it's such a pretty language, because really at its core, these are the functions. And then we just sort of wrap this with increasing complexity. But these are the 4 basic things that relational databases are capable of doing. Welcome to the second half of our MySQL lecture. This, in the second half, the first half we talked about the insert, update, select, and delete commands, the basic SQL capabilities. Now we're going to talk about some of the contracts that we're making with the database, having to do with the types of fields that we can store. We saw varchar 128 in that previous lecture. So we're going to talk about the various kind of text fields, various kind of binary fields, numeric fields, date time fields, and then fields that we do things like our special auto increment. And so when we start talking about strings, it's important to realize that there are two kinds of strings. String fields understand character sets, so if you have Oriental characters that are more complex to store, these char fields and varchars are actual characters, and so they can have a Korean name in them or something like that. Char is a fixed length field that allocates all the space. It's a tiny bit faster for smaller strings that are very consistent, where they're pretty much going to be filled up all the time. They're known, and so char. Varchar is more common because they allocate a little bit of space for how long they are, but then they only use the amount of space that's used. So if you do a like char 10,000, every row is going to have 10,000 characters taken up. So varchar is pretty common. Char and varchar can be indexed and used for lookups, like when you log in with your email and it wants to look your email up and it wants to index that, so it's really fast. So you tend to put something that's going to be taken from the user in a varchar field. Then there are text fields, and text fields are generally for paragraphs, textual information, because there's lots of times in databases we store pages of stuff. Not pages and pages so much, but like a single page, like in one of these little text input areas you see in various systems where you got a little bold and italics. All that turns into one blob of text. And so these are larger, they're variable length, and they're generally not used to do sorting or indexing or looking up. And there's sort of tiny text, medium text, and long text. I tend to really mostly use the text one for fields. I don't even make large varchar fields much anymore. If I'm not going to use them as an index, I tend to just call them text and be done with it. I don't think there's a real efficiency problem, at least in the modern versions of MySQL, to just use text for lots of things. There are these binary types that are actual 8-bit chunks of space, and they have no awareness of character sets. So you can't store anything other than 256-bit, 0 through 256 in each one of these 8-bit bytes. So they go up to, and so there's a fixed and a variable length, but this is seldom used, but they're there, so you might see those. Now, you can also store large binary objects, and this would be a image, a JPEG image or a GIF image or a PDF or a QuickTime, something like that. You can store these in databases. You tend to find that you don't want to store objects that are too large in databases. You tend to find a place to store them on the file system and serve them out of the file system. And so you tend to only use these things, 2 to 5 meg. You can go on Stack Overflow and say, when should I use a blob and when should I store it on disk, and it'll tell you that sometimes. And so real small things, so 2 megabytes. Like if you're uploading images and you can limit them to 2 megabytes, it's not bad. But the problem if you make too much data in blobs, then you end up with backup problems. So you can't back your whole system up. The advantage is if you put it in the database, you back the database up and all your images are backed up. If you start putting really large files in, then your database backup gets really large, and so you don't want that. So it's sort of this balancing act as to whether or not you use blob. But the database is perfectly happy of putting a whole QuickTime file, 200 megabyte file in it. It stores it reasonably efficiently, but then it takes responsibility for making backups of those things for you. Integer numbers, very much the kind of thing that you want to do. Lots of things that we do are integers, and integers are very, very efficient. They take up very little data. They're quick to compare. They're quick to sort, all kinds of things. And there are a number of different integer sizes. There is tiny ints, which are sometimes useful for variables that you know are going to have some 0 through 10 or something like that, but that's about all they're good for. Integer is the common thing that's used a lot, and then really large integers can be done with big int. Floating point numbers can be stored, and these are stored in standard floating point in 32-bit or 64-bit. And the 32-bit numbers tend to have 7 digits of accuracy, and the doubles, the 64-bit numbers, have 14 digits of accuracy. So that doesn't matter how many, the number of digits of accuracy is like that, because these are all represented as a power. And so there's not a lot of call for it unless you're doing kind of scientific data, but it's right there. But very little of what we'll do in this class will use float. We're going to use a lot of dates. So there are timestamps. So one of the interesting things is timestamps. Timestamps are actually represented as a number, as an integer number of seconds since 1970. If you look at the number 0, that's 1970. January 1st, something 1970. And then it's like a second is added. Now it turns out that this may overflow depending on how big you make it. It might overflow and we'll have a Y2K problem in 2037. But these are very efficient. They take a very little space. They sort wonderfully, and you can sort of look things up very, very nicely with timestamps, and it's a per second resolution. And so that's good. There's time, there's date, and then there is date time as well. And these are all different features, and there's a built-in MySQL function called now that allows you to, in an insert statement, say, you know, this particular field, just put the current time in because MySQL knows what time it is. Auto increment is a very important feature. When we get to the later lecture on database design, we will need these keys, these primary keys that are sort of the way we can most rapidly look up a particular row. And so we'll tend to add a special key field, like for this users field, we will have a user underscore ID, and it's going to be an unsigned integer. Not null is a thing that says it can't be empty. And auto increment says, look, we're not going to actually tell you what numbers to put in here. You just, every time a new record gets added, you just automatically increment it, and then the rest of the thing. So this auto increment says to the database, it's supposed to maintain the field. So let me show you a little example of that auto increment. Let me take this create table here. So I'm going to go into PHP, go home, go to databases. I am going to get rid of my people database by clicking here and dropping it. So if I do a refresh, and then home and databases, people is gone now, and I'm going to do a new create database. Using this command. So hit go. Oh, I've got to be in a database. Oh, I killed my database. Now I got to create database people again. So go back to SQL, create database people. I didn't mean to get rid of it. I should have just dropped the table. That'll teach me a lesson. So now if I go back to databases, I've got my people database. And now I can create a table. Table I wanted to create called users. Say go. So there we go. So if I take a look at the database, I've got one table called users. And if I look at the structure of that, it's got 3 columns. One is a user ID, name. These two were from before, but this one has auto increment. So let me show you what happens here in the SQL. Let me go back and insert some statements way from the very beginning. Way from the very beginning. Redo some of those insert statements with auto increment this time. Here are my insert statements. I'll insert in here. Now you'll notice, oops, paste the right way. I have 2 columns. There are 3 columns in this database now. And I have only 2 columns specified, and I have Chuck and c7@umich.edu. And that's because the 3rd column I have specified is supposed to be done automatically by the database. So I type go and I do a browse. And so now I can see this row. This number was assigned by the database because that's my auto increment field. So Chuck c7@umich.edu. So I can go back in this SQL now, and I can stick another thing, and I'll stick Sally in. Insert Sally. Again, no user ID. And I go back, and now there are 2 records. It's pretty predictable. It starts at 1, goes 1, 2, 3, 4, 5. Now I'll put these other 3 in, and you'll see it just assigns these numbers. Oh, actually, no. I'm going to go over here and use people show tables. Make sure I'm in the right spot. Yes, I am. And now I'm going to run. Oh, I should have put a semicolon on that. It's probably going to blow up. Yep. I need to put a semicolon on all of them. And that's okay. I'll do them one at a time. I'll do them one at a time. Copy, insert, semicolon. You see it's putting in 1 row at a time. Copy, insert, semicolon. Now I can say select star from users to see what's in there. And so you see in this that the user ID for the first 2 I inserted using PHP is 1 and 2, and then 3, 4, and 5 were these inserts that I did in this command line user interface. And if I go back here and I hit the browse again, you'll see these are gone. Again, I'm just reemphasizing that this database administrator is talking to the database in one way or another way, and the application could be talking all at the same time. These are not this is not the database, and this is not the database. The database is a thing that we're all talking to, sending SQL commands to. So they're all sending commands to that same system. So this is auto increment, right? And we'll figure out why we need to do this. But the point there is that I can create this field by marking it auto increment. I'm saying, you take care of everything. I'm not going to do anything. I'm not going to come up with these numbers. I just want a number for each row. You know, sometimes it's not as perfect as 1, 2, 3. It's just give me a unique number for each row. So there's a whole series of MySQL functions. We'll run into these when we need them. The one we've mentioned so far is now, where you can put now in as a value instead of like having to put the current date in quotes. If you just mean right this minute, you put now in the SQL query. Another aspect of creating these tables and setting up these contracts, this is what's called indexes. And so everything we've done so far is like five lines or 5 rows, so it's really really fast. And it's reading the whole thing, and we don't even notice that. But at the end of the day, if you had 100 million users and you were going to 100 million user records, and you were going to look it up by email, you would want to be able to just make an index so it can jump in more quickly. And so there are techniques to shorten this lookup, so you don't have to go through the whole thing. And the 2 techniques are called hashes and trees. And so in MySQL, you can give it a couple of different index types. One is a primary key index, and that's what those auto increment folks are. They're very little fast. They're exact match lookups, good for numbers. They're really fast. And then there is the kind of classic index, which is I'm indexing a character field where I might do the entire match or a subset of a prefix of it, or I might sort it. And so it has to have a sense of what's nearby one another. These indexes also help sorting, the order by work well. Full text is sort of like a search engine, and it's kind of a tweaky little creepy thing all by itself. Not a lot of applications use full text search because there are significant costs every time you insert something, and so it's used in highly specialized situations. So we'll use the primary key all the time for usually those auto increment fields, and then index for character fields that we're going to do lookups on or sorts regularly. So the 2 techniques we use for lookups, and this is pretty much the primary key index is good for this, and that's called hashing. And a hash function takes as input a large chunk of data and then runs a calculation to produce something smaller. And so the hash function is, you can go read up on hash functions, the various kinds of them. And what we do is instead of taking a long string, we reduce it down to a number. But the problem is that hashes might have collisions, right? So John Smith, when we run it through this function, might end up with 2, and then Lisa Smith will end up with 1, and then Sam Doe ends up with 4. But if we run Sandra D through, we'll end up with 2. And so we have to deal with what's called collisions. But when you do it, this can be very long and this can be very short. And it's a very efficient way to sort of not have to look to make the lookup table be based on these smaller numbers rather than make a lookup table based on these numbers. Now the key to hashes is they do not maintain order, right? And so that's why in, say, a Python dictionary, which is exactly a hash, it doesn't maintain order for you, even though that's counterintuitive. And that's because it's storing them and indexing them and looking them up in this very fast manner using hashing. Now, the other way to do this is when you need to have a sense of order. And so you could think of these as little spaces on disk, right? So we're going to look for, let's say, 10. And what this is these are chunks of disk that it reads in, or maybe chunks of memory, but let's just pretend they're chunks of disk. And if you're going to read the whole thing, it'd be costly. But you read the first one in, and then you have, in effect, this is telling you ranges. Right? When you look at this 7 and 16, that says, go to this other place on disk if it's below 7. If it is between 7 and 16, go to this place in disk. And if it's above 16, go to this place. And so if we're looking at 10, 10 comes in here. And it doesn't have to read all the way through, cha-cha-cha-cha-cha. And it can go straight to here, and then it reads through this, and then it finds 10 doesn't exist. But and so this is basically, instead of reading all the way from the beginning, and the key thing is there could be literally hundreds of these, right? And you could skip 50 easily and go right to the thing that you need. And then sometimes there's 3 levels of trees, and there's all kind of tricks to make these trees, but the basic idea is it saves us from doing sequential reading by we can read and then skip just to the part we want and then read what we want. And so given that the sequential reading could be very, very long and the skipping is like 2 reads versus however many we have to point where we get to our stuff. Okay, so that's called a B-tree index. And now what happens here, of course, is this actually then, the 12 points to some other area on disk, which is the actual data. So it reads here, and it goes there, versus reading all the way through here and then having to go to there. Okay. So, and when new records are inserted, like if we were to insert 10, well, let's insert 13 because it's easier to draw. It would look for where the 13 goes. It would put 13 somewhere on disk, and then it would put it in here, and then it would add it to this 13. And then point 13 to that little bit of disk. Now at some point, if it had to do a 3, the 3 would come in here, and then it would have to break this in half and put and make 2 little blocks and fiddle around up here. So sometimes these have to be reorganized. So there is some cost when you're inserting data into one of these B trees, but it's beautiful because you can do super quick lookups and you can make things come out in sorted order very nicely and very easily. And so if we want to add an index, we can either add the index at moment of table creation. So here was our previous table where we're saying da-da-da-da, and we're saying index name. So that just says, that's a contract that says, I'm going to use this name as a lookup, or I might sort on this name. So I want you to create these extra data structures so that sorting and lookup is really fast on name. And by not mentioning that on email, I'm just saying, look, if I happen to sort on email, I know it's going to take longer. But if you can possibly waste a little bit of disk space with one of these indexes, you can save me some time because I'm communicating to you my use of this name might be different than my use of email. You can also, if you already have a table, you can add an index. And this is often when we're in the middle of a system and the system's slowing down, like, oh wow, it's slowing down. Oh, let's go add an index and see if that helps. So I'll just add the index to the table that I've already got. It's not too exciting. It works. So I'll go in here. I'll go to the SQL. Now, at the moment that I'm adding this index, it actually reads the whole table and makes all the index and puts all the pointers and makes it all work just nice. We don't care about all that detail. We just go, and it's done. We don't even really see much different, but all we know is that if we sorted by name, it's faster. Now, of course, there's only 5 records, so it sort of hardly matters in this particular case. That just means this sort of name is faster than this sort of email. But it's meaningless because everything is fast. Oh, wait, bring that back down. So that's an index. And so this second half, we actually, in the first half of this lecture, we learned how the basic language works. And the second half, we learned how we can sort of begin to establish contracts with our database system as to how these columns work and whether we're going to sort them and different things. And this is just the beginning. There are many more details, but we've hit the high points of the creation of database tables and that kind of thing. So see you in the next lecture. Hello and welcome to my lecture on relational database design in MySQL. What we're really talking about here is the move from one table to multiple tables. SQL with its select, update, insert, delete provides basic CRUD operations, and that's how we insert and maintain data in a database. But that's not really where the power of the database comes in. The power of database happens when we model material in different tables and then connect those tables with what we call foreign keys. And it's this complexity and this separation of data and the smallest of connections and cheap, inexpensive connections that are much cheaper than sort of scanning lots of data. You just jump to a bit of data somewhere on a hard drive. And it allows us to handle billions of records in a hundredth of a second. And so it's all very clever. There's a lot of computer science involved. And database design, I'm just going to talk about the basics of it, is an art form that you get better with the more you do it and the more real production applications. People ask me often, what's the best advanced class? And the answer is the best advanced class is to work on a real system and have good mentors that can help you, because it's hard to know in advance all the things that you're going to encounter. So database design often starts with a picture that captures the multiple tables and the relationships between those tables. And it has to do with a problem space. This is a portion of a data model from a project that I have called Sugi, which is a learning tool hosting environment. And this is just a portion of the data model. And the data model pictures, and what this is each of these items is as a table, and then there's other tables. They give given names. There's data in these tables, and then there are connections between the tables, and these little roads model the connections between the tables. And we'll talk all about this stuff in this next couple of lectures. This can get really large. Part of a project, another project I'm part of is called Sakai, which is a open source learning management system, and this is just one. This is probably about 1/10 of the data model of Sakai. This is the part that models assessments. And so I had to zoom it way out just to see all the different tables. And you go like, why did they do this? It seems like such a simple problem. And the answer is performance. We build all these complex relationships and model the data based on the connections. And that's the important part of this, right? Here's like, address, phone number, but the speed comes from carefully not duplicating data and modeling as much as you can that will affect performance with these connections. And so often if you're starting a new application, you need to draw a picture. And you draw a picture of the kinds of different objects in the real world that exist in your application. And the first and most basic rule of data modeling, and there is lots of subtlety to this, but the most basic rule is never put the same string in twice. And so in a learning management system, each user has a name, and my name might be Charles Severance. If you were to look through the database tables of a well-designed learning management system, and you looked all through all the tables, you hopefully would see the string Charles Severance, when it refers to my name, one place. And then everything has to point back to that if it's going to display Charles Severance on the screen. You'd see Charles Severance displayed all over the place in the user interface, if it was you that was logged in. But in the database, there should only be one copy. And if you start allowing there to be more than one copy of who the current logged in user's name is, and then you do that a little bit, and then you put 100 million users in, and then all of a sudden you've got a lot of data, and then all of a sudden you got a lot of data to scan. And so it's so much easier to like have a little pointer to say, he's user 2012, and then bam, you've got user 2012. And so it has to do with efficiency. But we do want to separate out the real world things in our database model. So here's a little model that I'd like to start with. It's a model from iTunes, Apple's iTunes. And we have a number of columns, and we have a user interface. And so we've got to separate out the user interface from the underlying storage structure. And so in this user interface, we're saying we're going to model tracks. And there's going to be how long the track is, what artist it's from, what album it's from, the genre of it, the rating, and the count. And you could just put this in a big long spreadsheet. And I bet you've tried at times to model perhaps your DVD collection in a spreadsheet, and you find after a while that it's really kind of weird, and you replicate data and you start typing the same thing over and over and over again, and it just doesn't make a lot of sense because 8 to 10 tracks come from an album and an album-artist combination, and so in our database, if we just put everything into one table, then we would have to scan the whole table to find things. So what we have to do is we have to look through the data that makes up our application. Of course, this is far simpler than most applications, and we have to say, is this a new object that we haven't seen before? Like, an album is a thing, a track is a thing, a artist is a thing. And so then you say, or is the piece of data, part of one object, or is it truly a different object? And so we basically would sit in a room, a whiteboard, and we would say, which of these things are separate objects and which of these things are parts of other objects? And so the other thing you say is like, what's the most basic and what's the essential feature of this application that we're building? And what is its core model? And you're going to relate all these things together eventually. And it doesn't matter where you start, but it's a little easier sometimes if you start at the right place. So let's just say that the first thing we're going to model is track. Okay? And now we have to look at all the other things. Is an artist part of a track? No. Is an album part of a track? No, an album is a thing. An artist is like a person. A track is another thing. A genre, well, we'll figure that out. But certainly rating, length, and count, that's part of a track. It's clearly and obviously part of a track. So the next question is sort of what is the thing that's most related to a track? Well, I think it's probably album, right? An album really is, a track is made up of many albums, so a track belongs to an album. And then we say, okay, what does an album belong to? Well, an album belongs to an artist. So an artist make albums, so a track belongs to an album and it belongs to artists. Now the question might be, what does genre belong to? Where does a genre connect to? We could connect the artist to genre. We could say, a Led Zeppelin is a rock artist. We could say Who Made Who, AC/DC's album, that's a rock album. Or we could say a track. And now this is a point where, as we're designing our application, it might make a difference. If we decided that AC/DC was metal or rock, and then later AC/DC made a Christmas album, can AC/DC also be jazz? And so it's important where you connect these things. And so if you play with your iTunes a little bit, you will notice that every track, even on an album, can be of a different genre. And so the proper place to connect the genre is to the track, because we can change every one of these independently. Even though this is 4 tracks, this could be rock, this could be easy listening, this could be whatever. And by connecting genre to track, we can change these. Now, in this particular album, they're all the same. But we have now made a data model for this particular application. Okay, so now we have a picture of objects and how those objects are connected together. And this is going to turn into the table structure that we're going to use. And so now we're going to take how to take those relationships, those little arrows, and represent them in a database, right? We still need to keep track of who the artist is, what the genre is. We have to keep track of all these things, but now we've separated them out and we need to model those connections, right? We need to model those connections. If we're taking a really super sophisticated database class, we would talk at this point about the different forms of database normalization and first normal form and second normal form and third normal form and which one's better and why you do this and what it really means. That's great. That's some of the wonderful mathematics that underlies the power of what we're going to play with. But basically what we're going to show you is a light version of third normal form following pretty much one basic rule, and that is always, that's good. The rule is never replicate a string. It's the Charles Severance example. You can have a learning management system with hundreds of tables and billions of records, but the word Charles Severance, as it refers to a particular user, should only appear one place. And what we do is we use numbers to act as proxies for those strings. Anywhere we want to put, this belongs to Charles Severance, this comment came from Charles Severance. Charles Severance ends up with a number, 12, and then we put 12, 12, 12, 12, 12 instead of Charles Severance, Charles Severance, Charles Severance. And so we don't replicate string data. We reference the data, we point at it, and we use integer numbers for this. Integers are they're stored very efficiently, they're sorted very efficiently, they're accessed very efficiently, and so we have numbers that represent these little arrows. And what we do to take Charles Severance is we add a little key to it. We call it the Charles Severance's key, so it'll be a little number field. So we'll see how this all works, okay? And so we create these places that have a user's name, Charles Severance, then a user key, and then everywhere else we have the user key and we connect back to the user key. So if we were to model the relationship between artist and album in our little database here, we would have to add to the artist table a key, right? We'll call this artist underscore ID just by convention. I have my table names have capital letters in them, capital artist. My columns are all lowercase, and artist underscore ID is the key in the artist table that is magically AC/DC everywhere in this system. Even if we had hundreds of tables, we will use the number 2 to represent AC/DC. So when we're in a table, say like album, where we want to say, oh, who does this album belong to? And we want to say, this album belongs to artist ID 2. So that's effectively the proxy for AC/DC all over this database. And you can think of this arrow as having a direction. So artist ID points to a row in a different table, and that row is number 2. And the same is true for Led Zeppelin, points to a row in this other table. So these are those arrows that we drew before. Now, this album also itself has rows, and we put a key here as well. And so each album has a number, and so anywhere we want to reference who made who, we don't put the string who made who, we put the number 1. Same for Led Zeppelin 4, we put the number 2. So the idea is we can replicate these numbers very efficiently, put them all over the place, replicate them as many times as we want, because numbers are short, highly compressible, fast, all kinds of good things about numbers, okay? Now, I'm calling these things keys, and it turns out that we have some terminology about keys, and you just have to learn this, okay? Have to learn this. There are 3 general kinds of keys that we deal with, okay? The first kind of key is what's called a primary key, and that's the key we add to the table to generate this little number. So we call that the primary key of the entire row. The foreign key is the key that points to something, right? It's one of these pointer keys. We'll see this in a second. The logical key is the key that the world would look this up, maybe the person's email, for example. So the outside world and the inside world. The primary key is generally just a number that's used inside the database from one table to the other table, okay? But the outside world knows who this user is, and this user might be, c7@umich.edu, yada, yada, okay? So the logical key is often a string that might be typed into a form on a web form. The relationships need to be done using primary keys. Never use the logical key, which is a string, as your primary key. And logical keys, including people's email names, change. And so if you have that primary key all spread out around your database and you got to change all the primary keys, it's terrible. So things like email may not change, but people do change jobs. They go to new places and their email changes. And if you have 1,000,000 records, you want to change even that email one place. Now, a foreign key is the way we model these arrows. And a foreign key kind of has a start and an end. And so if album belongs to artist, we have to add a column to the album table called artist ID. So if there's a column in album ID called album ID in an album table, that's its primary key. Artist ID has a primary key in artist. But if we're going to have artist ID in the album table, that generally indicates it's a foreign key. It's a key in another table, right? It's a key in the artist table. So if it doesn't match album, that means it's a key. Now, you can name these things any way you want. You could call this X, and you could call this Y, and A, B, C. You can name anything you want, and you can call your, W and Q, right? You could name these crazy names. I don't name them crazy names, because if you name your variables, your columns and your tables in a crazy, non-disciplined way, then your head will explode. So please don't have your head explode. So I have a convention here that's kind of borrowed from Ruby on Rails, mostly. The only part where Ruby on Rails and I differ is they call this field ID without the table name. I like to put the table name there. And convention is style. So there's not like a perfect convention. I disagree a little bit with Ruby on Rails there. This is not a Ruby on Rails class. And so this is how I do primary keys. Ruby on Rails, I borrowed this convention from Ruby on Rails, but I don't like the primary key of ID on Ruby on Rails, but other things choose it as well. So now we have this concept of primary key, logical key, and foreign key. And so what we want to do is we want to take our picture and we want to turn it into tables. So we have to add some bookkeeping columns, some columns that are there just for the purpose of bookkeeping, okay? And we have to model these arrows, which means we've got to put a few extra things here and a few extra things here. So we're going to have to put something in this table extra to model this end of it. We have to put a primary key in every table so that we have something to point to. And then we're going to have another thing in here that points to here, and then we'll have another column in here that points to there. And so we need to add bookkeeping columns. They're not the data. The data is like rating, length, count, title of the album, etc., 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 title of the track. That's the actual data. These keys that we're going to add to these things are just to model the relationships between them. Okay? So if we just take a look at the track belonging to the album, so we have, the track, its title, its rating, its length, and its count, and those are just the data items. And so those things, track becomes the name of the table, and then title, rating, and length, and count sort of become the data items right here. And we're going to mark title as the logical key. Now it's still a string, and we're just saying, look, we might be looking these rows up by title, so be ready. So it's still a string, it's nothing particular special. Then what we do is we add, for bookkeeping, a primary key to the track and to the album, just so we have a little handle to grab tracks as well. We don't have anything pointing to tracks, but in our application eventually we might be more complex and have something pointing at tracks. So we put these little primary keys in just almost automatically. And then we have a foreign key because we've got to model this relationship. So we put a column in here, and that column ends up being called album ID because it's telling us this is pointing to a row in the album table. And so in my naming convention, that column is named album ID. And so you can see this as a kind of mechanical process where you've got the stuff you want to talk about, and then you put them in, and then you add a primary key to each of the tables, and then you add necessary foreign key columns as necessary at the starting end of these arrows. Okay? So if we just apply this process over and over and over, we end up with 4 tables that are 4 objects. They all have primary keys on them. They all have logical keys. Not every table will have a logical key, but for now we've got logical keys for all the tables. And then for each of the arrows we've got starting points and ending points. So we have the track that it points to both a genre and an album, and then the album points to an artist. So you see it's kind of a very mechanical translation from the picture of logical relationships between the objects that our application is working with and the physical representation, the way we're going to put it in the database, because we have to model these arrows, okay? Because the database doesn't have the arrows. We just have to say there's a column, and that's our way of keeping track of the arrows. So now what we've done is we've created a database model that can be turned into tables. Okay, so now the next thing we're going to do is do SQL to create tables that achieve these kinds of things. And you can go along, there should be a handout that's associated, or you can take the slides and cut and paste some of this SQL to run in your PHP MyAdmin or whatever SQL gadget you've got. So you're going to create a database. We'll create a database called music. So you use these things to make a database, keep it separate from our other databases that we've got running. And so we're going to run a series of create table statements. And we're going to kind of work outward from artist back to track. So we have to establish the leaves of our little picture before we can work our way in. And so we work our way from outside in on these create statements. So we're going to create a table, and this is the same as a create table, but we're going to start using a few more specific things. So we'll say create table artist. Whoa, come back. Create table artist. Create table artist and a primary key. Now what happens is we want the database to manage the primary keys. We are going to tell it to automatically increment and provide it, which means we don't have to put these on insert statements, because they will be given to us as they're inserted. If you're running this in code, you would insert the statement and then say, what key did I get? And that'd be okay. And so this is, artist has a name, okay? And so all this thing, integer, not null, auto increment key, is communicating to the database, manage this for us, make it be integers, and keep adding to this number, add 1 to this number each time we put something in. Then what we do is we create a table called album. And it's going to have a primary key, album ID. It's going to have a logical key title, and we're going to tell it to index that title using a certain way. B-tree index is a index that's good for looking up entire strings or prefixes of strings, as well as sorting. So we might want to sort by title, so we're going to use a B-tree index, okay? So that's how we indicate that it's a logical key. And you can have more than one logical key if you want. And now we also put a foreign key in. So artist ID is the starting point of one of those arrows, and we call that an integer. Now the other thing that we do is we communicate to MySQL, and this is a place where different databases do things differently. And so this is pretty much MySQL specific syntax, or at least mostly specific syntax, where we're basically adding what's called a constraint, and that says this is a foreign key constraint. My column artist ID is a reference, a foreign key, to the field artist ID in the table artist. So what's happening here is you're telling the database, telling MySQL, when you're inserting a record, when it's looking for artist ID, when you're putting a number in like 2 or 4 or 5, it's going to check to see if it exists in this table artist. And if it doesn't exist, it's going to yell at you. It's not going to let you violate the constraint. Now, you're like, oh, that's kind of mean. No, you're the one that put the constraint in. So you're putting the constraint in, which tells the database, enforce the rule that I've decided to enforce on myself, right? If you don't want a constraint, well, just don't put that in. But because we want to do this as a foreign key, and we want to do it sort of in a responsible manner, we're basically saying this points at this. And whatever number I put in this artist ID column, insist that there is a corresponding row that's there. Now, this on delete, update, and on update cascade, on delete cascade, on update cascade. What we're communicating there is if an artist ID row, or if a particular row is deleted from this artist table, it will go through all of the rows in this table and delete all the ones that have the corresponding artist ID. On delete cascade means that a delete in this will cascade into this where the artist ID corresponds. That's a way of ensuring that your database stays clean, and we'll talk more about that later. The same is true on update, which is much more rare, where if there was a row and number was 4 and we changed it to be 24, then in here we'd have wow, I'm making such a mess here. So if there was a row, something, and there was a bunch of 4s down here that were effectively pointing, these are all pointing back, right? So there's an artist ID, and we somehow went into this table and changed that to 24, it would then correspondingly change all these to 24. Okay? And so that's what on update cascade means, is if this artist ID number is updated in this table, it is updated in all the corresponding rows in this table. That's a more rare thing. It is less rare to take the row 4, 4, 4, 4, there's a bunch of 4s here, and a row 4 here, and if you delete this row, it goes through and cleans up all these rows. That's the far more common thing, and we'll talk about that in a second. So this is all part of the create statement. There is 3 columns, album ID, title, and artist ID. We've marked album ID as special because it's our primary key. We have indicated that title is a logical key, and that artist ID is a foreign key. And so we're modeling all of that, and we're exposing to MySQL. You could ignore both of these things. These are sort of optional, but usually the more you take what you know about your data and hint to MySQL as to how it's going to be used, the smarter things work out for you. Because MySQL is really smart, but if you don't tell it what you're planning on doing, it can't anticipate what you're doing. So if we take this pattern and we create all these other things, right? We're going to make a genre, then we're going to create a track, right? And you got title, rating, and length. We got a primary key, yada, yada. We're going to have logical key of title, and then we have 2 foreign key constraints. And we just kind of concatenate these things together, and when we're all done, those things will all be there. And so we fully modeled these 4 tables. We've fully informed MySQL of the foreign keys, right? Okay, so that's cool. So we go through and we create all these tables. We have to create them in the right order because the foreign key constraints assume the table was created earlier, right? So if you haven't created the album table and the genre table when you're running this SQL will blow up and say, whoa, table doesn't exist. So you got to do them in order, and I've got them in an order that will work because I do artist, album, genre, track. As long as you do that in order, they will sort of build, and then MySQL will make this web of connections as you're creating them. So you kind of run through all these things, and here we got a artist ID, and you can see that it's not allowed to be null, it's auto-incremented, yada yada, and off we go, and there's indexes, and all the things that you've told it to do are going to start showing up here. So then we do all these things. We got album, artist, genre, then we're going to make the track one, so that's all the track SQL. So we'll make that, and when we're all done, we have our track, right? And the foreign keys are not well shown in this view, but this and that are foreign keys, and away you go. MySQL is aware of them and will enforce them on insert statements. Now we're going to start putting some data in. So the first thing that we're going to do is we're going to also put data in kind of from the outside in. And that's because when we're going to reference the artist Led Zeppelin, we need to know what the number is. And so we're going to insert into the artist table Led Zeppelin, right? Insert it into artist, name column. What's particularly missing is the primary key. But that's because it's going to be automatically done by the database. And so the primary key is automatically done by the database. And if you take a look, it will insert the 2 records we've asked, and it will assign an artist ID for them, right? So that the artist ID has been assigned, and away you go, okay? And so now we know this. Now, in the manual work, you sort of have to keep this scribbling like, oh, Led Zeppelin is 1 and AC/DC is 2. Because you can't use the word Led Zeppelin anywhere else in this thing, and we're going to make tracks that belong to Led Zeppelin, right? Or albums that belong to Led Zeppelin. Now, in a program, there is a variable. You can basically say, oh, run this insert and give me like in X what that number is. And you can ask the database, what was the number that you just assigned after that insert? But we just have to go look at it because we're doing it in slow motion all by hand. But when programs do it, they like, boop, what was that number? and then have the number in a variable, then they can put that number in later insert statements, which we're going to do by hand, and we just got to remember that Led Zeppelin is 1 and AC/DC is 2. So we're going to start again, we're going to do the genre, we insert that, we end up with rock and metal, and so we now know what the little numbers are for rock and metal. Rock is 1, metal is 2. I never remember what these are. I don't have them written down on a piece of paper. I probably should write them down on a piece of paper. Hang on, let me get a piece of paper here and a pen for myself. So, 1 is Led Zeppelin, 2 is AC/DC. Then on the genre, 1 is rock and 2 is metal. So here's my variables. I got this on a little sheet of paper now. So now I have two tables. I've got my artist and my genre. So we haven't made any foreign keys yet. Now we're going to insert an album. And if you recall in the album, right, we have a title, artist ID. We still have a primary key. Album ID is the primary key here. Don't worry about that. It's going to be done automatically, right? So albums, we're going to refer to albums too, and so we have to have a primary key. But artist ID is a foreign key in albums because we're in the album table. Okay? So we have to explicitly insert, because we're the ones that know which artist this album belongs to somewhere in our user interface, right? We've got, oh, we're going to put something in for AC/DC. So when we put into album, we got to insert the title, artist ID. We do not have to insert album ID because that's going to be done automatically for us. Then we have to put in the title and the artist ID. But we're not putting in AC/DC, we're putting in 2 because we remembered that AC/DC is actually 2. And the same is true when we do Led Zeppelin 4, artist ID 1. That's ironic. It's not really 4, it's IV, it's a string, right? So Led Zeppelin is 1, and so we remember that. If we were running this in PHP, we would have a variable called $last_insert or something like that. Okay. So you get the point. And these end up just being numbers. Now, if you had put 7 in here, it would blow up because it would say, look, I don't have an artist row of 7. And that's part of the constraint. So you have to put in legit numbers that you've put into these other tables. So that's why the order of these things is so important. As you're building these relationships, you put the thing in, then you point to it. Then you put this thing in and you point to it. And you're connecting all these little guys together. Kind of fascinating. You got to get it right. But when it works, it's glorious. Then we got the tricky thing. We got to put all the tracks in, right? So we got, let's see, yeah, we got albums. So again, the track ID is the primary key, so we don't have to worry about that. All this stuff, track, title, length, rating, and count, that's just data. And then album ID and genre ID, that's modeling the little arrows, right? And so Black Dog is from album. Oh wait, I forgot the album numbers. Well, I should have wrote those down. But whatever, you get the point. So this is album 2, album 2, album 1, album 1. It's genre 1, genre 1, and genre 2, genre 2. Now, I started talking by saying you're not allowed to replicate string data in more than one place. You can replicate, but we still got to replicate data because there are more than one track on an album. So we have to put albums in twice. Here's a track, and it's on the same album. It's totally awesome to replicate numbers because they're efficient. Strings are bad, numbers are good. We went through all these machinations just to get to the point where we're using numbers as proxies for strings. So you do all this stuff, and now we have relationships. And it's hard to see, but if you carefully did everything, you now can effectively reconstruct these little arrows. These foreign key columns are the starting points of arrows. And then these are the lookups, right? So you can think of, you know, that links to rock, that links to rock, this links to metal, this links to metal. And so we are using these numbers here and also here as proxies for those strings. That's what we did. We worked really hard to make that happen. So now we have carefully built tables, we've defined the shape of those tables, we've put foreign key columns in the tables, and we've put data in the tables where we work from sort of the outside edge, we work from the outside edges in. So we insert these things, then we have these proxy numbers, and then we use the proxy numbers to represent these pointer relationships. This points to that relationship. And so these little numbers model the pointers. Now we have to reconstruct it, right? We went all this effort to effectively create a highly compressed, highly performant representation of our data, but our user doesn't want to see number 1 when they see Led Zeppelin. They don't want to say, oh, what does this track belong to? Well, it belongs to artist number 1. No. They want to see Led Zeppelin. So we have to reconstruct this all back up. So this is the power, right? The power is we've got this efficient storage model, and we got to work across these foreign keys. We got to sort of defeat the foreign keys, as it were. We've got these numbers, but we don't want the numbers. We want the actual strings. And this is the join operation. This is part of SQL. Join is an SQL keyword, and there's an on clause that basically says, this is how I want the connection between these two tables to be made. The join says, I want to select from more than one data from multiple tables, and the on clause says how all that data is going to be connected. Okay, so here is a select statement with a join clause. Make sure my pen is working. And so here we want to basically see in our user interface, we don't want to see that who made who comes from artist 2. We want to see that who made who comes from AC/DC. But it turns out that AC/DC and who made who are in 2 separate tables. And so we have to reconnect the data. We're not reconnecting it in the database. We're only reconnecting it at the moment we're displaying it to the user. So we're going to retrieve rows. Select is the SQL that lets us retrieve rows. So we have a little different syntax here. We say album.title. That's table name.field name. I want to see the album title and the artist name. So we're pulling fields from 2 tables. From, that's standard SQL, album joined with artist. Joined, the word with isn't there. So now we have 2 tables. There are 2 tables, table 1, table 2, that hold the data. So I want to get data from these 2 tables somehow glued together to create sort of a momentary view that is the data across both tables. And the on clause is an SQL keyword, and it basically says, when do I want to connect the rows? What's the definition of the corresponding rows? And this is like and all we basically say is, I'm interested in these virtual rows to happen when the album's artist ID field, which is this field, is equal to the artist's artist ID field. Join these 2 rows together when that's true. You can join them all, and then it'd be all combinations for both tables. You can try this in your system without the on clause, and it'll go, you will get 4 records. You get all combinations. The on clause reduces the combinations to only the ones that match. Okay? So that produces this output. Okay? Now, if you want to sort of see a little bit more what's going on, we can change it. And the only thing we're changing in this one is we're adding this little bit right here. We're going to look at this column and this column, which are the connector columns, right? So this is the foreign key from one table and the primary key in another table. So we're like, give me the album's title, give me the album's artist ID column, give me the artist's artist ID column, and the artist's name. And the rest of this from, album, join, that's all the same as before. And so what we see in the output right here is we see these extra 2 things, which are the connector fields. And you'll see that the only thing we see is when they're equal. And that's how we link up the data in this table with the data in this table for the join. So normally we don't show these, and we don't see this part right here. We only see the connected up data. But here we can sort of be a little more explicit to see the connected up data and see how the connections are being made. And again, for a good time, run this query and take this on clause out and see what you see. Okay? See what you see. And so we can do the same kind of thing where we want to connect the genre ID to the genre, right? So we're going to select the track title and the genre name from track joined with the genre table. That means we're getting data from two tables, right, from track and genre. Some would actually just put a comma here, some variants of SQL, but we're not doing that one. They'll just say track comma genre because it's just saying it's really coming out of two tables. The on clause again says show me the ones where this is the case, where the track's genre ID, which is this field, is equal to the genre's genre ID. And so again, out comes the information that we are looking for. And it get really complex, and this is where how you named your fields and track and tables makes a lot of sense. Can make a lot of sense, a lot more sense for you. And it takes a while to type this in, right? But the patterns are real simple. And we're now going to create this output right here, which is effectively the output that we want to create. And note that there's replication. There's string replication because the user wants to see it this way, but we don't want to store it that way. So we're going to select track title, artist name, album title, genre name. Those are the things we want to see. That's part of a select statement. From the track joined with genre, joined with album, joined with artist. We're going to pull data from 4 tables. And we want to connect the data, on clause, when to connect the data. And now we have to connect all of the little foreign keys. So if you recall, we had 3 little arrows, and you can each one of these is one of our arrows. The genre arrow, the arrow between album and track, and then the arrow between artist and album. And then we put ands in between. And. So that tells us how to link the tables. You could do this again without the on clause and it'd be interesting. But basically, these get long, but they really are a simple pattern once you understand. I tend to start with the thing I want, and then I kind of go in order, but the order really doesn't matter because all you're really saying is this is the superset of all the tables I'm interested in. And so I draw them in order, kind of starting from the most central thing and then moving out, because I think of it as looking up things in those other tables, but you can put them in any order. The order is not essential. And so we went through all this process to create our user interface that had a bunch of replication in it. In the middle, there's a data model that doesn't have representation, so we stick it all in, and we use join to pull it back out. And we've done this, and the value of all of this, of course, is not that it's easy. If it were easy, we would just put it in a flat file separated by commas and use split or something. But that's what makes it perform. Now, the one thing, in addition, that we mentioned, if you go all the way back to when we created the tables, was the concept of on-delete cascade. Okay? And so here we have the arrow that we originally were drawing this way because we were thinking of looking up the genre in the genre table. But you can think of this as sort of a parent row and a child row. And the key thing is, if we are to delete this row, using a statement like this, if we're to delete this row, that would break these references. When we say on delete cascade, what we're really saying is when you delete from a table where there are references back to that table for the particular row or rows that you deleted, wipe out those child rows. So it's cascading a delete, cascading to the corresponding rows where it matches. That's why it's called on delete cascade. And there might be many tables. It just, so if you deleted a artist, it would delete all the albums for the artist, then it would delete all the tracks for the albums, right? And so the cascade tells MySQL to keep our references clean. Now we don't delete that often, and there's other tricks, but on delete cascade is a very, very nice thing to do to make sure that you don't end up with broken links, so your joins keep working. And so after on delete cascade, it would wipe out those 2 rows, and there would only be those 2 rows left. There's a number of choices that you can have in on delete cascade. You can restrict, don't allow changes that break constraints, which means you can't delete that parent row. Cascade, which is what I just talked about, which means it adjusts the child rows. And set null means that you sort of empty out, you change the 2 to like null, which is not exactly 0, it's the lack of a value in SQL. So we've been talking about one-to-many relationships for a while as a relational. There is one more sort of core representation that we have to figure it out and talk about. That's many-to-many relationships. And there's lots of situations in this world where these arise. The one we'll talk about is from a data model from some open source software that I write. Matter of fact, it's the software I write that I use to host my Web Applications for Everybody website called Sugi. And it has to deal with different courses and people in those courses. And so we'll see these kinds of connector tables. The thing that we've been doing up till now is what's called a one-to-many, and that is when we have an arrow, when you look at those things, they'll often put some kind of annotation. And so this is like 0 or 1, and this is many. And so there can be many tracks for one album, many many albums for one artist. And so there's this end is a 0 or a 1 situation where there's one row here, but many rows. So you can have many foreign keys. That's the duplicates, right? So you can have 1, 1, 1, 1. This is the many in the track table, and that points to exactly one key in the album table. And so that is reasonable. Here is this duplication, right? We get this duplication 1, 1, 1, and there is 1 there. And so actually I probably should have this arrow going the other way. This is the many side, and sometimes they'll draw it this way. So if you have a mother with many children, there is 1 on one side and many on the other side. And so this is another one of those natural relationships that we have to represent, right? That's a normal kind of thing, and that's what we've been representing up till now. And frankly, if you've been playing along, artists mapping to albums, well, that's really a many-to-many relationship, and we kind of oversimplified it so that we could make it here. But like books and authors, or artists and albums, there really is what's called a many-to-many relationship. And the simplest way to think about this is there's kind of an infinite number on both ends, meaning that any number, an author can be part of any number of books, and a book can be written by any number of authors. And there is no way with a single table. So if we're going the way we've been doing it, you can't take one table pointing to another table. And so we end up with this table in the middle, and we call it a junction table or a join table or a many-to-many table. And we basically break this many-to-many relationships into two many-to-ones. And so this is a 1, and this is a many, and this is a many, and this is a 1. And so by having a many-to-many, we have a way to do this, and then we allow duplication. We don't allow duplication, so author 1 can be part of book 1, author 1 can be part of book 2, author 2 can be part of book 3, author 2 can be part of book 5. What we don't allow is duplication like 1, 1. So we actually make a uniqueness constraint typically on these tables. But you can certainly so that's not allowed. But we can certainly have duplication in these columns. We can have duplication in these columns. But what we do is we make the primary key in effect be the combination of those two columns, and we'll talk about that in a bit. But the key concept here is that we need to add another table, right? We need to add another table. We can't do it with just two tables. We have our books table, and these books is classic because it has a primary key, an ID field, a primary key, and away you go. And so this is what it looks like, right? We sort of draw a logical diagram that has this many-to-many on both sides. And then we make this table in the middle. And it doesn't have a primary key. It's rare to put a primary key in here. What we do is we make the primary key, our uniqueness constraint and primary key, be the combination. So we can have duplication in user ID, we can have duplication in course ID, but we can't have duplication of the combination of user ID and course ID. And so that becomes the primary key. It's like a composite primary key. Another important thing is sometimes we actually model a little bit of data at the connection point. In this case, we have a series of courses and a series of people, and we could have a role. So this role could indicate whether or not this relationship, it's not about the course, it's not about the person, it's about this membership that they have. Is that membership a student membership or a teacher membership? And so you can sometimes, but you don't model anything about the user, don't model anything, you only about the relationship, this connection, because there's many connections. So let's take a look at some code that we're going to play with now. We're going to create our user table. By now, I hope this is relatively straightforward. We got a primary key, yada, yada, yada. We got some uniqueness constraints, for email, and away we go. So we set those two up. Those are no different than if we were doing a one-to-many. The interesting part now is what we do in the membership table. And so we certainly create a foreign key, and we don't put a uniqueness constraint on that because we allow duplication in the user ID column and the course ID column. We do mark them as foreign keys using the normal thing. We say the user ID points to the user ID column in the user table, et cetera, et cetera. So we put these two things in. That's helpful with our on-update clauses, of course. And then what we say is the primary key is what we're saying here is the combination. The primary key is the combination of user ID and course ID, and that adds a uniqueness constraint as well. It says, okay, we're not going to allow 1 to be in this more than one row. Okay, so that's the picture of the tables that we build. It's not that different. It's just like we got two foreign keys going in opposite directions and no primary keys. And we don't have a primary key, but the primary key is a combination of the two keys. So that's good. So to fill this data up, we will insert the data into the courses, right? Insert users into courses. Again, we don't put the primary key in. We don't have to because it's auto increment. And we'll do these statements, and we'll get the primary keys now associated with these people. So that's just filling that data in and taking a look at it. And then what we have to do is create the connections. And so these connections are all numbers because they're two foreign keys and a role. And so if we take a look now, we're going to insert into this member table the user ID, the course ID, and then the role. These are the column names. And then the values here are course 1, user 1, course 1 as instructor, user 2, course 1 as student, user 3, course 1. And so this is where we're allowing duplication, but we're not allowing the duplication of those combinations. So user 1 is in course 2, user 2 is in course 2 as the instructor, user 2 is in course 3 as the instructor, and 3. So we got lots of duplication vertically, but in either of these columns, but we have no duplication vertically for the combination because the primary key of that table is the combination of those two values. And it's really not all that complex once you get used to it. It's just really two foreign keys kind of pointing in opposite directions in this memberships table. And when we get done with this, the membership table is just a bunch of numbers that captures it. And we don't have neither of these two things are the primary key. No, that's a foreign key. That's a foreign key, right? They're pointing away. And then we modeled the role here. So that's the data that we end up with. These tables are very efficient because it's all numbers. It's three numbers in this case. I hope there's sometimes you put a bunch of more data there, but in general, you just put three numbers or a couple of numbers there, and they're very fast to scan, very fast to join against, et cetera, et cetera, et cetera. And so once we have this, the join is pretty straightforward. The thing you think about as you're joining is in the one-to-many, you would join from this to this, and then you get like the genre names. But what we have to do here is we kind of join through the table. So if we're going to connect the users and the courses, we have to go user, membership, course. So we're joining through the table. We're using it to pull these records together to connect them because it's a connector. And so the join is pretty straightforward. Select username, member role, course title. That's the information we want. And we're actually pulling something out of this middle table. We're pulling this role column out. So we're going to sort of join through from the user, joined through, I say, member, join with course. And then the on clauses are just the modeling of the connection, which is connecting the user ID and the course ID. Right? User ID and course ID are connecting. And so it's just a simple on clause. Member user ID is equal user's user ID. Member course ID equals course ID. The obvious connection. If you name the fields the way I suggest you name them, you're all good. And then I'm just going to order these things by the course title and the member role descending so that the teachers come first. It'll do it mostly by course title, then it'll do second by role, and then within role it'll do it by username ascending. And so that way I get that's my little trick there to get the teachers to show up first in each class. So there's the PHP class, there's the Python class, and the SQL class, and you see all those memberships. And again, this is simple. If you figured out everything we've done so far, it's not that hard. And so if you take a look at this database, you'll see in a nice data modeling thing where we see here, and each of these data modeling has a different way of doing this. This is a one relationship. It could be a 0 or 1. It may or may not be there, but in this case, it's going to be a one relationship. And this is a many relationship. That's an infinity or a many relationship. So if you model this table in some kind of an SQL modeling environment, it will see all the things that we've done. And in effect, what we built is a many to many relationship between these two tables. I'm not a very good artist. Okay, so, and if you take a look at the data model, you can see that my data model has a too many to ones because it has a many to many relationship. It's a many relationship between users and context. Context is my word for course, because it could be groups or could be sites or whatever. And then there's two foreign keys, and you sort of see that, and away you go, and we get that many to many relationship. So this is really common. I do a lot of work in educational technology, so it's not surprising that I use users in courses. So to wrap this series of lectures up, databases are really important. And you might think that this is a trade-off and that you can say, you know what, boy, that's a lot of stuff. I don't want to do it. What you find is it doesn't take very long before your data gets so large that you can't do things, especially with online applications. You can't do things in a quarter of a second by reading data. If you just have one file to read and it's small, that's fine. But if you've got to read through and discard a bunch of information, reading flat files discarding information is really slow. Whereas databases leave these, by the time you've done all this indexing and primary keying and all that uniqueness, it's left trails. So it knows how to get to stuff super fast in ways that you don't understand. So in summary, it allows us to scale to reasonable and very large amounts of data. It means it's the way to build online applications. There's no real other good way to store it. Things like NoSQL, which you might hear of, they're good for some things, but the kind of shapes of data that we're doing, NoSQL actually is weak at. NoSQL is better for lots of documents with relatively low amounts of structure and links between the documents. And so we have to make a really strict contract. We build a really strong schema, and the schema decides what we show and don't show. And by giving a rich contract, we really can make it so the database can highly optimize using techniques that we can't even imagine to make this stuff go fast. And so you've learned a bunch about database design, but I will tell you that you can always learn more. And what I really enjoyed in my own career was the time at which I knew enough to talk to people who were smarter than me. And that's kind of what I'm trying to do here, is get you to the point where you can be in a room and then sort of be amazed when you realize, oh, wait a sec, I learned something really cool about databases because I understood the basic language of it, and now I'm listening to someone who is super awesome and way smarter than me. So hope you find it useful. Cheers.
Hello and welcome to our chapter on PHP and object-oriented programming. So one thing about PHP is we look in the history of it, it certainly did not start out as an object-oriented programming language. In the beginning, that was just thought of as too much of a sort of fancy computer science notion. And so PHP 4 was not object-oriented programming, 3 and 2 were not, and then 5 and now 7 are of course object-oriented. And what's happened in the PHP community is there's this amazing flip from being kind of against object-oriented programming to being very pro-object-oriented programming. And so while a lot of the stuff I'll teach in this class doesn't use object-oriented programming heavily, it uses kind of a more traditional way. If you look at a framework like Symfony or Laravel, they will be talking objects crazy. And if I was to switch this course to Symfony and Laravel, I would literally have to teach object-oriented programming almost the first lecture. But now we'll learn it sort of I think the better time to learn it is after you've learned the language and done a little bit of stuff. But the libraries, I prefer the object-oriented pattern. It is a little more complex to understand at the very beginning, and that's why I don't like teaching it right away for beginning users. But it's certainly very popular, and everything's kind of trending in that direction in PHP. And I think that's a good thing. I mean, I think that's a good thing, particularly because I don't think PHP should be the first language that you learn. So what is object-oriented programming? Well, it's a pattern. It is just a way of kind of organizing our code and data that sort of, instead of saying, oh, I got this big program and it's got some variables in it and I've got some code and some ifs and some loops and stuff like that, what we say is we are going to sort of create little silos of data and code, and then we're going to kind of connect them together. And that's the high level of it. And so mostly what I want to accomplish in this lecture is teach you about some terminology so that from now on, when we talk about portable data objects, PDO, I can say, oh, and that's a class, and that's a method, and that's an attribute. And then we made the object. I want to be able to say that, and I want you to understand it. So think of this as not so much building skill in how to build object-oriented hierarchies or da-da-da-da. That will come in time. It's really so that I can just use these words in plain conversation, and you will understand them. And so the big words we're going to learn are class, which is a template for some data and some code. Object or an instance, which is you take this template, and I use the cookie cutter. The class is like the cookie cutter, and the object is like the cookie. So one cookie cutter can effectively stamp out many cookies, and that's the perfect model for it. Inside of a class and object are methods and attributes. They're being defined in the class, and they're being created in the object. So classes sort of take up almost no space by themselves. They just are a template that when we want to, we can make an object. So the class kind of determines the characteristics of things, right? It's just, okay, this is going to have some functions in it that do this, this, and this. It's going to have some data that does this. This data is private. This data is public. It's a blueprint. It's a cookie cutter. It's a way to make things. It's a generic sort of description of something. Then what we do is we instance the class, or we construct the class, or we create the class. And then we can instance it many times. We can have a variable called X, which is this class. We can have a variable Y, which is another version of that class, another copy of that class. And so it's like, take the class, stamp out a cookie, and use it. Take the class, stamp out a cookie. Put one frosting on one cookie and different frosting on another cookie, and that's totally, the instances are the cookies, and the template, or the cookie cutter, is the class. A method is just a word we use to we distinguish functions inside classes from functions elsewhere. And so a class has methods, but these are really functions that only live inside the class. And so you create a function outside the class, and it's named XYZ. And there can only be one function called XYZ in the whole system, in all of PHP. But you can have a class called, dog, and it can have a function XYZ, and a class called cat that has a function XYZ. This is namespacing or siloing. And if you think about it from just a functions perspective, it would be like a local variable, except what this is within a class, it's a local function. And it's different enough that it's just a function, and you look at the syntax, you'll see that it's just a function. Now, when I talk about things like string functions, which are really, really, really important, or date functions or whatever, you see kind of this weird pattern. And one of my most challenging things in PHP is to remember what the order of the parameters of the string function, in particular string replace. And that's because these libraries were built in PHP 1, 2, and 3, and they were non-object-oriented programming libraries. So all functions are global when you don't have object-oriented programming. You don't have methods that live inside of classes. And methods inside of classes is a beautiful thing. You will eventually understand how beautiful that really is. But before object-oriented programming, we needed a way to sort of keep the concept of subtract, right? You want to subtract 2 strings. Do you want to subtract 2 arrays? Do you want to subtract 2 dates? Do you want to subtract 2 whatevers, right? And so what we did, and every language does this, is you tended to put like a prefix on. So the create, date underscore create, or date underscore add, means that I'm going to do some addition having to do with dates, or I'm going to create a date. And if I'm going to do a string, I'm going to do string underscore add, string str underscore this, or str underscore replace. And so we sort of created these little islands of sort of namespacing by just putting prefixes on. But you'll notice that they don't put it on every single thing, because some of those even predate, right? So go back all the way to Python 1. And so that's pre-object orientation. And when you're reading documentation, you will kind of know that when you see a set of functions that all have the same prefix, like, oh, that's kind of from the old days. Now that we have object-oriented programming, we're going to start seeing some of the library code being wrapped both in an object-oriented set of functions and methods as well as a non-object-oriented. So this is that same date-time stuff, except now it's kind of in a class. And so what you see here is there's a date-time class, and that is like a little, you know, isolation, and there's other things that are out here like PDO and other classes, etc. And so inside here we can use things like a function named add, and so that is not a global function named add. That's a function named add inside the date-time class. And so these are the methods down here. And so it's really convenient because now we can name these methods in a way that makes the most sense to us as programmers, both as the creator of the class and as the user of the class. And so an important part is to sort of be able to recognize when you're looking at object-oriented documentation and when you're looking at non-object-oriented documentation. And so just like much of PHP's documentation, it's very good about telling us what version that this works in. So you can only use the date-time class above PHP 5.2. That's actually pretty safe. PHP 7 is not everywhere yet, but PHP 5.2, you kind of want to be at PHP 5.2 at this point in time. That's a pretty safe bet. So if we look at the sort of coding pattern, you know, you're doing various things with this, and so in the non-object oriented, you say date whatever, set the time zone, and call a global function called time, and time gives you seconds since 1970, and it now this is actually adding 7 more days worth of seconds. We're doing a date calculation. We're formatting it. Today's date formatting in year, month, date, and then we have to pass in the next week, which is, next week from now, whenever that was, and format that. So you see in the non-object-oriented pattern, you tend to have to add extra parameters that are the data. And in the string, we saw that, right? You had to put the search string, the replace string, and the thing you were modifying. In an an object-oriented pattern, you don't need that. So let's take a look at how this works. So we're going to create a new variable called now, and that's a new date time. This now is a class, and this is our first instance. That's an object. Now is an object. We have taken the date time and stamped out a cookie, and that is now in now. Okay, and we can make many instances from one template. And so we make another one, which is we look at the documentation. It says, you can say today plus 1 week in a string, and it gets to the next week. And now so the new is this new thing that says take the class and stamp. It's the stamping action. Constructing is what it's called. And so, but now what we can do is we can access the methods. And this little thing here, the arrow, says here is an object. Go find the format method in the object and pass in the format string. And then here's a different object. Go find the format method in it and pass in this string. And so that is how we are formatting different values. We're formatting this variable, and then we're formatting this variable. Now we're achieving the exact same output between these two bits of code here. And so the nice thing, one of the things I like about it, in a very, very simple example, is if I was going to look at this thing and take a date format, well, which order are the parameters? Do you give it the variable that has the date value in it, or the format string first, right? Here it's really clear. This is the next week value, the variable. We know the format method, and there's only one parameter. And so this is where I like patterns better than non-object-oriented patterns. So let's talk a little bit, coming up next, talk a little bit about how we make one of these things ourselves. So now we've learned a little bit about object orientation in general. Now we're going to actually look at the syntax to build our own object. Now my goal in showing you all this is not necessarily so that you're going to write a whole bunch of objects. I just want to see enough of it to help cement the definitions of methods and attributes, classes, objects, and instances. So we'll start by taking a look at how you might solve a problem, a data structures problem, without using object orientation. And this is, in PHP for years, we could avoid object-oriented programming and complex data structures by just using arrays in super clever ways. And so let's just imagine what we're doing is we're creating a data structure about people. And they might have a full name or a given name and a family name. And so here we're going to have two variables of two people. And so the first one has a full name and an office. And the second variable, Colleen, has a family name, given name, and a room. And so we're allowing some variation within the structure because different people have different things. And so we want to write a function called get the person's name and take one of these as parameters. And what we basically look for is if there is a full name in there, that's what we're looking for. And if there's a family name and a given name, we're going to concatenate those two things together with a space. So this is just a bit of code so that we can tolerate different structures in these arrays. And it's a really simple example. And so we're going to say, what is get Chuck's person name, and that gives me the full name, Chuck Severance, pulling this out here. And then get me the person name for Colleen. Well, Colleen is different, but it still concatenates those two things together and gives me a blank. And so we don't have to worry in our main code what format these two things are in because we're sort of compensating for that. And this is one of the things that objects allow us to do is sort of capture things and just call a function to take care of the work, and so we don't have to write if statements or anything like that. Otherwise, we'd be putting if statements down here, yada, yada, and it'd be 4 or 5 lines of code every time we want to do it. So we put it in a function and reuse that. Of course, this is a pretty silly one. So let's just look at how we might do that in an object. And this introduces the notion of attributes. So we are making a new class. So if you take a look at the new class, we have a new keyword called class that's like the word function, except we're telling it we're beginning a new class. And so we're going to create a class called person, open curly brace, and then we can have some variables in here. And we'll talk more about the public stuff. What public means is this variable can be accessed by code that's outside the class, not just inside the class. So we're going to have a full name, a given name. Now you'll notice these are not strings. We're not really making an array here. We're making an object. And so full name, given name, and family name, and then room. And then we're going to add a function, and we name it differently. This is going to be a get name within person, right? And so we don't have to have the functions quite as long. And we're not even going to put any parameters in because the data is already part of this object. And so this variable, $this, is a special variable. You don't have to define it. It actually points to the current instance of the object, and it'll make more sense a little bit lower. So get name checks to see if the full name is not false and returns it. If the family name and the given name are not false, it concatenates those two things together and returns that with a space, and away we go. Same kind of basic logic, but the big deal is the this, and that's to look at these variables, but they're not class variables, they're instance variables. And this points to the current instance. Okay? Points to the current instance. So now, if we come down here and say, let's make a new person. So this new is the construction. Take the person template, make a thing that's shaped like this. It's shaped like all this. Make one and stick it in the variable Chuck. And here's a new little operator. Chuck arrow full name is changing, so now there's a Chuck variable out here, and there is a full name inside here, and we're putting something in that full name, and we're putting something in the room, putting something inside that. Now what we're going to do is make another instance, make another object from the class/template. Make Colleen equals new person. So that means let's make a new Colleen variable, and it has all these same things in it, has all the methods in it, and we're going to put the family name in and the given name in and then the room in. So now at this point in the code we've got two variables, two objects, two instances, one class, and now we can say let's get the name from the Colleen variable and then let's get the name from the Chuck variable, and it does all that same thing. And so if we look at what's going on right here, this runs this code, get name runs. And at this point in time, this is equal to Chuck. So Chuck is out here, and Colleen is out here. This points to the current one we're using. It's this one here. Okay, so we're calling get name within Chuck. While that get name is running, this points to Chuck. A moment later, we're calling get name within Colleen. And when that code runs, this points to Colleen. Okay, so this is sort of like whichever the current instance or object. Instance and object are the same thing. Class is the template. Instance and object are the same thing. Okay? And so that is kind of like how the object-oriented stuff works. And we'll kind of hit this a little bit more, but you get the basic idea of the arrow operator, the new operator, and the concept of this. $this is a variable that is only defined within a method inside of a class. That's why methods and functions are different. So let's also, now that we sort of know some of these new ideas and we've seen our own class, let's take a look at some of the kind of things that will happen as you're reading PHP documentation. So we've already talked about the little arrow operator that basically says go find the method or attribute within this particular instance. But there's also a way to access things inside the class, and that's the double colon operator, colon colon. Okay, and so these two things are important, and so let's take a look at some documentation. So if we look at this date time again, we see some constants. And so these are constants that are given to us by the class. And so there's Adam, they're namespaced. That's, to me, 80% of the fun of this is namespacing. So we can name something whatever makes sense. A cookie formatted date. The word cookie has all kinds of meaning in HTML and HTTP and all these other things, right? But we can use cookie, datetime colon colon cookie. These are class-wide constants. They're not methods, and so this is the class name, not an instance name. This is go look something up in the class, and that's the thing we're looking up, and so that grabs this RFC 822-bit, which is really just a predefined string that pulls that stuff out. So double colon accesses class-wide things that are part of the template, not part of the instance slash object. Then another thing that we look at is there's a couple of methods that have special names. And so the first one we'll look at is the one that's underscore underscore construct. That basically says is when PHP is going to construct a new date time, call this function. And we'll see how to do that in a bit. So it's the new operator that goes to construct. Now when you're reading documentation, it just means that you can read all the parameters that you're allowed to have. And you can see, oh, I could do a date time, I can have a string, I can do this, I can do a date time for a particular date. And you can go read this documentation for the construct method, and it tells you what you're allowed to put in the parentheses when you're making a new object from the class template. Okay? So underscore underscore construct documents how the new operator functions. Don't know why they didn't call it underscore underscore new. That's a good question to ask. Another thing to look at as you look at documentation is the notion of static. And static is a way that you can mark something as, in a sense, belonging to the class, but not to the instances. Well, actually, it also belongs to the instances as well. And so, let me clear this. When you see static, that kind of is in the way there. When you see static, you get a... You can call this function, this getLastErrors function, you can call it with the class name. So datetime colon colon getLastErrors. And so this is a way of creating global library code that can be run from the class, but we're taking advantage of the namespacing of the class. And so it's common to have a number of things called getLastErrors, but that's getLastErrors within the datetime class. Now the key difference when you're writing a class, which we're not going to write too many of them, is you can't use $this in static code because it's running without an instance existing, and so that you can just run it. And there's also static variables that you can put into a class. So the simple thing from reading documentation is when you see that word static, you expect that you're going to call it this way with the name of the class, colon, colon, then the method name, rather than, $X arrow method name. So, another thing, here's a normal method. It's not a static method, and so we're going to access this method using the arrow. So we make a new date time in the variable z, and then we access the format method. And you can see the parameters that you're allowed to put by reading the documentation. that has those things. And so you go in PHP document, click on that, and then you go be able to read what are the kind of things that you can pass in as parameters to this function. There are some really cool things. Most of what I just talked about, the concept of static and methods and class-wide static code, that's common across most OO languages. We'll see that over and over again. There are a few little weird things that are really quite cool in PHP, having to do with object lifecycle in web applications. And so PHP's object orientation, PHP was one of the last languages to become object-oriented, and by the time it became object-oriented in PHP 5, it was already a widely used and heavily used and well-understood language, and so there's some really cool features. I won't go into them, but anytime you see one of these underscore methods, it's usually sort of part of the bookkeeping of objects themselves. So up next, we'll talk a little bit about object lifecycle. So now I want to talk a little bit about object lifecycle. The idea of the object lifecycle is we define a class and then we start making objects / instances. And we want to, within our class code, jack into or hook into the moments where objects are being created and objects are being destroyed. And we call the moment of object creation, the new operator, constructing the object. And that's because it reads the class and then makes the object. And then says, here's your variable. Constructors are used a lot because they nicely preset things, and you want some internal consistency in your object, so you set things up. Destructors are seldom used. They're only used if we have taken some critical resource while the object was alive, and we want to make sure to give that critical resource back before the object variable goes away. So the primary purpose of constructor is to set up instance variables that have all the proper initial values so that the object is created in a coherent way. And so let's take a look at how this works. So we're going to make a class, and this isn't really going to do much of anything useful. We're going to name our class party animal, and we are going to create a special function. I mentioned before that underscore construct is our bit of code that jacks in to when the variable is being created. This is just a normal method, function something. The indenting is not so pretty here. And then function destruct is saying, hey, let us know, let us run a bit of code, and we're just going to put an echo statement in so we can take a look at how that works. Okay? So we say echo 1, right? And we do a construction. And so what the construct does, the new operator causes this to run. So out comes the word constructed, okay? And then we print out 2, and then we construct the second one, which runs this constructed code again. Then we print out 3, and now we call the method, so we've got 2 variables, x and y, running here, and we call something, so it runs this little bit of code in, and $this, in that case, THIS, it points to $x at that point, and it prints that out, and then we're all done. This is the end of the program. And so we print out the end. But then what happens is work happens after the end of this program where $x and $y are being wiped out and thrown away. And because we have registered an interest in the moment of destruction, we are informed of that. And all we do is print, hey, we've been called, but that is when PHP is deallocating our objects and throwing them away. But I mentioned that construction is very commonly used and destruction is rarely used. I just put that in to show how we in the class can ask PHP to do various things on our behalf. So I've already shown you that you can have many objects from one class. Each object has its own distinct variables, and we just make these with the new operator over and over and over again. And so here is another object, and we're going to actually take a parameter. We're going to have one variable called protected, and what protected means is that it can't be accessed outside the class. So the other thing we had was public, which we were able to mess with public. And so this is, the code in here is inside and this code out here is outside. So what you can't do is you can't say hi dollar hi lang, because lang is something that is the domain of the class itself. It's an internal variable and we just don't want anybody messing with it. Now, the outside world will need to set it. So what the outside world can do is on the constructor, it passes in the language that we're interested in, and then we store it in this lang, and so the hi variable is out here. And then we put the language in, ES is in there. We can't touch it, but we have set it. So a lot of the things that constructors do is set up the initial values that the class needs to function. But now it's in there. So we have made a hello gadget that knows Spanish, that knows that we're interested in Spanish. So when we're saying, hey, do this greet code, it doesn't need a parameter, right? We don't have to pass a parameter in because hi already knows that Spanish is its language. And so it just looks in the instance, pulls out the language, and then does the logic the way it wants to do the logic. Okay? And so that's passing in a variable in the constructor that's copied into a protected area inside the class, but then used inside the methods. So protected means it's okay to use it here, but it's not okay to use it there. So again, hitting on all these, class is a template, method is a function that's inside of a class, an object is the actual thing it's a variable, and the constructor is that which you call the moment it's created. So the next thing I want to talk about is how we do inheritance from one from one class definition to the next class definition. So the next topic is inheritance. And the idea of inheritance is you take a class and you want to make a new class. You can think of it as extending it and adding a little bit of special sauce to a class. And it's a really a good pattern, much like functions, of not repeating yourself. If you have some functionality in like a base class or in like a core class, and then you're going to specialize it a little bit. It's just another form of how not to repeat yourself and how to structure your code. Now, a big problem that people have when they do object-oriented programming is they figure that if they're not doing inheritance, they're not cool. And I will say that's absolutely not true. If you go for 5 years and you never do inheritance, it's important to understand it, but don't feel bad. You could write objects, you could use objects, and never do inheritance. You're using inheritance when you're using library code, because we use it a lot. When the day that you start writing a sophisticated piece of library code for other people to use, you'll be like, oh, thank heaven for inheritance. But don't feel like the goal. I mean, one of the biggest mistakes people make in object orientation is just trying to like overuse inheritance. So understand it, but don't feel like you got to show off and use it just to use it. So we have a parent class and child class. The child class inherits everything from the parent class except that which is overridden or added in the child class. Another word for this is subclasses. It's class and a subclass. I think of it also as extending. In some languages like Java, they use the word extend to say extend this thing. Okay, so here we go. So let's take a look at that code that we wrote before. And again, this is a silly example so that I can fit them on a screen. You know, I don't want to... But remember the class hello from before. It's got a language. We construct it and get the language, and we have a greet, right? And so now what we're going to do is make a new class. So that class is there the way it was all along. So just assume that code's there. And now what we say is class social, new class, extends hello. So what that basically does is that pulls in all of hello. The language, the attribute language, the constructor, and the greet method is all pulled in. You don't have to repeat that at all. And we're going to add one function, a function called by. And so this is the logic for the function by. And so now we can create a new social, passing in ES, which is really calling this constructor that's been inherited from the hello. And then we've got a hi variable, hi, and it's got a greet method, but this greet method has really been inherited from the hello. And then we have a by method, and that is the part that we've added in the social class. And so that's how that works, is that it really is pull all this stuff in fill up that class with all the stuff that's in the hello class. You could still make a hello object or a social object. Hello didn't stop existing because we added it. We just copied it and then extended it. So inheritance is the ability to take a class and make it and extend it to make a brand new class without harming the first class in the first place. Now I want to talk a little bit, now that we've talked about classes and inheritance, about the more sophisticated bit of visibility. I've told you about two levels of protection. One is public, which means that the variable can be accessed inside the class and outside the class. Private means it can only be accessed inside the class. That's the new one we haven't shown before. Protected means it can be accessed in the class, not outside the class, but in any derived class, in any child class, in any subclass. So that's protected. And so I used protected earlier, but private is the most protective thing. Protected means I'm sharing this data with subclasses and not the outside world. So let's just take a look at some sample code with protected and private. So here's a class. We got a public variable, we got a protected variable, and a private variable named pub, pro, and priv respectively. And so in this code, inside of a method that's inside the class, you can look at and touch the protected. You can touch the public, the protected, and the private. In the main code, this is the outside. So again, this is the inside the class. This is outside. And part of this is so the class can sort of build a protective barrier around itself and say, look, I'm going to let this little bit here sneak out so you can see it, but I am not going to let you see these things. You cannot see them. I'm hiding them from you. Okay? And that's mostly because it doesn't want this outside code that might not understand what it means to change that variable to be changing the variable. So just please don't change the variable. Well, you're not allowed to change the variable. So a public variable can be read, it can be modified outside of the code. But a protected and a private will blow up. It'll just fail, right? And and print hello is a public function. You can actually make private functions and protected functions as well. Methods. Okay, so now assume all that. We've got my class with pub, pro, public, protected, and private. And now we're going to make a subclass, an extension. So we're going to extend it by extending my class, importing all of the attributes and methods into my class. And we now have print hello. This print hello is not the same as print hello here. We've actually overridden it. And so now we have imported everything from this class except print hello we're going to define differently in the subclass. And so within print hello, we can look at the public stuff, we can look at the protected stuff, but we cannot see the stuff that is private in my class, right? We can look into the protected stuff in my class and modify it and touch it and look at it, but we can't look at the private stuff. And so private means I am putting such a wall around this data that even if you make a derived class, you still can't see this variable. And don't worry so much about why, just understand that there is this notion of wrapping data and having different levels of protection for that data. And when we make a new class here, we can still access the public data. That public data was originally from my class, not my class 2, but that works. But of course, the private and protected cannot be seen here in the outside world. Okay, so that's how that works. Don't worry too much about it. I really am more interested in you understanding the concepts. And the last bit I want to talk about is something that I don't recommend. You know, these days we mostly make classes exactly the way I just showed you, but a lot of older code would actually construct objects from scratch without having a class. So this is kind of a class. This is an object without a class, okay? And some people prefer this over just putting a bunch of keys, string keys in an array, because it's a little cleaner. It seems a little tighter than just strings. And so here we go. And there's this thing called STD class, standard class. And so what it does is standard class is like a class that is empty. It has no constructors, it has no attributes, it has no methods, okay? So you make it and you have a class. And so what happens now is there is a object called player out here. Right? There's a player object, and we start putting stuff into it. We start changing attributes, right? So we can make a name attribute and stick Chuck in there, and we can put a score attribute and make it be 0. We can add 1 to the score attribute. And so what's happening is there was nothing defined here. It's like an empty class, and we're defining it as we write our code. We're just creating variables inside of it. And so that's one of the things is you can take and put variables inside, attributes inside classes if you really want, right? And so there we go. So that's a class. If we were going to define the class, we could do something like this: class player. You know, there's a name variable and a score variable. But this is sort of inventing it from scratch. And so here, in the non sort of from scratch, you just make the class, you construct the class. The class has 2 variables in it, and then you can do things like access the attributes and print them out. So you can kind of achieve the exact same thing by defining a class. This is kind of old school, and so the older the code is, the kind of less it feels comfortable about classes, and it sort of treats classes as a variation on associative arrays. The more modern stuff, and increasingly you're going to see people really defining the classes and putting the attributes and the functions and the methods right in those classes and doing all that stuff. So I would totally understand if you watched all these lectures and be like, oh, object-oriented programming just scrambled my brain, because that is a completely rational answer and reaction to the first time that you see object-oriented programming. And so all I'm doing here is desensitizing you to object-oriented programming. I'm not expecting you to be a whiz. I'm not going to ask you to write objects. All I want you really to be able to do is read object-oriented documentation and construct PHP that makes use of objects. So we're going to be using PDO and other kinds of things in this class. And I want to be able to say, it's the PDO class. And then there's the connect method and the XYZ method and the attribute that's this. And it's a static attribute, so that's the : operator. I want you to be able to look at code, and I want you to be able to look at documentation. And that's really what my goal was. But these concepts of templates and instances and inheritance are powerful and profound, and if you go far enough in programming, you will come back to this and you go like, oh, I'm so glad that they built that stuff. But that's not here at the beginning. So I hope this was helpful. I hope you took out of this what you need. Don't feel like you need to master this. Just kind of understand the terminology, okay? See you on the net. Hello and welcome to my lecture on MySQL, PDO, and PHP. Now, if you've been coming all along and listening to all my lectures up to this point, starting with HTTP and HTML and SQL and PHP object orientation, and you have been sort of learning pieces, and this is the place where it's all going to come together, and I can use all those words that we've taught. Now, if you're watching this for the very first time, you might want to go back and watch those other things to kind of catch up, because the words, I'm just going to start using words that I hope to have covered in the previous stuff. But if you are with me and you have been with me all along, then congratulations on getting this far. Let's kind of do a little happy dance. You can do happy dance too. You're here, you've worked hard. You can actually now start connecting all the pieces here, like a high five to the television. There we go, we got a high five. So let's bring it all together. Accessing MySQL using PDO. So here is my favorite diagram. Someone will probably make a much more beautiful diagram, but it's got to capture all these things about the browser and the web server and the database server. We are now going to do what we wanted to do, and that's send a request. It runs, it's going to run some code, and this is what we're going to do for the first time. We're going to use the PDO library to make another connection to the database server, send some SQL across that connection. SQL is going to do magic, super awesome magic stuff, which we love, and send us back what's called a record set. And we're going to write a loop that reads through the record set and then slowly but surely produces HTML. HTML will come back, and then we'll have a page. And so for the first time, we're going to have dynamic content showing up on the screen that ultimately came out of a database. So if finally we're going end to end. We got a lot more to do. JavaScript, we haven't started talking about JavaScript. That's all sort of here, magic in here. So, but we're not doing that. What we're doing is finally making it all the way in, and PDO is what we're going to talk about today. And the other thing that we're finally doing is we're finally sort of finishing this diagram that we started with, and that is how these web dynamic content web applications work. And that is, there's application software. In our case, we're writing it in PHP, and it does the request response cycle, and it talks to the database and sends the HTML back. And the developer builds this code. You're the developer, you're building this code, and the database administrator talks PHP myadmin. So we've kind of done this bit, we've kind of done this bit, we've been writing PHP code, but now we're going to finally do all the way in and all the way back out. And so all these things are going to finally connect together in this picture that we did days, weeks, or months ago. Okay? So, I often tell you that PHP is evolving. That's one of the things that's charming about PHP. It's evolving in a way, and lots of languages are evolving, but PHP is very good at letting you have backwards and forwards compatibility of stuff. If you want to do something a little early, you can by sort of pulling it in, or if you want to keep something that PHP took out, you just check to see if it exists and you bring it in. The way database in PHP 5 was accessed has been changed. Prior to PHP 5, there were these MySQL underscore routines. And when we talked about object-oriented, I said everything, when you don't have object-oriented, you prefix them. And so they had MySQL underscore, MySQL connect, MySQL query, MySQL underscore this. Well, when object orientation comes along, they're like, oh, let's use object-oriented patterns because we can namespace all the functions. And so the first thing they did is a library that I don't like very well, I don't like this very well, and I don't like this other one, which is really kind of a almost one-to-one correspondence between taking out the prefix and making it an object, which you could do kind of like what they did with the date underscore and the date time object. But they also took the opportunity to kind of rethink from scratch the right way to build a database. And they were informed by lots of things in this. They were informed by Java, a thing called JDBC in Java, and other database patterns. And they wanted to be portable across multiple languages. It turns out if you wanted to talk to SQL, you had a set of SQL functions. If you wanted to, SQLite used SQLite functions. MySQL had MySQL functions. PDO, which the portable part, means that it works for Oracle, it works for MySQL, it works for SQLite, works for SQL Server from Microsoft, etc., etc. And data objects means that it's both an object-oriented pattern for its API, but it also returns you the record sets in a more object-oriented way. I could go on and on and on and on about how wonderful PDO is. I'll just say PDO is wonderful. The things I did before, I kind of understood when we first looked at it. Like, oh, PDO is different. I'm so used to this other stuff. But boy, once you start to use it, you're like, boy, how could we ever have survived with that old crappy MySQL underscore stuff? And so you can look on the internet the different things. But I'm not gonna pretend that there's a debate, because as far as I'm concerned, if you're not using PDO, you're foolish for a lot of reasons. We'll talk about some of those reasons as we go forward. Okay, so the thing you're going to have to do is you're going to have to make a database, and you may have done this already, or make a brand new one. So just create your database, MISC, and then the thing that you haven't done before is these grant commands. So these are things that you type to your MySQL, and what you're basically doing is taking all the tables, misc.star, all the tables in that MISC database to an account. You can put anything you want in here. At localhost, this is kind of IP filtering so that you can't connect to these things outside of your computer, and that's really good to make it so your MySQL is not exporting your data to the internet. And so this is basically limiting that says this Fred account that I'm making can only be used from localhost or 127.0.0.1. These are kind of two of the same things. And then this is a password identified by grant all on MISC Fred. So this ends up being the ID and the password. Sometimes MySQL sees it as localhost. Sometimes it sees it at 127.0.0.1. You probably need one or the other of these two things. I just put both in because I don't want to bother figuring out which one I need. Okay, and then you're going to switch into that database. So we're going to make some tables. And so make your database, drop MISC and recreate it if you want. Then we're going to create a table. and we're going to just do a basic table. By now, I hope, I mean, it's been a while since we've done SQL, but I hope you sort of remember it, right? We're going to make a table called users. That's the name of the table. We're going to have some columns in there. We're going to have user underscore ID, which is the primary key. We're going to have name. We're going to have email and password. All are 128 characters long, and we're going to do an index on email. That's kind of our way of saying logical key. Email is a logical key. In ODB, this is the thing that makes the foreign keys, the enforcement of foreign keys work. And then we're going to say char set equals UTF-8, so we can put in non-Latin characters and have it be okay. And so just go ahead and create yourself a table. If you don't remember how to create a table, go all the way back to the SQL lectures where we did that in great detail. So now let's put some users in, insert into users, name, email, and password. Here we've got Chuck and the password of 123 and Glenn and password of 456, right? And so we've created some records in our user database, and because it is we have this auto increment field, we're getting effectively a primary key for csev and gg@umich.edu. So what we've created now is sitting on our MySQL server. We've got a database named MISC with a table of users, and we might have other databases, ... with lots of tables in them, and that's fine, because MySQL just kind of isolates them. And so now what we're going to do is we are going to show you how to, in effect, log into that database from PHP. Okay, so you're in the middle of a PHP request, and now you want to log into that database. And you do this with an object-oriented pattern. So I'm naming my variable PDO. This could be $X for all I care. It really doesn't matter. Dollar whatever equals new PDO. PDO is a class. See how useful that object-oriented lecture is? PDO is a class. It's a template that's going to give us back a variable. And we give it 3 parameters as part of its constructor. The first is a connection, what we call a connection string. And that's defined. You can go look up the PDO documentation. In this, it says we're going to connect to a MySQL database. The host is localhost. In production, usually the database is on a different piece of hardware than the application, but on your laptop, it's going to be on the same. So localhost is like, oh no, we're not going to a whole different database server, but you might, in production, put this as something quite different than localhost. And then you have to tell it what port, because this is really kind of a TCP/IP connection that we're doing here. And if you're on a Mac with MAMP, it's port 8889. And if you're on Linux, or if you're on XAMPP, or on sort of a normal, 3306 is the normal default, and MAMP's weird default is 8088. Then you have to put the database name, and that's what name of the database, because you can remember, you can have lots of databases, and we've seen that when we're playing with PHP-myadmin. And then you have to give the password and zap. And so this ends up being just one line of code in PHP, and that makes a connection through which you can then send commands, SQL commands. Now you know SQL already, but now we're going to have PHP make a select or whatever, delete, insert, all those are going to be sent across this connection. So this variable represents, much like open file, the variable represents our way to access and send data to this, send commands in the language SQL, and then get results back through this PDO connection that we've made. But it's like logging into a system. And you're going to log in every time you get a new request response cycle. One of the first things you're going to do is log into the database, and then down there you're going to send commands and get the data back. And we'll see how all that works. So here is a super, super simple first application. So this is a PHP program. Right? So it starts with less than question mark PHP. I want a pre-tag, okay, just so that everything looks pretty. And the first line is make a connection to the database with these parameters. Fred and Zap are the account and the password. And then now I'm going to call the query method within the PDO, the $PDO object, which is in my variable $PDO. And I just pass in some strings, the same strings that you might type into PHP-myadmin or the MySQL command line. You just send it. So that's sending it to the database over that connection that you've made. And then what comes back is a record set. And so we get back this record set that we can access using this $ statement. And this is kind of like a file handle. It's a handle to a record set. You're going to loop through it. It's going to have a fixed number of rows. You're going to be told when you've reached the last one, and you're going to read it one row at a time. So every time you call statement fetch, the fetch method within the statement record set, And this is how to fetch it. Just for now, we'll leave that alone. We'll talk about that in a little bit. So each time you call the fetch, you get a new row. And if you run out of rows, you get false. And so we've kind of cheated here in that we put this in a while statement. So it's either going to get you the next row or it's going to be false, in which case it's going to leave the loop. Okay, so you could put this like a parenthesis, not equal, false, but that's kind of implied. So well, I had one too many equals there. I'm sorry about that. But it's kind of implied there. This both runs the loop as long as there are legit rows there, because row is not false when it has actual data. And then all we're going to do each time through the loop is we are going to print the row with print R. And then this will run however many rows that this select statement gets from the database, and we're printing it out. So give me a row, give me a row, give me a row. We're done with rows. Okay, stop the loop. That's what's going on here. And given that this is what's in the tables, this is what we see. And this is, to me, the lovely bit of this fetch associate is each row is an associative array with a key value pair, where the column name is the string key. So user ID, name, email. So those are really strings. It doesn't show you the quotes, but those are really strings. User ID maps to 1, name maps to Chuck, email maps to CCBY, password maps to 123. So this first row right here comes back to you as an array. And we're going to do more with that row. For now, we're just dumping it out for debugging. Then it goes up and runs again, and then it goes up and runs again, and then it gets this row. And it comes in, and then it prints that out. So we see that bit right there. The primary key is 2, the name is Glenn. And so it's as if we're reading a file or reading anything. We're getting a set of arrays, one array per row. There's also a thing, I think, called fetch all, which gives you an array of arrays. And it's not a bad way to go about it, because you're not really supposed to fetch trillions of things through a single select statement anyways. So that's kind of the simplest example. And when you're doing this stuff for the first time, stick with the simple examples. Don't get too complex. Okay. But generally, we don't want to write applications that have a pre-tag and print R as their data. And so this is all the stuff above this. From here up, that's identical. And from, well, here down it's not. Well, not quite. So we're gonna print out a table. So we're printing out HTML table border equals 1 new line. Prints this line out. Then we're going to do that while loop. And each time in the loop, we're going to print out a TR and a TD. Then we're going to print out the name. Then we're going to put out /TD start TD, which is this bit right here. Then we're going to print out the email. Then we're going to print out /TD start TD. Then we're going to print out the password, 123. This is a very secure system, prints the password right out. It's beautiful. It makes it a lot easier. And then we end the TD and the TR, and we throw a new line at the end, so it looks pretty. Then we go up, grab a new row, and do the same thing. And then when we hit this the third time, this becomes false, so it comes out and prints /table. And that renders like this. And so this idea of go to the database, get back a record set, loop through the record set, generate HTML, that's what we're doing here. We are reading the record set, and we are using with echo statements, we're transforming it into HTML. Now, in more sophisticated environments, you have templates that do this transformation, etc. And so yeah, there are different ways to do this, but this is the basic idea of taking a record set and turning it into HTML. Okay? After a while, you just send a select statement and then work with the data and do anything you darn well please with the data. Add it up, print it out, who knows what you're doing, right? You have all the power at that point. It's a simple concept and absolutely beautiful. So one of the things as a pattern that we do is we don't like putting this stuff at the beginning of every file, because you literally will eventually have 10 or 12 files and they will all want to make a database connection. And so you don't want to put the password in every database, every connection. So we refactored this code a little bit and put it from one file, put part of it into one file and part of it into another file, and use include. So it also makes it so you don't, if you're using GitHub or something and checking it in, you don't want to check your database password into GitHub, because that's kind of a security hole, especially if people can read your GitHub. And so the thing we then do is we take the PDO bit and we pull that into a file like pdo.php. And all we do is we, do something, maybe a side effect of the PDO. Now this set attribute, we'll explain what this is. What it really is, it's kind of like display errors. It's saying, please blow up when I make a syntax error in my SQL, because that's not the default. The default is to keep going, which if your SQL is bad, and what I mean by SQL is bad is like your SQL that select star from users isn't right. So you don't want to do that. So I just put this in. It's just a nice thing to say, look, if I make a mistake in my PDO, please totally blow up, because I'm mostly developing. You can change this perhaps in production, but in developing, that's like display errors. That's like quit now, give me some detail as to what I did wrong, tell me what's going on. But that's not what we're doing right now. What we're doing right now is we're just saying require once PDO.php. We're putting on a pre-tag, we're pulling this in. Require once.pdo.php. So in third.php, there's one of these and many of these, right? So this is like whatever, your this and your events and your book and your whatever, right? Bunch of stuff. So each file that wants to have access just says require once pdo.php, and you only put the password in once, and then the rest of this stuff is exactly the same. And so you have 3rd, 4th, 5th, 10th, 11th, and they all just require pdo.php. I probably talked a little too much about that. Okay, so up next what we're going to do is we're going to actually insert some data from PHP into the database. So welcome back. We just showed you how to do a select over a PDO connection to your MySQL database. But that's not the only thing we want to do. We want to insert, we want to delete, etc., etc., etc. So now we're going to talk about some code that's going to do a little more sophisticated SQL. The basic idea of making a string and sending it to the SQL database at MySQL server, that's going to be the same. We're just going to see examples of how we might use insert or delete, etc., etc. And you should probably be downloading all this code and looking at it. The slides really don't do it justice, but I kind of cover everything in the slides, and then I go back and re-record little videos that are just showing the code and show the code as it's running. So I go through them once in the slides and then once in sort of code demos. But you probably want to have the code up in a nice syntax colored text editor and see what's going on. So this is user one, and I always have these little things here down like this to say, oh, it's user1.php, so you know that if you go pdo.zip, and it's user1.php, and so that's what I'm working with, okay? Now this assumes that we have a pdo.php, so it requires it. So you'll see this pattern from now on that I don't put the PDO connection in, I just put it in one little file, and then I require it all over the place. So this is now going to do the model view controller stuff, and so like any model view controller application, I have this line above which is like the model, and below which is the view, the model and the view, and the controller is all these decisions and redirecting, etc., and routing, etc. And so what's going to happen is the first time through, this code is going to not be a post, it's a GET request, so it comes straight through, and it produces this output right here. It produces a form with a post coming back and a name, email, etc., etc. And so that's what happens when we do the GET, the first request. So there's 2 request response cycles that are going to happen. So it first paints it, then we type in this stuff, type, and then we press the Add New button. And when we do that, that causes, oh, I want to change the color. That causes another request, and this time the post data. So we're going to use isSet to say, is there a name field in the post data and an email field in the post data and a password field in the post data? That means that this stuff got filled in, right? Then this is the code that deals with the incoming post data. That got skipped the first time as we did the GET request. And so then what happens is we write some SQL. So we say insert into users, parenthesis name, email, and password. That's just a list of the columns. And then values equals, and these are little placeholders, colon name, colon email, colon password, say these are the values that we're going to read. Now, those are placeholders, and I'll print out the SQL, and that causes this to print out right here. And then we do what's called a prepared statement. So instead of running the query directly, we say, we pass this SQL, the insert statement, we pass it in and say parse it and read it and figure out where the little placeholders are. And then we have to do it in 2 steps. We say execute, and then we pass in as a parameter, The name maps to post subname, email maps to post sub-email, password. This, I could have made this be X and L and M, and then this would be M, L, and X down here. Oops, X. I happen to call it name, email, and password, and they happen to have the same name as these things, but it's not automatic. The placeholders, names are stuff you come up with, and these values right here are effectively from the form. So, what that does is that basically puts this data in here, this data in here, and this data in here. And then when we say execute, it actually sends that insert statement to the database. Okay? And so it right in here, at this moment here, it has done the insert, doesn't say anything, and then it falls through and puts out the form again. So it comes, we don't do anything here, we just kind of fall through and put the form again. So that's basically how user 1 works. It has this sort of model view controller. We run the code twice, right? We run the code twice. Once is a get and bypasses this that prints this out and prints out this. Then when we push this button, it runs the code again and comes in, and now these things, this code's triggered because those ifs are all true, and it runs through and runs an insert statement pulling the data from the form into the database. And so now those 3 values are now in the database. And so there we go. We take a look, and we take a look at our database, and we've got a 3rd record. And of course, we didn't have to do anything with the user ID because that's an auto increment field when we define the database. It's the same. The SQL you send from PHP is identical to the SQL that you would type in PHP MyAdmin. It's just identical. It's beautiful. I just can't get over how awesome it is. Okay, so now we're going to take a little bit of different tack on this, and what we're going to do is we are going to add a little pretty output. So it's not that different. Most of it's the same. This part up here is the same. If you look, it's the same. It just is the thing that checks to see when the post happens, away you go. But now what we're going to do is add this little part here, okay? And so we're just going to do a select, name, email, and password from users. So this is going to grab those 3 columns. We're not doing the user ID yet. And we're going to have a loop. We'll print out a table, and then we're going to print out table rows, 1 for each row, and end the table, and that's going to print this little bit out, right? So this is what was in a get request comes in, skips this part, then it prints out the 3 things in the table, and then it continues on, and then it puts out that form with a submit the way we did before. And so you can type a new thing in here, a new thing in here, and hit the submit button. It runs here, it does an insert, and what will happen is you'll see a little 4th row there. It'll look exactly the way you want it to look. Okay? And so this is just, now we've added a dump in a table of the contents of a dump of that table in a dump of the database table into an HTML table. The word table is being used too many times. Okay, so now let's look at how you might delete something. And so what we're going to do is we are going to make a little delete form. It's going to, we'll start just with this little form, just so you can take a look at it. And it's going to get the PDO connection. It has a little bit of code that it skips, you know, if it's a GET request, and the GET request just puts this screen up, and there is a user ID, a delete button, and we put in some ID, like 3. And then we hit the submit. We put the word delete on the button, so we hit the submit, and it runs again, and this time user ID is set. We say delete from users where user ID equals :zip. :zip is again one of those placeholders. And we do a prepare of that, which parses the SQL and sees if we did something horrible. And then we're going to execute, and we're going to say, okay, please take the post date of user ID, which is this 3 number, and then put that in here. So that effectively puts 3 into that right there. And then it runs it. And so that is what then deletes user ID number 3 from the database. So you hit that button, and it'll delete that. Okay? And so it runs, and you can see it prints out the SQL here, right? It deletes the user, it runs the delete, user ID equals zip. It doesn't show you that little 3 number, but it does it. And so then you take a look, and poof, user ID 3 is gone. Okay, and so that's how you run a delete. So now let's do user3.php, and this is just playing with the HTML. Okay? This is just playing with the HTML. So if we look at what we're going to try to do here, we're going to have a table. We're going to have a form to do the add. This code we've seen before, but what we're doing is this little del trick, little delete trick. Okay? So we're going to construct some HTML in that table cell. Literally everything else in this next program is identical, except we're going to put a delete button on the row. Now, these aren't very pretty, but you can make CSS and HTML to make them prettier. I'm just starting out making them crude to keep it simple. Okay, so what we have is we have the, up above there, we have the insert code up there. We have the delete code that we pulled in from that del code. And we have the table code that we haven't changed at all. This first 3 lines of the table code is unchanged. We pull the delete post handling, and the insert's up there too. It just, you're not seeing it here. It's, if you go into the user3.php, you'll see the insert code and the delete code. The delete and the insert code are different because it knows that there's a post of delete and there's a user ID. But the fun thing is how to get this little thing to come out. Oops, come back, come back. No. How to get this little guy to come out. And that is in a table cell. So we're table cell, third table cell. This is the 4th table cell. It's a TD and a /TD. And now I am going to put in the table cell an entire form. Okay, I'm putting a form in the table cell. I say it's a form method equals post, input type equals hidden. A hidden field is like a text field that doesn't show up in the UI. So in every one of those little table cells, the user ID, the name equals user ID, will have the value of the user ID, because this time I did a select asking for not just the name, email, and password. I also wanted the primary key for every row. And so then I print that out right here. So 1, 2, 3 will be that user ID. And then I put out a little input type equals submit with a name del and delete. And so if we take a look at this, and we look at the view source of this, if we look at the view source, it'll look kind of like this, right? So in that table definition, there's a form, there's going to be a hidden field with a value equals 5, whatever the primary key of this last added thing is, and this one will be like 1, 2, 3, 5. Each one will have, there's 4 forms on this screen, and this is just one of those forms. And we know which one to delete by it's different. So you can, actually is 5 forms on this. 1, 2, 3, 4, and then this is a form 2. So you can have many forms on a screen, and you kind of know with things like this what button is being pushed, right? So, so away we go. So we've got a little tiny form. When we click this button, it sends a post back to the user3, whatever it is, user3.php, right? It sends a post back, and then that post runs this code right there, and then does the delete. And then it falls through after the delete, and then it reads everything out. So if you hit the delete button, it will come back, and it will only show you 4 of them, right? So you can insert somebody, you could delete somebody. So you just play with this, insert, delete, insert, delete, insert, delete, until you really kind of understand what all that code is doing. So here is sort of the whole code bit for user 3. We start out with require pdo.php. We have the code that we got that does the insert, the form at the bottom. We have the little tiny delete forms that send to this. And because we've chosen our names and email and password have to be set for this code to execute, it knows whether to run this or whether to run this. So it only runs this when it's doing an insert, and it only runs that when it's doing a delete. And if it's doing a get, it doesn't do any of it. Just goes right by it. So this is kind of the model of our model view controller. And the little line is right there at the bottom. So we're about to switch from the model part to the view part. So this bottom part is the view part. Okay, so now we'll take a look at the view. The top half of the view, the first part, is that little HTML table. All right, so the HTML, head, table, and then we're going to do a query. Yeah, we're doing a little bit of work inside the view, which is a little tacky, but it's okay. We're going to do that. We can move that up and leave that in a variable and have it fall across as the context. But for now, we're just going to do a select. We're going to do a little printing thing. All this stuff here to print the little del button. That's the del button. Right? And then out we go. So that's the first half of the view, and the second half of the view is simply that form that is the form to add the new user. And so that, and then we're done with the entire thing and have a slash body tag. And so that's the overall outline of this user 3. So take a look at it and try to understand every single line. I try to keep them as simple as possible and take a look at how they work. So up next, we're going to talk about some of the issues on validation and security having to do with SQL injection. So we've seen how to read data from the database. We've seen how to send database commands like delete and insert to add and to remove stuff from the database. But it's probably just, I've been doing stuff a little bit sloppy, and I want to make sure we talk about some of the things that you have to worry about when you're taking data from users and using it inside your code. So if you recall, we talked about HTML injection, and the problem with HTML injection is if a user with ill intent, intentionally or even unintentionally, starts putting legitimate HTML into form tags and you simply echo that without thinking, they can sort of take over your background document. And usually they're not just putting out the word die, die, die. They're putting something like JavaScript in. And so if you are putting raw user input out, the browser parses it differently. The browser doesn't realize that this bit came from the user, and it's a problem. And so this is a danger when you don't clean up your data. And of course, the solution to that is HTML entities, which then turns that into ampersand quote and all those other things, which you talked about before. There is a similar problem with SQL injection. It's the idea that the user can type something. And this turned out to be a giant problem in PHP because it was so convenient in PHP to do the wrong thing. And beginning developers, PHP is a favorite language of beginning developers, so it was easy to make a mistake. Okay? And so PHP got a really bad reputation of highly insecure. It wasn't PHP's fault. PHP just made it really easy to be insecure. And as we talked about before, PHP is a language that expects that you're a responsible programmer. And actually they did some silly things in PHP 4 to try to solve this problem, and it was really bad, and they've undone that. But PDO, which I'm going to show you, there's a happy ending. They finally figured this out in like PHP 5, but they tried to fix it in PHP 4 and did a bad job of it. If you see things like strip slashes in existing code, then you're like, oh, that's from the dark times of HTML injection. But SQL injection is users who are trying to take form fields and do bad things to your database. So let's just say that you didn't want to do that two-step process where I did the prepare and the execute as 2 steps. That's good practice. But you say, oh, wow, PHP has this wonderful ability to use these $ inside of a double quotes. Wouldn't it be great and simple if I just did this? I just did a select statement with double quotes, and then I grabbed the email into this variable $E and the password in that, and I just put in a single quote inside here. Away we go, and so that'll just put the stuff right from the form fields right into this SQL, and then we're just going to run the SQL. This is bad. Bad, bad, bad. Really evil. Okay, so let's show you what happens. Okay, the problem is we are taking end user entered stuff, and then they can do things like they can take over our SQL. And it's even worse to take over our SQL because then they can break into our whole database. If they break into our HTML, they kind of can steal cookies and stuff of one or a few users that get caught by it. But in the database, they're in. They've got all your stuff. If they can get a hold of your database password and they're in and run generic commands on your database, you are in deep, deep trouble. So SQL injection is worse in a way. Not that either one is good, but it's even worse than HTML injection. So let's see what happens here. So let's say we've got our little user table here, right? And so we've got user ID, we've got the password, et cetera, et cetera, et cetera. And so we type in a person's email, and we type the wrong password, and we submit the login. And it basically says, using that code I just showed you, it says select name from users where email equals c7@umich.edu and password equals wrong. It simply take these two values and stuck them into that string, right? And then it does a select from that, and if it didn't get a record, then it says you didn't log in, right? Because it's matching both the email and the password. So that's pretty good, right? Worked just fine. That's a quick way to log people in. You do a query and then see if you got a row. And if you didn't get a row, you don't log them in. If you did get a row, you do log them in. That's kind of how login works. Okay, so what could possibly go wrong? So this, I haven't done anything evil. The whole idea of these injection attacks is that you're going to do something evil in these forms that you can sneak into the SQL and do a bad thing. Okay, so here is an XKCD cartoon. That's a very important cartoon. It is the canonical cartoon about SQL injection. I'll read it to you. So there is a mom, and she is making a call to the school. And she says, hi, or the school says to the mom, hi, this is your son's school. We're having some computer trouble. And mom says, oh dear, did he break something? And the school says, in a way. And the school says, did you really name your son Robert, single quote, parenthesis, semicolon, drop table, student, semicolon, dash, dash, question mark? That's the school. And mom says, of course, we named him Little Bobby Tables. And then the school says, well, we've lost this year's student records. I hope you're happy. And mom says, the very technically astute mom says, I hope you've learned to sanitize your database inputs. Or I would say, I hope you've learned an SQL injection lesson about how to do SQL injection and avoid it. Another way to say is, I hope you've learned to use PDO rather than doing string substitution to do your queries, okay? Or prepared statements rather than string substitution. Now, this is funny, and everyone loves this. I once met a student who changed their login name to null. So another fun thing to put into fields is null, because null is a keyword. And so if your name is N-U-L-L, but they use it wrong in the wrong place, then some things will behave differently for null. So I've met people who have actually tried to do this. There's things on the internet where people like create a license plate that's like semicolon drop table traffic or something, so that a computer will read this thing, do image processing on the text, and then hopefully they'll format the database of the whatever. But you get the idea. So, okay, that's a joke. I probably ruined it for you because I just am not a good joke teller. But the key thing is to put this single quote in, because the single quote is an active character, and they're expecting that this will be in some SQL, and then this will be the end of that, and then they're going to run a second SQL command. Semicolon, as we saw in SQL, allows you to run more than one command on the same line. Now, it turns out that they've taken this particular thing, meaning that PDO doesn't, unless you ask it to, respect semicolons in a single query. So they've kind of fixed this. You can't quite do this one. It'd be so fun if you could, but the modern PDOs and the modern databases, they don't let this one happen because it's just too bad. But we can still do bad things, and there are ways that they figure this thing out, right? And so remember here how we have this. We're going to make this select statement, and then we are going to, whatever the user types, we're going to put in right there. And what if I put in, P, quote, or 1 equals 1, quote. So I now, with no modification, have put in this bit right here, okay? And not that single quote, not that close quote. Sorry, let me start that over again. Let me get this right. From the P to the 1, but with neither quote. So the two quotes are part of the original SQL. And just like an HTML injection, that's not how SQL looks at it. It says the password, it's where the email is c7@umich.edu and the password is P or 1 equals 1. Well, 1 equals 1 is always going to be true, so this is always going to be true. So even though I don't know the password, I'm logged in. And so even though I can't use the semicolon trick to do really bad things, right? That'd be more fun. It'd be fun to say drop tables right here, but you can't because it doesn't look in this string. Semicolons are not respected in that string, even though they are respected when you're doing PHP-MyAdmin. When you're doing a PDO query here, it says, I think we're not going to do semicolons because it's so dangerous. And so you can tell it to do semicolons, but you can't But by default, it doesn't do semicolons. But it doesn't mean that this is without database, without HTML, the SQL sanitization, or doing this properly. What they want to do is they want to break in and figure out and log into your administrator account and then start doing all kinds of stuff with your administrator account, or figure out what your password is, or figure out what your admin password is, or figure out what your database password is by surreptitiously logging in. And so even though you can't quite drop the tables the way XKCD wants us to drop tables, so now that's the bad news. And prior to PHP 5, there was a long description about how to do this. But with PHP 5 and PDO, and this is one of the reasons that I'm like, don't use anything but PDO, this prepare statement that I've already showed you the pattern for does this perfectly. And so what happens here is we have this little place that's going to have the email and the password, but we have just these two little placeholders, right? We're not actually putting the text. And the prepare reads through and finds these little placeholders, and then it puts in the user data. But in this act of executing, it is doing stuff to this to properly escape it. Kind of like what HTML entities did for HTML, except we don't even do it. We just know that this works, meaning that this cannot suffer, if you're doing this, email and password cannot be used to do SQL injection, because the prepared statement escapes the data properly automatically, and you don't even have to escape the data. In the early days in MySQL underscore routines prior to PHP 5, prior to PDO, we had all these escaping routines that are kind of like HTML entities, but they were kind of ugly. You just use prepared statements, end of story. You don't have SQL injection. If you start concatenating stuff together, including end user data, then you're in trouble, right? Don't concatenate things together that came from the end user. Just use prepared statements. They're just another extra line. It's elegant, it's simple, it makes your SQL look pretty, you're not doing ugly concatenations, and so away it goes. Okay, so just use PDO, use prepared statements when you ever use it. So insert, delete, etc. Anything that you're putting user data in, you got to use these little placeholders, including selects. You might have a where clause in a select, where name equal or email equals EM. Well, this is a select, right? This one right here is a select. Even though this is a select, it's okay. We can get ourselves in trouble if we don't properly escape user input, even on a select statement. So up next, we're going to talk a little bit about more what'll go wrong. This is less about the SQL injection that we just got done talking about, and more about when you have syntax errors in your SQL. So like if you can't type select correctly, or you use a field that doesn't exist. And so it's a little bit tricky, and there's a lot of flexibility in how PDO errors are handled. I talked about this at the beginning of the previous thing when we set up pdo.php, but now we're going to look at it in some greater detail. So welcome back. Let's talk a little bit about how things can go wrong. Everything I've shown you so far is syntactically correct, but rest assured, as you start writing code, you're going to make various syntax errors. And there's a whole bunch of little error handling options that PDO has that we can play with. And so here is a bit of code. It's kind of like we're just doing this select. We're going to read a user. Select star from users where user ID equals whatever, and we're going to do a fetch. We're looking at how things go wrong. We're either going to say the user is not found or is found. And so, this is the default error mode warning. I'll talk about those in a second. And so this is going to work because this is the placeholder, and this is the placeholder, and there's a user ID. And whether it finds the user or not, it's not whether the user, the first thing to say is, if you do a select and you don't get a record, as long as the select is syntactically correct, then that's not actually an error. That's okay. You just get no row, and in this case you get a false row, versus a syntax error, like if you make a syntax error. So an example of a syntax error with this code right here is if, for example, I basically in my code I say :XYZ, and then in my little array I say :pizza. You will, at this point, it will blow up. It'll say, whoa, you don't have the right thing. It's not going to work. And so I couldn't find a thing that maps pizza properly. So it doesn't. And so that is the kind of error that we're going to run into, a kind of a blow-up error. It's like a syntax error. It's like an SQL syntax error. And so if you look at the documentation, there is a couple of different things. And the problem is that you can have it say, don't say anything, don't do any error messages whatsoever. You can say put out a warning and keep going. And the one I prefer and the one I set up all the time is what's called error mode exception, which means blow up right then and there, tell me what line of code is wrong, and quit. So that's why a couple of slides back I did that. And so if you run this code with this mistake in it, this XYZ and pizza not matching, it'll complain and then it'll just keep on going, right? It'll just keep on going. It's blowing up here in execute. Yeah, it's blowing up here, but it keeps on going. And that's kind of not what you want. That's not what you want. If you say exception, then it stops. And so it comes in here. We set this attribute, so make it be exception. And then we make the same mistake and it blows up here and it says, oh, uncaught exception, blah, 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 blah. But what's important is it stops. It stops running the code so that you can actually, it's dangerous to keep on running this code because you don't know if that was supposed to do something or if it's going to have an unintended consequence. So this is the way that I like it a lot. I like to keep it that way. And you'll notice that so if you set exception, you can actually do exception processing by enclosing the whole thing in a try-catch block, right? So you can have a try, and then you can have a catch, and that gives you some data about the exception. So either it runs and it works and it goes, or it runs, blows up, and then runs the catch block. So once you do exception, if you want to catch it. But the interesting thing is that, well, you can do this and print out your own message, basically, and so you have some control over it, and that message now is coming out of my catch block right there. And so it's not bad, but generally, you really want to quit. And you see how it says return here? It give up. It just stopped, and that's a way. Quit or exit, return, or exit, because you sort of want to print the message out, and this way you're controlling what the message looks like, but you're not continuing on. Because if this didn't work, and it's like a syntax error. It's like you made a mistake. I mean, this is a mistake. It wasn't bad data, or it wasn't missing data. That's normal. That's not going to cause an exception. You cause an exception because you kind of have like a typographical error in your code. Okay? So that's why you either use error mode exception and let it just blow up like it does here with a traceback, or do your own try-catch and print a message out under your own control. The nice thing about this, well, both of them are going to log stuff, and you might have to actually add here an error log so you can catch it later, because that's the next thing we're going to talk about is how error logs work. And so every time there's an error in your PHP, like what I told you to fix in display errors early on, so you just say display errors on. If display errors is off, the errors go into a log, just not to the screen. And the reason I tell you to put display errors on is it's hard to find the log. So now we're going to find the log. It's nice to look at the log, and when everything is going wrong, I mean, I still do this. Like, what is going wrong? And the other thing that's nice about the log is even if it's not you that's using your application, if someone else is using your application, you still can read the log. So on a production system, you can read the log. How do you find where the error logs are? They're just files on the server system. In the case of your desktop or your laptop, it's a file that's on your laptop. So go to PHP info. However you go find it in MAMP, click on PHP info, or XAMPP has its own place, or write a little script that prints out PHP info yourself. Whatever it is, the location of the error log is just another configured value. And so this says, for my particular thing, it's in the folder applications MAMP logs, and it's called the file phperrorlog.php. So you can find your way to the error log, whether it's MAMP or XAMPP or var log something 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 on Linux. You can open that file, and some text editors will notice as the file gets appended to and then give you the additional information. In Mac and Linux, there's this really cool command called tail, which just sits at the end of the file and just prints out the new things that come on. It just waits until the file gets extended and then prints that stuff out from you. And you can get like a tail command for Windows. Mac also has this thing called the console that can tail these things, but I tend to use command line and tail because then I can see it. And this is kind of what it looks like if you're tailing that log. You could just open the log in a text editor, but you might have to reopen it to see the new files because it just adds to the end. And so this is what it looks like, and I'm using, on my Macintosh, I am using a tail command, tail -F. And -F says, show me the end of the file, but don't stop and keep showing me new things that get added to the file. So it just sits there, goes blurp, 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 and new little lines come out. And all of this, all these little mistakes, whether it's a syntax error, these are just all these errors that are happening as I'm writing code, and I'm making mistakes in writing code. And here's this error too, right? It shows that this thing was it was thrown. It shows you the line of code, etc., etc., etc. And so these error logs are super useful, especially when you're in production and there's like users all over that are using your application and they're causing errors. And so you want to watch those logs roll by and make sure that you see the errors. I actually have little scripts that read the log every day and send me email for anomalies in production systems. And that's so that I know when you're using one of my production systems and you start seeing error messages, actually 15 minutes later I start seeing them on email. They show right up on my phone. So I get to see them. So I have a little script that reads these, and then anything new gets sent to my phone. And professional companies have all that monitoring figured out. So this was a super cool lecture. I mean, I'm really excited that you made it this far. We basically have shown how to make a database connection. I mean, it's like only 3 lines of code to make a database connection and send some data, send a SQL command, and then pull some data back, right? There's some fancier bits to it, prepared statements and these substitution parameters. We talked a little bit about SQL injection, why you don't want to do that, what can go wrong there. And as long as you use PDO and prepared statements for everything that ever comes through a user, then you'll be fine. And then we took a look at about how errors tend to happen. So thanks for taking the time to listen. Cheers. See you on the net.
Hello everybody, and welcome to another code walkthrough on web applications for everybody. The code that we're going to walk through today is the code for PDO. Now, one of the things that'll be interesting is everything we've done up to now you can actually run on web applications for everybody. But since this one needs a database, and I didn't set the database up for everybody to share on web applications, you actually got to download the pdo.zip and get it somewhere onto your local hard drive, right? So I've got actually all the code sitting right here. And so I've got all the code here, so you'll down pdo.zip and you'll extract it somewhere in your htdocs in a way that you can find things. And then eventually you'll have this stuff on your local host. So code PDO, that's all those files, so that now I can, run these things. This AA error check thing checks to see if you got display errors off, right? So that's nice. If you get a different, you might want to click on that and just see if it checks your errors. Always is a good idea. So one of the things that's important is it's got some notes in here, and you got to run some SQL commands. And so I'm going to make a database here, so I'll do some SQL, go back to these notes, create database misc, yada yada, make a thing called Fred and Zap, otherwise the things won't work. Now I've got a new database, so I go into that misc database. If I am on command line or in Linux, I might have to say use misc. And then I want to create some tables, and they're going to have user ID, name, email, password, and we'll make the logical key be email. By now you should know your SQL, right? And so this ought to be completely normal. Boom. I don't know what was mad about that. What was it complaining about when I typed that in? A comma or closing bracket was expected near key. Huh. But it worked. I don't know. Clear. Now, and the last thing I've got to do from the notes is insert a couple of users. Chuck and Glenn into it. Glenn is a real person, by the way. I'm a real person. So now in database misc, I've got users table, and if I take a look at that, I got two user accounts. So there we go. Now we can start playing with some PHP. So let's take a look at the very first bit of code. So this is important. So I'm going to put out a pre-tag, and then I'm going to call and construct a PDO object using the PDO class. And there are 3 parameters to the constructor. The first parameter is what's called a connection string. And it tells what kind of database we're going to be connecting to, which is MySQL, where it's connected. Now, most of the time in production, you put your database on a different server. It's got an address. Here, localhost just means we're on the same server, and we are. And then there's a port. Now, if you're using XAMPP on Windows or Linux, you're probably going to choose 3306 here instead of 808089. And then you have to have the name of the database, and that was the name of the database that I just created, the MISC database. Okay? And then you have to have the account and the password. And I did that in these notes. I made the account name Fred, and I made the password Zap. And you can just do this on your local computer. It doesn't really... There's not a lot of security holes of a database server because you have to be coming from localhost or from your 127.0.0.1 is another version of localhost, and so you can't connect from the outside world into this database unless your computer's been completely compromised, and then it just doesn't matter. So you don't really have to be too secure about this. Okay, so this creates a connection. It doesn't move any data. It just is a way for us to send SQL commands back and forth. And then we can use this returned object and then call the query method and send some SQL. So this is the same select star from users that we would type. There we go. The same select star users that we would type right there. Star from users, say go. And it returns these 4 rows as a record set. And then what we get back here in PHP is a statement, and then we can use that statement to fetch 1 row at a time using, and PDO : fetch associative array says we would like each row given to us as a series of key value pairs where the name of the key is, the name of the key is the name of the column. User ID equals 1, name equals Chuck, email equals CCBY, password equals 123. And this will give us a false, row will give us a false, which will stop the while loop. So this is a quick way to loop through all of the rows that are going to be retrieved and print them out with printr with a row. Now, if this database doesn't exist or something is wrong, this will cause trouble. But now I've got it all set fine. I can say goodbye to that. And if I run first, it should show that. Now, there's lots of things I could change. Let me just change something here. If I change that to be the wrong password, we'll see what happens here. So I run first, and it blows up. And that's because, and this is why errors are turned off, because I just blurted my password to my database. So I'll fix that, and it will work. And so this PDO, this will blow up if you don't have these things right. And so sometimes making this stuff work, when you first start out, that is the hardest line to get working. Once you have that working, the SQL usually is correct. Now, it'll make a different mistake. If I make a mistake with the SQL, it'll blow up a different way. It says, oh, you got some bad SQL there. So I'll fix that. We'll talk a little bit more later about how errors work. So there we go. Now, another way that we do this is we don't necessarily just use printr, and this is a good example of reading data from the database and turning it into a table. And we're just using echo statements cleverly to construct all of this data. So if I go to second, it looks nice, and if you just do a view source, you just see that there's table, and then there's the beginning of a table, and then the data that came from the database, the end of a table data, a new one, data that came from a database, on and on and on and on. And so we just construct, we loop through, and instead of just dumping it, we actually produce some kind of pretty meaningful HTML. Now, another thing that we do is we tend not to want to put this statement in every line of every file that we're ever going to do, because a lot of websites have like hundreds of files, and we don't want to put the password and all the database connection information into every single file. So we refactor it. and we use a require statement to pull in another file. The rest of this is just a read to read and print all the stuff. So if I look at third here, boom, out she comes. But then I look in PDO.php, and all this does is sets up this variable $PDO. I could name this anything. I just happen to name it $PDO. The class is capital PDO, and $PDO is the variable that I made. And I'm setting an error attribute, and I'll talk about this in a bit. This error mode, I'm saying be aggressive with your errors and blow up and stop rather than continue on. So that is this. All we did here between first and third. First we did it here, and in third we turned that into, let me select, save. And in third, we just did it all in a require and put it in a separate thing. And it's so you don't leak the passwords, and that's just a really general good pattern. So that gets us sort of started talking about how we make a connection to the database and how we send an SQL command and how we loop through the data that we get back. Hello and welcome to Web Applications for Everybody. Right now we're working through some of the code for the PDO, Portable Data Objects. Now you have to run this on your own local host, and you have to follow the notes to get things set up. We did that in a previous video. So what I'm going to play with now is a little more useful code, user1.php. Okay, and so if I take a look at user1.php, we follow the pattern of requiring PDO.php, and of course PDO.php has my database connection information with ID and password. And I'm going to use sort of my model view controller pattern where I'm processing the data at the top, and then I have my template at the bottom. So this is all the silent processing code. And then here is the logic. And so on a GET request, it just is going to fall straight through here because there's no post data. And it paints this post form, which is exactly this. And it gives me a name, a password, and an email. And so I can say Sally at uiuc.edu, and Sally's password is 999. And then I hit post, and then that's going to come back in the top of this script again, and this time these three variables are going to be set. Okay? So when I hit add new here, it's going to add another value. And so it runs through here, and here's the SQL, and this is PDO. PDO basically has placeholders for :name, and password, and we'll talk about why this is later. I just print out the SQL, and that shows this insert. And then it runs that statement, taking the name, email, and password from the post data. Now, I didn't have to name, email, and password the same, but sometimes you do that just to keep yourself sane. And so that did the insert. And so I did an insert as a result of a post. So if I go take a look at my new rows, you see that now I have a Sally row. Pretty cool, huh? Okay, so that's user 1. Let's take a look at user 2. So user 2 basically is going to, in addition, this code here is the same. It's the code to do the insert, and this HTML is the same. But the only thing I've done different is I'm printing out a table and then printing out all the data. So if I go to user 2 instead of user 1, it looks exactly the same. This form is going to be at the bottom. And so, but we see the old ones. And so now I can say something like Fred. Fred at umich.edu. And a password of some random set of numbers. And this form here is the same. The difference is now when I do the post, it's going to come in here, it's going to do another insert, and then it's going to fall through, and then it's going to show me all the new ones. And so now we have this thing where, there you go, and Caitlin. So we'll put Caitlin in. So we now have this thing that's both showing us each time we, oh, I kind of messed that up. I'll have to fix that later. Her email is wrong. I didn't do any data validation. But you can see this one here where we're sort of also we're querying, we're reading and constructing the table. So we've kind of communicated a few of these things. And so if we look, let's take a look at our database, browse, and there's Kate. Okay? So now what I'm going to do is I'm going to show you how we might delete. Now the key thing to deleting is you're not supposed to delete on a GET request. And so I'm going to write this thing called userdel and pass in the user ID that I want to delete as a post parameter. So let's go into user to del. And so now I've just painted a form right here. User ID is a field, and I'm going to delete the Kate one that I just made a mistake typing in. So I'll put 5 in and send a post in. So now I'm going to, when I hit this delete button, it's going to run here again, and this time post will be set because it'll be set from that 5. And I'll delete from users where user ID equals :zip. That is a placeholder. I'll print out the SQL and I'll prepare it, and then I'll run it mapping zip to the data that came in from this field over here. So this code's going to run when I click this button. All right, so we'll go hide that. So it ran, and the user's gone. Oop, that didn't look very big. So when I go over here and I browse it, Kate's gone. And I can get rid of 4. I can say 4, delete. And I take a look, and it's gone. Now here's the thing, just to remind you about SQL, if I delete 42, there's no 42 here, that's not an error. Because I said delete from users where user ID equals 42. Well, there was no user ID 42, so it did exactly what I asked. That's not a syntax error. It's a syntax error if I don't spell the word delete right, or the word from right, but having no records that get deleted is not itself an error. So that's how we do a delete. So the next thing I want to talk about is use3.php. And that is really just combining all these things together. So I have the add code here, right? And then I have the delete handling, and then I have the HTML. So let's just bring user3 up. It's like doing all of it together. So it shows everything, but the interesting thing is this little tiny delete button here. So most of it we've seen before. We read and we put all the stuff out, and then in this last field right here, in this last field right there, it's probably easier if I just view source and show you what it looks like. In this last field, I put a form. Let's make this a little bigger. Make it bigger. The last, so TD is the last column, and then /TD ends that. And in that table is a little miniature form. It's a method equals post, input type equals hidden. Hidden input fields don't show. User ID equals 3. And then I have a submit button that has a string del with a name equals delete. So this form has actually four forms on it. This page has 4 forms on it. There's a form, there's a form, there's a form, and this is a form as well. And I can tell which of these buttons was pushed. And that's why I named this one delete, so I know that that's a delete, and then I have add new. And I can also tell up in this code whether or not it was a delete that a post, or it was an add post. So the add post code is right here, and it looks, if it is a delete, none of these things will be set. Email, password won't be set. If it's a delete, then name, password, email won't be set, but user ID will be set. And remember, I'm putting user ID in here as a hidden value, which is the primary key of the user ID. So how do I construct that text? Well, it's pretty simple. I have the table, TD, and then I print out the form. This is just text. Hidden user ID, name equals user ID, value equals, and then I concatenate the actual row to user ID. I don't need to use HTML entities here because I know it's a number because it's an internal thing that I invented. And then input type and new line and form. I'm just kind of constructing a form from echo statements. That's exactly what I do. Okay, so if I click on Del here, Glenn is gone, and it came back up to the top. So it ran here, it came down, it ran this bit to delete because that's the button I hit, and then it fell through and produced the table. So for us, it looked like this just vanished. So we'll make a new one, Rohita, umish.edu, password is some stuff, and we'll add, and poof, it shows up. So that time I pushed this, and this post code triggered instead. And so I can have different forms doing every different thing here, and it all just kind of works. And so that is user 1, user 2, and user 3 walking through. Hope this helps. Cheers. Hello and welcome to Web Applications for Everybody. We're working through some of the code that we have, the PDO code, and we're in the middle of it. And the code that I want to show you right now is code called login.php. Okay, and so here's login.php. So let's walk you through what it's going to do. Of course, let's start with the data model. So here's our people. We have passwords like Chuck123. We should of course be hashing these passwords, but for now we're just doing plain text passwords. And we're going to log people in, and so so if it works, I can type in c7@umish.edu and password of 123, a perfectly fine password. c7@umish.edu, password of 123, and it says, "Yay, you're logged in." And if I say c7@umish.edu and I say password of not 123, it says, "No, you're not logged in." Isn't this cool? So let's see how we do this. Login1.php. So require1.php. This is the post code, and we'll just leave this for the moment. We'll come back to that in a second. And then I put out this form that is just to take the it simply gets the email and password and then posts it. So let's take a look at what we're doing here. We're pulling in the post data. We're pulling email and password out of the post data. And look how fun we've done this. We've done this with a double quote, and we're using the variable substitution that you can input email equals single quote single quote for the email and password, and we create the SQL. We run the query. We grab to see if there's one row. If there is one row, row is non-false. If there is a row, if there's no row, row is false. And basically, you're not logged in if the row is false, and you are logged in if you got one row and your login success. And so that's how it works. All right, c7@umish.edu and 123 runs this select statement, right? And I can go run that select statement right here. Run the select statement. And I found a row. I got one row. So that means that I'm logged in, and that's exactly what we see. We see that we've got the record set, name maps to the string Chuck. So we select name from users, where email, and so login success, right? And if I do c7@umish.edu and I put in the wrong password, then it gets no row because there is no record that matches these two things. Okay? So that seems like a good idea. But it's not a good idea at all. And that's because there is this thing called SQL injection. And so this is the classic explanation of SQL injection. It's a XKCD comic, and mom is saying, hearing the hi, this is your son's school, we're having some computer trouble. And mom says, oh dear, did he break something? And school says, in a way. And then the school says, did you really name your son Robert, single quote, semicolon, drop table student, semicolon, dash, dash, question mark? And mom says, of course, we named him Little Bobby Tables as his nickname. And then the school says, well, we've lost this year's student records. I hope you're happy. And then mom says, and I hope you've learned to sanitize your database inputs. And the problem is just like with HTML, if we're taking data raw from the user and putting it into strings and then sending that to the database, a clever user can type an evil thing and take over. So let's try to become evil and break in to our thing. Now, what I need to do is I need to type into the password something that has a single quote in it, because then I can convince it that it's a single quote. So here's one that's pretty good. So I'll say csev@umich.edu, and I'm going to say that the password is single quote, or P single quote, or single quote 1, single quote equals single quote 1. Now, again, it's just like when I was doing HTML entities. I am going to put this string right there, and then SQL is going to interpret the single quotes that I just sent in. Okay, and so this is not the right password, but then when I submit it, look at the select statement. The select statement is, this is what I typed. This is the unescaped data that came from the user. So I meant for it to be that this was the password, but that's not how SQL is going to read it. It's going to say this, or, and that's SQL, 1 equals 1, which is always true. So there is a record that's going to come back, and we used in the code the existence of one record as login successful, and so away we go. So I just broke into this system by figuring out a cleverly constructed password to get in. Okay? That's bad. That's bad. Now, I wish I could show you a little drop table students, but they made it so that this query right here won't do semicolons unless you force it to do semicolons. So the more fun thing to do is to add a semicolon in there and do a second SQL command. But they took away all the fun, so I can't even demonstrate that. So I can just demonstrate cheating and logging in without actually knowing the password. So how do we solve this? Well, it's so easy. The way we solve this is we use login2.php instead, and we use PDO the way it was meant to be used. And if I put in the single p quote or 1 equals p quote or 1 equals 1, it's not going to work. And that's because the SQL that's actually sent has these placeholders in it. It doesn't have the actual text. We actually pass in the text to this execute, and this execute carefully escapes, as much as necessary, all of these user entered values. It assumes anything that's being mapped in here might be dangerous. So it's like, create a little place, don't let this data escape. Create a little place, don't let this data escape. If they put funky characters in there, do whatever. It's kind of like HTML entities, and before we had PDO and prepared statements, there was a series of MySQL escape things that made the code look really nasty. Now we just use PDO, and many languages have these things where they parameterize all their SQL. And so the answer to this is just use PDO prepared statements. Don't use string concatenation, especially when user entered data is present. Never ever use string concatenation to make SQL when end user data is part of the query. And end user data is inevitably going to be part of the query. So that's why PDO is my best friend, and I love PDO, and I can't say enough good things about PDO. And so that is how we do avoid SQL injection. Okay? So I hope this little code walkthrough was helpful. Cheers.
Hello and welcome to our lecture on cookies and sessions. So cookies and sessions are highly related, but I think probably the most important part of this lecture is to understand the difference between cookies and sessions. Cookies are a part of the HTTP protocol. It is a relationship between the browser and any server. Cookies are a browser feature that then servers take advantage of to implement sessions. So sessions are data stored generally inside the server and sort of unlocked by a cookie. So we're going to look at each of these separately. Just keep them separate. So, like I said, cookies are an HTTP thing, and so it is basically a way for a script on the server to store a little bit of data in a browser. So there's this little database sitting there, and we'll see that database in a second. And it can store data in there, and then when new requests come in, the cookies come in with it, okay? And so it's like a temporary or semi-permanent storage on the browser that can be written by the server. And this is the way that, I mean, we just assume this now, that somehow the servers know my browser on my laptop versus your browser running on your iPhone or whatever. But that wasn't always the case, right? These browsers originally were all kind of anonymous. They were all the same. And they would ask for documents, and the servers would show the documents in the most basic form. But things like logging in and logging out and having, you know, access to your email on yours and mine on mine, that was something we kind of had to invent, because the early days really were stateless, meaning that every browser was treated the same. There was no way to mark a particular browser. But that didn't last very long at all. And so cookies are this idea of scribbling a little mark, a little sort of a breadcrumb, as it were. So your browser gets one, my browser gets another one, and somehow the server now knows the 40 or 2,000 or 100,000 browsers it's working with by putting a little different mark on each one of them as it encounters them. And so cookies are different than sessions, and cookies are different than logging in. Although cookies are used for sessions and cookies are used for logging in, they are just part of the request response cycle. They don't cookies don't force their way into the server, but we use cookies. So the way it often works on many sites is you have a cookie the first moment that you have a web page, hit a web page. And you'll notice there's some EU laws that basically say you have to have a little top part that says, our site uses cookies. And they're saying that because they want to store data in your browser, and EU has basically said that you have to ask permission, which is probably a good idea. And so the browser comes for the first time to a website, notices that it has no cookies on this browser, and then wants to send a page back that marks that browser with a cookie, and potentially ask permission to do so. And then once the permission is granted, then the cookie is sent. But then, so that's the first page, or the first or second page. And then from that point on, every time that browser requests a page from that same server, it includes those cookies. There can be more than one of those cookies. And so it's like, hello, here's your number, here's your serial number, dear browser, and please send me the serial number on all successive requests once the user has given permission. And so they're siloed by web address, and so you don't send a cookie from the bank site to your learning management system, and you don't send your learning management system cookies to your social media. They have an expiration date. There is such a thing as a session cookie, which only lasts as long as the browser is open, and then they sort of are flushed out, and others are written to the permanent storage, like the disk of your computer. And then that's why sometimes things know that you're logged in, you know, days later after you've shut your computer down and shut your browser down, and then you come back. And so some of them are permanent. They all have expiration dates. Some of them have, you know, expiration dates well over a year. And some of them have expiration dates as soon as you close the browser, they're gone. And that's why you have to log back in. And again, cookies and login aren't the same thing, but cookies are how login is kind of unlocked. Okay? PHP, of course, does a superb job of cookies. We'll talk about with sessions and other things, but right now we're talking about cookies. There is a set cookie function, and there is a super global called $_cookies that is like $_post or $_get. And so this is the simple thing. You know, the cookie processing is handled by PHP, and again, before the first line of your code runs, the cookies are pulled and extracted into a key value pair. Cookies are key value pairs. When you set the cookie, you have to set the key and the value and an expiration time. And so here I'm saying, is there a cookie named Zap sitting in the browser? If there is not, here we're processing a request, right? We've got a GET request or a POST request. Did that POST request include a cookie from the browser? If it didn't, then we're going to send a cookie back on the response, and then we're going to see that. And we're going to say, and this is like saying Zap equals 42, and then sending that out to the browser. So it's like they're an associative array or a dictionary of cookies or whatever. And there's limits on how many cookies you can have and how big they can be. And as long as you're reasonable, you're not going to get into trouble. But you can't send, 100,000 characters. There's other mechanisms in browsers that allow larger amounts of storage. Cookies have a significant, because they're used so much, they put reasonable limits on them. Okay? And so here is the first time that we have hit this. You can go hit this and then look in your browser console and look at the response header. Okay, so this set cookie is part of the response, and it says basically zap equals 42, and so this is the response of that particular program. This particular program that says, oh, I have to run this code, this set cookie code, and so it sends the set cookie header. Now, you can't have any output before the set cookie, and anything that has to do with headers, and we'll talk about a couple things that use headers, you got to send them first, which is fine because in my sort of model view controller world, I have this part of the code that's the top part of the code and then the bottom part of the code, and this is always silent, so you can do things like headers in it. You could not send the cookie down here. You can't. Once you've sent that first actual character of text to the page, you can't send cookies anymore. So this, you have to actually open the incognito browser or a brand new browser and then go to this URL and look immediately at the response that you get, and then you'll see the set cookie. Because you're never going to see it again because it only detects it once, because then you can look at the cookies in your browser, and you look in Chrome, you look under applications and then cookies, and then you see the cookies and you see, oh, zap is 42. Excellent. So that is where it's stored. Now, in the earlier days of these consoles, you could change this value. You can still change it, but I think they made it harder to change it or something. It was so fun to just change cookies. Mostly what you can do when you change cookies. So you have to assume that they're user data on the user's computer, so you can't trust them. We do have things that actually sign cookies securely, so if you alter them, at least we know they're altered, and so there are signed cookies that the server signs. It doesn't stop the user from altering the data, but it does allow the server to say, looks like you've been altering your cookie data, and I'll just throw that away. Okay, and so you can take a look at the cookies after that first request response cycle, and you see the cookies, and then what you see is every request response cycle, the first thing you're going to see is that, there is a cookie here, right? Zap42, this was from $_cookies, and you will see that in the request headers, because there are request headers and response headers. Request headers are get and then a bunch of headers, and then and that's how it works. Response are header, 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 blank, content, right? And so you can hit this refresh as many times as you want, and you will see that it sends that cookie, because that's the job of the browser. It has received a cookie, and now on every request it must send a cookie. So you can see how useful this might be. It's our way of the zap equals, we've chosen the name zap, but 42 is the mark that we put on this particular browser. Now, everyone gets 42, but that's okay. Okay, and so if we look at this sort of as a picture, right, the browser comes in, there is no cookie on it, and so then we call set cookie once, and we send back a cookie, and then that cookie stays in the browser forever until we throw it away, or if it's a session cookie, and then every request from that point forward, the cookie shows up and ends up in the variable $cookie. Okay, so that's kind of how it works in PHP. Of course, you can clear them, closing the browser might, time expiring. Eventually, and the user owns this data, they can throw it away anytime they want. I mean, you can go into your developer console and wipe out that cookie. And if you wipe out the cookie in developer console, then you hit the refresh again, then it's going to send you a new cookie. It'll send it back to Zap42. So that's sort of a quick understanding of cookie. Up next, we're going to talk about PHP sessions. So now we're going to talk about sessions. So we got to keep cookies and sessions separate. That's a thing I told you got to worry about. And so cookies are a little tiny key value store, key value in the browser, right? And the PHP can send them, and then the browser sends them back on all future requests. And so that's what cookies are. They're small, there are not too many of them, but they're very, very useful. So one of the things that we use cookies for are sessions. So what we do is when we see a session is often a particularly named cookie, you'll see them in a bit, and we see, oh, this browser we've seen for the first time, and so we pick a large random number, 42, and then we send the cookie back and say your number is 42, and at the same time we create a little file somewhere, or a piece of memory, or a piece of a database, or something for that number. So we have this connection between the browser's number and a server, a number of some piece of data on the server. And so now what we do when we get a new request coming in, we look at the cookie and then we grab that. And so we pull the session data in. So the cookie comes in, but we also pull the session data in. And this is another set of key value pairs that you can have pulling that data in. And then if there's another browser, right, comes in, we say, oh, welcome new browser from a different country or whatever. We'll pick a new number and send you out and mark you as browser 6F. And then from that point on, 6F comes in, but then when it comes in, the cookie comes in, but we also pull the session data. And then inside your program, you can change the session data and it gets written back. And so what happens is as the request response cycles happen, you are reading and writing. The way we think of the session is it's just a place that you can read and write. So if you write in one request, you can read it back in the next request. And believe me, we're going to do that a whole lot. There's lots of really wonderful use cases of having some bit of data that persists across request response cycles. And that's the essence of a session, is we do that. And we use cookies as the mechanism to make that possible so that we know that one browser is this session and a different browser is this session. And so when this script runs, it knows it has data that it's stored for one browser and has data that's stored for another browser. So it's super awesome. It's just awesome. So we often create sessions right away when we first meet them, but first we have to send the cookie, pick the number, send the cookie, and away we go. And the session identifier is usually this really, really large random number that is encoded in hexadecimal, like all hexadecimal is. It's like 0 through 9 and A through F, and it's representing in a single character position the numbers 0 through 15 with only one character. And so it's a kind of a compressed form of numbers. And we make them long because we want session identifiers to be a relatively large, randomly selected number, because literally if you can guess the session identifier of someone else's session, you can sort of break into their session. Okay, and so part of it's security by if you can't hide it. But this really large number, trillions of numbers, so it's hard to guess. Now, if you can sort of sneak over somebody's computer and grab their session, maybe, but that's usually not. There are way better ways to break into people's accounts than catching them in a coffee shop when they go to the bathroom and going and logging into their computer and pulling their session out. There are way better ways to do that, because one thing, you have to be in the same coffee shop. Or maybe you put crappy software on their computer, but whatever. Session identifiers are large random numbers. Server encounters new browser, no session cookie, simply picks a large random number, sends it out as session cookie, and then creates a file that corresponds to that large random number. And the file, the session file, is the data that only the application can change. The cookie data belongs to the user, but the session data belongs to the application. And unless there's a bug in the application, the user cannot change the session data. And so you can just go to pretty much any old site. In this case, you can go to my Sugi page, and you can look at the first page. You got to kind of open it and look at the first page, and then you will see a session cookie. And then in this case, Sugi is a PHP application, and it sets a PHP session cookie. And the PHP sesh ID, you're going to see a bunch of those, and you may have been seeing them in your browser as well, because if you're using the autograder, you'll see that it uses cookieless sessions, and it has to protect itself a different way because it's using cookieless sections. Cookie sessions don't end up on you don't see them because the cookie's kind of this hidden thing. And so PHP sesh ID, you can even change that name inside PHP, but the default is PHP sesh ID. So you go to most sites, you look at your cookies, and if it says PHP sesh ID, it's like, well, that must be a PHP application because it's setting the session for me. So if we take a look at this picture, as I've sort of described, we are marking browsers. So now what we have is different browsers, right? Different people's browsers. and we give them each a little different mark. We pick a random number, and then what we do is we have a corresponding bit of data on the server that allow us to store keys and values in here. KV, keys and values, x equals 2, x equals 4. Whatever it is we want to store, and then when this browser finally comes into us, we reassociate the session, and then we know that this particular browser, we set x equals 4 the previous time we talked to them. Okay? And so that's the idea, that's the basic code. I mean, that's the basic structure of where the data lives. Now, in PHP, we have to call session_start to say, hey, PHP, this script that we're running right now wants to use sessions. And so you tend to put that at the early part of nearly all of your scripts, session start. And once session start has run, then the global array $_session exists. And so it's a super global like $get, $cookies, and $session. So $session is not the cookie data, but to find $session, it has to look at cookie data, right? And so, and the cool thing about $session is you can put it on the right side or the left side of an assignment statement, because if you modify session, at the end it stores that back on disk. And so you can think of the session variable as a variable that lives from request response cycle to request response cycle, right? So here comes a browser, and it writes something into session and it stores it, and then the response goes back. Time passes, and then it comes in. Now this was a post. There's $post, but after this response is sent, $post, that $post is gone. But you wrote something into the session. Now here it comes again on a GET request, and there's a $get variable. But then the session data comes up, and so the session data you stored here comes back for this later request. This is time passing, right? And so this one stores something else in session and then sends the response. The $get data doesn't exist, okay? And then more time passes. Browser hits it again, in comes a post request that's all new, but then it pulls the session data out, and then it does something, and the session data is rewritten, and then the response goes, again time passes, this post data is long gone, the post and the get are ephemeral, they only exist for the period of that request response cycle, but whatever you store in session comes back for the next request response cycle. So you tend to say, oh, I'll store this at the end of this response, and then I'll be able to grab it at the beginning of it. And we do that all the time. It's really pretty cool how that works. Pretty darn cool how that works. So if you really want to know something about your sessions, you can actually go into your PHP info and you can look for the key session_save path, and then you can go into a folder on your XAMPP or your MAMP. It'll be somewhere on your hard drive. And you can actually cruise down and look at that stuff. And you will see a bunch of files. By default. You can store this stuff all kinds of places, and production sites don't store them in files. Big production sites tend to store them in fancier Redis or Memcache or some other fancy thing. But in the default, and the way we're running for our development and for small to moderate sites, they just store them on disk. So they're little disk files, and you can take a look at them, and you can see that they are named ses_, exactly the same as that big session ID that's in the cookie. And so you can figure out by looking at your cookie and looking at the name of the file, and you can actually open your session data. Now this is a file on the server. You can only do this on the server. The user can't do this. The user can see their cookie. They can't see their session. If you open it, don't write it, or you can throw them away. But you can kind of see, if you look carefully, it's just some key values. But some of these things that are in here are, some of those things that are in this are arrays, and so they kind of have a serialized version of those arrays. Or it's just strings, and so this is not something you're supposed to look at, but you can kind of see roughly the kind of stuff that's in there in those files. And some people get good at reading this, and they actually debug applications by what? Oh, what's wrong? What ended up in that session? And some people go actually look at this stuff. But I'm just showing it to emphasize that these session bits are sitting on disk. So in PHP, the way we do this is we say session start. Now session start does a couple of things. It does whatever is necessary to get the session started. So if there's no cookie, session start does a lot more than if there is a cookie. If there is no cookie, session start picks a session identifier, creates the session on disk, sends the cookie back, and then creates the $session variable, which you can then use. Okay? So let's go through that again. When there is no session cookie, it picks a random number, makes a session file, sets the session cookie and creates the $_session variable. Okay, if there is a cookie, it looks and it finds the file, it reads the file and sets the $session. The one thing you know is after session_start, as long as you do it before any output has been sent, you will have the $_session will be set. So this is make it, set it, find it, however you got to do it, get me a $_session. Okay, so that's what it does. And you put this way toward the top of your code. Maybe the first line, maybe the second line, but you don't certainly put this after any output. Session destroy effectively deletes all the keys in the session. And so here's a little bit of code. It's right now just to demonstrate how session works. It's not particularly intuitive, or it doesn't really solve a complex problem. So here we go, right? Session start. First line, first executable line. You see I'm using kind of my model view controller pattern. I'm doing all kind of silent stuff up here, although I am sending echoes out, so it's kind of a little not perfect. So session start basically guarantees that $session, a new superglobal, exists. Okay? And I can say it's a key value, it's just an array. If is set session subvalue. If it's not, then I'm going to print out that session is empty and set it to 0. So the key to session is you can have it on the left-hand side of an assignment statement. Super awesome. That is, without any further effort on your part, writing that key value onto the disk. And if you want to look at this and run this code on your own computer, you can go see the little disk file and you'll see, oh, there's a value and it's got a 0 in it. Cool. So if it's not set, I set it to 0. And then else if the value is less than 3, then I go pull the old one out and add 1 to it and send it back. So it's going to be 0 first, then it's going to be 1, then it's going to be 2, then it's going to be, but if it's then 3, then it's going to come to here. So if the session value is greater than 3, this will be false and it'll come to here. Then it'll do a session destroy and then a session restart in a sense, and then away we go and print that out. And all I do with this little click me is click, click, click. There's a couple things you can do. You can echo the session ID, and that's showing that big random number. And then I'm doing, it's kind of often that you do just a print R of $_session. So you're like, what the heck's in my session? Because a lot of your code will be putting stuff into session and taking stuff out of session. So here's how that code runs. The first time it, it's using pizza, not value, but you get the idea. So it's using pizza as the key on this particular one. And so the session is empty and we set it to 0. Then we click it again. The next time you click it, the session is 1. Oop, 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 oop. Come on, come on. All right, the next time you click it, the session is 1, then the session is 2, then the session is 3, and then it just restarts the session and there's nothing in it, but then the next time you click, it'll go back and do the same thing. So you get the basic idea. So this code uses pizza instead of value in this little bit of code. So it's pretty much the same as that. Okay? Okay, so one last small topic is sessions without cookies. Now, if you've been using my autograder, you have been seeing sessions without cookies, and I'll just say that they're trickier, and we'll talk about that when we get back to sessions without cookies. So now I want to talk a little bit about sessions without cookies. Sessions without cookies is kind of an advanced topic. The only reason I kind of like to talk about it at this point is if you've been using my autograders, you've been seeing sessions without cookies, and you've been seeing that cookieless sessions, you've been using them, and so you're like, scratch, 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 I'm using the autograder, but it's not setting a cookie. If you have a simple full screen application that's got a web page and you go and you log in and you log out and all that stuff and shopping cart, normal cookie-based sessions work great because if you have the whole page, one site, that you can set cookies. But increasingly, browsers are not letting you set cookies in situations where you might be functioning in an iframe. Or if you want to open an application on multiple tabs and log in on different accounts in the different tabs, that doesn't work very well with a global session cookie. On an incognito browser, if you open an incognito browser, they get a different copy. Each one gets a different copy of the cookies. So you can log in as two people. Multiple tabs, you can't log in as two people, but incognito browsers, you can log in as two people. And so There are times that it's good for you to not use session cookies, and increasingly as applications move from running in the server to running in the client, they tend to use cookies less and less, and they use like tokens and stuff like that. And so it turns out that PHP has probably the nicest support of any programming language, any web programming language, any web framework that I've ever seen for maintaining sessions without cookies. And they're a little weird because you have to still create this mark on each browser and then get the mark back and reassociate. And so the way this tends to work is you can you set them either in form requests or anchor tags, okay? And so here's a bit of code that we can play with, and just take a look at how this works. Let's go to nocookie.php. There's no cookie. We've got a session ID, and the best way to look at this is to view the source of it and see what's going on here. And so what's happening is if I click on this href, you'll see I've got a get parameter, which is PHP sesh ID. So the whole idea of a session is it's got to be the same from request to request. Okay, and so if I click on that, you'll see how it reassociates with the same cookie. And also if I click on a form, I've got this input, a hidden tag that is the key of PHP session ID and the value of the session. Okay. And so regardless of what I click on this anchor tag, so look at that right there, see the PHP session ID there is, and I'm still adding one to the session and it's working, and so there are no cookies in this session, and I can also send the form, and if I send the form, it still knows because the form is sending this hidden value, because hidden values are like text except you're not seeing it, right? So it's right here, there's a hidden text field, but it's not showing. And so this way I can implement this little cookie, this little thing that updates the session 0, 1, 2, and then 3 resets it, the same thing, right? I can do this either with anchor tags or with form tags, and PHP actually has added all this stuff automatically, and this is what I didn't mean to click there. This is what I like about PHP. If I tell it I'm going to not use cookies, then it does its best to maintain them, okay? It alters. You'll look at the source code and you'll see I didn't put this on here and I did not put that input tag. So when we take a look at source code, you'll see that. So that's how it works. It's cookieless, and that's why if you're running my autograders, you keep seeing this. Now, my autograder, go ahead and try to break in. I probably shouldn't say that, but my autograder protects itself in different ways by checking the IP address that it comes from and the browser that it's coming from, and so it's a little harder to break in. If you do sessionless cookieless sessions, and you don't protect yourself otherwise, you're actually kind of opening yourself up for a world of hurt. And that's why I wrote a whole bunch of code, and that's why I encourage people to use frameworks rather than just roll their own. But okay, enough of that. This Sugi stuff that I've written is designed to run with multiple sessions in multiple tabs, work in iframes, etc., which are the challenges of cookie-based sessions. That's where cookie-based sessions are challenging. Okay, and so here's the code, and this is kind of advanced. I'm not really telling you that you're supposed to know every bit of this stuff. But basically there's some settings that you set to say, hey, don't use cookies, don't only use cookies, and whatever this is, you can go Google Stack Overflow and you say, how do I not use cookies in PHP? And they're like, put these 3 things in there. So you put these 3 things in there, and after you do that, these things are informing session start to use cookieless sessions, which means they're not going to, session start at this point is not going to try to set a cookie, and it's not going to look at any cookie. It's going to assume that the cookie detail is going to either be in $_get or $_post under the session ID, right? So if you saw those, it was PHP session ID equals as get or PHP session ID as post. And then from that point on, it's exactly the same code, right? You just use session. Cookieless sessions are no different except these 3 lines of code, and that's what I like about PHP and cookieless sessions. But don't overthink this, just understand that it's possible. And in other programming languages and other web frameworks, it's possible. You just have to manually put it on all of the gets and all the posts. but PHP friendly, thank you PHP, does it for us automatically. I don't know why they decided to do such a nice thing, but it's turned out to be very, very useful to me because, like I said, I have applications that need to have different session information in different tabs. Now, my applications are not the same as your typical social media site, but I have reason for needing this. And so the rest of that code is no particular thing. The session ID is the same. It's all the rest of that code is identical. You just say, hey, PHP, do this. Now, a couple of caveats. If you're doing things that we haven't done yet, like Ajax and JavaScript and things like that, or you're constructing URLs in the browser, you have to pass the session ID back to those folks. So if you're using those kinds of things, and if you are bookmarking a URL or emailing a URL, you might actually be logged in because you are inadvertently compromising your session. And I have built ways in applications that use cookieless sessions to have an additional layer of protection to make sure that the session ID is not the only thing that that we've got. Okay, so even though that summary bit of the sessionless cookies was kind of advanced, the basic idea of cookies and sessions and how to use sessions in PHP is really simple and ultimately very elegant. And up next, what we're going to talk about is how we use this session thing. So we're going to assume session, assume cookies, but then what do we do with it inside of our applications? So the applications of sessions is really the next topic.
Hello and welcome to Web Applications for Everybody. Today we're going through some of the session and cookie examples. So this is a very simple example called cookie.php. And basically what it does is cookies are key value pairs that are stored in the browser. They're a bit of data that the servers can store on the browser, and we store it using the set cookie. And we can say that it's almost like a dictionary or a associative array that lives on the browser. We say zap equals 42, and then we give it an expiration time of now plus 3600 seconds, which is an hour from now. But we're only going to do this if the cookie is not set. Now, this turns into a header on the response, and the first time we do this, we'll notice that it's not set, and then we'll set it. Okay, so you got to set up. So I got a fresh, brand new browser, and I'm going to go straight to that bit of code. And so we can see on our developer console, hopefully the cookie is going to be set. So here we come. And now I can take a look. And so I look at the request. The request is a get to that URL. And so what happens here is now, because of this is a header. This is a response header that set the cookie. And what that basically says now is that every other request from this point forward, that cookie has to come in. Now we can actually see these cookies under Application, Cookies, HTTP. Now these other things have to do with automated thingies that are gathering data, whatever. But this is the zap cookie. Now I can hit delete here and get rid of it. Matter of fact, I can delete all these guys too. I just get rid of them. So I just got rid of those cookies. These cookies belong to me. They're my browser. In the old days, you could actually change these. I don't know how you change these as easily as but you can change these. And so cookies are not something, they're something the application sets on the browser, but they're not something that you'd think of as reliably owned by the browser. Now, so there's a cookie sitting here, and it set this cookie on that request response cycle, and that's because the current values of the cookies are copied into this very global, super global $_cookie in PHP, and because I was hitting it for the first time, there was nothing there, so we set it. But from now on, if I ask for this again with a refresh, it is not going to give me the cookie because it's going to notice that I've sent it. So if I take a look at this, the cookie array has zap equals 42, and the way that was populated is in the request header. The request header that the browser sent to the server, it sent a cookie header that says zap equals 42. And so what PHP does is it parses this zap equals 42 and puts it in this variable $_cookie, a super global, like post, like get, etc. And so because it saw that was already set, it didn't feel the need to set it again, right? And so you'll notice there is no set cookie, at least not for Zap. There's all this other crap that got set again because I deleted it. I don't even know what those things are for, but whatever. Now, if I go and I take a look at my application and I look here, this one got set again on that request. But if you hit refresh over and over and over again now, every time there's going to be, the cookie is going to be there and it's not going to have to be set again. Now, if I delete it, and then I hit refresh, and I take a look at the cookies, it's back because this code detected that it wasn't there, but once I delete it, it doesn't get sent on the next request. Okay? So that's cookies. That's cookies. Cookies are key value pairs that come in the browser. Now, let's talk about sessions. So sessions are not the same as cookies, although they make use of cookies. And so in PHP, if we want to use sessions, we say session start. And what happens, this is called sesfun.php. I won't hit enter yet. What session start basically does a whole bunch of stuff. Session start, if there is no session cookie, and there is no session cookie here, we'll see one in a second, it actually picks a large random number for the session ID, then sends that out as a cookie, session cookie, and then creates this superglobal called $_session. Now the data in $_session is not stored in the browser. It's actually stored in a magic place in the server in such a way that if you modify session in a request, it actually stores the data in a server. So once you've done session start, you have this magic variable that doesn't come from the client, doesn't come from the browser, it comes from the server on every request response cycle. So you can put data into it and then you can take data out of it. And so it's pretty cool from one request to the next. Okay? And so let's go here to network to start. And I'm still on cookie.php. Let's clear that. Now when I hit enter here, it's going to retrieve sesfun.php. And it's going to notice that there is no session cookie, and it's going to pick and create a session cookie. Okay? So if I look here and I look at the response, you see a set cookie. The name of this cookie is PHP session ID. That's actually something you can change in PHP. And this is the large random number that was picked by it. Okay? And so the session is an array, and I set this array to be pizza equals 0. So $session was created on this first request, but it's empty because it's the first request, and so pizza is not set, and so it says session is empty. Look at that, session is empty, and then it sticks a 0 in there, and then down at the bottom it prints it out, so we see the 0 is in the session. Now this 0 in pizza has not come back to the come back to our browser. If we look at the cookies, we have the session ID, which is kind of unlocks the session on the next request, but it doesn't store pizza equals 0. Pizza equals 0 is stored magically in the server somewhere. Now, if I hit refresh, let's move this down a bit, move it down a bit. If I hit refresh, it'll come back in, session start, will see a cookie this time. It'll send the cookie this time, and it'll say, oh, pizza is set because of this code, not because of the cookie, because it will be the same session because it will send this back again. And session some pizza equals 0, and then it's going to say, oh, but it is set, so this is going to be false, so it's going to drop down here, and it's going to look at the current value of sessions of pizza, which is 0 right now. If it's less than 3, we're going to retrieve it, add 1 to it, and stick it back in the session and say added 1, and then print this stuff out. So pizza is now 1. It's still on the server. The cookies haven't changed. If I click it again, that code will run. It'll be 2, right? And then it'll be 3. So now, next time I click it, session sub pizza, a server variable, this server variable that's going from request to request to request to request, this server variable is going to be greater than 3. Oh wait, maybe I got to click it one more time. Click it one more time. Oh no, it is 3 because it's only less than 3. So because it was equal to 3, it ran this, which is session destroy, which really takes out all the key value pairs from the session in the server, and session start. But you'll notice that our session ID didn't change, but then when we print the $session variable, it is now empty. And so what session destroy really does is empties out the $session. The next time this runs, the session ID is still not going to change because that's still in the cookie. That's still being sent every request, and it unlocks the session. The session just on the server happens to be empty, but the next time we click it, it's going to say, oh, session's empty, and set it to 0. Session's empty, set it to 0. So now, if you really, really, really want to, you can go to your localhost 8080 and go into your MAMP and go to PHP info and then look for the session save path. So that is the session save path. Now I'm going to go show you what happens inside the session save path. I'll open up a terminal and I'll change directory into the come back session save path. So in this session there are actual files. Let me just do this, open dot, so you can see it here. But I can actually open these. I'll use old school VI to take a look at one of these things. And these have what's called a serialized versions of the basic stuff that is in a session. Okay? And so that is data. You're not supposed to mess with that, but just so that you can kind of see that these sessions variables are stored on disk somewhere. And I don't particularly know why this one's not storing very well on disk, but that's a different problem. So there is sessions. And I hope you found this particular video on cookies and sessions useful.
So now that we understand sessions and cookies, we're going to start using them for useful things inside of our applications. And one of them has to do with moving between pages, sending data from one page to another, and then doing things like logging in and logging out. So if we take a look at my happy little picture, we're going to start by talking about how we inside the server can actually send a response back to the browser to tell it to go to a different page, and that's called the redirect. And then once we've kind of got the redirect understood, then we're going to learn about ways we use the redirect, where we have something that comes in, and instead of just sending an answer back, it sends a redirect back, which causes the browser to come in again and then actually gets the response. So that's called the post redirect. And then the next thing we're going to talk about is we're going to talk about how we have to use sessions when we're doing those things, and how we, at the end, will implement a login. But right now, what we're going to talk about is how we can send a request, and this application can send a response that says, go somewhere else, to cause it to go do a request to the same server, or even a request to some other different server. Okay? So that's what we're going to talk about right now. And the way this is going to work is it starts by pointing out that when we send a request and we get a response, as part of this there is always a code. The code 200 means that everything was okay. 404 is another code that many people mean you ask for a document that was not found. And so the code that we're going to learn and talk about right now is the 302 code, which is document moved, also known as the redirect. So there are these HTTP status codes. You can go look them up. When the server answers back with a legit response, it says 200 OK, which means, OK, go ahead and look at the rest of the stuff, read the HTML, display it. 404 says 404 not found. If you go to that URL, you know, nowhere.htm, you'll get a 404 not found. And if you go, to drchuck.com without a dash, you will see that that redirects to dr-chuck.com. Now you got to scroll way up, but you'll see that that does a redirect for you. And so the way this redirect happens is that you send the 302 and then you tell it where you want to go with a location header. And if you remember, in the request response, you send the get or the post, and then back comes some headers and then a blank line, and then the actual data for the screen. Location header is one of those things, and if you get a 302 as your status, then you look at the location header. And so there is a function inside PHP to allow us to send various headers. Location is just one of many headers. The set cookie command is actually a header that's part of the response header. When we looked at set cookie, we went down and saw the response headers, and there was a set cookie one. You don't use set cookie with header, but for other headers, we just call the header function that says add something to the headers of this response. If you do an echo, it adds it to the body of the response, or a print, and if you do a header, it adds to the header. So the format and the syntax of the header command is you say header, and then the name of the header is something something colon, followed by a space, followed by some parameter depending on that header. Now the key to that is, like many things like session start, like set cookie, they all have to happen before the first line of output. And I don't know how many times I'm going to tell you, I'll just keep telling you every time I think about it. That's why when I structure a PHP application, I sort of have this line above which there is no output. No output above that line. And that's so I can do headers, I can do routing, etc., etc., etc. And so what we have here is a little form that just is one little input box where, and if it's set, I'm going to do a header which redirects to reader1.php. If it's a 2, it's going to redirect to reader2.php. You can put a parameter on the end of that, that's okay. Or you can redirect to an absolute URL, and that's okay too. Now one of the things that's essential to this is you also do a return, because you don't want it falling through and producing that output. Pretty much when you're going to send a redirect, you want to send the redirect but no output. Generally you can send output and it will sort of blink badly sometimes and follow the redirect. It tends to believe the redirect rather than the output, but return says stop processing in this script. It comes in, comes down here, sends the header, and then it's done. It doesn't put this out because the redirect is kind of like a null response that says this is not the right place, go somewhere else. And there's two redirects. There's a 301 and a 302. The 301 is supposed to be permanent and the 302 is supposed to be temporary. You can read up on the documentation. There's some subtleties to it, but we just use 302 for the redirect. So if we run this little application, reader1, and you type a 1, then it will end up sending itself back to reader1, right? It'll send it back. If you put a 2 in here, it's going to go to reader2, and you'll notice that you can put a parameter on that. And if you type a 3 in there, it's going to go to drchuck.com. So you hit submit, it went to this page, but then it went to that page, and the response from that page was, hey, I'm not here, I'm not going to give you anything, I want you to just go to a different page. And so the browser sent a post, and this thing sent back, go somewhere else. And so it went to drchuck.com and then got the page for drchuck.com. And so you can really reroute the browser from within your PHP application using this location header. So here is how it looks if you watch it in the developer console. After I've entered a 2 in here, I put a 2 in here and press submit. You'll notice that the first thing it does is it does a post request to reader1.php, and that's because, well, I was on reader1 when I pressed it. So that did a post, and instead of getting a 200 back, I got a 302, and then it went and was forced to do a second get. So in this one, I post it, and then it does a get to reader1 with parm equals 123. And if you look at the second the second response, you see that the actual page that we're seeing right here came back on the second one. If you look at the response of the first one, you will see that there is no data in the first one. There is simply a location header that says go somewhere else. So that's how it moves the browser around. We in the PHP can say, hey browser, go somewhere else. And we use it for a lot of different things. So the first thing that we're going to use this is what's called a post redirect get pattern. So that's what we'll talk about next. So now that we understand the redirect, and the redirect is a simple HTTP level thing. It really doesn't care about PHP, it doesn't care about anything. When browsers receive a 302, they go somewhere else. Now the somewhere else might be right back to the same script. And that's what we're going to talk about in this situation right here. So we have, we send the request back, and now we're going to send a post, and then the post is going to, our response is going to be a 302 to the post, and then it's immediately come back and do a get to the same page. and then it's going to come back and parse the response. So we click a post in, and it's going to go on. Oh, let me draw that a little more prettier. So we click on a post. We're going to go into PHP. The PHP is going to do its work, and then it's going to actually redirect and then cause the browser to come back in with a GET request back to the same script, and then actually send the real response that's going to be parsed. So we call this the post redirect GET pattern, and it's something that's necessary that we have to do on posts. But again, the 302 and the 200 and all that stuff and the post and the GET, that's all happening with a request response cycle. Now we're going to talk about a pattern that we use to accomplish that. Okay, so every bit of sample code that I have shown you so far in this class that uses post is wrong. Every bit is wrong because you've never hit the refresh button and had this little nasty message come up. This message right here. This message right here is an unhappy message. And the way you do it is you get it by having a post form that you hit the submit button and then you press the refresh. So if I go all the way back to post, a couple lectures back, I told you the purpose of posting was when data is being changed. You never change data in a GET. So the browser has sent the post request and got a page back, and if you press refresh, it's going to send the same post again, which means you either have deleted money from an account or ordered something online, and it's like, hey, you don't be wanting to do that. Don't do that. Are you sure you want to do this again? Because I'm going to send a post again. If you say continue, I'm sending the post twice. And this is not your application. This is the browser protecting you from doing something twice that you didn't really mean to do twice. So what we don't ever want to allow that to happen. And so there is a trick that we use when we write applications so that this never happens. If you ever hit refresh on a page in an application and you see this dialog, that means that the programmer is very unprofessional. That's the best way to put it. Just like, are you kidding me? You are sending back a page to a post request. Are you kidding me? Okay, so it really means that the browser is going to protect you from double posting. It'll do it if you say yes, but it's going to stop you, and it's just really tacky and it's ugly. It's a bad user experience. You never want the browser to be talking to your user. You want your application to be talking to your user. Okay? And so the idea is that upon finishing the processing of a post, you do a redirect. And you do a redirect right back to yourself. Now, we'll see sometimes a redirect elsewhere. That becomes routing after a while. In the next example, we'll do that. But it's post redirect get. Okay, and so here's kind of a picture from Wikipedia that kind of captures the same thing. We do the post, we do the work, we do a redirect, and then automatically there's a get which pulls the page back and the new page. And so what we see is we see just a brand new page, but if we hit refresh at this point, it runs the get again. So that's what this is really saying. This is like, oh, you do a post and the data comes back with a 200, you hit refresh and it runs the post again, and that's the problem. So Wikipedia has a nice page on this whole concept of post redirect get. And so this is the code that I told you was so bad. This is the code that I'm now ashamed of that I even taught you in the first place. So I have to fix this. I have to kind of redeem myself. And so if you remember this code, it's got this top stuff. That's nice. That's the model. Remember, this is the view and the controller and the context are going back and forth, right? Remember all that stuff, right? And if we go up to the top, we had the idea. We still have this line. We're not getting rid of the line. We like the line. We like this line. And basically the idea is these variables fall through. They either fall through this way or they come and modify, and they're still falling through. And then they go down to the thing. But in the case of a post, it comes out and it continues. And that's, the get is okay. But the post is the non-okay bit. We do not ever want to process. This is what I call processing the post data. We're doing something with it. We're reading it. We're evaluating it. We're sticking it in a database. Later we'll stick it in a database. Or we're checking a database. Or who knows what it is we're doing. We're working with the post data. The key is you're not supposed to ever fall through in the bottom. And that's what's wrong with every post example I've given you so far. The problem is that coming out of the bottom of this, there is actual data, these old guesses and messages. And so the problem is we don't want to respond to the post, but the data in $post or $get, it's going to go away for the next response, right?
So that's why session's important. So this all kind of adds up together. So we still have this bottom part, and this bottom part needs data. It needs the data for message and old guess, right? Is that old guess? Yeah, okay, it's not called old guess, it's called guess. So good, I'm not crazy there. So it needs these things to come in. But the problem is we can't allow a post to just filter down. We cannot have this be the response to a post. That is not allowed, because that's when you hit refresh and it asks you, do you want to repost the data? So let's look at this done a little bit better. Now the problem is we still have got to pass the data from the data from the message and the guess. We got to pass it to the future, but we're passing it to a future request response cycle. But hooray, we have got the session, and we can do that with session. So this is the right way to do this, okay? So you come in, start a session. Yay, we talked about that last time. If we've got a guess, we're going to remember the old guess, and then we're going to store it in a key called guess in the session. And then we're going to do our message logic, and then we're going to put the message in the session as well. And then we're going to redirect back to ourselves, guess2.php. So now it's going to come back with a get request and then a return to get us out. So redirect, tell the browser to go somewhere else, and return says we're done with this script, meaning we never fall through. That was the part that was the problem. The falling through was the problem. Okay, so if we look at this code, on a get request, it just drives straight through. On a post request, it comes in, and then it leaves, and then it forces another get request. Okay, so in that case, there's three requests. The first get request to show the form. The second is the post request that receives the form and processes it and sets data in the session. And the third request is the get request that's going to show our little picture, and we'll show you in a second just how that happens. And that is, it happens because now there's a get request once to show the form in the first place, and a second get request that comes after the post request. The post request never even happened. It happened above us. But now we're coming in with this post. But we still need to know whether or not there was an old guess and whether or not there was a message. And we simply look, oh, if there is in the session a guess and in the session a message, that must mean we are on the second get request, not the first get request. So that's what we do, is set session guess, we pull out session guess or a blank, and if there's a message or false, depending on whether or not we're really teaching ourselves or determining whether we came from the first get request or the get request after the post redirect. This is cool stuff. I mean, if you've been watching all along, now you understand. This is like, it's beautiful, it's simple, it's elegant, it's like amazing. Okay, I'm too excited. So, this comes through, two get requests. One of them, it has messages false, so that doesn't print out the message, and their guess is empty, so it doesn't print out. The second one, color. The second one, so it prints the message out and it prints the guess out. And so that's how it works. And so if you press 41 and enter submit, you will see that there is a post request that gives us back a 302 that redirects back to the thing, and then the browser, in a blinking instant, the browser goes and grabs the get request, except now this get request can put in the word too low and put in the old guess, because it pulls those out of session. And if you hit refresh, it still knows what the old guess was, and it's still, because the session, now we've had a third thing. We've done another get. We did a get, a post, a get, and a last get, but it just pulled that data out of session because we didn't take it out of session. Everything we put into session stays until we explicitly remove it. We could have removed it if we wanted to, but we didn't. And so even in refresh, even when we, come back. Even when we press refresh, it knows this information that came out of the session. And it's a get request. It's not a post request. It's a get request. So the post and the redirect. So that is your basic post, redirect, get. Meaning that if you're processing post data, don't put output, stick everything in session and then redirect it, and then in the get, you pull it back out of session and do it. So it takes 2 steps to produce that page. So understand this, because up next, we are going to talk about log in and log out and sort of bringing all these things together. That thing I just showed you was what's called a flash message, meaning that it shows up.
So log in and log out using session. We're going to show some error messages and how other ways that we can use session and redirect to even start routing between different files as well. So now that we've learned about redirect, we've learned about post redirect, now we're going to start sort of just using post redirect to accomplish things. And the thing that we're going to look at first is the patterns that we tend to use for login and log out, and how the session and the cookies work together for login and log out. So recall that when we first looked at sessions, we weren't really logging anybody in. What we were doing is creating a key value store that's associated with a particular browser. So if you have 100 browsers, you'd have 100 little sessions, and each one has its own key value store. And the cookie is the way you look up the session, but the cookie is not the session itself, because the user can change the cookie. And in effect, it's presenting the cookie unlocks the right session. But you don't want to set a cookie that says this person is logged in and their username is Chuck. You don't want to do that, because the user can change the cookie anytime they want, and they can lie to you. That we can sign cookies, and there are ways to create cryptographically secure cookies, and that's a little better because at least they can throw them away, but they can't sort of change them once they're cryptographically signed. So, but let's not worry about that. The cookie unlocks the session, and whether you're logged in or not, you want to put that in session data. And so the act of logging in, you need a session, but then whether you're logged in or logged out is checking to see if something's in the session. And when you check their password and you put something in the session, as long as that stays there, then they're logged in, and when you log them out, you just take that thing out of the session. So all the rest of your application checks to see if there's a certain piece in the session. The user can't touch the session directly, they can touch the cookie directly, they can only touch the application reads and writes it. So it's protected, and that's really important, because you don't want the user to read and write everything. You want to read and write the things that you want them to use. So away we go. So this is the application that we're going to run. It's a sample application with log in, log out, flashing error messages, post redirect, and using the session to indicate logged in and logged out. And you can download all this code and take a look at it. And I'll record a little code walkthrough for this as well, if that is a more fun way for you to see it. But let's just kind of go through these slides and take a look at how this works. So the first thing we're going to look at is the login. Second, we'll look at index.php. And so here's your login code. And the key thing here is we will see this in a second. Yeah, let's look at this slide first. No, doesn't matter. We got to start somewhere, so let's look at this slide first. So a get comes through, and you put out this form. And the form has an account and a password. For now, I'm just making it type text so you can read your own password. And then you submit. So you submit back to login, its method equals post. We're submitting a post to login.php. And so then, once the post comes in, right, the get comes in and just goes through and paints that screen. The post comes in, session start. If we see that there are these variables set, we are going to first log the person out by taking the account key out of the session. And the account key is what we're going to use in the session to indicate that they're logged in. So somewhere here you're going to check the password, and for this particular application we're just going to make it be UMSI is always the password. So that means password is correct. To indicate that it's correct, we're going to set in the session the account is the post account. So that would be Chuck or csev@umich.edu or whatever. And then we're going to put a little flash message in. This is called a flash message, named success, and we're going to say logged in, and then we're going to call the header to redirect to app.php because we're in login.php, and then we're going to return if that's what happens. On the other hand, if you don't have the right password, you're going to set a message in the session, kind of like the too high, too low in the previous example, and then redirect back to ourselves, and then return to get out. And so it's either going to come back to us with an error or success in the session, well, error in the session, or it's going to go over to app.php with the person logged in or not. Okay? And so now let's take a look, take a look at this code, and that is, here we are in the body of the login, and now we check to see if there is an error key is set, and If it is, we're going to print it out with color red and unset it, so we're taking it out of the session. This is a pattern we call flash, meaning that if you get a bad login error, then it shows a red message like bad login, but then if you hit refresh, you don't see it again. So we're going to take the error out. We didn't do that in the previous example with the guessing game. We kept the message in the session, but now we're going to take it out, and we're going to have the same pattern if there's a success string, and we're going to print it out and then take it out. And then we do the form. And that basically is how we get to a screen that looks like this, that has the incorrect password, this came, and this is still a get. So you hit this button, it does a post, a redirect, and then this flash message. And if you hit refresh at this point, you would see that screen again. That's because it's a flash message. And so post, redirect, get, flash is the idea of putting a message in the session, then you redirect, and then that screen pulls the data out of the session and then removes it from the session, displays it on the screen once, and then deletes it. And then if you hit refresh on this page, you don't see the message because it flashed at you once and then it was deleted. So that's called a flash message, and it's just another pattern. And so if we look through how the flash message works, so you're sitting here on the login screen, you send a bad password, and so then it says, oh, and it can't send a real HTML, but it does put the string bad password into the session under the error key, and then it redirects the browser immediately to login.php and says, hit me with a get. And so then the browser instantly does a get request, login.php wakes up, it reads the flash message, and then it produces the output, but then it wipes it, but it wipes it out of the session, right? And so the user sees bad password. And then what happens is if they then hit refresh, on the next screen that they see, there is no bad password because it's been removed from the session. The act of producing this actually wiped it out of the session. And that's the idea of a post, redirect, get with a flash message. We throw the message in the session, we show it once, and then we wipe it out, and it's not there anymore. So it's only on the next get request that we see a flash message. And it's very common for little error messages that you don't want to be hitting refresh and the error message stays there. Refresh, bad password, refresh, bad password. The old guess was not so bad, so we didn't really want that old guess to be too low in the message. It wasn't a bad design, but for a login screen, you probably want to use a flash message, which only lasts for one next request response cycle, and the further ones don't do it, right? So it takes it out. So that's a flash message. Okay, and there's the code that does the flash message, and you'll see, I mean, when I write my code, I kind of pretty much always use the string error and success, and I put them in, and pretty much I just do this over and over, and the next thing you know, I make a utility function that just does these things, because I do the same pattern in the beginning of my code over and over and over again. You're doing flash messages all the time. Sometimes they're good and you want them to be green. Sometimes they're bad and you want them to be red. Okay? Okay, so let's take a look at the application code, the app.php. And so if the way the app.php works, if we go all the way back up here, should have these screens a little lower. When you first go to app.php, it says please log in. And once you're logged in, app.php says please log out. And so we have to look at how you write app.php in a way to do this. So here's app.php. App.php comes in and it says, it puts out a flash message, checks to see if there's a success message, that's the little green logged in, and puts that out and then unsets it, that's the flash pattern. And then we are going to check to see if we're logged in. We say if the account key is set in the session, if it's not set, then press login to start. Else, this is where your whole cool application would be, or press log out to get out when you're done. And so that's how the presence of the account key in the session tells you that you're logged in. And in the code that does the successful login, that sets that key. So if we follow this through now, you are in the login screen, you send a post request, and it's good now. It's a happy post request because you got the password right. And so we set the account key in the session, and we stick a success message in called logged in, and then we redirect, but now we're redirecting to app login.php. We're not redirecting back to ourselves. In the error case, we are redirecting back to login.php, and this is why I call this kind of routing, right? We're choosing in the first part, which is routing is a controller function in the model view controller. So we are being a controller and we're saying, oh, I've got this data and I'm in good shape, and the next thing I want the user to see is app.php versus I've got this data, the password's wrong, I'm going to set an error message, but the next thing I want the user to see is login.php because I want them to log in and try again. So the routing decision is controller, and you see that in that code. So it redirects to app.php, it sets logged in the session of under success, and sets the account in the session. So now we're at app.php, the browser does a GET request to app.php, and it checks the account and use that to generate the if then else, but it also sees logged in, and so it says, oh, that's a success message. I will send that back to the browser in a flash, but then I will wipe out, right? I will wipe out that flash message, the success message, but I didn't wipe out account. Okay, so account stays in the session to indicate we're logged in. We're logged in until that goes away. So now every time it goes back to app.php, account is still in the session. So it reads it and it knows that you're logged in. And so as many times as you do this, you're going to stay logged in the whole time. Now, the most fun code to write is the logout because it almost always looks the same, and that is you start the session, you throw away all the keys in the session, and then you just redirect back to app.php, and poof, you are logged out. So you press logout, you go through this code, and then you come back to the same file, and now it says login because the account is no longer in the session. And so that's login, logout, etc. right? And so now you've came in before, now you're back to logged out because you remove that by doing the session destroy. So, in this series of lectures, we've talked about cookies, we've talked about sessions, we've talked about how we do sessions in PHP, we talked about post redirect, we talked about the redirect header, we talked about the post redirect pattern, we talked about flash messages, etc., etc., etc. Thanks. See you on the net.
Hello everybody and welcome to Web Applications for Everybody. Now we're doing a bit of code walkthrough. We're in the section on how things happen with routing. And what we're going to do is we're going to talk about this redirection code. And it's really dumb code. It's really just a post form that I put in a number, and depending on the number, I am going to redirect to different places. So let's first take a look at the notion of what redirecting is in general. Right, and so the location header is basically one of the HTTP headers that you can send. You send a GET and it returns and says 302 found, and then it says location : where you're supposed to go. And so just as an example, if you go to www.doctor, my normal URL is drchuck.com, but I also have drchuck.com with no dash. I got it much later, so what I do is I just automatically redirect it using that redirect to my drchuck.com. So you notice the URL changed here. So I switched it from one to the other using this location header. So you went to the Dr. Chuck with no dash, and then you were told to go to Dr. Chuck with a dash, and that's a redirect. And that whole notion is there. And so we have ways in PHP to set these response headers using the header function. So echo or print sends data to the body of the response, and header sends data to the header, the part that comes out first. And so let me do a view developer console so we can watch the network go by. Network. So here we go. So let's take a look at reader1.php. So I'm doing a session. I'm not really using the session in this particular one. I'll use it in the next one, so I probably could get rid of that. Okay, it won't have session next time you download that source code because it does not need a session. It really doesn't. There's no session in it. So if I post a 1, it's really simple. If I post a 1, I run the code redirect back to itself, because you can redirect back to the same script, and then I return. Or if I post 2, I redirect to a location, and in this case I add a get parameter to it, which is reader2.php, which is really just a copy of the exact same thing. So reader2.php is just so that I can sort of be at a different place. And then if I put a 3 in, it completely redirects to some other place, right? drchuck.com. Okay? So I'll put in a 1 here, and let's watch the network console. I hit submit, and so this was a post of the value 1 to this URL, and what it gave me back is a 302 found, which is not the same as a 200. 200 means good news. 302 means, like, I know what's going on, but you're at the wrong place. You need to go here. So what happens is, immediately, without us even seeing a blink of the eye, the browser stops talking to this URL and switches to that URL, and then sends a GET request to that URL. And so that's what we actually see. Now I'll refresh this so we only have one thing in there. And if I say 2, you will see that I do a post back to reader 1, because that's where the post goes, but then reader 1 is going to say, oh, go somewhere else, and the place I want you to go is reader2.php parm equals 123. So then it goes and instantly grabs this, zip. It grabs it with a GET request. And so that's the screen that we're seeing. Okay? And so if I type a 3, and remember reader 1 and reader 2 are the exact same code. If I type a 3, it is going to go to location www.drchuck.com. So let's put a 3 in, clear the network, put a 3 in, and watch what happens. Boom. Now we're at drchuck.com. So there's all kind of crap that comes out, HTML and CSS and whatever. So let's just look at the first 2 requests. I scrolled all the way back up. The first one, I did a post to reader2.php with a value of 3, and it responded 302, go away, and it said, here's the place you're supposed to go. So it immediately, my browser immediately saw this and then did a GET request to drchuck.com. It of course retrieved all that HTML, and then it said, oh, I got to bring a picture, and yada, 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 yada. And so that's all these other 71 requests are the rest of that. The redirect is what happened here from this post with this redirect to this GET. Okay? Okay, so that gives you a quick overview of the redirect, and come back, we'll talk about some of the ways that we can use the redirect. Hello, and welcome to Web Applications for Everybody. Today we are going through some of the code for the routing. We've done some redirecting, and now I want to play with this code, guest.php. And so this guest.php code. This is the code that I use to introduce model view controller. And so the model part here is the silent data processing bit, and the view is the part below it with a few little bits and pieces being injected, kind of an HTML template with some dynamic bits in it. And then the context sort of falls from this top part to this bottom part. But I want to show you a flaw in this. So if I do 41 and it's too low, that's fine, and I do 42 and it's just right, and I'm really happy. The problem is that I'm sitting on a post. The last thing I sent was a post, and if I hit refresh, because posts are considered by the browser to be expecting to modify data, like if you were going to decrement your savings account, you would do it in a post, the browser doesn't want to resend a post request for you just without your knowledge. Now this is not coming from my application, this is coming from my browser that's keeping me from doing something stupid, right? It says you might be decrementing your bank account balance or transferring $100 twice or something, right? So to run that, I have to do this. We as application developers, we have lost control of the user experience at this point. And so, you know, that's pretty tacky, and we're not very happy about that. And so there is a way to fix that, okay? And that is to never generate output on post, and you can say post, you can Google post redirect get, and you will see some Wikipedia pages, which I love so much, and I even use this in my lecture, that basically says the problem with the post and then a 200 that comes back, and then you hit refresh and it sends the post again to generate the page, and that's the dangerous moment, right? So what we want to do is we want to do a post, and then we do the work, and then we redirect back to ourselves with a GET request, and then we put the actual page out on the GET request, and then if you refresh it, it's doing a GET request over and over, and so that's all cool. The problem is what if we want to put a message out on this screen and we are generating the message here in this post code, like success or message or guess too low or whatever? What we're going to do is we're going to use the session to copy the data from this moment to that moment. Okay, we're going to look at the session to copy from this to this. So we have to use the session to get the message, because otherwise what we were doing is we're just putting the too low message out right here, but we got to do a post redirect. So we're going to know the too low message here, and we're going to send it in the session to the next one, and it's going to pull it out and then print it. Okay? So this is the bad one. Falls through, produces output as a result of the post. Here is the good one. Now, one of the first things we see in the good one is we have to use the session because we're going to pass data. Pretty much almost everything except this little bit right here is the same. All the HTML entities and all that stuff is the same. And let's go to guess2.php. Okay. Now the problem is that this data up here in the model part has the old guess and the message, and it wants to communicate it, but it's going to come through here and then come through again. So it's not, the post data is gone, the get data is gone, but the session data is not. So one of the things we do is get the context, and that is the data we pass from the model to the controller, get the context into the session. So if we have a post of guess, we calculate the guess, and then we stick the old guess into the session with a key guess. Because remember, you can write this, you can put stuff into the session and it just stores it for later. And then we do the old logic and we say a session sub-message is the high, low, great job, and then we redirect back to ourselves, and that causes the browser to immediately grab and get a new copy of us. So it comes down, but this is a GET request, so this was a POST request, but we say don't do it, right? And we're right here in this picture. We're sending back the answer to the POST request, which is do a GET request, which immediately turns into a GET request to the same page, right? So it's going to come back in. POST is no longer defined, but session is defined. So we look down here and we go like, oh, okay, well, let's grab the old guess. If there's a guess in the session, we'll grab that. And if there's a message in the session, we'll grab that. Oops, that should say false right there. I don't quite know why it doesn't say false right there. So we'll save that. So if message is not equal to false, we print it out, and then we print the old guess. But we pulled them out of the session because we're in a second request response cycle. The second request response cycle. So we pulled the data out of the session to produce that page. So let's do it. So let's do a guess of 41. Now, let's do view developer console. Okay, so look at the network. So we're going to do a post to guess 2. And there you go, a post to guess 2, and we send the guess in 41, and we got back a redirect of 302, which says it's not really a page, it's something else, and the something else sits here in the location, says go back to guess 2. So we're redirecting back to the exact same script, and so the browser immediately grabs that script and it sends a GET request to it. And that GET request comes down here, grabs the old guess out of session, grabs the old message out of session, and then it renders this. And so the actual output is here to the GET request. If we look at the output of the POST request, there is nothing, and that's because up here, after we did the redirect, we returned and got the heck out of there. So we didn't fall through. We kind of caused us to come back by saying, come back to this same script again, please. And away it goes. And so there you go. That's sort of a post redirect implementation. And the pattern will be when you have post data, you eventually have to put things in the session, do a redirect, and return. And so we'll see more complex code, but this pattern of set the session up, do a redirect, return will be done over and over and over again so that we can follow the best practice rules of post redirect get. So I hope you found this helpful. Hello and welcome to Web Applications for Everybody. In this little bit, we're talking about some of the routing, the redirecting, the post redirecting, the no refresh on the posting. We did all that before. Now we're going to actually sort of talk about the login function, where we're talking about all these things together. And so here we have this application. And this application is pretty smart. It detects that you're not logged in, and then it sends you to a login screen. And so you can log in on any account as long as the password is UMSI. And now we're logged in. And there's a little success message here, and then you can log out, and now you're logged out. Okay, so there's several files. There's app.php. This is made up of app.php, login.php, and logout.php. So login, at least so far, this application doesn't do much. It actually doesn't have any post handling, so the model part is just get the session started, and then we drop into HTML. Blah, 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 blah. We'll come back to this success bit in a second. This is what's called a flash message. But what we're doing is we're basically using as the indicator, whether you're logged in or not, the keys account being present in the session. So if the account key is not in the session, which it is not there when you first start out, it says please log in. But if you have logged in, then the account is in the session, and that's where we say, hey, here's a cool application, and go ahead and log out. Okay, so it comes in, starts a session. There is no account key in it, so it says please log in, and that's just a standard href, so we go over there. While we're doing, let's look at Developer Console, get that start up, get that ready for us, because that'll be so much fun. Now, login is where the fun begins. So here we have login. We have model code up here at the top, session start, of course, and here's our post code. We'll come back to that really quick. And so now here is our body, and the first thing we're going to do is these things we call flash messages. And so I'm going to put errors in the session under the key error, and I'm going to put good things that happen to us in the key under the key success. Okay, and so at the beginning of this please log in, right here between those two things, I'm going to check to see if there is an error in the session, and if it is, I'm going to print that out red, and I'm going to unset it, and that's why we call it a flash message. And so in this case, and the same would be true if there's a success, except I printed out green and then I unset it. So right here between login and the start of the form, there might be a message or may not. And so if in the case now where I have a bad login, right, and I press login, it's going to come up here, it's going to see the post, and it's going to unset the session sub-account. That logs out the current user. Remember I said that when the account key is in the session array, then we're logged in. So that's kind of a logout. If the password is equal to UMSI, then you're good, and we're going to log in. And if it's not, we're going to not log in. So we're going to do this code first. We're going to set the error to incorrect password, and then we're going to redirect back to ourself. We are in login.php, and we're going to redirect back to ourself. So we did a post. That's a post. And then a redirect back to ourselves. But we also sneaked into session this little thing. So after the redirect, a get comes back in, and this code triggers and runs, and out comes incorrect password. Now the interesting thing is, because we have removed it, if I refresh this page, and it is legit to refresh it because I'm sitting on a get request, if I reset it, that password, that error is not there. It only showed up once. It's a flash message. That's why we call it flash. It flashes on this, but then if I do another request response cycle, it's not there. And we achieve the flash by getting it out of the session once we've displayed it. Okay? So now let's talk about what happens when you have a successful password. So we'll go, Sarah, and then UMSI as the password. It's going to come up here, and this is now really starting to get very controller-y feeling, because the controller routes. In this case, it decided to route back to the existing script that we were coming from. But now, once the password matches, we're going to put up a cute little success message in the session, and we're going to set the account. And this account signals to app.php that login worked. So we're sending a message in the session from one script to the other script. So this redirect is going to happen. So I'm going to log in correctly. So login is a post, and then it redirects, but in this case you see that redirects to app.php, and then it does a get, and so this is the response that comes from that get. But then if we look at app.php, we see it checks to see if there's a success message in the session, and it prints it out in green, and then it unsets it so it's a flash. So if I refresh it, that's no longer in the session, okay? And this is where we would have some cool application stuff, playing a game or something. And then we're going to go to logout.php. So logout.php is always my favorite script to write because it all pretty much has 3 lines. We start the session, we wipe out the session, removing the account, and then we redirect back to app.php. So let's clear this bit out, and I'll press logout, and we're going to do a GET request to logout. This is not a POST request to logout. And it clears the session. So it was a GET request, and we sent a 302 as a result of a GET request after having wiped out the session, and then said go back to app.php. So then it goes back to app.php, and it runs through. There's no success message, and there is no key. And the account key has been gone, it's been taken out, and so we just logged out. Okay? So I hope that's useful to you. It brings all this stuff, a model view controller and post redirect and all that stuff is now working quite a bit in this particular small application that just has 3 files.
So hello and welcome to our lecture titled CRUD, Create, Read, Update, and Delete. We have been a long way coming, to get to this lecture. In a sense, there's nothing new in this lecture. We've been doing all these things. We've been deleting data. We know how to talk to the database. Things like redirect are important. Things like flash message are important. And so now what we're going to do is we're going to, in a sense, take the code we've been writing all along in these various applications and refactor it so that it looks more like a typical application. And then we'll use the idea of the ability to insert, delete, update, and read records in the database as a pattern for lots of applications. So this is where we kind of review everything we've talked about for the last so many lectures. So we've done most of it, but we're going to do it a little bit differently. And we have this database. This is one from a couple of lectures back, and it's got this little delete button, and it's got an add button, and it does, so this is like the read, this is delete, this is the C button. We are not doing any updating yet, and so that's the new thing we're going to do. But usually we take these things and don't put them all on the same screen. So we're going to break these pieces into different screens and put them in different files, and that's typically how we do these things. And so we'll end up with a bunch of files, like a file to do the add screen, a file to do the edit screen, a file to do the delete and edit, and all those things. And so we're just going to pull stuff out. So it's not really all that new. So just as an example, the first thing we'll do is we're going to have an insert screen that's add.php, and then we'll have the index.php that does nothing more than lists all of the items and then gives us an edit button, delete button, and an add new button. And so it's code we've written, but we're going to move it around. So let's take a look at some of the index.php. We are removing all of the insert code into its own add.php, and so there's less in the index.php code. We're going to require pdo.php. We're going to start the session and then start our HTML, and there's no posting here. So this is a script that's only going to do gets, because the add was the reason we did post in this kind of code before. So we have our model up at top, but there's no model. And so the view down here, we start our body, and the first thing we do is print out this flash. And so this notion of the flash messages, and that's checking to see if either error or success is out, and then printing out a red version of the error or a green version of a paragraph with the error in it, and then unsetting them. Unsetting removes those keys. So if ever this index starts and it sees one of those two things in the session, it's going to print it out, and away we go. So that's going to become a pattern we're going to do over and over again. And then we print out a table, because we're just going to print the table out. And we do a basic select, a select statement, and we pull out, and in addition we get the user ID, the primary key, and then we make out table rows and use HTML entity, show out the name, password, and then we put in this time we're not going to use a form, we're just going to use an href. We're not actually posting back, because in those other ones we posted back, and we'll see why we do that in a moment. So we simply do a get request to edit.php user ID equals, and then 1 or 4 or whatever, and delete.php, because now we've made those other files. So this code is getting a little bit simpler in a way as we're sort of pulling it out into pieces, and then we just have a link to add new. So this is a relatively simple program. It checks, it has no post data, it doesn't expect to be posted to, it's only a get, but it will print out flash messages, and then it just loops through and prints out our data and has a couple of links to the other pages that are properly formed. And so this leads to these edit buttons. If we take a look at what's underneath these edit buttons, they are just get messages, get user ID equals 2 or whatever, etc., etc., etc. And then we just go to those pages, edit.php and delete.php. So add.php is code that we've just really pulled out from that old code that we were doing in a couple of slides back, or a couple lectures back. And so it's pretty much the same. We're going to have a session. We pull in our database. We have some view code, model code right up here that's doing our database. And this looks exactly like the add code from before. We set up the insert statement, and we execute it with the stuff. And the difference is now that when we are done with that, we put a little flash message in the session, and then we redirect back to index.php, and always remember, return afterwards. And so on a post, this is going to come in like this, do this work, and then leave. And then on a get, it's going to come in, fall through, and display the form. Okay? So that is code we've done before, but it's also simpler. So the last time we looked at this code, it was all, the index and the add was all one, but by pulling them out, we're keeping them a little easier to understand. And so that's helpful. Okay, and so when we finally hit the add button, right, we press the add button, it comes in, it does the post, it does the insert, and then it sets the stuff in the session, and then it redirects to index.php, and there's that little bit of code in index.php when we get back here to index.php that pulls that thing out and puts out the little green message. So that's the flow. We're in index.php, we hit the add button, we come to here, we hit the submit button, go back through, and then we go back to index.php with the word record added upon success. Now, this code is a little simple. We might want to check for errors. We might check for data validity. I'm keeping that out of here just so that it fits on the screen nicely. But the data validation actually fits right here, because you do want to do all the data validation before you do any inserts into the database. Now, the delete.php, again, is code that we've done kind of similarly before. One of the things that you'll find is that deletes often have pop-ups or some other page, and part of that is to get to the point where the actual delete is done as a result of the post. So in this code, delete.php, we're going to have a get parameter, user ID equals 4. We're going to grab our database, we're going to start our session. We're doing a get, so the post isn't there yet. And so what we're going to do is we're actually going to pull up the data, because this user ID 4 or whatever may or may not be a valid user ID in our database. And so the first thing we're going to do is we're going to do a select, pull up the person's name so that we can then echo it. We're doing it and pull out that 4 in that get parameter. So where user ID equals 4. And then we're going to do a fetch. And if we didn't find a row, that means that somehow this number is bad. And we're going to put a error message in and then redirect back to index.php and then leave. Don't fall through. Pretty much when you say header, you pretty much want to return is the next statement. And if the get falls that comes through here, the get actually comes through here. If the get gets to this point, then we're going to put out the person's name with HTML entities, of course, because they might have a single quote in their name or something dangerous. And then we have the user ID as a hidden field. That's the user ID, and we pulled that in with a select statement. And then we have a delete button, and we just have a simple href to go back to index.php for canceling. So we make this a post. Got to make it a post, because if the post comes back in, when we hit this post button, it's going to come back in here. And so we only want that to be a post, so that for all the rules that you're not supposed to modify data on a post. And then when we finally hit the post button, press the post button, it comes up, it runs the delete,
does the delete, and then says record deleted in success, and then redirects to index.php and ends the script. So what happens is now you know all these things, these patterns will get more and more comfortable for you. So that's a delete. And this is the flow, right? You go from, you click a delete button, which has a get parameter on it, which goes to here. It produces this. This is a post back, and then it runs the post code, sets this thing in session and redirects to index.php. And there, of course, the code is in the index.php to pull out the flash message and remove it from the flash message. And so that's the flow. So we do a get request here, a post request here, and then a redirect and another get request. So we're still redirecting from a post to a get, but we're redirecting to a get of a different script. And we are sending this session, using this session to send that message to a different script, and so that it's okay. And so that's part of the controller function, is the routing from one thing to another. And so the only thing that's really new, everything else of that code was kind of stuff we'd seen, other than the fact that it's using post and redirect and flash messages, but the edit is the only thing that's a little bit weird. And the weird thing that the edit has to do that's different than all the other screens is it wants to put the old values from the database in. Okay, and so we're on a get request, so it's going to go right past the post stuff. Okay, so on a get request, delete ID equals 7 or whatever it is, user ID equals 7. And so we're going to go pull out the data, select star, which is name and email and user ID and everything from the database. We're going to get 1 row or 0 rows. And so we'll run this thing and we'll fetch our row. And if we get a false, that means that something bad happened. So we send it. When you just put in an error message and go back to index.php and leave. So you kind of know that's a safe thing. Just get out of here. But chances are good, if the link came from index.php, this is going to work and you're going to have an actual row. And then row is going to have the key value pairs of all the columns of that row. And it'll fall down now into this next bit of code. And so what I do here is I'm going to take and make an HTML entity, the name and email and password, and then pull out the user ID. And I'm kind of now in the view part. So all of a sudden it says edit user, blah, 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 blah. And then you have this typed in stuff, the name for the value, email, password, and the user ID. And I make the user ID hidden. The notion of having a form with a hidden tag that's like the primary key of what's being updated, that's a pretty common notion. So in here is the user ID for whatever it is, so that when you press the update button, it knows what user ID that you mean to update. And we name these things name, email, password, and user ID, so we can then take a look at them when we're responding to the post code. And so what happens then is, of course, you go to the edit, and that's a get request, with an ID equals on the end of this thing. And it has the old stuff in it, and then we modify it, right? We make changes to it. It has pulled these out, and now we're about to hit the update, which is a post request coming in, and there is the hidden variable of the user ID that we don't see in there. And so we can check to see if the name, email, password, and user ID is set in the post data. That's just kind of a sanity checking. If we were going to do any error checking of the validity, which we should, I'm just not doing it here, it'd be right here. And this next code of running the SQL, the update statement, update user set name equals colon name, email equals colon email. These colons, remember, are just placeholders for PDO. And then we're going to prepare that, and then we're going to run it based on pulling the post data in from the form, and then that'll work. And then here we go, these 3 lines. You're going to type these 3 lines so many times. Set a success message of record updated, and then redirect to index.php, and then return so we don't fall down into the get code. And then that'll cause a get request to happen here, and then index.php will pull out that success message and wipe it out and print everything. And so there's not really all that much new in here. Pretty much the idea is this looks kind of like an add form, except that the add form now has value equals for all these things, which then we pulled out of the database. We pulled out of the database right here. So we pull the record out of the database, We complain if we don't find it. If we do find it, we write the same form, but we just put value equals in to have all the old values, which means now you can just go in, drive around and edit them, and then hit the submit button, and then send the data in and run an update statement, and then come back to index.php with a success message. So I encourage you to take a look at that code. I encourage you to understand pretty much every single line of the CRUD example. It's not that hard, right? But it wraps up a whole lot of things about posting and redirecting and PDO and like so many things. Now you can look at that and understand hopefully every single line. And now we can go from just sort of learning the basic mechanics of HTTP and how we manipulate HTTP and what are some of the underlying things we have to do. But instead now we can start building more fun applications because they're all slight variations on CRUD: create, read, update, and delete. And so going forward, it'll be more fun than it has been because we know enough at the end of this lecture to build basic PHP applications.
Hello everybody, welcome to Web Applications for Everything, yet another code walkthrough. The code we're walking through right now is CRUD, the CRUD application. Now you'll notice if you click on the CRUD application, it won't let you run it on Web Applications for Everybody, and that's because it requires a database connection. So you're going to have to download it and run it somehow on your local host to sort of see what's going on. And so there we are, we got CRUD running here. Make it a little bigger so you can see it. Because it has to be set up, and I have this MISC folder, make that a little smaller, this MISC database. And if you're a little concerned or confused about how to get things set up, in the CRUD folder there is a SQL notes on how to set this database up and then insert some users into it. So basically the idea of this CRUD application is it's not really that different than anything else we've done. We're really kind of moving code around and cleaning it up and bringing it to sort of the best practices. So before we have done things like, in the PDO file we did things like user3.php where we sort of had a delete and an insert and a table all showing in the same thing. So in a way, this is the file from several lectures ago that's the closest to what we're going to do in CRUD. But what we're going to do is we're going to have a set of we're going to pull some of the functionality out and kind of clean it up out of user 3 and move it around and then come up with a pattern where we have a file each for the insert, the delete, and the update, and the list. And so this turns out like the index file is the thing that does the list. Let's just play with this application for a second. So here's our index, and it shows what's in the table. We can add a new thing. Caitlin, C-A-T-Y-L-Y-N @umich.edu, and then 987. So we have an add page that does the add, and everything has a cancel to go back, and then it redirects itself back to index.php with a little success message. And then if we got a delete, we can delete this and delete it. Now it's gone. And then we have like on edit, and we can make changes. And then update it, and it changed it. So we're kind of routing between these four main files. There's sometimes a view file, like a view.php that we click on, but we have so little data that we just kind of do it in the index.php. So this is not that different than anything we've done before. So let's go ahead and start with index.php. The one thing you'll notice about index.php is I'm using hrefs to go into edit with get parameters user ID equals 1 and into delete. So there's no forms on this, and so there's no posting going on. There are just hrefs. These are hrefs, and this is href. So if you look at the top, the kind of the model part of index, there's nothing there. All I do is pull in the PDO and I start the session. And then I have flash messages, and pretty soon this is gonna, it won't take long, I'm gonna stick these in a utility file and just include them. But basically they check to see if there is a kind of a residual from whatever previous thing was executing, if there's an error or a success, printing it out and then deleting it to implement the flash pattern. This table is pretty much code we've done before. We make a table, we make a row, and then we make 1, 2, 3, and then the fourth column is this edit/delete. And all we do is we put an anchor tag in, edit.php with a query parameter, user ID equals the primary key of the user ID, and that's the edit text, and then the delete.php, and that's the ID equals and the delete text. And so that's how we end up with hrefs. And then we just go to add.php to go to add new. So let's take a look at the add code. This yellow stuff, this is just my browser. I wish I could convince the browser to stop doing that. That's the browser pre-filling stuff in. And the add code is kind of like the user3.php code. It's got some intelligent post code. It requires PDO-PHP, session start, gets things going. And then it has it's not doing a very good job, but here's the beginning of the view. It's not got a doc type or HTML, sorry about that. But it does check to see if there's an add flash, and we'll see we'll use that in a second. And then we just have a simple form, and then we have a cancel. I'm just making the cancel be a href rather than a fancy button. Now, if we take a look at the post code, this post code does a bit of data validation. Now I'm finally doing some data validation. And this is the model code that says if there is these three variables that are in the post, a at a.com, and a is the password. If those are set, first we're going to check to see if the name or password is less than 1 in terms of length. And if that's not true, then I'm going to say missing data. Oh, so let's execute. And then I'm going to redirect, right? Set an error, redirect back to the script, and then quit so we don't fall through. So we're going to be doing that all the time. So let's send bad data, and here we go. So if I do a view developer console on this and take a look at the network tab, and let's make another mistake, get rid of that, blah, 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 but we'll keep the rest of it blank, and we're just going to say add new. You'll see that it does a post to add.php, and then it sets the error, and then it does a redirect back to add.php, which immediately does a get to add.php, which is what then gives us back this page with missing data, right? So that comes out. So that's a post redirect, and this is a error checking, a data validation error checking post redirect, and that's exactly what we want. We're going to check to see if there is an @ sign in the middle of the email, and so if we have non-blank stuff here, right? But there's no @ sign here. It's going to complain. It's going to come. It'll make it through these stirlens, but it won't make it. So this is my pattern. Data validation, looking good. Check this one, looking good. Anytime you quit, just quit, right? There are other ways to do this, but I try to make my data validation kind of in a protector pattern where I'm not going to let you go any farther. I'm out of here if something's bad. So this one's going to say bad data with a post redirect. And if everything is fine, it does an insert using PDO with the substitution parameters, name, email, and password. We prepare the statement. One of the things is you don't put debug print in here because we're still above the line, and so we don't get to print the SQL out. I tend to it's a little harder. You can print this stuff out, but then you don't want to. You want to sort of comment out the header because you want to be able to see the output if you're debugging in here. But we just do the insert. We've done this before, and then we put a success message, and then we go to index.php. So we're doing controller function to go there. So x at y.com and some password, and we hit new, and so it redirects and goes back to index.php, and index.php has a success message. And because it's been wiped out, at the end, we hit refresh or get, and that message goes away. But the data doesn't go away. The data is still there. So that's the flow for insert. So let's do delete next. So delete, remember, it just is a href coming out right here. It does an href user ID equals and then the primary key. Now let's take a look at the delete code. So here's our model. So we're going to ignore that. Now we are going to check to make sure that the user ID we've been given is correct. So if I somehow can find my way to delete.php, it says missing user ID, sets an error and goes right back to index.php. So somehow that didn't work well. But If it's a URL that we constructed, the user ID probably is in there. So then it's going to demand that. Then it's going to do a select where the user ID is whatever this number is, 8 in this case. And if we don't get a row, then we're going to say bad value for user ID. So if I do user ID equals, come on, 800, it's going to say bad value for user ID and then redirect to index.php. See how easy this is? You just like check a problem, boom, set a flash variable, send it back. Okay, so now finally we're going to get to the point where we're going to put out a confirmation dialog, and we're going to use HTML entities. We're using the short print this variable out, but we call HTML entities just in case the user has named themselves Mr. double quote input type equals button or whatever, or little Johnny Tables for all we know. And so we're just putting that out, and that comes up here. And so X is the person's name. Then we have a little form with a hidden variable, which is the user ID, the primary key of this user. And then we have a little delete button or cancel button that's really kind of routing us back to index.php. But then the post comes in, and we post the delete. We're checking that's the delete that comes from the submit button. Right, post sub delete the name. So if set post sub delete, that really means that delete button was pressed and there is a user ID. We want to double check these. Don't skimp on these. Check for everything you're going to use, because the last thing you want is some kind of a trace back in here. So just double check stuff. This kind of guardian pattern is what it's called, to make sure that we don't run code when we're not sure the post is set. So we're not just deciding when to run this code, but we're also making sure that all the preconditions necessary to run it are okay. So we're going to run a delete statement, delete from user ID, whatever. We're using prepared statement and all that PDO goodness. We say record deleted, and we redirect to index.php, and we return these 3 lines. And these 3 lines are like, yup, you better get it, because it's what you do. I want to go here, and I will please display a green message, record deleted. And so when I say delete, it does that, right? And goes back to index.php and has a nice little success message. And I keep saying this, if I refresh, the success message goes away, but the data doesn't change. Okay, so that's a flash. So we're zooming through this. So the only thing that's a little new, actually most of that was code we'd already had, is just a lot cleaner now, right? So now let's go into edit. Let's take a look at edit. Edit's a little bit different. It's kind of like an add. Here we go again in the model part. We're going to say if these things are set in the post. I'll come back to that. Again, we're going to be clever, and we're going to check to make sure that we know the data. But now we're going to select all of the stuff, right? So select, and we wait if there's no rows. So if someone had like somehow gone to a user ID number that doesn't exist up here, well, we won't do that. It works just the same as the delete code. I probably just grab this code right here from the delete. Looks like it's exactly the same as the delete code. And then I'm going to start printing the data out. And so I'm gonna use a little. I'm going to do HTML entities row sub name, email, and password, and put them in the variables n, e, and p, and pull out the user ID. That's just to make this a little more concise. Here's some HTML with some little bits of PHP variables being dropped in for the existing old values. Now I've already called HTML entities on these 3, so they're okay, so we're safe. And so that's how these old values that were pulled from the database in row number 1 get there. Now I'm sitting here waiting, and I'm going to say Chuck, right? Chuck, and I'm going to do a post, and then the post is going to come in here. So this is the first time we've seen an update, but it works just the same as anything else. It's exactly as you would type update users set column equals placeholder, comma, column equals placeholder, column equals placeholder, where user ID equals placeholder. Then we prepare that statement, and then we execute with the data from the post. And of course, this is solving our problem of SQL injection because we're using prepared statements in PDO. And we should, in time, we'll put error messages here, etc. But for now, this is mostly going to work unless it blows up because we have a syntax error in the SQL, which we don't. We set a success message, record updated, and then we redirect, and then we stop. You know, pretty much as soon as you say header location, you're going to quit. So I've changed this to Chuck. I say update, and there is my data. And of course, it's a post redirect. I don't have to tell you that by now. I think you kind of got it. Edit, we do post to edit, get no response, but then it redirects, and then it gets this thing back. So that's pretty much it, right? That's pretty much the CRUD code. It's not that, compared to everything else we've done so far, it's not all that new. It's just coming up with a nice organization for the code so that we can make sense of it and not make these applications too complex. So I hope this was helpful, and I hope the rest of the code walkthroughs have been helpful as well.
Hello and welcome to my lecture on JavaScript. JavaScript was invented in 1995 by Brendan Eich while he was working at the Netscape Corporation. And he sort of invented the first prototype of it in 10 days. It was invented in a great hurry, and it was really designed to be a language that was very approachable, that people sort of view source in their browsers and figure things out, and it would make programming available to lots and lots of people. It eventually became standardized as what's called ECMAScript. So you'll hear it sometimes referred to as JavaScript and other times referred to as ECMAScript. So basically, if we take a look at a document, we got some HTML. It is interspersed with the HTML, which is really different from PHP because we sort of have the less than question mark PHP. That switches to server-side code, but this is not server-side. This is actually run in the browser. So the PHP code, if it has JavaScript in it, simply emits this, and then as the browser is reading the page that it's reading, it's like, oh wait, I've got to switch into code. And so this is a HTML tag, and it actually comes back to the browser and is run in the browser. And so we intersperse the JavaScript in with the rest of the HTML. Now, JavaScript looks a lot different in between the script and the /script tags because it itself is a programming language. And so it's got for loops and all this stuff. And so we flip back and forth. Now, important thing, just sort of looking at this bit of code right here, this is all interpreted in order. So the browser is like, oh, I saw a paragraph, out comes a paragraph, right? And then it hits this JavaScript and document.write. Document is an object inside of JavaScript that is the access to the actual sort of not the screen, but the backing document that's behind the screen. So document.write with a P tag, this is actual HTML. This actually produces output HTML. And it happens between one paragraph and second paragraph because that's where it happens. The no-script tag is in the situation where the browser doesn't support JavaScript. These days, it's less and less common for browsers to not support JavaScript. Used to be that there was when JavaScript first came out, there was sort of a debate as to whether or not you support JavaScript, but most full-featured websites demand JavaScript at this point. There might be some other thing like NoScript, if you're talking to a web scraper or a web crawler or something like that. So there's NoScript tag is a way for you to print something out in the case of if the JavaScript is not enabled on the browser that you're sending it to. But basically, we start in script and we end in /script, and then we put some code in the language JavaScript, and that's what we're going to talk about today. So one of the first things I always like to do when I am programming is how to get a debug statement, okay? And the alert function takes as a parameter a single string, and it prints it out. So here's a very simple bit of JavaScript. The browser sort of runs this. Oops, hang on. Turn the scribbler back on. The browser kind of runs this, and it stops. And depending on your browser, it may actually stop when in the middle while the page is still displaying. So let's take a look at this particular one. Let me clear this and go and run this one. Here's the sample code. We'll run this first one. We already saw that one. Make this just a little bigger here. And so you see this little thing is still spinning, right? Over here it's still spinning. And that's because it's sort of still processing the page, and the alert has actually completely stopped the JavaScript. So the thing that's going to happen right after the alert won't happen until I press OK, and then it finishes. Okay, so the alert stops right now, and it's really stopping the interpretation of this page. So alert is it doesn't just print out output, but it stops JavaScript processing. So it's a pretty strong form of debugging, if that makes any sense. And so alert's just an executable statement. There are three ways that you can put JavaScript into a document. One is inline within the document using the script tag. You can also put it on things like on-click methods, on things like hrefs, etc. Or you can include a whole file. We'll see all of these examples. So this is some code that we've sort of been playing with all along, but now it is time to sort of understand what's going on here. So this is an anchor tag that is this tag right here. And we have an on-click method. So this is within the anchor tag, right? And it says when someone clicks on this anchor tag, I want to run this JavaScript right here. So the bit in between double quotes is JavaScript. And JavaScript can use single quotes or double quotes as strings. So we tend to reserve the double quotes for HTML. So on-click equals double quote something, double quote, that's HTML. And then quote, high quote, single quotes in this case, is some JavaScript, and we're calling alert. Now, return false has to do with, normally if you were to click on an href, it would actually follow that link, okay? But if you say return false, it won't follow the link, and it'll just run this code and not follow the link, okay? So let's take a look at that one. So if I click, it's going to actually run the JavaScript rather than doing what it normally would do. And if you recall, it would go to jso1.htm, but it's not going to because we did the return false. Okay. So return false is the way to indicate that we don't actually want to do what normally would have happened if the click happened. So you can do both the on-click method and then let the tag do what it normally would do, or you can say I'm taking over and doing that. So this is just one form where we're putting JavaScript right on a tag. So here's another way to do it, and so this one we showed before, where we just did a script tag and an end script tag, and then had document write. You might see something like this. In HTML5, we tend not to do this, but this is validation to make sure that the JavaScript passes a strict HTML4 validation, but that's less important as we're moving to HTML5. So we talked about this one. And then the third way to do this is to actually use the same script tag and say I would like to load this file. And this then script.js has to be a file that has some content in it. And in this case, we just have one line of JavaScript. We don't have a script tag. It's just JavaScript itself. It knows that it's JavaScript by the fact that we're inlining it. And so that's as if we typed all that stuff here. Now, this is kind of a silly little example. It actually just moves that document right into the file. But that's another form of including JavaScript that you will commonly see. So syntax errors in JavaScript are a little bit different. I mean, we can make mistakes. It's a programming language. But the problem is that most of the time you're using a JavaScript page that you did not write, and you're just using, Twitter. And if there's a JavaScript error on a Twitter page, you as the Twitter user, it doesn't do much good for you to be told that there's a JavaScript error because you can't fix it. Syntax error, missing semicolon, who knows what it's going to be. So the browsers tend to be very, very silent about any kind of a JavaScript error, but the code dies. Sometimes there's a little red icon that shows up in the lower left-hand corner. So here's just an example of a bit of bad JavaScript where we're just going to have a double quote that starts and ends in a single quote. So that's a syntax error. And what we will see is that this will run it will die here, so this code doesn't finish, but then it actually gives up on that script block and then continues, and you'll see that this one will run later. Okay, so let's go ahead and show this. In JS05. Oops. So it did not tell us anything about that first syntax error, but it didn't run that second alert, and then it actually finishes. Okay. So, like I said, the end user is really not supposed to see the error, but we as a developer need to look for errors. And so as we're writing JavaScript, you instinctively, something won't work. You'll make a change and it won't work, and your brain's got to go like, oh, wait, I made an error. I've got to actually explicitly look for it. And so there are developer modes in all of these browsers. I'll play with the Chrome one here. So let's take a look at how you turn on developer mode. And sometimes you have to enable this little message to just show up. But at the end of the day, I can like to view JavaScript console, and I'm going to hit refresh, and you will sort of see what's going on here. It runs, but I see the error, and I can even click right here, and I can see the exact place that the error happens. So increasingly, these browsers all have nice debugger modes in them, and I've just popped up a debugger, and it's got this little thing, and I can look at the console, I can look at the code, and go back and forth. And so this is, can I make that a little bigger? Yeah. So this is a useful thing, and you as a developer, you'll tend to often just leave this sitting down here at the bottom when you're working on code all the time, where it's like, I just leave this on all the time. You kind of do it with console, and you run it, and you see something like, oh, wait, and then you know how to go look for that error. Okay? So that's very important, because there's no good way to see these things unless you've got this console turned on. Sometimes your browser will say, go look up JavaScript errors, but it really wants to hide these from end users. You as the developer of the website have to get this stuff right. So alert is kind of a blunt instrument in that it stops running the code. And sometimes you have a loop or something. You want to put some debugging in it. And so these debuggers have added a console.log method. And you can pass in a string, and you can console log all kinds of stuff. And so basically what you can do with the debugger turned on is you say, console.log, and it'll come out in the log. And so this same console.log that we were seeing allows you to see things. And it just runs. And so that console.log is a very useful thing, and it allows you to, even inside of a loop or inside of an event or an onClick method, to be logging stuff without stopping. If you do an alert, it stops. But if you do a console log, it just streams by in the debugger window. And if the end user doesn't see this, only developers might see it. So I tend to, in some of my sites, you can go look at them, and you'll see the console talking, and you can see a play-by-play of what's going on inside of one of my sites. Now, depending on the browser, the console object may or may not always be there. Sometimes it's there when the debugger's on. Sometimes it's not there when the debugger's off. So my favorite thing to do is, whenever I'm going to do a console log, I say window.console, which won't cause an error, and so that means that if the console exists, then I will call console.log. This is just a real succinct way of saying that, window.console and console.log. Another way to do it, you can look up all kinds of ways to deal with console.log. This is my preferred way to do it, but you can also just, if the console function doesn't exist, console variable doesn't exist, it sort of sets that up and sets a log function, but this is my favorite way to do that. So the debugger, as we mentioned, is a great tool for debugging JavaScript. You can pause the debugger, so let me show you how to do that. Let me go back. You can pause code. Oh, sorry, got to clear that. Pause code. So here's JavaScript 01, right? And I can look at the source. And I can put a breakpoint here by clicking right there. So I now have a breakpoint at that point. Now, the page is already run, so once I set the breakpoint, I've got to hit refresh once to load the page. Now that it knows where the breakpoint is supposed to be, it'll run up and stop at the breakpoint. Okay, and so now it is paused in the debugger. You can see that it's paused in the debugger. You see this little spinny guy, meaning the page isn't done loading yet because we've stopped it. And we can look at variables and global variables. There's all kinds of stuff that we can look at. Document, object, model, all kinds of things. And I just click right here to continue the debugger. And so the page completes. Now that's a very, very, very simple introduction to using the JavaScript debugger, but it's very, very valuable. And you'll get used to how this all works after a while. So let's now talk a little bit about the JavaScript programming language. So JavaScript is a programming language. And it's just like other languages, it has its little quirky things. So JavaScript was informed by lots of languages that came before it. It has two basic forms of comments. One is a double slash, which is like a C++ form of a comment that says from here to the end of the line. And you can also have multi-line comments that start with /* to end, and that's like a C language comment, which, you know, this is what we like. We like both single-line comments and multi-line comments in JavaScript, and that's quite nice. White space and new lines do not matter, although we, rigorously indent to make our code easier to read. Statements end in semicolon. There's places you can leave the semicolon off, but it's a little different than Java and C and other C-like languages, but most programmers just program as if they were in Java and put all the semicolons in, and don't try to remember the complex rules as to when you don't need semicolons. So here's a good example of white space that simply does not matter, right? Here is, x equals 3 plus 5 times 4. It doesn't matter if there's a new line or lots of white space. The same is true if there's a new line. I mean, it's as if that white space and new line doesn't exist. Variable names are pretty typical. The only thing that's kind of weird is you can have $signs. They're optional. I'm not sure exactly quite why JavaScript allowed this. I think sometimes language designers are trying to appeal to people coming from different languages, and so maybe people coming from PHP or Perl might have felt more comfortable. The problem is that if you're in a file where you're mixing PHP and JavaScript, it's sort of considered tacky to use the $sign in your JavaScript code. You want to really use that in your PHP code. PHP requires $sign. JavaScript allows it, but again, we tend not to do it. Okay? But other than that, it's pretty much standard stuff. Start with a letter, case matters, underscore. We tend to use underscores for variables that are internal, you don't just have random underscore variables unless it's sort of like global variables or internal variables or some kind of a special variable. String constants are nice. Single quotes and double quotes kind of work the same. You have things like new lines that work in either single quotes or double quotes. Again, not all languages are similar like this. Single quotes, but they're equivalent. But what we tend to do is we tend to use single quotes in our JavaScript constants unless we absolutely need to use double quotes, because we want to use double quotes for the HTML elements. And sometimes you're writing JavaScript that's writing HTML. And so it's nice to sort of, in your mind, just say if it's double quote, we're using an HTML. If it's a single quote, it's a JavaScript string constant. And it uses standard C like backslash either in single quote or double quoted strings. Clicking the wrong place to clear the screen, but we got this screen cleared. Numbers, floating point, integers, just exactly what you would expect. We'll talk a little bit in another lecture about more detail about arrays, but if you just have a standard array, the syntax is pretty natural. They're zero based and use the index operator with square brackets, and so kind of like lists and integer indexed arrays in PHP as well. Standard operators, plus, minus, modulo. We have our post increment, which is, k plus plus is, pull out the value for k and then add 1. I'm using the console here. I'm actually just typing these into the console. K plus plus says, give me the old value of k and add 1, and that's why k is 4. This is a predecrement, which means take out the 4, subtract 1, put it back in, and give me the post-decrement value. So, but don't use those too much. But we do use modulo, and we use plus, minus, and those guys like that. So operators are pretty basic. Like many C-like languages, we have the side effect operators, plus equals, minus equals, star equals, standard side effect operators. Comparison operators are very much like C and very much like PHP, in that there's also a triple equals as well as a double equals, where there's less conversion going on, and the triple equals is kind of like equivalent to, where there's no type conversion going on, much like PHP actually. Logical operators, again, like PHP, double and is and, double ampersand is and, double vertical bar is or, and not is exclamation point. String concatenation. This is probably the part when I switch from one language to another that drives me nuts. I like how PHP uses the dot, but JavaScript uses the Java and other languages more common syntax of plus for concatenation. And it does do aggressive type conversion where needed, and so there's no like string function or anything like that that you might use in Python. You concatenate a string and an integer, and it's like, oh, I'll turn that integer into a string for you, and it concatenates. Okay. Variables, of course, have types. It is a little counterintuitive. Like, for example, here we're adding a string and a number. In PHP, we would expect that to be a number, but in JavaScript, it's a string. Here we're doing a multiplication, so that's going to turn that into a number and then add 10 to it, so we get a number. And then you will see in JavaScript this thing called nan. Okay, nan is a floating point concept called not a number, and that usually you get it by dividing by 0 or doing something else illegal. And you'll see it often in dynamic web pages where you'll see nan, and you're like, oh, that means JavaScript's in action, and probably divided by 0 or something like that. Nan is sticky, so like if x ends up being Fred times 1, it has no idea what to do with that, although PHP would know what to do with that. Fred times 1 is not a number, but then not a number stays not a number if I can add 1 to it. Not a number plus 1 is still not a number, so it's kind of a sticky value. Once you end up with a computation that's not a number, there is no way to do more computations to that value and change it back to a number. It does variable conversion. It's a little bit different. We can also end up with infinity by dividing by 0 by mistake. There is an isNan function, and so we can do these kinds of things, but in general we just sort of avoid doing silly things like multiplying Fred by 1 or dividing an integer by 0 in JavaScript. So these are just some functions that you can play with. There is an operator called typeof, which basically tells you what kind of a thing you've got, and it returns a string. And so type of y, because that's crazy, y is equal to quote why question mark, and it is a string, and so you can check, and you can also find out if something is undefined by looking at the type of an undefined variable. Functions are as you would expect. The keyword is function, and you got a function name followed by your arguments, and of course the arguments are really just temporary placeholders so that they kind of correspond to the call, first and second thing, and they sort of work, and there's a return, and the return value becomes the residual in the expression from whence it was called. That part all looks pretty straightforward. The thing that's not straightforward, and I find it really annoying, really annoying, because in this respect, JavaScript works differently than virtually every other language that I'm used to, that any of us are used to, and that is if a variable exists, like this GL variable, if that variable exists before the function sort of is defined, then this GL is a global GL. Not because I called it GL, but just because it goes like, oh, does GL exist? And it does, so I'll just hook those two things together. So if you look at this code, right, it sets GL to 123. This function is defined that changes GL to 456. We call the function, and then we print out GL at the end. And the global GL, the outer GL, the GL outside the function, has been changed to 456 because this hooks up with that global variable. Okay? Counterintuitive. In every other sane language, this GL would be a local GL within that function, right? But that's not particularly sane. So we have to sort of have a way of overriding that. In any sane language, you'd have to say global to make it escape the bonds of the function. But in JavaScript, we use the var keyword to force it to be local. So you'll see var all the time. Var says, make this a local copy, and even if there is a global version of it, then this is local. And that's why when this code runs, the global 123 is separate from the local 123, and it stays 123 globally. Now, let's talk a little bit about arrays. JavaScript supports both linear arrays and key value associative arrays, but they're kind of actually a little different than associative arrays in PHP. So linear arrays are really simple. You can effectively append into them, and then you have a linear array. You can create an array, looks a lot like PHP there, and then you can set the 0 item and the 1 item. That works as well, and then you just print them out, and you've got an array that's just got 2 items in it, and away you go, and use the index operator as you might expect. You can also use the array constructor, where you say array and then you have a thingy, and you got a 2 item list, or you can use the constant syntax, which is square brackets, and you get the same kind of a thing. Let's talk a little bit about control structures for JavaScript. They're very much like most of them. If statements work like you'd expect, while loops work like you'd expect, counted for loops work like you'd expect, and in loops break and continue work like you'd expect, because it's all very C influenced. So here is the definite loop for, the in, right? And so if we have in this case, this is an object with 3 member variables. For ball and balls, that's going to sort of iterate. Ball is now going to iterate through these 3 things. And if we print out golf, which is a string, and then we look up balls sub ball, so that is a string. Balls sub golf, balls sub tennis. So it prints these guys out, right? So that's an in. It uses the in keyword, similar to Python. The whole purpose of JavaScript is to mess with the browser's document object model. So JavaScript was built to run in the browser. It was built to manipulate the text that is the page. So the document model is like this thing that we can make changes to, and then the browser is rendering whatever is in the document object model. And so it manipulates the HTML document, and it is a object-oriented syntax where we say document.this, that we can hierarchically go and we can find all kinds of things. But the problem is the document object models aren't universal. It's universal that there is a document object model, and if you know the structure of the document object model for a particular browser, the syntax to get to a piece of a page is well understood. And so we can read and write this thing. And so it's, document.head.title.something, or document.body.h1. And so there's this hierarchical structure that represents the page. But unfortunately, the shape of this picture is different for different browsers. So not all browsers represent their page exactly the same. The exact same HTML would produce a different document object model in different browsers. So you have to test your code over and over and over on each browser. If you are doing you're actually sort of just going straight down the document object model to find a form or a header one or something that's in there. And so you end up with these bugs. This is just a bug in Sakai, an open source project I work on, and all of a sudden you're just always seeing these Internet Explorer bugs because, you know, if you're going deep into the code and using the document object model and you test it on Firefox, you test it on Chrome, and you don't test it on IE, then it blows up and you get all these ugly bugs. And so using the document object model directly is generally kind of tacky, right? It's just life's too short